Java. No. That was so whatever.
That was the most horrible intro I've ever seen in my life.
So you want to learn Java, huh? Wow. So you want to learn Java.
Why?
Well, if you must.
So I can pad my resume.
Java's fine. You're gonna like it.
All right, naysayer. Welcome to Programming in Java from Whippet.net. Kevin and Brian are here again to take you through an amazing journey through another amazing programming language.
Yeah.
Now, Brian and I do like Java. We'll talk about this a little bit. We like Java, but we have little things that we would like.
Just like in all languages.
Yes, yes. So let's talk about, Brian, in the introduction, where did we come from as a group? You, me, you there watching the tutorial? Where have we come from?
Right, so we know the basic learning, we know the basic concepts of learning computer programming.
Yes.
So we already started learning those, we got those now down, we're
flawless.
With the procedural language
everything.
of C.
Yep.
So we know the top-down structure, then we started getting to object-oriented programming, then we went into C++ and Objective-C. Now, Objective-C and C++ were two bolt-on OOP languages.
Yeah.
Java is really interesting, and it's very interesting in its invention because it's a pure object-oriented language.
And it's the first pure OOP language that we're exposing you to here in Whippet.net.
And it's very nice. It's a good implementation of it.
It's fantastic.
It had to happen.
So when you start to look at the structure here that we talked about in the introduction to computer programming, when we talked about the language generations, well, obviously we didn't learn the first generation because that's just
ridiculous.
We didn't get into the second generation because that's also somewhat ridiculous. I don't really have a punch card machine at my house, to do that kind of stuff. But we did start in Generation 3. That's where we began. Generation 3. Now we're getting into Generation 4, which takes you to the languages that are prevalent all over the landscape today. And that includes the Javas of the world, the C Sharps, the
Ruby, the BB, whatever. Yeah, exactly.
So you are now, you went back to the 60s and now you're today.
Nice.
Or at least the 90s.
Yeah.
Where are we going, Brian?
Alright, so now we're going to begin learning the next generation languages. These next two are going to be pure object-oriented language-oriented languages.
Alrighty.
So what are some of the differences? Like, what does that mean exactly? So in a bolt-on language versus a pure language, a bolt-on language, object-oriented structures are a class that you import that enhances the underlying language. It's just classes and interfaces that are used like objects that sort of add on to the underlying.
But that's not necessarily true because object-oriented programming, in order to have those objects, you need to have enhancements to the language.
Exactly, that's true.
So the language has to have something built on top of it to support the objects that you will use.
Whereas a pure language, that's built from the ground up with that in mind when they designed it.
Absolutely. When they laid the foundation, OOP was at the forefront. In bolt-on, it was some old thing that they just built some new shit on top of.
Right. And in a bolt-on language, programs can be both procedural and have object-oriented entities. If you remember in C++, sometimes we would kind of do the object-oriented style main.
Right.
That still came from the main entry point of main, which isn't changeable in the procedural structure.
Right, we also had main functions as the starting point in those languages, in Objective-C and C++.
In a purely object-oriented language, the programs are completely constructed within objects.
Right.
So the entry point is in an object, no matter what. Also in a bolt-on language, there are some distinctions between primitive and complex data types, but in a pure object-oriented language, typically the data types will inherit from like a master object class and then extend out into the different data types that you would use.
Yeah.
Different kind of classes you would use, and it gives you like a really nice polymorphic environment because they're all sharing the parent class.
In kind of that's the same spirit of the NS object that we talked about in Objective-C, although a little bit more baked into the actual language itself.
Right. Also, in a bolt-on language, it's really common for a program to compile directly to machine code, but in a pure object-oriented, a lot of times there's this intermediate layer that is a translated version of the code that you wrote, and that gets compiled in runtime.
Yeah, and the reason why they do that is to try to enhance the portability of the of the code itself.
Right.
So instead of compiling something for a specific hardware, you compile it for just a bunch of stuff, and then
you compile it for a platform, and that platform can run it and interpret it on many different environments.
Precisely. So Brian, what is Java?
All right, so it's a multi-platform, pure object-oriented programming language and an application runtime environment, and you have to have that application runtime environment.
Absolutely.
We'll get into that a little later.
It was released in 1995. So when I think back, wow, what was I doing in 1995?
Listening to Nirvana, maybe?
Yeah, well, Nirvana. Well, Kurt died in '94, so I was still mourning his death in 1995. I was
so
moving.
Sad.
I was moving on, Brian. I was moving on. And in 1995, Java actually made the list of Time Magazine's best products of the year.
Ooh.
And Java was the only technology or computing product that made the list. And if you want proof, there's the link right there
Nice,
to that article in the Time archives.
It was originally developed by Sun Microsystems, which has now since been bought out by Oracle.
Yeah.
And the language syntax is based on C and C++, and one of the things that they wanted to keep in mind is keep it as simple to C++ as possible.
Yep.
As similar to C++ as possible, so that it's not like a completely alien and foreign weird language.
We didn't have to train people too much.
Right.
Yeah, that was one of the big philosophies. So the code, as Brian was mentioning, the code does not compile directly to machine code like we're used to in C, C++, and Objective-C, but rather a specific type of bytecode. So the design is intended to allow all the bytecode that you can possibly produce to execute on any architecture, and the differences between the different systems is the actual runtime environment, not the program. And this is the WORA principle that was the foundation of what Java was built on, and that's write once, run anywhere. And we'll talk in a little bit...
More or less.
Yeah, we'll talk a little bit more about that, but that's the Java philosophy.
So to be able to pull this off, the bytecode runs through a virtual machine, and that virtual machine has it installed on a different platform. So when you go to, let's say you're in Linux, you download the Linux distribution of the Java virtual machine. If you're on a Mac or you're on Windows, you download the Windows distribution of the Java virtual machine.
Right.
And specifically like the Windows 7 or the Windows Vista distribution.
Yeah, x64, x86,
exactly,
whatever.
Right.
Yeah. Java is also known in some circles as a de facto standard language. And the reason why is because even though Java is accepted pretty much industry-wide, it's, at least to my knowledge, and I couldn't really find anything that's specified otherwise, it has no standard recognition. Unlike the other languages that we've talked, like, ISO C++ standards, and Java doesn't have that. But it's still generally accepted.
Right. So originally they were going to call it Oak.
What a stupid, horrible name that was. Although Java's not the greatest name, but Oak?
Yeah.
Hey, dude, you program in Oak? What?
Oh,
Get out of here.
Supposedly, there's a large oak tree outside of one of the developer's office windows, and he's like, let's call it, like, Oak. The developers were informed by the lawyers that Oak was trademarked by Oak Technologies and that they would all owe $5 billion tomorrow when they are fired. So once the new development team came in, after the other guys were fired and cleared out their desks, the legend then had it that the creators of the language had an intense brainstorming session.
Yep.
And they just kind of kicked around some names and couldn't really pin anything down.
And apparently they drank a lot of coffee during these meetings.
So they thought that they were releasing a cutting-edge technology. They wanted to market it in a way that didn't sound like too nerdy or too overly technical. So Sun's marketing department was putting pressure on the team because obviously, like most departments and companies, they didn't really want to do the work themselves. They just diluted the pressure onto another team. Having the developers come up with a name? What kind of marketing department is that, assholes? Like, what the So anyway, they finally figured out Java, and it was selected, trademarked, stamped, sealed, and delivered.
Yep, all done. So where does Java exist in the real world? Well, Java, you can find it, and we're not completely confined to this, but this is just kind of like an overview of places where you'll see Java. Applications, console or graphical applications, in many different platforms. JSP, the Java server pages, which is the server-side web scripting.
Right.
Applets or crashlets, whatever you want to call them. Programs. Programs that are embedded in another program. Mobile devices such as cell phones, tablet PCs, and other mobile devices.
Like BlackBerry and
Crackberry,
Android.
Yeah. Or embedded, like sometimes you'll see a little Java icon on your DVD or Blu-ray player because it's running Java software. And also a lot of high-definition televisions that have more complex, settings and weird stuff you can do will actually have a Java runtime inside the television.
Yeah, it's cool.
And the software that runs your TV is Java.
I would argue the most often place that you'll find Java is probably in Java server pages.
I can see that, but you see it in a lot of places.
Yes, you do.
Yeah.
Yep. Is JavaScript at all related to Java?
Yes.
No.
Oh, why you gotta break my heart, Brian?
You're breaking my heart. So it wasn't even created by the same developers. Java's son Microsystems, God. JavaScript is Netscape Inc. God. Whatever happened to Netscape? Oh, they were bought out by AOL, that's right, and they ruined them forever.
AOL is
AOL tends to do that, don't
a joke.
they? Yeah.
Well, they ruin themselves eventually.
Like every tech company that's bought out by a media empire. Like MySpace.
Oh, yeah, that's true. They went right down the hole.
Yeah. JavaScript's name is generally a marketing stunt to try to jump on the tailcoats of Java's popularity. It was originally supposed to be LiveScript. Legend has it that Sun let Netscape use their popular language names so long as Java was supported in the Netscape web browser.
Yeah, now some of this is speculation. Some people swear this is true, but it is generally considered that JavaScript is called JavaScript to coattail off of Java because the languages are not related at all.
And if it's not true, that's a fun story.
Yeah, it's funny. Who cares? So the philosophy of Java, Brian, is to be simple and familiar first and foremost.
It's a good idea.
So do not deviate too far from C++ syntax, because the assumption is, especially back in the mid and early 90s, most developers were exposed to C++ at that time. So,
and they were, and they still are.
Right, so why not keep it similar to that? So the language's design is to be simple enough that a would-be developer that is familiar with C++ does not need to go through any arduous training programs to become a Java professional.
Nice.
So the familiarity aspect and simplicity aspect is to also create a completely object-oriented ecosystem that will support complex tasks and make them very much simplified.
Right. So instead of if you need to, create a socket and connect to another thing, Java's awesome for that.
It's amazing.
Yeah. You just jump into the packet, say, "Hey, I want to make a socket. I want to make it do this." Done.
Right.
Like it's nice.
Yep.
It's very cool. And so it took a huge leap forward in that layer of abstraction, having that package framework and that whole ecosystem of objects ready to use, like we saw in with Cocoa. It's kind of a similar thing.
Only way better.
Yes, exactly. So
there's no run init object right.
It's very intuitive. It's very it's not necessarily a good thing to learn on because you really want to know the lower level first. But it does make programming very quick. Also, their philosophy was to have architecture neutral execution. So like we were saying, that write once, run anywhere, the Wara mentality, you should be able to compile source code into a language that's not specific to the machine that you wrote it on, but that it can be interpreted during its runtime in a virtual machine on a variety of different system architectures.
Right, and then that bytecode that it produces is more efficient to interpret than source code. Right. Which is what that whole thing is all about. So also performance is very important. I'm going to put an asterisk next to this. But this is, we're just not blah, blah, blah. Since the runtime layer provides significant overhead, they wanted to develop advanced interpretation techniques to maximize the processing output.
Right. Now, we're not saying that performance is good. We're just saying in Java, performance is important.
Yeah, it's important. There you go. So there's another thing that to help with performance is they believe that there is no need to support unnecessary or rarely used programming concepts. So there is no support for structures, unsigned values, or pointers.
Isn't that crazy?
Which I find kind of holy for a few of these things. But that's what
it's kind of nuts.
Yeah, it's kind of weird.
Really, that's your performance increase tactics. Like that's probably why it's not very fast. I don't know. Sorry. It's fine. It's fine. I like Java. Memory management should be automatic. That's kind of nice. They have garbage collection process, so developers aren't really responsible for managing memory.
No release?
So
I don't know what I'm going to do with myself.
If I can't drain a pool, I'm lost. I'm going to drown if I can't drain a pool.
Nice.
So there's a runtime component that keeps track of all of the reference pointers and automatically cleans all the unused references for you.
Which we're not used to. We haven't had this experience.
We're going to get spoiled. Yeah.
So let's start talking about the cost of Wara, which is run once, run anywhere.
Sounds like the cost of war.
So the execution time is significantly slower than C, C++ due to the overhead of the Java virtual machine. So modern implementations of the language have attempted to correct this, and despite what some snooty guy that thinks that he's some awesome mathematician says, a lot of people still have problems with the speed.
Yeah.
You know, even though some people say mathematically you really can't tell the difference between C and Java. Well, yes, you can.
Well, mathematically, you can't tell the difference between a man and a woman.
Yeah, there you go.
I don't know. You probably could mathematically. I don't know.
Historically, Java had problems with bugs. I mean, come on. Do you guys remember back in the day when you would get like your web browser would crash all the time?
Or even a Java swing app.
Yeah.
You'd bring that thing up and click a button and it would be like,
well, even Java written applications that I use to this very day in my job are not stable.
Even on like Unix.
Yeah.
I know you've run across a couple Java apps in Unix, like, you know, through X Windows and stuff, and you're like, what the hell is this?
Yep. This has significantly improved over time, but Brian and I, throughout our professional careers, have a stain in our hearts from Java programs.
And I'm sure it's getting better. I'm sure it's good.
Maybe.
Well, you'll see.
But here's one thing that Brian and I have always had a problem with, is like, we don't believe the cross-platform sales pitch, because we've seen so many instances where this has not worked, worked as sold.
Yeah, it's true.
You know?
Well, and the other thing, too, because a Java virtual machine is only going to support a certain version of the SDK. And so they just don't have enough time to redistribute all of the Java virtual machines every time they come out with the new SDK version. Mm-hmm. It's just not enough time, especially when you get into J2ME and some of the mobile stuff and some of the this here and that there.
Or if you work in like an environment where you have like a closed down environment where you're like running maybe a Unix server that probably is still running
and you
version 1.1.
Yeah,
right.
So the problem is you can't execute, it won't even let you. It'll just say, I'm sorry, your Java virtual machine's too old. And you'll be like, can you even try and see if you can run it? It's like, no, I'm not even trying, man.
Yeah.
It wants this newer version. So it does cause a lot of problems when you actually get into like the reality of making something cross-platform compatible. And sometimes I found it's actually easier to write something in C, C++ and recompile it for different platforms.
Yeah.
I mean, whatever.
Well, you know, there are some Java fanatics.
I wrote it on the Android and it's not running on my Unix machine. I don't understand why. It runs in Windows, but I can't run it on my BlackBerry. I don't get it. Like, it just doesn't work that way. I'm sorry.
There is a very strong divide on this issue because there are some Java fanatics that say if it's not written in Java, it's not written properly. I've heard people say that to me before.
Wow.
Yeah.
Huh.
But there are also people that when you have this exact same conversation with them, they will, to the death, say that you're wrong. Maybe they just haven't seen it. But I don't know how people have not seen it. You and I have seen it a lot of times.
Yeah.
How no one else could have seen this, I have no idea.
Because they're blind, I tell you. They're blind.
They're blind!
Damn dirty Java. I don't know. Doesn't make any sense.
You're talking about the wrong tutorial. That was the other one.
Yeah, true. So it's our opinion that here at Wiba.net studio thing that Java belongs in the same lineage as C and C++ because it inherited many of the elements of program structure and syntax from C and C++. And although these languages aren't used for all of the same purpose, they kind of can be. So C inspired C++ and Objective-C. C++ and Objective-C inspired Java and C#.
Although more C++ than Objective-C.
Yeah, but there's definitely a very clear line from C, C++, the idea of Objective-C, to Java, and then Microsoft saying, oh, we gotta do something too. Here, C#, ta-da!
Visual Basic is dying? How could this possibly happen?
Yeah. Well, you like Java because it's close to C++? Well, we'll do like C+++. That'll confuse people. What about like C asterisk? No. What about like C#? Okay, that it's like C, C++, C#. People just think it's right in the lineage.
Yeah.
And we'll just circumvent the idea of Java altogether. I don't know.
They tried. So here's kind of in my eyes,
very nice,
a visual of what Java looks like.
Oddly enough, that makes perfect sense.
We have a bunch of packages that have a bunch of classes or abstract classes that have other classes that have other classes.
Very nice.
And then our little main function on the bottom right inside of our main bubble that has access to all of this. Right.
Yeah.
So Java's kind of weird. And as we start going through this, and if you start reading documentation, you'll see a lot of instances of multiple inheritance. Java has a lot of multiple inheritance. And the objects and instances are very relatable. I mean, if you look at like any of these lineages, like the brown line on the top, any one of those are kind of synonymous with its parent. So you can see there's this like nice little ecosystem of family trees kind of spinning off everywhere, which way.
Beautiful.
And then we had that guy, the brown guy in the middle that's sterile, and he just can't have children.
Oh, yeah.
So he's just sitting there all by himself.
Aww. All by myself. So let's take a look at the Java platform. We have Java Standard Edition and Java Enterprise Edition. The Java Standard Edition contains all of the most common libraries in that beautiful ecosystem we just saw, and the API, right here, nice. And APIs for the most common application development. So the Java Standard Edition is that 80% rule.
Yeah. Mm-hmm.
Java Enterprise Edition is the rest of the 20. It has everything that the Standard Edition contains, but it also has additional libraries for like more advanced to more complicated server-side stuff and more advanced programming.
Yeah, standard JSC is probably the most common that you'll come across. Yeah. It's just like Brian said, it's the 80-20 split.
Yep. Also, there's the Java runtime environment itself. This is actually the bytecode runtime environment. It's kind of the virtual machine that executes that bytecode. It provides a structured and standard environment for which that bytecode can run. So this is the program that gets installed on your computer that executes your Java bytecode program. The Java virtual machine manages the program and external resources. So like memory management, for example, is automatic. And if you're having out-of-memory issues, you actually adjust the configuration on your Java virtual machine to increase memory.
Yep.
Not necessarily in your application. It also handles application runtime security. So untrusted software can be ran within a virtual machine that has very limited permissions.
Right.
And no matter how ambitious that thing thinks it is, it's still contained within that virtual machine, which then in turn only has certain security restrictions on it.
There's like a little bubble that it runs inside that protects it from the rest of the system.
So since the Java virtual machine executes bytecode, any language that has the same code can be executed. So, like, for example...
By the JVM.
Yeah, exactly. Yeah. So, like, there's 1,000 different ways you can produce bytecode. You could just make bytecode. Yeah. If you really wanted to.
If you're really hardcore,
yeah. If you're weird. But there are bytecode compilers for other languages. So, like, you could write in Perl or TCL or Python and execute it on the Java virtual machine. Isn't that weird?
Yeah, it's crazy, Brian.
Because it's just reinterpreting those requests into a standardized bytecode language.
Yeah, absolutely.
No big deal.
Absolutely.
Nothing fancy.
So how does the Java virtual machine compare in how C works? Well, you guys know that when we write a C++ program, at least the way that we did it in our C++ course, we write code. We compile that code into machine code, which, as you guys know, is binary. And then we directly execute that code on the machine. So this little box here represents the computer, and the code is being ran directly inside that box. It has unadulterated access to everything inside the box.
Right. So when we look at a program that we generate in C and C++ that we build and make, if you were to grab that executable and look at it, it's like... Yeah, it's binary. It's a binary executable file.
It's machine language.
Exactly.
For that specific system architecture.
Yep.
Now, Brian, how is Java different?
Well, in Java, you write the program, and you compile it just like we did before, but instead of making a machine code file that's a binary executable, we have this blah, 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 blah bytecode. And instead of that bytecode running on the machine, it will execute that little mystery bytecode inside of the virtual machine. And that virtual machine on the fly will produce the machine code that'll be executed on the computer.
Absolutely.
So it just puts that little layer in there to abstract your compiled code from the environment it's running in.
So what are some of the benefits of this approach? Well, you have guaranteed program behavior. So anything that I write in my Java program that I port to another system that has a compatible Java runtime environment will behave. There might be some speed differences because of architecture and Java resources. Like maybe one has more RAM than the other. But if I make a swing application where I click a button and a little pop-up comes up, it will look exactly the same and behave exactly the same on every system I run that on.
It's kind of nice.
So code will execute on any system that has a compatible JVM.
It's a noble approach.
Yeah. So resource management is not the responsibility of the system, but rather the runtime itself. Think about how revolutionary that was in 1995.
Yeah, it's awesome.
Poor code can be isolated into its little bubble, and it will not drastically affect the system that it's running on.
So like memory leaking and buffer overflow and all that kind of stuff.
Buffer, overflow, what?
So it's just no big deal, you know?
You're dumb, Brian. I don't like you. Oh wait, there's more. The downside! Why do you get the good one?
Oh, Java slower execution. You can't even you can't even use Java program unless like a JVM exists for the intended system. So like, if they don't release a JVM, like if my operating system is like way more advanced than they can get the virtual machine out in time for, I can't even run my program on it.
But think about how lame that is. With like a C++ program, you could just run it, right?
Exactly.
With a Java, somebody gives you a .class file, and you're like, what do I do with this?
Yeah.
Oh, no, you run that against the Java interpreter. What?
Well, here's a perfect example of it. At this point in time, which won't necessarily be the point in time when you watch this video, Mac OS X Lion is in a preview right now, right? Like it's in beta. The beta version of OS X Lion, at this point in time, Apple decided they want to take a stab at not using Sun's Java implementation. They kind of want
Sun anymore.
Oracle's, sorry. They wanted to do their own.
Of course.
And it doesn't really work.
Yeah.
So, at this point in time, there isn't really a Java runtime environment for that operating system. At least not one that really works.
Yeah, it's kind of lame.
Anyway, so that's not a bad thing, but it just means that because that new when a new operating system comes out, or when an operating system wants to make drastic differences in their infrastructure, either they have to be dependent on Oracle, they're at the mercy of another company to support one of the primary languages, which is kind of not a good business decision.
Absolutely not.
Or they have to do the pain in the ass work of writing their own virtual machine for Java.
Right, but then
and getting permission from Oracle anyway to do it.
But even if they do that,
because Microsoft did it and they got sued. You remember?
Yeah.
The Microsoft virtual machine?
Yeah.
Java virtual machine? So it's a pain in the ass, and it's not really like good for business for OS builders, you know? Anyway, so programs might not run if the JVM versions are mismatched. So if somebody developed it on an older version of the SDK, or on a newer version of the SDK, and your virtual machine is an older one, and you don't have privileges to update it,
right?
Sorry, you're out of luck.
Yep, SOL.
Also, the JVM is a common target for hackers.
Oh, big time. Big time.
So it's an external application that runs over top the operating system. So a lot of non-computer savvy users aren't up to date.
Nope.
So all of those exploits that people found in like unupdated Java virtual machines are vulnerable. Not only that is going to be the virtual machine that's installed on everybody's computer.
Yeah.
So it's not like the WYSIWYG program is going to be the one that somebody's going to attack. They're going to go for the biggest hit, which is Java virtual machine. It's known. No matter what Java program you're running, it's on everybody's computer. That's just like a gaping, big, huge bullseye. Right.
Well, you think about what you just said, Brian, is if there are, like, let's say you're running version whatever, and it's okay, there's a known exploit that I can like pass through and hook into your kernel by doing all this weird shit. Well, you're surfing porn one night because porn websites are notorious for having like weird little
Java applets that pop up in ActiveX and
so in one of these malicious,
not that I know, I'm just saying.
In one of these malicious, you know how they have the top 100 sites everywhere? No, maybe I'm the only. Okay, well, whatever. But maybe you go to one of those.
Juarez.com.
Something like that. So you go to those websites with either innocent or, as long as you don't tell your wife, innocent intentions, and the Java applet detects your version, sneaks some code onto your computer, executes it, you've been attacked. And that's a big downfall of using the JVM.
It is. Absolutely. All right, and then we have not the SDK, but the JDK. That's the Java Development Kit.
Of course.
And that's basically a series of programs to assist you in developing Java programs.
Nice.
Most notably, a compiler, a debugger, documentation generator, which I'm not a fan of personally. I love documentation. Not a fan of the documentation generator. The Java loader, which can interpret Java compiled files, and the Java command line shell.
Nice.
Not bad. It's a must-have.
It's like a soup of Java happening.
Yes,
it's like the ABC alphabet soup.
Nice. I like it.
So let's talk about some common structures of Java applications. Now, they're not all distributed this way, but let's just kind of take this for example. In this particular case, I have some source code files. Java code files typically end with the .java file extension, and this is where your class code is written. Now, depending on how you've written your class code, you can structure it differently. It's typical for Java to have one class for each file. Although you can get around that, but that's not the preferred. It's kind of like with the Objective-C, like, no, you can't use that formatting character.
Right.
Java wants you to have one class per file, which is a little bit of a nuisance, but, you know, it serves its purpose fine. Now, these are then compiled into .class files, which are bytecode files, and these are quote-unquote compiled Java files, but they're not really compiled. But I mean, they're compiled, but not
they're as compiled as Java's going to get.
Yeah, right. And then you can also, you can actually run these files using the Java interpreter, but what a lot of people will do is if they have multiple class files, they will then, what I call jarchive them into an archive file. So Java archive files typically end in a .jar extension, and they basically contain files supporting data, documentation, for a Java program. And some people will, in their jar files, include their source code, but a lot of times it's just like the .class files, and if there's like little images for their GUIs and what, those will be in there. There's like this meta stuff. We talk a little bit about Jarchives in a little bit, but that's just kind of like an overview of a common structure of a Java program.
Not too bad.
Yeah, not too bad.
All right, so the program structure goes back to the modularity model.
Right.
So if you remember back in C++ when we kind of showed you this, it's similar. So here we have like a larger main object.
Right.
And a bunch of supportive objects that kind of spawn off of that. Then we have the modularity enhanced model, which is like C++ and Objective-C, where we have, that main object, but then you have other objects with objects inside of those and smaller objects that kind of on their own, and they can all talk to each other and have them orchestrate whichever you want. Then you have the object-oriented model, which is more Java and C#. And this is where that main function is inside of a larger containment object that contains classes that then make references to other classes that contain other objects and so on and so forth.
It kind of looks like the universe when you look at it from this. It's like, or like cells, like
bacteria.
Yeah.
I'm gonna eat you. So let's talk about our working environment for the sake of the labs in this course. The operating system we're going to write in is going to be Microsoft Windows. We figure it's probably going to be the most common that you'll have, and we want to show you the most common environment that most likely one you'll be familiar with.
And also, those of you guys running Unix and Linux, I mean, you're usually like a more advanced computer user, and you know how to run, you know how to install this stuff. You can follow all of this stuff in Unix and Windows, but
the Windows people can't follow Unix as well as Unix people can follow Windows. Right?
Precisely. There you go.
So if you're running Linux, you know what's up. You're fine. If you're running Windows, we got you covered.
You know what's going on.
So we're also going to be using the Java Development Kit, which we talked about, and we'll get directly from Oracle, and we're going to use our trusty old ASCII text editor, Notepad++.
We're coming back to Notepad++, baby.
So we'll show the process using this working environment as we always try to with our minimalist approach. Mm-hmm. And then later on in the course, we'll kind of get you up to speed on NetBeans, for example. But for the sake of this, we want to focus on Notepad++, the JDK, and kicking it off.
The way that we see it is if you can code it here, you can pick up an IDE.
Oh, yeah, absolutely. Like you can jump to whatever you want, right?
Now, if I were to show you a Hey Buddy program here in Java, how do you feel about I mean, does this make you feel happy? This is not what we've seen. What the f*** is this?
This isn't so much a, hey buddy, it's more of a, hey buddy.
Maybe we should have put a question mark.
Hey buddy. Okay, so let's break down what we have here. What's going on here? This is a little static void main inside of the class.
Open it up and let's sniff around. So
let's get up in that ass. Spray paint in there and just
any class in Java that has a method that is public and static and void and called main is the main class.
The entry point.
Yes.
And there can only be one.
There can only be one. So this class, Hey Buddy, is the name of the class, which would be our main class declaration.
So this public static void main. Public static void main. Public static void main. Nail that down.
Yeah.
That will always be our entry point for the program. Only one of them.
And look at this, Brian. It's encapsulated in an object right off the start.
Right, exactly.
Beautiful.
Yeah. And it's not instance level, it's static.
Right, yeah, because we don't instantiate, you can instantiate the main class, but in order to define an entry point, you don't instantiate the main class. Right. So here we have the system class. Now inside the system class has all kinds of members, whatever, instances or whatnot. So we're going to be evoking the system class and evoking its static member inside of it. And the static member is
print stream.
Well, it's out. A print stream, but it's out.
And then inside of out.
But hold on.
Oh, sorry. Oh, this replaces std out. So this is like cout. It's a print stream object. It's similar to what we saw in C++.
Yeah, and we'll start talking about later what a print stream object is, but in the system.out context, out represents standard out, and as you'll see later, you can actually redirect this because a print stream can go to anything.
So any handle. We
can easily switch this to anything we want.
And inside of this object, there's a method called println. So instead of printf, we use println. And println exists inside of the out object, which is inside of the system object, which by default is pointed to standard out.
Right.
This can take just a single string, hey buddy, and print it out to the console, or whatever standard out is pointed to.
So this is more like puts, because when you think about puts in C, it writes out your string and then it puts a new line.
Exactly.
Same thing here with println. So now, Brian, let's go through the process on the Wibbit.net's background.
Virtual console.
On compiling and executing HeyBuddy.java.
Okay, so first off, we'll list all of our Java files.
Why not?
Which is HeyBuddy.java.
Hey, buddy!
Then after that, we're going to say Java compile, Java C.
Yeah.
And we're going to compile our HeyBuddy Java file.
Now notice, Brian, unlike the GCC, which is really all that we've been exposed to at this point, unlike that, we're not specifying an output file. Very fascinating.
Yeah, because there's always going to be a one-to-one correlation between the bytecode and the Java file it came from. It's going to just have the class.
Boom!
There it is. HeyBuddy.class.
Yeah, and as you can see, it's almost 4 times as big as a source code file.
Yeah.
Nice. So now, Brian, now that we have successfully compiled the program, we can execute it against the Java interpreter by saying Java and then the name of the class without saying .class.
Right.
It's kind of a dumb little thing, but you just don't say, you say the name, no .class. If you say .class, it'll bitch at you.
It's clean.
Yeah.
So what happens? Let's kick it off. Ready?
Hey, buddy! Nice. Very nice.
All right, so we're going to trash talk Java because it's fun.
Yeah.
But don't misunderstand it. We love Java. It's fine.
Yeah.
It's an amazing language. It was a genius idea. It was leaps and bounds forward. It really pushed the industry. It gives you so much power. But we do hold a grudge against the language. It's not Java's fault.
Not really, no.
We were exposed to it in a weird way.
Yeah.
While we were in school.
We were traumatized by Java.
Yeah. We went from learning C++ to learning Java midstream in school. And
they changed the curriculum like the next day.
Right.
Oh yeah, by the way.
Which was funny because the teachers didn't know the language, nor did they really have any interest in learning it.
Oh, it was horrible.
Yeah.
Terrible.
So the students are telling the teachers like, hey, this, just type. And they're like, I got this. I got it.
Now we turn to page 75.
Right.
Yeah.
It looks like, why is it in a class? Why is main in a class? I don't. But the problem is when you're starting out and you're just learning just the idea, now that you've kind of gone through the intro and the object-oriented C++, Objective-C, whatever, now you've gone through the other courses, it's kind of a no-brainer. But if you're just starting out and you're seeing that public static void main inside of a class that we call whatever we want, how do you get your brain around that idea?
Right.
Like, coming in cold, you've never programmed before, and how do you understand that like there's a class level method on the print stream object called out in the system class called printline that we're going to execute against? Like, you don't even know what a string is. You don't even know what an int is.
Yeah.
For sake. How are you going to just cold cock and jump into that? Like, you can't do it, you know? You're going to be floppy.
Yep.
So it's not a good idea. So because of that, you get a lot of people who don't really understand the language that write in it, and they just kind of
oh my God, you are so right when
they
you
just
say
sort of do things that kind of emulate other things that they see happen, and they don't really understand why. It's unfortunate. And because Java is so forgiving, kind of, I mean, because of the nature of how it's in the virtual machine and how the object structure is really kind of wonderful, in C and C++, a really good developer can write really good software, and a really bad developer can be very dangerous.
Absolutely, yep.
In Java, a really good programmer can make some kind of cool stuff, and a really bad programmer is not that dangerous.
Right.
So that normalizing factor kind of doesn't let some people shine in certain circumstances, but
it also doesn't let other people fail.
Right.
But it,
so that's an advantage
coddles.
and it's a disadvantage.
Right.
So it's worth really learning the language if you're going to do it, know what you're doing and do it well.
I think that Brian made a great point that some of the sloppiest code I've ever read in my life came from a Java program, and I think it is because a lot of educational institutions try to start would-be programmers in Java with no context.
Right.
So what they've done is they have like some text document that has like 50 methods in it that they know works, and they can just copy into this, copy into here, and like a lot of times it's not relevant. And like the weird things they have to do to like make it work in the context of that program is often very horrible.
Right. So really, we don't hate Java, but we also don't hate John Bon Jovi. We just hate his fans.
Yeah.
And I'll say this in our defense. Visual Basic is kind of like John Bon Jovi. So you don't necessarily hate Bon Jovi, but you really hate his fans. You know? So we kind of hate Visual Basic for that reason. You know, I mean, the guy's going out in a blaze of glory. It's not his fault, but you hate his fans, so you kind of in turn don't really like him. You know, it's just kind of how it goes.
Not as bad as Visual Basic, we still treat Java with a lot of respect.
Yes.
I want to say that clearly. And it's not the language's fault that there's a lot of bad programmers. It's the fact that educational institutions have failed those students considerably is why there's lots of bad Java programmers. So it's our duty to get you guys off on the right foot, get you guys in the field with as much history as possible so that when you get a job that makes you write in Java all day long, you know where this came from, why it exists, and how you can be the best programmer possible.
Right. And also, the reason we did the intro, C, object-oriented, and C++, really, the main reason we did those is to help you learn Java.
I
mean, that was our motivation.
Yep.
We know not that many people are going to have that many uses of just jumping into C and writing in C.
Absolutely.
But knowing C is invaluable.
Right.
So, we strongly encourage you to go back and view those courses.
So that's it.
I hope you're excited. It's well worth learning the language. It's a very cool language. And you're really going to get your mind blown on how they pulled off this pure object-oriented language environment. So stay tuned.
I'm excited.
You're going to like
I'm excited. I'm sweating, Brian.
Hey guys, welcome to the first lab in the Programming in Java tutorial series with Kevin and Brian from Wibbit.net. I know we're both...
I mean, seriously, I'm really excited.
And you just can't hide it?
And I just can't hide it.
So we're going to just kind of take the same approach that we've done with everything else. We are going to set up the environment and just basically write our Hey Buddy program, and that's pretty much it for this one, right, Brian?
Yeah.
Okay.
Yeah, we just want to make sure that you can kind of get up and running.
Good. So the first thing we're going to do is we're going to kick open our web browser, and we're going to go to just good old Google. And when we get to Google, Brian, let's just look for, what do you want? Java JDK? Java Development Kit? And the first hit's going to come up with the Java Standard Edition, and that's what we're going to be using.
Yeah, Java has kind of like two different versions. Two different branches. You have the SE and EE, and the SE is the standard edition, EE is the enterprise edition.
Mm-hmm. And there's also ME for mobile.
Yeah, that's true. Mm-hmm. Absolutely. And like some other ones, but between those two, you have, between SE and EE is the enterprise Java Beans idea, and like some server-side stuff that's a little different.
Right.
So EE is the one that you would pay for, and it gives you some like more packages for creating enterprise applications. So obviously you want the SE.
Right. So we're going to go with SE, and I believe we're just going to select the Java Platform JDK 7, right, Brian?
Yep. Mm-hmm.
Okay. So Java Standard Edition Development Kit 7 downloads. So here.
So here, make sure you accept the license agreement so that Oracle can sue you for using their free language later.
Yep. Check it out. I mean, just got Linux, RPM, compressed binary, Solaris, and we're going to be running Windows x86.
Wait, where's the one for Macintosh? What's up with that?
I don't know. Why is that not here?
Interesting.
Okay, so I'm going to select the Windows x86 download. That's what Brian and I are going to do. And, whoops. I did. Look at that. Look, it's selected. Look. Watch this, Brian. Watch. I'm going to have to click off and then click back on. Way to go, Java developers. Way to go,
Oracle, for being a shitty, bloated company.
Yeah. They can't even get a JavaScript event right. Okay. Now we're going to download this, and 5 minutes from now, we're going to be installing this.
So what's interesting is, so there is no, there kind of like isn't a JDK for Mac, even though it's like totally platform independent, like you have it on all the platforms, whatever. So Apple Developer, like the developerapple.com site, has a JDK tools for Mac OS X. So, well, if you get NetBeans, you're gonna have it all kind of like packaged in there. You know what I mean? Mm-hmm. And Xcode will kind of like let you do stuff. So Apple just kind of has a different approach.
Okay.
Slightly, and it still does the same kind of command line stuff, just a weird way. But the thing that has changed is here's one of the kind of like the faults with Oracle in a number of ways. Oracle they want to make money and they don't want to spend a lot of money. So like for Android, Google said like Oracle or Sun at the time, like we need you to do these kind of things in order for us to use Java on our platform. And they said, well, we don't really have time or money to do that. So Google's like, okay, well, I guess we're just gonna have to like do it ourselves. And then they sued them for doing that later. Apple was like, okay, we're going to have a new operating system. It's going to be called OS X Lion. We need to have a Java virtual machine. And Oracle's like, we've been kind of busy, like rebranding PeopleSoft and stuff. So we can't really. And so Apple was like, okay, we're not going to have the release of our operating system contingent on Oracle's slow ass getting around to having like a, whatever, virtual machine. So Apple rewrote the JVM for Java and got permission from Oracle to do this. So when you install OS X Lion, you're not actually installing Oracle's, you're installing Apple's.
Good for them.
Yeah, which is really cool. Microsoft tried to do that some time ago, and they were sued. Because before, it used to be a Windows system update to install the Microsoft Java runtime.
Mm-hmm.
And they had to retract that because they got sued.
Damn.
So it's kind of a mess. I mean, whatever. It's kind of a mess.
So we've ran the installer application. It's quite thunderstorming here now. Boy,
cool.
It's nice. It's got a nice little backdrop for the beginning of the Java course,
It's yeah, it's kind of like blowing past here. It's still raining, but it's not thundering. So you're probably getting what was above my head a minute ago.
Yeah. So we're just gonna kind of do the next our way through. Just kind of let all the defaults kind of settle in, and basically this is going to give us the basic tools that we need to compile a program and to run against an interpreter. Now we kind of explained in the introduction lesson exactly what this is going to provide for us, so it shouldn't be any shock to you guys when we see it.
You know what I don't like?
What's that?
I don't like when a progress bar fills up multiple times during a process.
I don't mind if there's two progress bars, one to show you the task progress,
yes,
and one to show you the entire progress.
Okay, yes.
I don't mind that.
But you know what I would do?
What?
If instead of having a second bar that fills up, I would have a bar with a pie chart at the end of the bar. And the pie chart at the end of the bar is the specific task, and the bar would be the entire process.
Mm-hmm. Yeah.
So like the little pie chart would fill up and then clear and then fill up, or like fill up and then empty out and fill up and empty out for every task.
Yeah, I've in a lot of graphical applications that I've written, I've done that approach where I've had two different, at least if nothing else, two different displays of this is the current task.
Yeah, which is
this is the entire process.
It's better than just having the tasks go back forth. Because right now there's no context to how far along in the process.
Right. Yeah, it's like, should I watch a movie? Should I go get something to drink?
Exactly right.
Should I just sit here? Right.
And I don't mind not having some sort of like time estimator because time estimators are always like f***ed up anyway.
Yeah, they're never even close, right?
No, so like don't even bother. But you should have like a total progress.
Yeah.
Because even just seeing the bar like creep along, you're like, oh, well, I got some time. Like it's better for you to gauge it than it to tell you like 30 seconds, 42 seconds, 57 seconds,
95
minutes.
4 days, 7 hours, 26 minutes, and 14 seconds. I think we've gone through unpacking. We're going to install this. This is the Java runtime environment, right?
Cool.
So we're installing the runtime environment here. And we're also given 3 billion devices run Java sales pitch.
Yeah, that's cool.
Yeah.
How do you calculate that, really?
Well, because, look, they're counting cable boxes, credit cards, ATMs, televisions. They're just counting everything.
Whatever.
Parking meters.
Why would you bother using Java to write something on a parking meter? Like, how complicated could that be? You should basically be able to write a parking meter and like just in machine code, you know?
Or just have it completely mechanical.
Yeah, that's true. Why even right?
Yeah, you know, exactly. I'm gonna look at my
credit card transactions on parking meters now.
I'm gonna look at my my Asian sex robot and see if she has a Java inside sticker on the buttocks.
It'd be funny. It'd be like you go to like your Asian sex robot and you're like, hey, so do you mind if I like up a put it in your and then you get like a reflection error because it's like I was not designed to do this.
All right. So, anyways, now that the Java development kit is installed, we should be in a situation where we can start messing around. But just like when we were doing with C and C++, we're going to have to add a few things to our system path.
Yes, absolutely. So let's take a look at our C drive and see where this thing installed.
All right, so we'll go to our C drive.
Okay.
All right, so then we're going to go to Program Files and Java. And inside here, you'll see JDK and JRE. So let's go to the JDK.
Cool.
And inside here, there's a directory called bin.
All right.
And inside the bin folder, you're going to see java.exe and javac.exe, which are two applications that we're going to use a lot. So when we get into this path, however it is that you get here, if you're on a 64-bit system, hopefully you installed it correctly. If I don't know, whatever. Just we'll copy this.
Right.
And we'll do the same thing that we did before on...
See, because the thing is we're going to use those two executables like all the time. So we want to put it into our environment variable so that we can just kind of get at it whenever,
right.
you know?
So we'll right-click on Computer and go to Properties.
Yep.
And then we'll go to the Advanced System Settings.
Ooh. Advanced.
All right. Environment Variables. And go down to your path, which we've done this... We did this already in C and C++. So if you look here at the end... Our min.gw is still here from when we did this in C++, so we'll add a semicolon, and we'll paste that in there, and we'll select OK.
Cool.
OK.
Awesome.
OK.
And
we'll
long story short, we're good to go.
All right, so let's get into
let's test it out.
Let's get into the command prompts. All right, so let's get into
let's test it out.
Let's get into the command prompts. All right, now it's in the libit.net. Let's go to the desktop. So we'll kind of do the same thing that we've been doing. Let's make a directory called, what do you want to call it, Java?
Yeah, we'll just call it Java.
Java. Java. Now let's see here. Let's see. Can we run Java C? Yes, we can.
Hey, look at that.
Can we run Java?
Cool.
Yes, we can.
Nice.
Okay, now we're making the assumption that you fine people have followed our other tutorials, and if you haven't, well, screw you. We're gonna open up our trusty Notepad++.
Right. And you can use Notepad or whatever text editor you're comfortable with, but Notepad++ is awesome.
So let's go ahead and save as onto the desktop. We'll go to Java, and we'll make a heybuddy.java. Okay?
Cool.
Nice. So the first thing we're going to do, Brian, is we're going to define our class.
Okay, so let's call it, hey buddy.
Why not?
Hey buddy.
And since this is, and we'll talk more about this later, but since this is a public class, the Java code file has to be called the same name as the class. We'll talk more about that later. So here's our public.
So, public static.
Yep.
Which means it's not on an instance of this class. It's just on the class. And then void. It doesn't return anything. And then it has to be called main, and that sets this as the entry point to the class.
Right.
So that means that this will execute naturally from hey buddy.
Yep.
And then we can get their args. And we'll go into this later.
Okay. So, just like we were kind of expressing in that the hey buddy, we in the hey buddy code that we looked at in these slides, we're going to be calling the system class, and we're going to be interacting with a static instance of a print stream called out.
Okay.
And inside of this static field, there is a method called print line.
Ooh.
And in there's many overloads, but one of the overloads is it will accept a string. So we can just say, hey buddy.
Hey buddy.
Right?
Yeah, cool, we're done.
We
Let's
can
test
save
it
this
out.
file.
Hopefully.
So when we go to our command prompt, we can do Java C, which is the Java compiler.
Yep.
heybuddy.java.
Cool. And look at it go. Yep. So now let's see, do we have a class file?
Let's see here. Dir. Hey, look at that.
Hey, look at that. Cool.
Now, Brian, to execute that class file, we're going to call the Java interpreter.
Yep.
And the name of the class without the dot class.
Right.
Right. So we run that. Hey
buddy.
Buddy.
Oh, that's awesome. So we're up and running. So that wasn't too tough to get it up and running, right?
Nope.
We just download something real quick, open a text editor, and we're good to go.
Absolutely.
Hey, Brian.
Yeah.
I'm going to explore your package.
Oh, we gotta censor that. Oh, that is nasty. Oh, good God. Dude, Frog, put that away. That is...
Proportionately, that's not too bad, though. I mean, that's
Wow.
it's not a frog or a donkey.
So check out my Java package.
Wow.
Whew. All right, so we're gonna kind of swim around a couple of Java packages and just kind of do stuff.
Wow, I feel violated.
I do, but I do like the look on his face, though. That's pretty brilliant.
Anyway, Java allows packaging up classes into like namespaces. We'll say these namespaces can be archived into a Java archive.
Yeah, they don't have to be, but they
A
can.
Jarchive file.
Yeah.
And then that Jarchived package can then be imported into code, and we can absorb its functionality, just like importing a header file.
Or like a namespace. A package
go.
is kind of synonymous with a namespace.
And it's really just a massive collection of packages forms the whole class framework that Java is built on.
Absolutely.
So Java's value, a lot of Java's value really comes from this massive package ecosystem full of all these cool classes.
So, alright. The core class concept. All classes in Java inherit from the same parent class. Wait a second.
We've seen this before.
Have we seen this before?
Interesting.
Oh, similar to NS Object when we were doing Objective-C. Nice.
I'll be no shit.
Holy f*** me and the fucking shit cock blow.
Classes inherit from the object class, which comes from java.lang package.
Wow, that's
I know.
crazy.
It doesn't sound as abstract as like NS Object. It doesn't sound as generic, but
And it also doesn't have like a company's name attached to it.
yeah,
You
but
know, like it doesn't say sunjava.lang, you know?
Yeah, true. Anyway,
You will see the descriptor superclass in Java a lot. And the superclass is basically just a class where many other classes derive from. Now, we've seen this concept before. So don't sit there all glossy-eyed like you have no f***ing idea what we're talking about, because if you skipped the Objective-C course, although it's not really required on the C lineage, because it is like a Mac-specific thing, at least the way that we taught it, go back and just watch that stuff. Very simple concepts to understand.
but also a superclass is also known as a parent class or a one abstracted class.
Here's an overview of the classes in the java.lang package, and you can see a lot of basic stuff in here, like boolean, byte, character, even class?
Wait, where's the unsigned integer? Oh, it's not there.
Oh, there is no. Oh, you got me going there.
You can see void is in here, which is interesting.
Yeah, string.
So void's actually a class.
And then like the object.
Yeah, nice.
You gotta love it. It's beautiful.
So you can check out a list of packages at download.oracle.com
/ version. That's a version, by the way. So
Yeah,
it's different with each version.
Some of the common packages that we're going to talk about is Java.io, Java.math, Java.net for networking stuff, Java.util, Java.crypto.
And Wibbit.net. Wait, that's not on there. So Java.io contains the standard input and output classes. Now this is sort of, you could almost equate this to the fundamentals of the stream concept in C++, where
Yeah, like IOStream.
you have a stream that's designed to work with files, it can work with memory buffers, it can work with network streams.
Nice.
It's like a generic concept in Java, and the way that you apply it is what actually defines what it does. So here's kind of an interface summary, and the interface, which I think we talk about more in detail later. What interface is basically the same thing as a protocol and Objective-C. It's just an abstract class. So you can see here's a list of some of the abstract classes that come with Java.io, as well as a summarized class summary. So you can see stuff like buffered reader. We're going to use that. Buffered writer. File. We're going to be using that as we go through this. File input stream, file output stream, file reader, file writer. We're going to tell you guys the differences between all of these different file streams and when you would use one over another. And I want to note that something in there says depreciated. But I wonder if you'll get denied from the App Store. So, I mean, you can see that there is just a whole bunch of stuff that this class provides, including a print stream?
String
Print
writer?
writer?
Yeah.
Huh.
It's cool.
Didn't that dot out instance kind of?
Oh, yeah, that's right.
That's crazy.
So system.out is a print stream object instance.
Holy crap. And we also have an exception summary. Now, in Java, how do we say this without sounding like a bunch of dicks? Java sucks when it comes to being f***ing exception handled.
It's like a overbearing parent.
Oh my god. And every single different type of exception, there's like 5 bajillion, fajillion,
Yes.
macajillion, but
And you'll start memorizing them after a while.
I don't. I've used Java for years. I don't know anything about the list of exceptions because there's so fucking many of them.
Yeah, I know.
It's unbelievable. These are the exceptions for this package only. That's crazy.
Yeah.
And they
it
all
is
have their
crazy.
own thing.
Yeah.
It's
It's
insane.
nuts. It is nuts. Balls.
Yeah, it is.
I also got Java.math.
Yeah.
Which is awesome. This can also perform different types of algorithms on very massive numbers, which is very nice.
Yeah, it's predominant use, yeah.
Sometimes very big integers are problematic. This solves that problem.
The big numbers.
Yep. So numbers that exceed just standard integer and double types are handled in a special way. If I remember it, they're kind of handled like a string in a weird sort of a way.
Yeah.
It's very useful in cryptography, where you're dealing with extremely large numbers. So Java Math, basically, the classes that are available is really just big numbers. So you're not going to find absolute value of or the greatest common denominator of. Really, it's just big-ass numbers.
Yeah, and
if I need a big-ass number, this is the big-ass number store.
And they're also immutable, which you guys know what that means, right?
Yeah.
See how this is all coming together?
Yeah, isn't that weird?
You guys are starting to see the Wibbit.net learning approach now.
Yeah.
As time goes by, we don't have to say as much. But
And then a rounding modinum, which is whatever.
Yeah.
No big deal.
So Java.net provides classes for integrating applications with networks.
This might be my favorite one.
This is great. Here's like a little basic interface summary, and we'll get accustomed to a few of these later when we do our socket programming lab. We could also take a look at some of these classes just to kind of get your feet into it. So you see, look at that. There's an IP4, address version 6.
The datagram packet. That's
Holy crap,
cool.
that's pretty awesome.
Yeah.
What else do we got here? We have network
URLs.
interface, a socket, which we're going to be using those. URLs.
URL decoder and encoder, which is cool.
Man. And then the URL stream handler. Yeah. And then, of course, another f***ing block of exceptions. I mean, how many damn exceptions are they going to make us memorize?
Java.util. So this is a lot of like miscellaneous stuff, like date, collection, legacy classes, just like random utilities. Some of these are great, like enumeration, iterator, list iterator. Like these are really valuable things. Sorted set, unsorted set. So let's look at the classes. We have an abstract list, array list, which is very common.
Yeah.
Arrays, date, currency.
Calendar.
Yeah, calendar, dictionary, which is really useful.
Yeah.
And then things like linked lists, which we've seen before, and now they kind of do it for you. Hash tables, which is way convenient. Like really useful stuff.
Random number generator.
Now you would think that'd be a math, but not so much.
Yeah, not in Java.
Timer task,
Stack.
vector. Like these are really useful stuff. Like util's like a pretty like cool sack of tricks,
Yeah.
So it's a lot of classes that you would find yourself writing your own versions of in C++ and using them over and over.
Yeah.
They kind of did that for you, and they just kind of give you this nice little. It's like a Swiss Army knife in Java.
Yeah.
basically.
There you go.
And of course some exceptions.
More exceptions. Why do they keep doing this to us, Brian? So Java.crypto contains classes for cryptographic operations. It drastically simplifies encryption and decryption within your applications. Big time. Now, interface summary, we're looking at a secret key, which is an abstract class.
And we can't tell you about that right now because it's a secret.
It's a secret. Oh, wow. Look at these things, Brian. Cipher. We have key generator.
Nice.
Oh, my goodness. Secret key factory, which is a factory of secrets, I suppose. I don't know. And some more exceptions.
So, how do we use a package? If we wanted to insert a package deep into our source code, I don't know. What would we do?
Let's jam that package deep in there, Brian.
So, just like we would include an external code file in C and C++, in Java, we import an external package.
Wow. So here's an example of referencing every single entity inside java.io.
Yeah, actually
right?
we're consuming that into our program.
Well, actually, in a technical sense, you're not. The way that Java functions, which is different than C, C++, is when I'm writing a C program, and I say include stdio, it actually takes stdio and compiles that into my program. When I say import java.io.star, what it says is, in the context of java.io, be aware of everything.
Oh, yeah, cool.
So it doesn't actually include that in your bytecode. It just tells the bytecode where to go to get its references, because remember, this is supposed to be running on a machine that is the same everywhere.
Yes.
So that's why it's designed that way.
And all those virtual machines have all of those packages.
Exactly. And if there's a package that you wrote, it has to come along with your software and referenced in a different way, which we'll talk about that in a little while.
Cool.
So if you take a look at this is another program in Java that we can kind of analyze. We have a main method. and our try blocks. Now, we have a little IO exception here, which I don't know if that's even the right IO exception, but they're all kind of inherited from one another, so they kind of...
Yeah, it's an input-output exception. It's good.
So check it out, Brian. We have a file writer.
Nice, a file writer object.
And we're setting this equal to a new instance of file writer, calling the constructor that takes in a string, which is the path of the text file that we're referencing.
Oh, I miss constructors.
Oh, man. Remember this from C++?
Yeah.
Same shit. The same shit. C++, awesome. You can move into this. But there are some kind of dumb things about Java, like once I declare a file writer, I have to then encapsulate that inside of a buffered writer to the right to a file. Okay. I can do that.
That's cool.
Let's do a little buffered writer and make a new instance passing it the file. And then I can do that instance.write.close. That's crazy.
Whatever.
That's awesome.
Hey, it wrote to the file. That's cool.
And there's tons of ways you can do this. We're not going to really scrutinize this too much because we have some labs coming up where we'll look at this stuff.
All right. So now in this, now that we've kind of explored packages and explored the idea of packages, let's just kind of like try one out real quick.
Okay.
So what we're going to do is we're going to import a package, define a class, and just print out a random number. That's all we're going to do. And the random number is going to come from a Java util random package. So we're going to import.
Well, actually,
Java.
before we do that, let's do a save as.
Oh yeah, absolutely.
And we'll just call this random number.
Yep.
Dot Java.
Dot Java.
Okay. And on the first line, Brian, you want to import what?
Import java.util.random. And I think it's a capital R in random.
Mm-hmm. Now, this is not, if we were to do something like this,
yes,
we're referencing every single class or every single entity inside this package. By doing this, we're just referencing one class or one entity inside this package here.
Exactly.
So either way you do it, it's not like it's inefficient to do this, because like, you know how when we were doing stuff in C++, we would do like, well, this is actually taking IO stream and putting that in your program, so when you compile it, it's larger. Since Java has the whole runtime environment built into it, we're just actually going to say inside of the package java.util, just be aware of all the classes in there. So it doesn't actually expand the size of your program. It just points your program in the direction of where the classes are. Which way do you want to do it, Brian?
Okay, so after we, so let's just do it with random, just to kind of like make it clear of our context.
Our intentions are made clear.
Yeah. So we're going to do a public class called random number.
Okay.
And then inside that, we're going to have a public static void main string with args. Okay. So all we're going to say is, let's say random. We're going to create a new object of type random, and we'll call it like R or random or whatever you want to call it.
Okay.
Is equal to, and then that's going to be a new random number, and we're going to we're just going to have like a default constructor. Right.
Okay.
Exactly.
Right.
So now we're just going to do a system out print line, and then we're going to pass in the randnum.nextInt, and then we'll pass into that value 10.
So this is kind of using the Oracle documentation,
yes,
the random class. So if you guys wanted to come in here and find out how to use the random class, I mean, all I did is I went to Google and I just typed random or Java random, and I got it on the first hit. So from here, it tells us what it does, the constructor summary. So you can see this if you want, but you don't have to if you call the default constructor.
And then we have right.
You also have next. The one that we were looking at here is the nextInt.
Yep.
So if you want to see how you can use this, here's the description. But if I just kind of select this, it takes me down to an overview of what it does. This is actually, cool. I think this is the actual code, isn't it?
Yeah. Mm-hmm.
So the parameter n is the bounds.
Okay, cool. So let's do a nextInt, and then we'll pass in 10. So it's some random number between 1 and 10.
Okay. So we'll say 10. I think that's 0 and 10, but that's whatever. That should be good.
Yeah, and then maybe before that print line, we'll do a system out print. Your random number is.
Okay, so print with no new line, like a dice.
Perfect.
Nice.
All right, let's kick it.
Java C. Random number.java.
Yep. Mm-hmm.
Java.
And then Java random number.
Random number. So there's 2.
Cool.
There's 7.
Hey, look at that.
There's 1. Now let's do a for fun. Well, I is less than a random number. And this will just be 10 as well. So we're going to create a random number of random numbers.
Nice.
See how that looks. Java C, Java. So there you go. So it is 0. So there's 0, 3. So look at that. See how it's like a different number of random numbers each time?
Very cool.
That's pretty neat.
Yeah. Awesome. So that basically gives you an idea of like how to import a package and use one of those classes that came from that package.
Right. And just to kind of show you, if you were to just put a star right here, let's just take a look. Let's do a dir. Look at the size of the class file at 606. Mm-hmm. So now let's recompile it and do a dir. It's still 606.
Yep.
So again, that shows that you're not being inefficient by specifying, I want all classes, because again, you're not actually pulling it into your program, you're just referencing where to find it. Hey everybody, welcome to the first remote recording of Wibbit.net.
All right.
Yeah, Kevin and Brian, for the first time, are recording in remote locations in the world.
In remote stereo.
In this lesson, guys, in programming in Java, we're going to be talking about data types.
Oh, exciting.
Yeah, Brian, so tell me some shit about data types.
Well, Java data types is interesting. It's not too far from how they're treated in C, C++. Primitives are treated in a similar way. And Java has a pretty good mix of like primitive and object data types. Like as you found in some of the other languages, sometimes they try to go for, wall-to-wall objects, and sometimes it's as many primitives as possible. You're going to find like you can use int just like you're used to, but there's also, an integer with a capital I, for example.
Right.
So you get a good mix of whatever you need to use whenever you need to use it. And if you have an integer and you want the int value, it's really great. You just .int value. It's very easy.
Right. Yeah. And that also kind of helps too, because it also has a lot of like static methods for maybe converting from string to integer to string, and that kind of stuff. It's very simplified.
Yeah, so unlike Objective-C, where sometimes it's a little convoluted to get what you need out of it, it's not too bad at all. So every primitive data type in Java has like a wrapper object counterpart that appends useful functionality to it. So you'll see that.
The wrapper has like an M&M counterpart? Is that what you're trying to say?
Yeah.
Okay. Yeah. So Java has 8 core data types, right? So these are the primitives in Java, and these are actually real primitives. So they're not objects, they're primitives. So just like in other languages that we've talked about, a byte, which is an 8-bit integer, and it's often used to represent a byte of binary data. A short, which is a 16-bit integer. An int, which is a 32-bit integer. And a long, which is a 64-bit. This is starting to look damn familiar all of a sudden. Wait a second, there's something weird. What is that last one? Boolean?
Oh,
Boolean?
Nice.
Okay, so in Java, they're so f***ing cool that they just don't want to say bool. They say Boolean.
But notice these are all lowercase.
Oh, yeah, very good point. Very, very good point. Now that's gonna change, Brian.
So here's like a brief example of, we have just a main method and our main class, and we're just kind of setting some variables, like, you can typecast them as a byte, short, int, long, double float, char, boolean, whatever. Boolean is false, not like yes or no or whatever. It's just false or true, spelled out. Characters are as you would expect, encased in single quotes. Single.
Yeah, apostrophe, whatever.
Apostrophe, there you go.
Yeah.
And the float, if you notice, ends in the letter F.
Doesn't that kind of differentiate the difference between a float and a double or something?
Yep.
Something weird like that? Yeah.
Yep.
But, just as you guys see here, declaring a primitive instance or a primitive data item
Ball's easy.
Is exactly the same in Java as it is in C++, and even, Objective-C, and they're all the same. All of them are the same.
And that's why, so once you get that foundation of the C and C++, you can just start hopping from language to language like there's no tomorrow, especially once you get out of the Objective-C freakiness and into, like, normal languages like Java and C#. You'll pick it up quick.
Now, Brian, there's something suspiciously weird here. I'm starting to feel kind of weird, and that is because why, Brian?
Yeah, what was with the deal with they're all signed?
Yeah, that's kind of stupid. Yeah, so Java does not support unsigned values, and a lot of people really, really hate this, but a freaky number, I guess a lot of people like this. I don't get why they like it. I think it's kind of dumb, but you start thinking about values that can never be negative, like the length of a string, the length of an array, like a byte, like when you're talking about binary, those can't be negative. Unicode,
how much
ASCII
overhead
characters.
Could it possibly have caused on the compiler? It's not like it's crazy slow.
It's laziness. Now, some have argued that this is more efficient, while others say that it's stifling. And you'll see in anti-Java rhetoric or even pro-Java rhetoric, this is actually one of the topics that almost always comes up.
It's generally believed that it was a design choice. Hopefully it wasn't like a whoops, I forgot.
Which is probably likely, I don't know.
Yeah. Maybe they were too busy trying to figure out what else to call it other than oak, and they just got confused. The belief that it simplifies day-to-day tasks, I don't know, because there's so many day-to-day tasks that I get stumped on because I'm like, oh, signed or unsigned? Oh, I can't make up it's like picking Tupperware at a grocery store. I just can't decide. Something that, like, in expressions where signed and unsigned values are mixed, you could possibly have, like, data loss issues, data integrity issues.
Yeah.
Using all signed values removes this risk. Yeah, I mean, usually it should kind of tell you. If the vast majority of expressions are signed, then why waste the energy? Why bother? That's fair enough. If a developer needs to use unsigned integers, just be a better programmer. Figure out some sort of way to, like, restrict it. Not a big deal. And some opponents think that Java wasn't meant to be like a computer science language, so it's like a blue-collar developer, environment, but that's,
Yeah, now Brian and I aren't saying this to defend Java. We're just putting this down as common things that we have heard that defends this practice. On record, Brian and I think it's really stupid that there are no unsigned values.
Yeah, but it doesn't, like, piss me off or anything. I mean,
it pisses me off a little bit. Just a little bit.
Whatever. I wouldn't have done it that way. I'll put it that way.
Yeah. Well, you're not cool like the Java people.
Yeah,
so unlike C++, Java allows primitive data types to be encapsulated into a class. When we started talking about packages, which we kind of talked about a little bit before, there is a package called java.lang that contains a lot of these primitive
data types.
Yeah, thank you very much.
Which is really interesting that it's not on the, it's not like on the base language level. They're actually in a class somewhere.
Huh? Yeah, kind of like we saw this when we were doing stuff with like NSString and NSNumber inside of the Objective-C course that we did before. So the object is basically surrounded by methods and fields that will support it, such as like manipulating stuff, extracting stuff, converting stuff. And we've written similar stuff in C++. Like you guys remember when we wrote the WString or the integer class. The integer class more so was written to kind of prepare you for this concept later. But we had static methods that did conversions. We had instance level that did all kinds of crazy fun, awesome stuff.
Right, and so as you'll find out, what you actually did was you wrote basically the integer class for Java and C++.
Yeah, right, exactly.
And you're going to see exactly the same thing coming up soon.
Yeah, so when we start talking about primitive objects and classes in Java, typically primitive data types will begin with lowercase. So, for example, we'll have int or char as lowercase, and complex data types like classes will begin with capital letters. So, integer with a capital I and the full word spelled out, integer, and then instead of char, it's character with a capital C and the whole word character. Holy crap!
Oh,
wow! So you could.
All right, So just take the primitive data type name, capitalize it, and stretch it out so that it's not like a short word, and you got the object data types.
Yep. That's pretty much it. So this is just kind of a look at a package summary from, I think, java.lang, and it shows some of the data types that come along with Java, and we have highlighted some of the ones that we've talked about already. When we start talking about the object data types, one of them is the Boolean. So in the Boolean here, we have static fields. So Boolean has a false. So like Boolean.false is false. Boolean.true is true. Those are two static fields that come along with it. And we're able to construct it with a Boolean value, construct it with a string. And then here we have those methods like extracting the Boolean value, all kinds of fun, crazy stuff. Methods,
like you can convert it to a string, you can get the value of, and the equals you'll find on all these objects.
Yes, because there's no operator overloading. So here's just kind of a little example of using the Boolean class data type where we just set the instance. And remember, this is going to be an object, so this is going to be a pointer. So when I say Boolean, my bool is null, we're just pointing at no memory space. Remember this from C++, right, Brian?
Yeah.
Yeah. So then we can set it to a new instance of Boolean, Boolean.true, Boolean.false. And then if you really want to see what this program does, because I don't want to show you because I'm too cool, just compile it and run it yourself.
Alright, so now let's take a look at the integer class. So you'll probably recognize a lot of these methods. So we have the double value, we have the float value, you can get the int value of it, you can also parse an int. So you can take in a string and get the integer value of it, which is, of course, extremely useful.
Yeah, very nice.
You can get it to a binary string, which is kind of cool. And obviously the dot equals is very important.
I wonder why that is, Brian. There's also other cool stuff like this.
Yeah, like toString you'll use all the time, value of, which is great.
2 hex string, 2 octal string.
Yeah, I know. Isn't that cool?
Nice.
It's convenient.
Now,
it's like luxury methods.
Now, we really don't want to go over every single one of these, so we just kind of gave you 2 numerical data types, the Boolean and the integer, and when you guys are ready, just kind of review them at your spare time and just kind of get used to the method structure, the field structure, and how Java has split apart the instance level and static methods, because they all pretty much fit that same exact model.
Yep. Alright, so now let's look at arrays. So Java will let you kind of do it however you want to do it, or pick your poison when you're defining an array.
Wait, Poison like the band Poison?
Oh yeah. Like your mama don't dance and your daddy don't rock and roll.
Nice.
Although that's really like Loggins and Macinda. I still think of Poison when I hear the song.
Yeah. So do I.
Loggins and Macinda, really?
Did you really pull that out of your ass? Is that like really who did that song?
Yeah, Kenny Loggins.
Oh my
like
God.
the guy who did Footloose and like the Caddyshack.
Oh my
song.
God, Footloose.
Yeah, the guy who did that song, it sounds like your mama don't dance and your daddy don't
No,
rock and roll.
I've heard it.
It's like really like country-ish.
I've heard it before, but I haven't heard it in 1,000 years, and I've heard the
Yeah.
Poison version 1,000. What the f*** are we talking about? Wait a second.
I don't know.
Is this
Anyway,
Java?
so there's two syntaxes for that's how excited I am about Java. Seriously. It just goes to show.
Yeah, we love Java here at women.net.
Yeah. So syntax 1, syntax 2. So there's 2 different types. One where you kind of do your data type, and then your brackets to kind of dictate that it's an array, and then the name of the variable, and then new data type and the size. Or you can put the brackets on the other side of the variable name. So if you like saying, for example, if you look down at the code, there's a class, main class, void main, and we declare int bracket n equals new int 10. Or on the right side under syntax 2, it's int n bracket equals new int 10.
Yes.
I like int n bracket, but
You do?
yeah, oddly enough,
I prefer the int bracket.
naturally.
Yeah, well, of course I'm going to have to like what you don't like. That's kind of how we work.
So there's a lot of common ways. If you want to just kind of load it up with a bunch of things, you can say int bracket n or int n bracket
Boo.
equals, and then in curly braces, you can just pass it a comma-separated list of values. And if those were characters, you would just, encase them in the single quotes.
Yeah,
Each one of
we
those.
saw very similar syntax in C++.
Exactly. You can also just say, like, I want a new int of size 10. You can also do, like, 2-dimensional arrays, like you see in the double, which is a 2-dimensional array of each double type. So this is a 2x3 array, or matrix, or table, or however you want to call it. You can also kind of use the curly brace notation if you look on the second example on the right, where it says double bracket, and then the row value is 1, 2, 3, 4. You can see it where you sub encase the records curly braces.
Right,
as well.
right. And that's how when Brian and I were talking about in the introduction to computer programming that a 2-dimensional array is kind of functionally the same thing as a 1-dimensional array of 1-dimensional arrays. And if you look at that, that's exactly what that is. Each one of those sub-curlies is a 1-dimensional array encased inside of a 1-dimensional array.
So you also don't have to declare out the size ahead of time. In the last example, you see where it says new int 5 and then bracket. And then as we iterate through the loop, we can declare that it's going to be, this element is another array of size 10, this is an array of size 10,
right.
and so on.
I hope that you guys appreciate what we did when we went back to C, because remember, Brian, in C, when we were doing the dynamic arrays in C, where we would do a C-alloc, and then we'd do like the int star C-alloc, and then for each we would do another int star C-alloc.
Yep.
I mean, it's functionally the exact same thing. You gotta love it.
Yeah.
I love programming. So when we start talking about strings, Brian, Java has a string class that derives its likeness from the C++ class. So it very much kind of used C++ as the model for how it was going to design its own class. The difference being, Brian, In Java, a string is immutable. In C++, it's mutable.
Right.
So the class structure contains all kinds of stuff like constructors, methods, and fields that allow you to extract the data, store data, and retrieve stuff about the data, like the length, uppercase, lowercase, all that kind of stuff. And you can kind of see right here in the constructor summary, it will take a lot of different types of data, like a character array, a byte array.
Basically anything you have, it'll take it.
Pretty much. And here's...
Especially because of the lack of overloading, it really should.
Right. And when we look at an example here of how to use a string example, now notice in Java, Brian, it's a capital string, right? So string,
right.
No lowercase string. My string equals hey buddy. String 2 just equals a new instance of string, calling the default constructor, which does nothing. Then the last one, we're doing a new instance of the string, and we're calling the constructor that accepts a character array, and we're just making a character array that says hey buddy.
Nice.
And as you print these three out, you can see that we're just using the print line. And even though, Brian, we don't really have any operator overloading in this language, there are some forced operator overloading. Like in this one, I can say my string 1 equals plus my string 1, but that's not operator overloading as we had discussed it in C++.
Cool. So here's some of the methods that come with the string class. So you can get like a character at an index, a lot of stuff that you're familiar with now, I would imagine. You can do compare it to another string lexicographically. You can concatenate strings by passing another string into the concat method. You can figure out whether it contains a character sequence. If the content equals something else, you can copy the value of.
Yeah.
Then you can do it with an offset.
Ends with?
You can see if a string starts or ends with another string.
Yeah.
You can see if it equals something else. You can pass it a format.
Yep. And then just
tons of stuff.
I mean, you can look index of if it matches this.
I love index of. I've always loved index of.
I use it all the time. Look at like replace.
Not all languages have it. It just blows my mind.
Replace all, splitting a string with a regular expression.
You know what I also like?
What?
See how substring is begin index end begin and end index?
What? A substring classically is start index count.
Right. I don't like the count so much. I like the end index.
I hate like TCL style.
Yeah, I like it. I like it that way.
I like go in to character 2 and then take 3. I like that way better.
Yeah, I don't like that. I find it sloppy.
Well, I find your face sloppy a lot of the times. So this just kind of closes out
to uppercase to lowercase, trim, left trim, right trim, whatever.
Yeah, so it's very similar to stuff that we've already seen before. What the f*** is this example?
So here we have a main method. We pass in some arguments. So we pass in quotes, Wibbit.net plus Java equals super awesomeness with the spaces and everything, but we encapsulate it all in quotes.
Right.
So what you'll find is that, if args length is 0, then it's going to print out no arguments, which isn't what happened. If the args length is greater than 1, then there's too many. But the bowl of oats is just right, so...
This porridge is just right!
Yeah. So then my string is going to be equal to the first argument that was passed in.
Ooh, but
yeah,
calling the
so
constructor.
When we print that out, you see that it didn't interpret this as multiple arguments. It interpreted everything encapsulated in the quotes as one long string, which is great.
Just like we've seen in other languages.
Yep. So we print out the length. And then we can do the first half and the second half of the string by saying we're going to go mystring.substring. We're going to start at 0, position 0, and then we're going to go until position the length of the string divided by 2. So that's the first half. So it's wibbit.net plus Java equals. And then the second half, we start with the length divided by 2, and we don't pass it an endpoint.
Ah.
And it just kind of chops it.
Yep, so that means go here and then go to the end of the string.
Yep, exactly.
Nice. So, this is kind of an example of how we can have these different classes intermingle. Now, you'll see that we're importing java.util.random. So, java.util is a package, and .random is a class inside that package that we're going to be referencing. So,
very cool.
Yeah, very, very cool. Just so, look at how simple declaring random numbers are in Java.
Yeah, wait, where's the time seed?
Yeah, I know. So, we're just doing random equals a new instance of random, a string output string, integer 1, so we have n1, n2, n3 equals a new instance of rand.nextInt. Holy sh**!
Nice.
Now that's cool. That's cool. And then the other one is another random number, and then n3 is going to equal the addition of the integer values of the previous two. Well, we do some pseudo operator overloading, but Brian, what are we calling? What method are we calling on that integer instance?
ToString?
ToString.
I wasn't sure which one you were referring to. Yeah, we just call it toStrings,
See,
and we
Brian,
just take it as strings. It's great.
This is the problem with us doing this remotely, Brian, because I'm pointing at my screen and you have no idea what I'm pointing at.
That's why I need to see you on a webcam.
Oh no, that's not happening because I don't even think I'm wearing clothes right now. But what this will do is this.
Why do I feel like somebody's watching me?
Nice. But what this will do, Brian, is we'll have those two random numbers, and then the addition of the two random numbers, and then using the integer class to convert those to a string, concatenating them together, and printing them out to the screen.
Very cool.
Pretty awesome.
Yeah. So the final data type is very interesting. So the final can be used pretty much anywhere. You can use final as your passing parameters when you declare a method. So we can even say like final string bracket args, and it'll block it, and we can put it anywhere. And what it does is once you declare something final, it eliminates any setters. Like you can't store anything else into that. It locks it. So it's saying basically that like this is now the final state of this variable.
Mm-hmm.
So if we say final int my integer equals 1, 2, 3, 4, nothing can ever change that from being 1, 2, 3, 4. And if you try, like in this example where my integer equals 4, 3, 2, 1, it's just going to crash.
Right.
So as you can see down below, it'll say cannot assign a value to a final variable.
Mm-hmm. Absolutely, Brian. And there's different, like you were saying, there's many ways that we can use the final access modifier, and we'll use that we'll show in other instances and other situations where this is useful.
Yeah, and a lot of times, if you just want to protect your parameters coming into a method, in case it's by reference, you're going to screw with something else, you just mark them final just to make sure that nobody's going to come in and with them.
Right. Now, one thing to keep in mind is if it's an immutable object, this is great. If it's a mutable object, you can still interact with methods that might change values inside that instance, but you can't set it equal to a new instance.
Right.
Enumerations, one of the great data types in all languages. And if you look at this, I mean, you can copy and paste this into a C program, and it would work just fine. It does the exact same thing. So in this example, we're just creating an enum, and we're just using it, and we're just using it by
cool.
using the date class. Using get day so we're checking which day of the week is it, and at the particular time that we ran this program, it just happened to be a Tuesday. Wait, is today a Tuesday? Ironically, today is actually a Tuesday.
So what's cool is you just like you normally would, you just say day of week, and then it'll give you your options, and you say Tuesday.
Right, and just like in C, if these values are not explicitly set, we're going to go from 0 to n. So Sunday will equal 0, Monday will equal 1, and so on and so forth. Because remember, an enum is nothing more than just a set of integer constants.
Yep. Structures?
What about structures? What's going on here, Brian?
Structures?
Structures? Anybody need some structures?
No, they closed down and became Express.
Java doesn't support structures, Brian?
That's crazy.
That's the most fucking shit that I've ever fucking heard.
I can't imagine a situation where oh no, wait, wrong language.
Although it's absolutely applicable in this case.
Yeah, so some suggest use a class of public fields instead. I don't know. Whatever. I can take or leave a structure. I like structures, but I don't mind not having them. It's okay. That's a fine workaround.
Yeah.
Public fields in a class, it's fine.
So as this kind of shows, this lesson kind of shows, there's a lot of different types of data types that we can use in Java. And there's many different ways that we can use them. Right, Brian?
Oh, I thought you just cut out. Oh, okay, yeah.
Brian, I can't hear you.
Oh, this remote session. Yeah.
Hello? Hello, Brian.
Yep.
Hello, Brian.
Thank you for watching.
There's a problem.
Thank you for being a friend.
Hello?
Traveling around the world and back again. And so this isn't too unfamiliar from C++. And if you aren't familiar with C++, we can't tell you often enough. Get a good understanding of that before jumping into this, because it will do you a world of good. But if you haven't, as you can see, it's pretty straightforward.
Yep.
It's not too bad.
That's it.
Anyway, we'll see you in the next one. Hey everybody, welcome back to Programming in Java. In this lesson, we're going to be talking about exception handling.
Wow.
a core piece of Java, something that you just can't avoid.
You can't, and no matter how badly you wish you could avoid it, you can't avoid it. Anyways, Brian, I have a fun little joke for you.
All right.
What 2 words make up 90% of a Java program?
I know the answer. Try and catch.
And that's the truth right there. Oh man. So in application development, we typically have 3 major types of exceptions that we watch out for. The first one is is what we call a checked error, which is basically a known application error. It's also sometimes called an internal error, and it's basically an error that we have complete control of. So for example, if we're taking in, a good example of this is when we're pulling in like command line input and it comes in as a string and we need it to be a number. Well, it's our responsibility to check to make sure that that is a number, because it's not the program's fault if that crashes. That's the developer's fault if that crashes. We also have an error exception, which is basically an unknown error. So it's called an external error, and it's something that we typically don't have control over. So like, let's say your application's reading off of a USB drive and then the person unplugs it. Well, that's not something that was assumed when the application was running. This user was kind of being a jackass and he unplugged the damn USB drive, and And then we also have runtime errors, which are unrecoverable internal errors. And it's an error that is internal to the application, and it also cannot be anticipated. So if there's some issue with an API that you're importing, for example, maybe you're importing some external code that's compiled code that has bugs in it, a memory leak or something like that. We have no control over that. And there's also logical errors. Your program will most likely not crash when a logical error takes place, but your program will not behave at all the way you want it to. So that's something that you really can't take into account when you're doing exception handling. Yay, Brian? Nay, Brian?
Perfect. Yeah, it's flawless. Yeah. So Java wants you just to exception handle everything.
Yep, everything.
So much so that you'll notice some people use exception handling as a way to manage a logical flow of something. So for example, if somebody's going to pass in a series of parameters and one of them is the valid parameter that you want, but they don't have to pass it, you'll try to use it knowing that it could be a null value. And if it is a null value, it'll crash, and then you do something else in the catch to accommodate for that other condition. Almost like an if-else. Yeah. Which I think is a horrible way to write code.
I completely agree. Yeah.
So it's kind of tough to explain, but basically it's called hard crashing or catching later.
Yeah.
So people will design the program intentionally to crash in order to handle a different logical flow of the application, which is not what we would recommend doing.
Yeah, and it's also the way I look at that is lazy programming.
Yes.
That's
totally
completely lazy. You really shouldn't be writing software if that's how your software is designed. Yeah, exactly. You should feel terrible about yourself, Brian.
So really where you want to, exceptionally handling can be a great thing. I mean, it can be an amazing thing. And if you really get into it, you use it well, it should be able to if you write something procedurally and not so object oriented, you think to write lines of code in terms of a particular path. Okay, I have a function and my objective of the function is to do X, Y, and Z. And if anything gets in the way, well, I'm just going to freak out.
Yeah.
Which should happen with proper try-catch and exception handling, try-catch usages, is I try to do X, Y, and Z, but if this happens, I can kind of accommodate and I can adjust and I can take another course of action, or I can go back to the user to clarify input, or I can, validate sources or flag something as a potential security problem. You can really start getting into a very organic and adaptable application instead of just, I try to do 1, 2, 3 failure, 1, 2, 3, 4, 5 failure. I mean, it can be much better than that, especially in an object-oriented world.
So let's kind of take a look at an example of an I/O exception. So in this code, we're importing java.io star, and we have a main class called myClass and a main method. And inside this main method, Brian, we have an instance of a file reader object, and it's pointing at a file at c:\temp/file.txt. And what we're doing is we're reading 1 byte at a time. So we're in a sense, since this, I guess we can make the assumption that this is an ASCII text file, we're going to be reading in 1 character at a time. But the problem is, Brian, if I were to take this code as is and I try to run it against the Java compiler, I'm going to get this error. It's going to say, whoa.
You're going to get a disappointed parent is what you're going to get.
Wait a second here. You have something here that can blow up, and you didn't try to catch it.
Don't go out of the house looking like that.
Yeah. What will your mother think of you if you walk out of the house looking like that? So this is just basically yelling at us saying, dude,
This is Java saying that you just wrote whore code.
Now, if we wanted to fix this, there's obviously many ways we can do this, but this kind of take a look at one way we can do it, and that's by declaring throws. By declaring a method with throws, you are declaring that this method must be wrapped around in try-catch blocks. So when we go back at this code here and we have an instantiation of this instance and we're calling the .read, well, these methods are throwing, and we'll show you an example of this in a second. So that's the reason why the Java compiler is forcing us to have a try-catch around it. So it's basically a way to force exception handling, but one way that you can kind of sneak around this if you're lazy, like me, I do this all the time, is if you're in the main method, well, throws just doesn't really do anything, so it's like a way of just avoiding exception handling. So if you take a look at this, Brian. What do you think about this code?
Nice.
It's a lazy way around the problem.
That's way lazy. That is not something you want to do.
What I've done is I've thrown the responsibility then back up.
To nothing.
Yes. So if you had a different method that was running this by saying throws, well, then the responsibility of catching it is at the layer above it. Well, this code right here, there is no layer above it because it's the main method. So, but what happens is if I run this program and it fails, the program will crash, and it will crash hard. And this is just basically throwing a generic exception, but we can also get more specific and we can throw an IO exception, which, as you know, Brian, how many exceptions are there in Java?
500 million trillion billion.
And that's being very generous.
Yeah. Well, and you can make up your own too. So a lot of classes that people implement, or a lot of like code that you import just from whatever the source is, will have like their own exceptions that they make up. So it's a never-ending list of exceptions.
Yeah.
I like the my balls are too sweaty exception. Okay, so now let's put now instead of just kind of like bubbling up the exception in the bad way, let's do it the good way, or a better way.
Or a different way.
Different way, yeah, there you go. Another Java way. So now let's take the block of code that, where we try to read the file, and we put it inside of a try-catch block, just the entire thing. So as you can see here, we have like the try, curly brace, and then our file reader instantiation and all the rest of it, which has different types of throws that could potentially happen. And that whole area is all caught by just a generic exception EX. So what we're going to do is anytime an exception happens, we're just going to print out the message from that exception object. Now, all exceptions that you'll find, like IO exception and all that other kind of stuff, are all extensions of the exception object.
Right.
So they'll all have like a get message, for example.
Mm-hmm. Yeah, the exception can kind of impersonate all exceptions. So if you don't know what exception you're catching, you can just make an exception, and usually that will just be fine.
Yep. It's the Big Daddy Sacks exception. If we set it to a file that's not there, like C/temp file not there, which doesn't exist, trust me, you'll see that we'll get an IO exception. And the message in the IO exception is exactly C:/temp/file not there.text in parens, the system cannot find the file specified.
Wow.
So it's kind of cool. It's really not bad.
Yeah. And one cool thing to keep in mind too, Brian, is instead of doing system.out.println, we're doing system.err.println, which is going to write this out to standard error.
Yeah.
Kind of cool.
Very cool. Yeah. So if we were to get more specific, and instead of exception, this was IO exception, you could put catch IO exception, do something, and then immediately following catch regular exception EX.
Yeah.
And it will match on the most specific exception it can, and it'll continue down until it gets broader.
Right.
So you can like take action specifically for an IO exception.
Yes,
for example.
Yeah, for a specific type of exception.
Yep.
Good call, Brian. Now, if you wanted to kind of make this a little more specific, instead of putting a try-catch around the entire code, we can just try, we'll create our file reader, set it to null, and then create the instance surrounded by try-catch. And check this out, Brian. In the catch, we're using a file not found exception.
Nice.
And if the file is not found, we're just going to print the message out in return. And then if we are able to link to a file and we'll try to read a file and there's a problem reading it, well, then we're going to hit an IO exception. So that's one way you can break it up. But like Brian said a moment ago, you could just as easily put that all within one try-catch block like we did here, and just have two different catches where one is an IO exception and one is a file not found exception.
And then the last one's a generic one for anything else that could happen.
Yes, precisely, Brian. Precisely.
So there's a ton of exception classes. Obviously, we're not going to go over all of them because that would be ridiculous.
Yeah, do you guys have 15 hours to go over this? I don't think so.
I mean, Java's boring enough as it is.
Yeah, right.
So The Java gods are angry. Excuse me.
Ooh, are you okay there, buddy?
Whoa, sorry about that. Didn't mean to offend Java.
Well, it sounds like you didn't put a try catch exception around that sentence that you were just saying. So
yeah, right. So if you get time, review the documentation. It's not too bad. Or just kind of use it as a reference guide, like familiarize yourself with it, but just kind of know where it is, know how to get to the documentation so that you can reference it when you need it.
Yep. So Brian, let's talk about throwing an exception. So just like
throwing up an exception?
Throwing up an exception so that Brian's big baseball mitt can catch the exception. So just like in C++, we can create our own exceptions. So this allows us to check for errors in our code and throw the exception to the one level above it or the calling code based on a situation that we dictate and that we control. So that's pretty awesome.
Wayne's World?
Which one? Yeah, which one?
Wayne's World, the first one?
Yeah.
When Garth was like, if you're gonna spew
into this.
Man. That's like exception handling. That's like a perfect analogy of Java exception handling. If you're gonna spew into this.
Nice. All right, so Brian, what is this code here doing?
Let's see. If we don't have any arguments, it throws an exception and passes a message. If it's not the exact number of arguments we want, it's going to throw the same type of exception but with a different message.
Yeah.
And then some other stuff.
Yep.
So we'll try to like convert to a double, and we'll try to access arg0.
Right.
And same thing with args1.
Yep, so also, Brian, the main method throws exceptions. So that means on the if and the else statement, notice how we're just throwing. So let's kind of follow this flow. So if we were to compile this program using Java-C and then run against the Java interpreter, and we just run the class without passing an argument, well, it's just going to crash the program. It's going to be that there was an exception in the main method and there were no arguments passed. That's what we said. Now, if we pass 4 arguments, we're going to get the wrong number of arguments there, buddy. And so now let's run it again here where we pass wibbit.net as the first argument. And it should crash here, input.
Because 5's not a double.
Yeah, there you go.
I mean, wibbit.net's not a double.
Right, yeah. Although it does have a period, so I don't know.
Yeah.
It could be weird. I don't know, whatever. Anyway, so in this one, we're trying to convert the second one, and the exact same exception happened. It's trying to convert a string into a number, and then when we just run this with 5, it converts it just fine, then it performs the rest of the code perfectly.
That's awesome sauce.
So, Brian, if I were to write some code using some Java, like a Java class or some Java methods, how could I know which type of exception that it's throwing?
I'm not sure what you're asking me.
The question is, if you don't know what type of exception something is throwing, how do you find out?
Well, first, I guess you'd look to see what the method you're going to use is. So, like, in this case, let's say we're using setOut.
Okay.
Hypothetically. So we go to the Java documentation, and we look up the setOut method. And the setOut method documentation has, like, a bunch of information for us. It tells us, like, what it does and how it works and what the parameters are. And then it tells us what it throws. So if you notice here in the documentation, for setOut, for example, or println or whatever you want to look up in the documentation, it throws security exception type exception.
Right, so if you were to put a try-catch block in your catch, the type of catch is a security exception.
Nice.
Yes, very awesome. So the exception handling is great, and exception handling is one of the most, it's like that like annoying friend that you had as a kid, like he had a Nintendo and you didn't, so you wanted to be friends with him, but you hated him because he nagged the hell out of you. That's what I think of as exception handling, Brian. What about you?
I don't know if that makes any sense.
I don't think it makes any sense either, but I'm gonna go with it. I'm gonna pretend like that made sense.
But the only thing I can think of is like exception handling in Java is like, for me, it like feels very soft. So like I had a Sega Genesis.
Yeah.
And a couple other kids my age had like a Super Nintendo.
Right.
And whenever I'd play the Super Nintendo, it was like kind of strange because like the controllers were all like kind of like soft and round and smooth, and like the graphics were kind of soft and like not very fast.
Right.
To me, that's how exception handling in Java feels like. It feels like Super Nintendo.
Feels like Super Nintendo. Nice.
Versus Genesis. So in that sense, I can relate.
Yeah, because Genesis is more rugged. You know, it's more like
just do what you want.
You
like
can
if it
smack
crashes,
me around.
You deal with it.
Yeah. I see what you're saying.
And it's faster.
Yeah. Cool.
Anyway, have fun with it, guys. See ya.
Welcome back to Programming in Java, and here we're doing a lab on just kind of messing around with a few different exceptions. Now, we just went through the lesson on exceptions, and we showed you kind of how to catch them, and what we're going to do in this one is we're going to be practicing throwing an exception and catching a list of exceptions, and just kind of seeing how all that functions.
Right, so we kind of mentioned that, when we can catch an exception of just like whatever the type of exception it is, but we mentioned that we can have like multiple catches on a try block. Mm-hmm. So in this lab, we'll just kind of like, just to give us practice, we'll make a try catch block and we'll make sure that it catches multiple types of exceptions.
Okay, so we'll do an exception lab Java, cool. Exception lab.java.
All right, and we'll just import Java lang so that we have some of the Java lang exceptions available to us.
Java.lang is already imported by default.
Oh, okay, never mind then.
Yeah, otherwise you couldn't use string or anything like that.
Oh, yeah, good point. All right, never mind.
So we'll do the public
static main, public static void main. There we go.
Okay.
Perfect. Look at that. Look at us go.
All right. So let's
Okay, so let's create integer. We'll call it input.
Okay.
I don't know. And we're gonna say that the integer input is equal to 0, and then let's try to parse the argument that comes in.
Okay.
And store it into the input. So that's going to be in the integer class, right? Mm-hmm. Parse int, and then we're going to take in arg0.
Okay.
Right. So we're not checking to see if there is an argument or not, which we should, but...
Well, actually, Brian, we don't have to because we're try-catching this.
That's true. Good
because
point.
We can catch multiple exceptions, right? Isn't there an index out-of-bound exception? So inside of this catch, Brian, just like we discussed in the videos, we can kind of stack a few of these to catch this problem.
Mm-hmm.
So we can know what the problem is. So, in this catch, the first one that we'll check for is to make sure that this arg sub 0 is valued, meaning the user actually supplied at least one parameter.
Right.
And this is of type array index out of bounds exception.
Cool. And we'll just call that like EX or E or whatever. Okay, and then we'll print out to the screen saying please enter a
param.
Yep.
And then we can do system.exit, which is basically the same thing as in C++. You would say return 0.
Right.
So we could also just say return, but just for the sake of exposing you to something different, we'll do that.
Yeah. Okay, so now we're going to put another catch on right after this.
Okay. So
we're going to stack multiple catches.
Okay, what's this one going to be?
This is a number format exception.
Number format exception?
So this means that if they passed in a parameter, but it's not a number, like you pass in the word balls... it's going to have an issue,
Right.
And we can print out the message from this too. So we'll say error parsing, or please enter a valid number, or error parsing integer. And then we can also say...
like that, maybe?
Yep, and we can also say, we can add to the print line the exception message.
Mm-hmm. Let's also send this to error instead of out, because they're errors.
That's true.
And then you said that you want to add... the exception.
So it's a get message.
So we'll do another print line.
Yep.
And then we'll call the exception instance, and we'll run the method called getException.
Get message.
To get message, sorry.
Mm-hmm. Okay.
And that should tell us the actual problem, right?
Yep. Cool.
So
now we have two stacked catches that will catch two different conditions.
Mm-hmm.
One if they didn't pass in a parameter, and one if you pass in a parameter that's not a valid integer.
Right. And if all else if everything ends okay...
And you can... Yeah, right.
What do you want to just say? What do you want to do? Just type write input out? So we can say like, %d is an integer. How does that look?
Great.
Okay, let's see if we can get a compilation. So Java, C, and what did we call this? Exception lab.java. And that worked. So now if we run Java exception lab, enter a param. See that, Brian? Look at that.
Cool. Nice.
Now let's enter a param.
Right, and that's not a valid number.
Look at that. And
look at that.
The cool thing was, when we ran this the first time, we successfully executed this catch here.
Right.
Then the second time, so error parsing integer for input string that... Actually, we could probably make that a little cleaner and just say error parsing integer, and then it should say the message after that.
Cool. Oh, yeah,
We're good. All right. We're good. Now Java, Wibbit.net. So error parsing integer for input string, Wibbit.net.
Nice.
Right.
Awesome.
Very
cool.
very cool.
So now let's pass in a valid number and make sure that it works.
Okay. 999 is an integer.
Cool. Now do 999.5.
Okay. No!
Yeah, kind of cool, huh?
Very cool. I like it.
So that kind of like expands upon what we showed you in the coursework to kind of show you how to like stack up those catches and just how to like use it in general, you know.
Yeah, it's very useful.
Hey everybody, welcome back to another round of programming in Java.
Yay, Brian, yay. What? I'm just so excited that we're doing Java still.
Especially, yeah.
I mean, every time we start a new recording, I'm like, yay! Thank you, Java gods!
We're going to be doing console input and output.
Yay.
An essential part of Java if you're needing to, test stuff, get started, get moving, be able to see what the hell you're doing. It's solid. You need it. We'll give it.
Yeah. So
golden.
It's kind of lame, Brian, because we've actually already been talking about this. We've shown examples of using system.out. We've shown system.error. So what else could there possibly be? Why are we torturing our viewers, Brian? What the hell?
Why are you doing this to me?
Why are we doing this? So when we take a look at this example, Brian, we already know this. We have a system class, and there's an instance of a print stream in there called out, and then there's a method on that print stream called printline. There's another instance of a print stream called ERR for standard error. So when we break this apart, like I said before, there is a static instance of a print stream. One of them is designated for standard out. One of them is designated for standard error. So that's kind of cool, right? Yeah. Nice. Tell me, Brian. Tell me more about this print stream that is so mysterious.
So if you were to instantiate a print stream, you can use some constructors that take output streams.
Interesting, Brian. So does that mean that you can redirect std out and std error to anything you want?
Yeah, girl.
Oh, shit. That's crazy, Brian.
So some other methods on there is you can check for errors. You can close the stream. You can print doubles, floats, blah, 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 blah.
You can flush the
print
toilet.
Line, flush the toilet. Print line of any type.
Look at all the print overloads and the print line overloads. And also,
nice.
One thing to keep in mind is pay attention to these methods because there's a lot of other classes for like file output that will actually use this, that will inherit from this class. And you can print line to a file, you can whatever to a file. So like,
absolutely.
This stuff is reused all over Java. And even though, Brian, we have all these cool print ln things, we can still use our best friend printf.
Nice. That's awesome.
Yeah. So what is this doing? I'm scared.
So let's like just take a quick example of using printf, which we all know and love, so that we can use format strings.
I love it.
I do. It's nice. It's awesome. So we make a timestamp, and we use a method that's on the system object called current time mils, and we divide it by 1,000, so we get secs. So that gives us our timestamp. So we're just going to print out the program %s at %d. So it's going to be a string and a digit. And we're going to pass it the string started, in quotes, and then we're going to pass it the timestamp value. Then we're going to sleep for some like random amount of time.
Ah.
Yeah, very nice.
And look at this, Brian. We're using some static methods, one current time millis that belongs to the system class, print as f, obviously, and there's a thread class in the thread class.
Isn't that awesome?
Yeah.
That's how easy it is to like sleep. You just thread sleep.
Wow, that's cool. Which we're going to get into multi-threading later, but check that out. It's just a thread, and then inside the thread class, there's a static method that will just take in an integer, and it will just sleep. That's awesome. Gotta love it.
Right, so we created a new random instance that passes the next int 5,000 to just give us some random number up to 5 seconds.
Yeah, nice.
So then we set the timestamp, the current timestamp, like another one, after we've slept for some span of time, and then we print out that timestamp too. And in this case, we keep the string the same, and we can just pass it ended instead.
Very nice, Brian. Well said. Here's another example of using a similar type of structure as we did with printf, but instead of using printf to format the output, we're going to use the format method, which is a static method attached to the string class.
Nice.
So if we were to do that exact same program that we just did, but not do it with printf, we can have a string instance. In this case, we're calling it started string. That's equal to string.format. And then check it out, Brian. This program %s in at %d, just the same thing as printf, but instead of sending that out to the console, we're storing that in a string.
It's awesome.
So then we could just use the system.out.print, print the string, sleep for a random number of milliseconds, and then get the time again and make another string and print that out. So
for Objective-C folks, this is like the
Oh, God.
There's like NS string with format string,
Yes.
basically.
Yep, exactly.
It's kind of cool.
Except for you don't have to put like nil and there's no like weird comments.
But it's like way more intuitive. It's just string format. It's not like NS string pass in it, alloc in it with format string passing of something and the blah blah blah.
Now, Brian, as we were saying before, since the out instance inside of the system class, that static out instance, since that is simply a print stream object, that means we should be able to override that and then redirect std out to a different place.
Absolutely.
Now, how would we do something like that? All
right.
It's crazy.
Well, let's walk through it. So let's say we have a file, and we'll call it just like stdout.txt.
Nice.
So we create a new output stream object and a print stream object, and we'll just set them both to null for now. And what we'll try to do is we'll try to instantiate an output stream instance. So we're going to set it to a new file output stream, and then we're going to pass it out file. So this should, unless there's an IO exception, this should establish a output stream object that's now tied to that file name. So long as that's successful and we continue on, we'll try to set the print stream now to be a new print stream that is based on that output stream that we just created tied to the file.
I see where this is going.
Yeah, so if that succeeds, now we have a print stream object, and if you remember the constructors that we reviewed for the print stream object, they take in an output stream, which we've tied to a file. So now we can pass that print stream into the setOut method.
Holy crap.
So if system.setOut passes in print stream, it will hook up out to that print stream we just created.
Wow.
So in theory, if we now use system.out println, out is now redirected to a file. So anything that we pass in, anything that we print, will send the text to a file.
Let's see here. So in the Whippet.net virtual console, we compile the program, and then inside of the directory where this program is, we have the Java file, which is the source code file, and the class file, which is our Java bytecode file. So if we...
You know what I like about the Whippet virtual console?
What's that?
Is the rounded corners makes it out like a 1950s mainframe screen.
Yeah, like the mission control console that they had in the old NASA.
Like the old oscilloscopes and stuff. It's great.
So we run the bytecode by calling the Java interpreter, and what the hell, Brian? We have a system.out but that print line. Why the hell didn't it print anything? I'm so confused. But if I dir it, there's a file called stdout.txt, and if I run it with Notepad, holy shit, I see my text in the file. So
awesome.
we have successfully redirected standard out simply by changing the pointer that the out instance is pointing at. Beautiful. So we have complete control over that. So if you wanted system.out to send like over a TCP socket to like your computer so you can watch everything your girlfriend's doing on her computer, you can do that if you want to.
Or whatever. Or something way less creepy.
What? I have security issues, all right?
Your quote-unquote girlfriend. You mean your girlfriend with the restraining order? It's not like you're not anonymous if you're just creeping. You know?
Well, but the restraining order is the reason why I have to do these things, Brian. Okay, give me a break.
Anonymous is like, that guy's not with us. I don't know what he's doing.
Okay, it's like every creepy kid in every 80s movie would be considered a stalker today. That's all I'm going to say.
It's just showing that you care.
Like remember Pretty in Pink, the guy Duck or Ducky, whatever?
Oh, yeah.
That guy would be arrested in today's society.
That's true.
Because he was like waiting outside the club for Molly Ringwald, like standing outside of her house.
Ended up being the hero. You're right.
Oh my God, that guy was creepy.
Yeah.
Anyways, wow. What is it about teaching Java that makes us go off on tangents about stupid things that don't matter from the 80s? All right, so Brian, so let's talk about console input. Now that we know how to show the user what our program wants to display, how do we retrieve data from users?
Well, let's see. We had an output stream. What about an input stream?
That sounds like it might make sense. Now,
so like we have in, we have out, and we have error. We also have in as part of like the system library, which is great.
So inside of the input stream class, we have all these methods like available returns how many bytes are left, which we'll show an example of that. Closing the stream, reading from the stream, and like
so instead of writing, it's reading.
Right, and if we have a certain amount of characters that we want to skip, we can use the skip method. And now here's an example, Brian, of us reading data from a user. Now tell me how the hell this thing works, because this is insane
all
looking.
Right. So let's go through this.
Yes.
Also, keep in mind we keep doing the throws exception so that we can keep the code clean and showing you like just what we're trying to focus on.
It isn't good practice, but I mean, we don't want to squeeze the code so small that you can't read it.
Right.
You know?
The point is just to kind of like drill down to the particular concept and continue. You know.
Yeah, if you want to see how a programming language really works, we do C# next. So just hang in there.
All right. So character user input, we'll just start with yes, you know?
Yeah, set no value, yeah.
While the user input character value is either uppercase or lowercase y, we'll keep on asking to continue. So like continue yes, continue yes, continue yes. So what we're going to do is we print out the line, we print out the prompt first. And now we don't do a print line, we just do a print because we don't want that new line character in there.
Yep. Mm-hmm.
So we do system out print continue, yes or no. Then integer c is equal to system.in.read.
Yes. Now we're reading this as a byte, so that's why it's coming in as an integer.
Right. So now the user input becomes a typecast character of that input.
Yes, but we're only reading 1 byte. So if you type like yes, it's only going to capture the first character.
Right. And then we say, while the system in it is available, then we continue to read.
Yeah, like remember how in C, we would get all kind of tripped up because we would have, I don't know, like get char and you type in a bunch of characters and like
and you have to like flush out the buffer and stuff.
Right. This is the equivalent of flushing the buffer in Java.
Right. So how do we read a line of text? Like that was all well and good for just grabbing the first character, but what if we want to do the whole line of text? So in this case, we need to create a buffered reader object. And this reads text from a character input stream. And it just kind of buffs up, and then we clear it, and then buffs up and clear. You know, it's like a blowfish, just kind of like doing its out.
That's a really good analogy. I never thought of it that way before.
Eating and shitting or something, breathing or filtering water or whatever how blowfish does. I don't know, whatever their purpose is. Inputs. So then we have an input stream reader, which we discussed, which is kind of like the input stream in, which is the opposite of the out, into a class that creates a bridge from a byte stream to a character stream. So we'll kind of see it in action. But basically, what this is going to do is it's going to read bytes and encode them to the Unicode characters. So it kind of does that translation for us as we're like pulling in the bytes. So what the deal is here. So let's create an input stream reader object, just like we were talking about, and we'll create a new one and we'll pass in system in.
Oh, that's kind of cool.
Yeah.
So so we're like passing the command terminal as a parameter to this class.
So then we create a new instance of buffered reader, and the buffered reader we pass in the constructor the in stream because that's what we want to be tied to. So it's like the hip bone connected to the thigh bone kind of thing. So now we say system out print line, and this is just our prompt. We just don't do print line, we just print. Enter a line of text. So that's our prompt. Then we create a new string user input, and that's going to be equal to the buffered reader, and then the method on the buffered reader, read line.
Nice.
Isn't that awesome?
That's cool.
So that buffered reader kind of gives you the flexibility. The buffered reader built in that robustness for you to kind of have the convenience, like I'll call them 4th generation luxury methods that the language just comes with, like readline. So it just saves time. I mean, in C, you're always having to kind of like write your circumstance to do this of your like preferred thing. It's just kind of built in that just grab a buffered reader and off you go.
Yeah, so as the user is typing, it fills up the buffer, and once they press enter, that executes this method, so then the string will equal whatever that buffer has accumulated.
Yep. So then you just print out you typed, and then you print out whatever's in the user input.
That's awesome.
Yeah.
That's
way easy.
That's very sexy, Brian. Here's another example. So we're going to create an instance of a string user input. We'll call system.out.print, and we'll ask the user to enter a line of text. Now in this case, Brian, here's what we're doing. We're calling the toString method that belongs to the character class, and we're bringing in 1 byte typecast as a char. So what we're doing is
we're kind of doing the buffer, so to speak.
Yes, exactly.
It's kind of a manual where we start pulling all the characters in.
Right. So then once we store that first character, just like in that last example where we were checking to see if available was if there were still characters available and we were skipping typing them? Well, in this case, we're going to capture them and we're going to concatenate them together. So user input plus equals character dot toString, and then we're going to run that same code over and over and over again. So just like you just said, Brian, this code is manually creating that buffer. So this kind of shows like what that buffered reader is doing for you that you don't have to do.
Nice.
So it just kind of helps you realize what's being done for you.
Yeah, what's going on?
Yeah, so
what's under the hood?
So console input in Java isn't that bad. I mean, it's not
cool.
It's not as cool, I think, as CIN or Cout in C++, but it's still pretty cool.
Yeah, I don't know why, but for some reason, CIN and Cout in C++ is my favorite.
That is the best I/O.
I like piping it out like that. I don't know. It's
weird. The whole
weird.
stream concept in C++ is pretty good.
Yeah. Anyway, see you in the next one.
So in this lesson, Brian, we're going to talk about file input-output.
Nice. A very natural thing to talk about after talking about console I/O.
Yeah, it kind of looks like we were lazy and we just took the same template for C++ for Java, but you know what? Who cares? Nobody's actually paying attention to that. So let's talk a little bit about Java I/O. So Java gives us a package that contains many classes that help simplify input and output, including file I/O. So Java.io has the capabilities to work with input and output streams. So some classes can directly interact with files. Others are best used with multiple instances of files or encapsulating other instances inside of itself. And there's like tons and tons and tons of ways to achieve file I/O. And just like anything else, Brian and I can't show you everything. So we're going to kind of show you the more common methods of file I/O in this lesson.
So what do we have here? Let's see. We got the file class.
Yeah.
For file I/O, it's a very, they try to name things very intuitively. It's just file. It's kind of cool. Some of the constructors can take in, another file object and, a string of the child or the string of a path name, which is probably the most common. Yep. Or a URI, which is kind of nice, too.
Yeah, so you can do the whole file : / blah 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 blah.
Yep, if you need it. So you can set something or you can test. I guess these are read only. But you can determine whether it can read, whether it can write. You can compare it to another path, another file path, which is great. You can compare to another object to see if the objects are equivalent. You can create new files. You can create temp files. You can delete. You can delete on exit, which is awesome.
That's cool.
So once you're done with the file, you just get rid of it.
That's really, really, really cool. That's awesome. That's quite useful.
It is. Yeah. Absolutely. Equals. It just checks to another file object, not the actual file equivalent. And then exists is, of course, always very useful.
Right.
In this test, a file or a directory. You can get the absolute file. You can get the absolute path, just as you would expect, the full path. You can get the canonical path.
What the f*** is that?
Let's call it the relative path.
Okay.
You can get the name of the file, just the file. So one of the things that's nice about this is with these methods, sometimes you have you want the full path file name, you want just the file name, you want to get, whatever the case is. You want to find out if the path is absolute. Are we referring to a directory? Are we referring to a file? Is directory, is file? Those are really useful. It's good for recursively iterating directories and stuff.
Because the file class will accommodate both files and directories because from a technical sense, when you start looking at, how computers
the same thing.
Manage this stuff, they're pretty much the same thing.
Yep. So why bother having a directory thing all separate?
We can also test, is this a hidden file? We can get a Unix timestamp when it was last modified, the size of the file. We can also, look how cool this is, Brian. There's a dot list that returns an array of strings with the stuff with the things.
If it's a directory, you can list all the files in the directory, which is awesome.
Yes, with list files. That's awesome.
And then list isn't just the files. List is all of the files and the directories, but if you list files, it will return you an array of file objects, which is great.
Right, and you .mkdir, so it'll make the specific directory, but you can do mkdirs if you have C:/ this, it will create all of those recursive paths for you.
It's awesome.
And we could also rename it. We can set the last modified time. Now this is kind of cool, Brian, because I'm going to tell a little fun story about this. When I was in college, I had a friend who had a paper that was due at midnight, and what happened was, this is a true story. So she was like, all right, well, it's 12:10 a.m. and I haven't turned the paper in. I was like, don't worry, give me the file. So what I did is I took the file and I wrote a program that changed the timestamp on it so that when she sent it to her professor, it said that it was 11 p.m. when she last saved it. So technically she got credit for it because she was done by
Genius. That's awesome.
Yeah. That's my little fun cheating story.
That's cool.
Don't try this at home, kiddies.
Definitely try that at home.
Definitely. Hey, man, if you're smart enough to do it, use technology to your advantage.
Exactly. So let's take a look at an example of using the file class. So we'll write a program that expects some argument, at least one, and we'll expect that to be a file path. We take in the argument 0, we store it as the string file path, and then we create a new file object, and we pass it the file path, which, as you remember, was one of the constructor.
Right.
So if f.exists, and that returns a Boolean value, so if that's true, then we print to the screen that the file exists, otherwise we say the file doesn't exist. So pretty straightforward, but it shows how to construct a file and then how to evaluate that object to determine if the file exists in the object instance.
Now that is cool. So when we take a look here, we're checking for these arguments, and then we jump down here, and if the file exists, we jump out to our file system. Now, since this is handled in the Java virtual machine, it doesn't get down to that abstract level, like not the abstract level, but like the machine level. So the Java virtual machine will then run through our file system to determine whether the file exists or not. And then if it does, it's going to tell us file myclass.java exists. That's pretty cool.
Sweet.
It's pretty easy, too. So when we start talking about text versus binary in general, you can tell the difference between a class that works with text or works with binary by its name. So if a class ends with writer or it ends with reader, it most likely works with text files. That's
an excellent point.
If a class ends with stream, it most likely works with binary files, but there's one thing to kind of keep in mind, and that sometimes they try to kind of fuck with your head by having like something called an output stream writer, and you're like, whoa. So this is a stream, and it's it ends in the word writer. So it's...
Yeah, that overrides it.
That overrides the fact that the word stream is in there. So don't get tripped up. Just if it ends with reader, or writer, just assume this is text. Ends in stream, assume that it works on the binary or the byte level.
Yep, you'll kind of get the sense. So let's take a look at the inheritance structure of Java output for text all the way from an object to the file writer. So let's walk through this.
From life to human.
So at the root, we have an object class. So this is like a Java root superclass. All objects in Java come from this class. So that's kind of like an NS object. In Java, it's just an object. That's the base object class. So then extended from that is a writer class. So the writer class is an abstract class, which is specifically designed for writing to character streams. And most of the time, this serves as a base class for like all of the writer classes that you'll find. So for example, they'll extend the writer class to create something like output stream writer. And then like there's all the different types of stream writers and different types of writers that are all based on that same base writer class. So if we look at the output stream writer class, what this does is it converts the character streams to byte streams using an assumed character set. And it can write directly to files, and it can also be inherited. So we go so far from just a base object to an object that can kind of handle like the idea of like maneuvering information and data to a particular use case of it. And then we go from that and inherit that and extend it into the file writer class, for example. And there's like some other ones that extend that as well. So the file writer class is like a luxury class or like a convenience class. And it uses the output stream writer to write data, but this kind of gives you some like convenience methods to say like write a line of text to the file. And it just kind of does it for you,
Right, and when we look at this inheritance structure, just like any brilliantly designed inheritance structure, we go from bottom up as generic to specific. So we have a convenience class. I mean, we're so rich and wealthy that we just have convenience classes all over the place.
That's why it's 4th gen language.
Yeah. Then we backtrack to something that kind of is the intermediary between the binary stream and the human character set, like Unicode or ASCII, or Unicode 8-bit, Unicode 16, whatever. And then all the way back to like, what is an object? I mean, that's pretty awesome.
Yeah, it is.
So when we start taking a look at, here's an example of using a file writer, and we'll just kind of walk through this code. So if the arg's length is 0, we're just going to be like, all right, wrong number of arguments, whatever. In this example, we're going to point out a file, so we're going to make an instance of file, new file equals the file path that was sent in as the parameter. Then we're going to run through this try-catch block, creating an instance of the file writer, passing it the instance of the file. Now, what some folks will do in this type of situation is they'll actually encapsulate the new file path inside the new file writer instantiation, but to eliminate confusion, we didn't do it that way. So now we have a file writer instance that's actually locked into a file, and we can do the FW or we can do the .write method on that file writer instance and write, hey buddy, out to the file, and then just close the file and we're done.
Nice. That was awesome.
That was really awesome.
Yeah. So, like, interacting with files, your development time starts reducing drastically.
Yeah, big time.
And it reduces drastically, like, out of the gate. So with none of your own libraries that you've developed over the last 5 years, and you have, like, your nice little packages and stuff, and without getting, like, third-party libraries or, like, fishing for this open-source project that's got, like, weird, whatever. It's kind of, like, out of the gate, ready to go, that has all that stuff for you. It's kind of cool, and it can really save a lot of time. Reduce the lines of code, too. And the chances of bugs being in these objects are not as likely as the chances of bugs being in libraries that you make.
Right.
So let's reduce it. So this is very convenient. Reduce a lot of line of code. And here, let's take a look at how we can even, like, they provided us like a little hop skip to even reduce it further. So in the last example, we created a file object and we passed that file object to the file writer. Well, the file writer constructor has a string overload so that we can just pass it the file path directly. We don't have to create that file object.
Yeah.
So if you look at this, we create file path is equal to my file, and then we create a file writer and we pass it my file, the file path, and then we can just write to it and close it like you're done.
Hey, buddy!
That's 4 lines of code, and the string line you could just put the string directly in it and argue that it's 3 lines writing to a file.
Yeah, but that's because we're throwing main, Brian. If we didn't throw main,
that's true.
I would add like 57 more lines.
We really should have like 16 exceptions and a try-catch block around this. But
so now let's talk a little bit about output to binary files. Now we have that same base object at the top that all objects inherit from, but in this case, we have an output stream class, which is an abstract class that acts as a superclass for binary output streams. And I think we talk about this when we get into classes, and we've also dealt with this in protocols in Objective-C. But an abstract class is a class that's designed not to be instantiated. It just kind of serves as like the base class for inheriting classes. And now we have a file output stream class, which is a class that writes raw binary bytes to a file.
Nice.
So this motherfucker is out there on the 0 and 1, like he's all just like 0, 1, 1, 0, 1.
Now, remember, this doesn't have the word writer in it.
No, it does not. It says stream. It doesn't say stream writer. It says stream. So here's an example of writing Wibbit.net as a byte or a binary stream. So we're making another reference to myfile.txt. Now, Brian, we're going to create an instance of a file output stream, and we are going to then make a byte array. And our byte array is going to be 9 bytes long. And as you can see here, as we just kind of follow this code, from 0 to 8, we're just storing, typecasting the character WIBIT.NET, so Wibbit.net in bytes. Cool. And then we're going to write that out. So that's actually going to write out the text, but we're treating it as 8-bit chunks, as bytes.
Right, so what we're passing to that write method is actually a byte array.
Exactly, right. And here's another way that we can do basically the exact same thing.
But with a for loop instead.
Yeah, so here what we're doing is I'm making a string that says Wibbit.net, and what I'm doing is I'm just going to go for I equals 0, while I is not the end of string, so text to file dot length I plus plus. We're making an integer b that equals text to file, so we're using the dot char at method, which is, like if there was operator overloading here, it would be like bracket, kind of like we did in the string class in C++. Right. We're just yanking that out and writing one character at a time as a byte to the text file. Or to the file.
Yeah, it's wicked cool.
Yeah, that's really cool. I mean, that's really, really ridiculously awesome.
All right, so now let's take a look at the flip side where we talk about Java input. And now, because we're talking about reader, and our destination is file reader, this is the text world, not the binary world. So, similarly, we have a reader class. This is an abstract class that inherited from the object base, and this is just the base class to kind of like manage pulling the base data in. This is just an abstract class. So with that, we can use it to extend into things like the input stream reader. This class, what it does is it converts those byte streams from the reader object to character streams using a like an assumed character set. So it can read directly from files. So then we can use this and inherit it in things like our convenience classes, like our file reader class, which makes it way easier to read files. So this uses the input stream reader, and this just gets like just way easy stuff, like the file read line from the file until you've read all the lines, you know.
Huh, interesting. So this kind of acts almost like reading from the command line.
Yeah, exactly.
Interesting.
So here, let's look at this example. So let's create a file reader object, and we'll just create a new instance of a file reader, and we'll pass it like a file name, mainclass.java,
So
because we know that'll exist.
We're reading this code file.
Yep. So we'll start out with like int b for like a little buffer integer, since it's like a byte at a time. So we'll say file reader.read, and while that buffer is greater than or equal to 0, so long as it's not reading null, we will print the integer typecast to a character to system out, and then read the next one. Read the next one. Read the next one until we get a null, and then we'll close out the file reader. So this is just going to like traverse byte by byte, character by character through this exact code file and print it out to the console.
Right. And
It's really convenient.
In a more technical sense, this isn't byte for byte, this is character for character. Because like the different encoding sets may have different data in the byte stream, but the character sets will be interpreted differently, and then it will just show you the characters.
It's true.
So when we start looking at another class here, the buffered reader class, which is something that we've touched it a little bit. We've seen it walking around in the distance.
We've creepily grazed its thigh.
So you'll see stuff in here like read line, skip. We've already seen that kind of stuff before. Now, what is this, Brian? How is this different, and why is this really, really cool?
So let's say we create another file reader object. Well, this time we'll pass that into the constructor of a buffered reader object. Right? So now we have like this buffered reader on top of the file reader. So instead of like always checking to see like, do we have something? Do we read it all? Do we have something? Where are we? Where'd we go? Where do we go next? So now we have this buffered reader. So we create the string file line, and we say like while, and then file line is equal to read a line. So that read a line will return a string. It'll get stored as file line, and so long as that operation is not null, which is really interesting.
Yeah, it's cool.
That means that it's successfully performing this operation, and then we'll print it out and do it again.
Now wait a second, Brian. Didn't we use buffered reader when we were doing console input too?
Yeah.
Wait a second, so console and files can be treated the exact same way?
Yeah.
Oh, I feel like I'm an infomercial, you know, where the guy asks the other guy a completely staged question, you know?
And they both extend the reader and the writer, so they're children of the same grandparent.
Does it really cook chicken in 5 minutes? Why, yes, Tom, it certainly does. So now let's take a look at reading binary data. So we're creating an instance of a file, and we're pulling in this Java file. We're making a file input stream,
right, no reader.
Stream, and we're having a byte array equal. Well, we're making a new instance of a byte array. And check this out, Brian. The byte array equals the length of the file.
Weird.
So we're actually building out in memory enough space to store the entire file contents. Then we call the instance of the file input stream and call the .read method passing that byte array. So it's going to, by reference, right, because this is an array by reference, we're going to be filling up that byte array, and then I'm just going to write that out to the screen. So this is a way that we can take in a binary file, read every single byte in one shot.
And you know what will often come up from this program?
What's that?
Java lang out of memory.
Oh yeah! Oh my God! Oh yeah! You're right about that.
So hopefully that clarifies reading and writing from files and how insanely easy it is.
Yeah.
So once you get used to doing it to a console and then versus a file, you can kind of start now seeing like that hologram between the file and the console leaves you with those streams and those reader and writer objects, and that should give you the idea with which to attach it to like sockets or anything else you could possibly imagine.
Yep, cool. All right, guys, we'll see you in the next one. Welcome back to Programming in Java from Webbit.net. Kevin and Brian are here again to take you through a ridiculously awesome, super cool, f***ing awesome, ridiculously nicely cool, awesome. Sorry, had a little infinite loop in my head there. Lesson about methods in the Java programming language. Okay, I'm sorry, I got...
Nice.
I'm glad I got that out of my system.
So you won't find very many functions in Java.
Yes.
So if you remember in C++, we talked about like object-oriented design. Even though C++ isn't pure object-oriented programming language, we still talked about like the design of object-oriented concepts.
Yep, exactly.
So if you like kind of spent time thinking about this and reviewed the Intro to Object-Oriented course, like you'll be glad you did.
Oh yeah, definitely.
Because Java builds all of their methods the same way. It's no different.
Yeah, and that's the entire reason that Brian and I actually went through object-oriented design was specifically to prepare you for Java. So like that was the step, Java. That's where that all comes from. So if we kind of review the whole concept of classes
That's
methods.
one big-ass main class.
That is a big main class. So inside of my main class, I have a static method, which is my main method, and then I can also have other static methods for whatever configuration, for converting, whatever. Then I can have my instance level methods that I have to instantiate main class in order to actually access. And then I have my fields, which could be either static fields, public fields, private fields, or any combination thereof. And then we can also do crazy stuff like setting global field variables, Brian.
That's awesome. So they can be class or instance level. So you can say on a class level public static, and then set something to be static is like constant. So you can say public static int public class global is, you know, you can do it private, you can do it protected, and you can also do it where you can change them. You can say public int, private int, protected int, whatever, and you can access those wherever within the scope of that main class.
Right. So the whole concept of static is the same in Java as it is in C++. So it belongs to the class, and then the instance level don't. Now the cool thing about Java that C++ does not have, and that's top down. Because in Java, I can have my main method here and my fields down here, and even in main method is still aware of those fields from even though it's way up there, because Java is not a top-down language. It's not procedural like C++ is and C is.
Let me say something real quick, just in case we lost anybody, just by any possible chance, just to make sure that you that you know, if we say that it's static and that it's class level, that means anywhere else you can say like main class dot and then get to it.
Yep.
And if it's instance level, if it doesn't say static, then we go to the instance of that class, like instance X or instance
right,
Y.
Like we would have to instantiate main class to access those three fields below.
Right.
So when we start talking, Brian, about some like basic ways we can declare methods in Java, how do we do that?
So we can do instance level and a class level declaration. And the big difference, as you'll notice, between the two is class level has the word static after the access specifier. Mm-hmm. So the access specifier is kind of like if it's publicly accessible.
Yeah, public,
if it's
private,
privately
protected.
Accessible, if it's protected. The return type is like void or int, string, whatever. The name and then the parameters. So the main difference is between its access specifier level and the return type. On the class level, you just say that it's static.
And I'm going to be an asshole for a second. If you don't know the difference between public, private, and protected, go back to C++.
Yes, that's true.
We're not here to hold your hand anymore. You're a developer now. You're a grown developer. Act like one.
You're a grown-ass developer, fool.
So here's an example of making a static method that belongs to the main class. And what this static method does is, well, it's just called read all text. And it has that same naming convention that we've been using in pretty much every language except Objective-C, because that's kind of weird out name stuff. But we're reading, which is the action, all text is the description, and it throws IO exception. So inside of that method, we're going to just create an instance of file reader, which means what, Brian? If it's a reader...
It's binary.
No.
It's not binary.
You just... Oh, man, you suck, Brian.
I zoned out. There's like too many words on the screen and I totally spaced out. And I was like, wait, what's he talking about? I got a 50-50 shot at this. Oh, got it wrong.
Swing and a miss, strike three. So we're going to be reading as a text file, as Brian, being the idiot that he is, has no idea. And we're going to do that little concatenation manual buffered reader that thing that we showed before, where we're just going to read in one byte, and then as long as that value is not -1 or below 0, we can then concatenate to return string, close the file, and then return that back. So in the main method, we can just create a string called file data, and then just call read all text. Then it will just read the text, and we can print that out. On the right-hand side, you can see that this reads in the Java code file that is listed on the left. It's kind of cool.
Nice. So now let's take a look at doing the same thing, but on the instance level. So here you can see it's not static anymore. It's just public string read all text. And it functions kind of the same way. So you'll see we say we have file data is whatever, and we try to say file data is equal to main class instance. On the first line, we say main class instance equals new main class.
So we're making an instance of the class that we are inside of.
Right.
You gotta love that.
We just cloned ourselves.
Yeah,
that's illegal in the United States, by the way. You gotta go to France to do that.
You'll see that in Java a lot, especially when you're dealing with swing applications.
So then we refer to that main class instance, and then dot read all text. And then it can work that way.
Beautiful, Brian.
Yeah.
Gorgeous, baby. Now, we talked about the final specifier. I don't know, it was the access. I don't know how we defined it before. But before, we were talking about final in the context of variables, right?
Right.
So,
variables, parameters. What's
the difference, Brian, between a method that's just a plain, regular, ordinary, boring method and a method that is then defined as final?
Well, kind of how it sounds. It's kind of intuitive. Like, they are final.
Huh.
So, when it comes to, like, inheriting methods, in class inheritance, Java's kind of the opposite.
It's kind of the opposite of C++, that is.
Right. So, in Java, you can always override methods.
Yep.
Anytime. In C++, you'd have to, like, declare them as being virtual. Java, it's just like a given. They just assume that you're going to be, like, overriding all the time.
Yep.
So if you need to, like, put a lockdown on it and say, like, this was not designed to have anything else happen, like, we need this to only explicitly do what we defined in this method no matter who inherits this class, we can put a final on it and kind of, like, lock it down.
Yep.
So that nobody can override that method from that point on.
Absolutely.
So it's really easy to declare a method as final. All you have to do is just use the final keyword.
That's it. It's very simple. So here's an example. On that read all text instance level method that we looked at in the last example, all that we're doing in this one is we're calling it public final string as opposed to just public string. So now if some other class inherited from main class, it could not overwrite this method.
Pretty cool, huh?
Yes, and if you didn't do this, just like Brian said, you don't have to declare something as virtual in Java like you do in C++. It's fair games. Any method can be overwritten at any time. That's that's a really cool thing about Java, but it's also a very different thing that some developers coming from languages like C# and C++ takes them a little bit of getting used to. But when you really think about it, Brian, that's pretty damn cool.
Yeah, it is. It makes it very extensible.
Very much.
So the $1 million question.
Oh, man.
So what the hell is going on passing parameters? Like, what the crap? Is it reference? Is it value? I don't know. I can't tell.
And depending on who you ask, you're going to get an entirely different answer, and it seems like nobody's consistent about this. But Wibbit.net will define once and for all what we're talking about here.
Woohoo! So how does Java handle passing parameters to methods? Any object instance, all object instances are pointer references. Just all the time, it's an absolute given.
Yep.
Just like anything that's a descendant of an NS object is an instant, is like a pointer.
Yep.
All objects in Java are pointer references.
Every single time. Yep.
All primitive types, like the lowercase int instead of like the uppercase I integer, the lowercase int or the lowercase char, those primitive types are always passed by value. They never have a pointer reference.
The only time when this gets gray is when you're talking about arrays, but just like in C++, arrays are considered in Java they're considered objects, sort of. So like an array will pass by reference or by pointer reference just like an object does.
Right. Or at least like an array object, right?
Yeah. So some people try to debunk this statement. You'll see all over the place a lot of controversy, a lot of inconsistency, but Brian and I are going to prove exactly what Java does using C++ code. So here is an example of a Java code file where we're creating a public string, which is an instance level, and we're calling it string value. So since this is a public field, if we create an instance of main class, which we do on the next line here, we can do m.stringValue equals my string, and I can print that so the user can see my string. Now, I'm going to send this to a method that's a static method, so I'm just going to say I'm going to pass m, so we know, Brian, that m is going to be passed as a pointer reference, right?
Yep.
So when I do my MC instance equals a new main class, well, if this was passed as a reference and not a pointer reference, this would actually work. But since this is passed as a pointer reference, big difference. When I make this new instance, it's not going to function. So when I say now my instance dot string value equals new string, new my string, it doesn't work.
We now have that instance pointing to something else.
Exactly. So in C++, you could look at this code and you might think that this makes sense, but it does not actually work this way. It doesn't work this way at all. You are, you must be thinking about a reference. So here's why this doesn't work, Brian. In memory address 0, I set test string. And this is C++ code in case you're getting scared and confused, but you've already went through the Whippet.net programming in C++. So
naturally.
You're an expert at this. So we make a new instance of a string, print out that value to the user. Then I send this as a pointer reference to this other function, and this function creates a new instance. So when it comes in, it's pointing at this same memory space, but I make a new instance, and then I assign that to my str label. So str is actually pointing at a brandly new allocated memory space, and that's why when we come back to this main function, my string's value equals the same, and that little new test string is orphaned.
Exactly. So here's another example. So if objects are passed by a value, why does this work? So let's take a look. So we have a main class instance, and we say m.string value is equal to my string, and we print that out. So m.string value prints out as my string. It works perfectly fine. Then we say change string value, and we pass it m. Now this time we're not creating a new instance of the main class instance. We're just simply passing in main class MC instance and setting that string value to new my string. Now when that method finishes executing, we then go to system.println and we print that string value, and we can see that it changed. Because we're changing the value at that memory space.
Exactly. So we're
not redirecting some instance to a new memory space. So this is right.
Anybody that tells you that Java passes by value all the time, this is your proof that they're dead wrong.
Let's try to clear this up or confuse you more, whichever. So on the left is C++, on the right is Java. So you can see in the C++ example, when we call change string, the change string function, we pass it by pointer reference with the ampersand string. So if we pass it by pointer reference and then we create a new string, that's assigning the input string variable to a new memory space. So the original value stays the original value, never becomes the changed value. So in the Java side of it, when we call change string and we just pass it just plain old string, this is coming in as a pointer reference, and that's why the change value doesn't change.
Yeah, Yeah, these two code, this code here functions exactly the same.
Let's take a look at it if we just passed in C++ now. If we just pass it not by pointer reference, but if we just pass in the variable string, str, you can see that it changes the value.
Well, in this case, Brian, we're passing by reference because in the function,
the parameter,
yes, it's string ampersand, which means that instead of passing the memory space, we're literally passing the variable as a value.
Right. And so when you change that variable, it's affecting that memory space. It's not pointing some other instance to a new memory space. It's actually affecting that memory space.
So that's why it's incorrect technically to say that Java passes by reference, because this is passing by reference, but Java doesn't behave this way. That's why it must be specified that it passes by pointer reference, because that's how Java behaves.
That's how it rolls. So let's look at passing by value. So here we have two class-level global variables, a global x and a global y. And then we have a method that's just called swap. And what it does is it switches x and y. So it stores x into a temp variable, sets x to y, and then y to temp. So it just switches what's in x to what's in y, right? So
it seems.
So we print out global x and global y, and you can see that global x is 21, global y is 15, no big deal. Then we call swap global x and global y, and that swaps the values of x and y, but when we print it out, the values didn't change. It's interesting, huh?
Yeah, because the swap occurred within the scope of the swap method only.
Right, we didn't say global x equals global y, global y equals temp. We just said x equals y, y equals temp. So we're referring to the now value parameters inside of the scope of that method.
Yes, so this shows that they're passed by value. Now let's take a look at a situation where we can perform a swap, and this is by passing a class instance, because as we had already proven and already shown, the class instance is going to pass by pointer reference. So if I create, instead of having a class level, now we have an instance level, public int global x global y, and we create an instance of main class. We print that out to the user, then we pass the main class instance to the swap method, and what that will do is that will just swap them within the memory space that main class instance sits. So now when we print that out, you'll see that now x and y have been swapped.
Pretty cool.
Very cool.
So now let's look at passing by pointer reference and array swap. So here we have a swap array, and it's just a array of size 2 of type integer. And it's just filled with 1 and 2. And then swap array does kind of the same thing, but only in this case we're dealing with an integer array. And then we have index 1 and index 2. So what we're going to do here is we print out array value 0 and array at index 1, and then we swap them. So we pass in the array, and then 0 and 1. And what happens is, it's affecting the array. When the method is done executing, that array has been affected. So what that means is that the array, even though it's of a primitive type, was passed by reference. It's pretty crazy, huh?
It's very, very cool. So just to kind of conclude this whole Brian and Kevin are smart and everybody's stupid discussion, this will behave differently. Why? Well, because there's strings coming in and they are by pointer reference, but that's just a label. So within the scope of the swap method, S1 and S2 is just a label. So when I say string temp equals S1, and then I change the value of S1, it seems like I'm changing the value, but I'm literally taking what S1 is pointing at and pointing it at something else. So when I return back to the scope of the main method, that variable has not been affected. It was only affected within the scope of the swap method, and that's all that we're gonna, as Forrest Gump would say, that's all I gotta say about that. And, well, actually, that's not technically it. The same thing happens in C++, as demonstrated here with using pointer reference.
Hey!
Hey!
Alright, so now we'll talk about passing final parameters. So we talked about, we kind of talked about this before. We'll just kind of reiterate it on it just to make sure we drive it home. So we talked about how if we make a method a final method, if we use that final keyword, nobody else can change it if they inherit that. You can't override it. So final also can lock parameters. So it protects the value from being reset. So if my object was a final object, we can't set it to a new object, but it doesn't protect mutable objects from being manipulated. So you can change a value of a final variable, but you can't point it to a new memory space. You can only affect its given memory space. So here's an example where we say public static void swap. So this is a class level, and we're saying that index 1 and index 2 are final.
Wow, boy, that just sounds really and that's it! It's final!
Yeah. So where the problem is the problem is actually happening on the plus. So it's not that we're using it in an array, it's that we're trying to increment it and affect its value. Mm-hmm. So that's a niche.
Niche?
Like Bruno?
Yeah. So now let's talk about method overloading. So in Java, method overloading is pretty much exactly as we experienced in C++. So when we talk about method overloading, we have a main class here that has static and non-static entities, right?
What the hell is that? There's 3 write logs. That's impossible.
There's 3 methods with the exact same name, but they take different parameters.
That's crap.
So inside of the static main method, we're going to then just basically be calling a method called writeLog that takes in a single string, which basically represents the output to the log file that we want to write. Right? So that's here. Now what happens?
Okay, so this one just takes in a string. So here we have the writeLog method, the first one, and all this basically does is create a new date object, which comes from Java util date, and then we create a file object, which is a new file, and that is connected to a new main class instance where we call exec directory plus the logs. So execdir is that crazy long reflective getting the path of where we're executing from, plus logs as a directory.
Yeah, so even though this is a file object, this is actually a directory because, Brian, file and directory are going to be synonymous.
Right, so there is no directory. I mean, you don't. C# does, Java just has file. It's all basically a file.
I also wanted, the reason why Brian and I don't endorse this method by calling an instance just to retrieve a field from that instance, so we have a new instance of main class .execdir. We put that here because in Java, the garbage collection is so nice that people have gotten so lazy that they will write code that does this, and you'll see this kind of code an awful lot in Java.
Yeah.
So we just wanted to make sure that we exposed you to that.
It's true. So basically what we're going to say is if this directory doesn't exist, then we're going to do the mkdirs. And mkdirs will drill its way all the way down to this path in case it needs to create more than one directory along the way, but it shouldn't. We'll just do that to be safe. So then we create a formatter object, and then the formatter object is we're going to pass it a format just like printf, and that comes from Java util formatter. And this is going to just get the absolute path and get, establish a date. And the date's going to be using the date object, which does get year, and that does that plus 1900 thing, so it's in that style. And it's going to do a get month plus 1 because month is indexed at 0, and then get date, but it's just indexed at 1.
Right. So what we're doing here is we're getting the exact directory that this program is executing from. We're making sure that there's a directory called logs, and we're also making a log file that has a 4-digit year, a 2-digit month, and a 2-digit day.
Right. So now this calls the same method, but in this case, it's a method that takes a string and a string. So now this calls the same method, but in this case, it's a method that takes a string and a string.
Awesome. So in that overloaded method below, all that we're doing is we're creating a new instance of a file by passing in that log file path and the log message that we want to write out. So this just basically hands off control down to this method down here. And this method down here is going to actually be doing the work by making a file writer. It's going to actually write the log file out using the write method, close the file, and then it's going to return the number of characters that it wrote out. So all of these kind of condensed down.
So if you're in the main method and you don't want to call it just by passing it the message, if you want to have more control over it and specify the file you want to write to, you can create that file instance and you can make sure that file exists on your own. Name it whatever you want, format it however you want, and then just pass that file object into write-log because that's also public. So you can use any one of these options however you want. They're since they're overloaded.
It gives you as many options or as few options as you can possibly have.
Yep.
And the outcome of this program is if you look at this output up here, and we have a directory c:\wibbit.net/java/src/log example. And inside here, we have this code file, and it's just called mainclass.java. And there are some depreciated classes in here, which is the date class, because Java wants you to use the date calendar class nowadays.
Yeah,
but
whatever.
just forget about that. Forget about depreciated stuff for right now. So you'll see that in this directory, there is no folder called logs. But we do have the .class file, which is the bytecode file. So now, if we execute this program, it just writes starting and also writes starting out to the screen. But now, in that directory, there's a folder called logs. Now, it doesn't matter where we run this from. It will go to the executing directory and place a folder called logs. And inside there, we have a file that's formatted year-month-day.log. And inside of it contains that text starting.
Very cool.
Look at that!
Hey!
Hey! That's kind of neat, huh?
It's awesome. Let's talk about abstract methods. So a method that's declared with no implementation is an abstract method. So it's kind of like a stub. It's like a prototype, but not exactly. It's usually used as a design template for an inheriting class. So it's like a protocol, but not so forcefully, I guess. So used in abstract classes, we'll kind of get into those later. But an abstract method is just kind of generically saying you should probably maybe want to implement a method like this.
Right.
Later.
You want a method that's named this that takes these parameters.
Yep.
Basically, it's trying to tell you how you want to write your program.
And what the reason for that is if you have a bunch of different types of classes that are all inheriting from the same base class that have this abstract method, then you can kind of write your code banking on the fact that if an abstract animal class, gets inherited into a zebra and a horse and a cow, that they will have certain types of methods that you can rely on if they're all from the animal class.
Yep, it's guaranteed to be there. Exactly.
Right. So here's an example of abstract method. So here we have abstract class, and we did just declare the class abstract by just sticking abstract in front of it. Pretty straightforward. Abstract class file input. So the whole class is abstract. This whole class is not implemented.
Right.
And we'll get into that more when we talk about classes. But so to declare the method abstract, we just say it's publicly accessible. It's going to be publicly accessible. This is just abstract concept. It's abstract. It's going to return a string. That's the name of it. And that's the types of parameters, the name of the parameter values that we're going to pass.
Yeah, and we'll kind of expand on this when we get to classes, but we just, since technically abstract methods are methods, we figured we'd bring it up now as well. Now, in C and C++, we did in C, we did an example where we used VA args, for taking in a variable number of parameters. And you know how in C, Brian, and also in Objective-C, we could use the ...
Yep.
And that basically says, like, okay, any number of whatever the hell, give it to me. Well, here's an example where we can use that exact same concept in Java. So
that is awesome.
It is awesome. We have a static method here that just adds integers. Now, by saying int ... numbers, what I'm really kind of saying is this is an array, and it's an array of numbers that are coming in comma separated, which is really, really cool because you remember, Brian, in C, we had to specify the number, or we had to have a string that we had code that parsed out the number, and then we kind of worked from there.
Yeah, it's extremely annoying.
Yeah, here we can treat this as if it's a Java array. So up top we have int addition of numbers equals add integers 1, 2, till 10. When down here in the add integers method, the num args is numbers.length. So just like we're interacting with an array, the sum equals 0 for int I equals 0. While we're not at the end of the arguments, I plus sum plus equals. So sum equals sum plus the current value. Return sum. That's pretty awesome.
That's very cool.
Yeah, and what you'll see in a lot of Java code to kind of keep this abstract is instead of having an int type, there will be an object type. So it could be whatever type you want.
Just generically an object type.
Yep, exactly.
Okay, so here's a case where we take in, and this gets kind of cool. We're gonna make our own printf.
Awesome.
Yeah. So just like Kevin was saying a minute ago, we can take in like an object of whatever type we want. So let's say we do a format string as a string, and then some number of objects as args. We can then just carry those right along to system.out.printf and pass args, which is just like an object array.
Yep.
And printf will take that, evaluate it against format string, and off you go. It's really cool.
It's so beautifully implemented in Java.
Yeah, and also just as a side note, and we'll get into this more later, if you iterate through args, even though it's an object type, every object has a class, and every class has a class type. So we can evaluate every object to find out what object type it is.
Reflection.
Anyway.
Yeah, so that's kind of, I want to say in a nutshell, but we did kind of spend a lot of time on this because methods in Java and when we get later on to other languages, and the pure object-oriented concept, methods are very different than they are compared to languages like C++. So
and I'll say this, I mean, you made it through the methods, lesson. Methods are kind of like the meat and potatoes of Java.
Yeah. Mm-hmm.
So if you understand methods, you understand the classes. If you understand the classes, you understand the object-oriented nature. And once you got that, like, that's the linchpin. That's like, if you're lost with Java for any reason, that's the key to understanding the language.
Yeah, that and exception handling.
Yeah.
Sweet.
Yeah.
All right, that does it. We're out of here.
All right. Hey, buddies. Welcome back to the next lesson on classes. So we covered a lot of stuff so far. We covered, the console, the file IO, and we just talked about the methods. The classes are the last big piece in understanding Java. So once you get methods nailed and once you get classes nailed down, you're golden. The rest of it's kind of downhill. It's now just sort of like the interesting ways of using and putting all this stuff together and how Java sort of orchestrates all of this. So let's dig into it and let's get into classes and kind of look at the nuts and bolts of how that works.
Awesome, kiddies. Let's get your shovels together. So here we go. Now we're actually sliding down if this Wibbit.net course was kind of like a water park water slide, we were kind of moving. Now we hit the part where you go straight down into the pool. You know what I'm talking about, Brian?
Nice.
Like at the end of those water slides, there's always the finale where they just drop you in the water. That's where we are now. So it's no secret, right? In pure object-oriented programming, or POOP languages, C-P-O-O-P, pure object, whatever. We're going to be working with classes, and we're going to be working with classes an awful lot. As a matter of fact, every program no matter what it is, even if it just says, even if it actually doesn't do anything, you're actually working with classes.
Yes,
right?
Always. It's a given. Everything is.
So now that we've used classes, now let's actually learn about classes in Java.
Well, and that's also why I generally think that Java is not the best first language to learn.
Oh, absolutely not.
I'm sorry, like a lot of colleges teach Java as like your entry-level language. I swear that's a bad idea.
It's stupid. And well, I'm going to keep my mouth shut because I'm going to say something I don't mean. But I think that's also why you get a lot of people coming out of college that have absolutely no skills. Yeah, okay,
Yes.
you went through a 4-year comp sci degree. Now I need you to do some crazy stuff. I need you to pick up some software that was written 10 years ago and work with it. I don't know what a pointer is. What? What do you mean you don't know what a pointer is?
It's no joke. Like, yeah, it's no joke. I haven't seen well, I don't go too far on a tangent.
I was explaining to like a new developer recently about something about in this one language how it references this pointer in memory, and the guy, who's not a young guy, he's been a professional developer for a while, actually closed his eyes and shook his head when I said that, and he's like, "Whoa, what are you talking about?" I'm like, I'm just talking about
What?
I'm just talking about pointer references, and it's like that's like way above me. I was
No way.
I swear, and that's where teaching people at this level and starting them there. That's why you're actually creating stupid developers.
Yeah.
And Whippet.net will not allow you to be a stupid developer.
The truth of the matter is, employers don't value it depends where you come from, but generally speaking, an employer doesn't really. When you apply for a job in a development department at a company, you're going to be interviewed by like the senior developer.
Mm-hmm.
So you're probably going to be interviewed by like maybe the only guy who knows what he's talking about there, or maybe just one of the guys who knows or girls that knows what they're talking about there. But they, above all else, will have seen people come straight out of college, credentialed up on a college diploma, and not been able to do anything.
Right. Mm-hmm.
So showing self-initiative, showing projects that you've worked on, showing, even if it's like stupid stuff, it doesn't even matter. It doesn't have to be good, like a good idea that's like a big money-making idea. Just showing like, oh, hey, I made a program that did this. I made like a log viewer.
Yeah, right.
That can like constantly read in files and not keep locks on them, and like parses Apache logs for me in a nice way and put it out as an open source project. And like I did these defects for Firefox browser or whatever. Those go so much further. Like I can't tell you how many leaps and bounds more valuable that is than a college degree. So.
Yeah, that's how I got my first opportunity. Is because of stuff I did on my own.
Same here, and that's how I still get opportunities now.
Yeah, that's true.
So everything's a class, and there's some common naming conventions in Java for like how to name classes. And generally speaking, when you're naming a class, you want to use camel case starting with capital letters. Is that Pascal case? I don't know. I always get those confused.
Well, you know what, Brian? I think that's like the 10th time that you've said that. Hold on a second.
It's not something I ever remember.
All right, so camel case, according to Wikipedia.
Yeah, see how it starts with the lowercase c?
Yeah, well, hold on.
But it can also start at the upper. I don't know,
see,
weird.
look, it's and that's that. I don't understand. Like, I've had snooty guys get like, no, it's not a camel case. Well, go fucking read Wikipedia because yes,
it can be bold.
This article calls the two upper camel case and lower camel case. It can be either or. So anyone that tells you there's a difference is just being a smug.
Yeah,
that's just that. So,
yep.
There's another truth that Whippet.net just shoved down your throat, huh? So yeah, it is camel case. Sorry, Brian. Sorry.
No. I
know you're on your Mac right now thinking that you're all cool, but it's camel case.
No. I just had a flashback to somebody correcting me saying it was Pascal case, and I felt like, all right, asshole. And so that's why I was like, maybe it's, I don't know. Anyway, whatever.
You should email that guy the Wikipedia page.
Camel case. Anyway, so usually it's like the upper leading camel case style. So for example, like string, integer, boolean, and if you combine those, like if it's my string, it'll be like capital M, Y, capital S string. So there's also like you won't see it here because we try not to do it. That we desperately like push against this because it's. But in the Java world, you'll find acronyms everywhere. Like everybody is just acronym crazy, and it sucks. Read any book on Java, and half of the book is just like 3 or 4 uppercase letters. It's really stupid.
It's like working for the government.
So there's this acronym. So like people just keep on, like every framework has their whole different set of acronyms. Like it's just a mess. So everybody started going crazy with this. Like these are literally acronyms that you'll find being used. And this first block is actually like acronyms in conjunction with each other. That is like a JAINTM, TCAP, JSAR, ITU, PIMO, EG, RITC. Like, it's ridiculous. Like, this is just like there's tons of them, you know? So people started to, like, in this really lame trend, people started to, like, not really use normal Java classes very often that, like, come with the Java framework. So they kept getting all these, like, weird frameworks and then using all of these objects in these weird frameworks and, like, violating the Java standards. And it started, like, branching all over the place in these open source projects for these different weird input. It's just like just a mess. So it started getting all over the place. So some people wanted to try to convince people to go back to using the Java objects in just the framework that comes with Java. So they started calling it Pojo for plain old Java objects. So, and it actually, like, kind of worked for some reason. So a lot of times when you hear people talking about Pojo, they're talking about everything that we're talking about here. So, like, any kind of Java util dot something, you know, like date or format or buffered reader or whatever it is, those are just plain old Java objects. It's also known as Pojo. So you won't hear us calling them that after this slide, but because we're not tool bags. But everybody's acronym crazy. Help us fight against the acronym craze and just stop using acronyms.
Absolutely. This is similar to our fight back against the Apple developer community, where, like, if somebody has a question, just answer it. Don't be a dick. Same thing here. Exact same thing here. Let's talk about methods in relation to classes. So we have the same naming convention rules that we have in C++. So even though in Java it's common to use capital camel case when naming classes, you don't have to. You can use lowercase. You can start with an underscore. You just can't start with, like, numbers, and you can't have spaces. All that kind of stuff still applies. There is no need for a template like we have in C++ and Objective-C. There is no templating. You just start defining the class right then and there.
It's kind of nice. I actually kind of like it.
Oh, yeah, it's really nice. You can, but you probably shouldn't for readability purposes. You can ignore top-down declarations like we showed before because Java is not technically procedural, although it reads procedurally. Objects are not instantiated procedurally, so everything is kind of all over the place. As long as they can find a reference to it, it will find it. So top-down is dead. Some common naming conventions for methods in Java are similar to how we were preaching in C++ and how we were preaching in Objective-C, where we have camel case with the lower camel case. So, and also trying to use the action description. So open file, read text, get date, that kind of stuff is pretty much the naming convention that you'll see in Java.
So let's take a look at an example. Let's create, oftentimes we'll create this person class because it's just such a, an easy to understand object structure. It's easy to reference. So we're just going to have like a first name, a last name, and a birthday and a population. We say class person, and this is in person.java. Each Java file should kind of like be just for the class that's the file is named after. So person.java is just class person, right? So we wouldn't put multiple classes in here. The only thing that's going to be in this file is the person class.
Right. We'll discuss that in a second about the whole file thing with classes.
So we say class person, and then in there we just start implementing it. So we say like we have a protected string, which means it's instance level because we didn't say static, and we start it with an underscore for all of our like private internal or for the instance level stuff. So we have a first name and a last name, and we just start them off as just being blank empty strings. Then we have a protected date, birth date, which is just a new date. And then we have a public static int, which means that it's class level, not instance level. And we call that underscore population, and we set it to 0. So no matter which instance you're in, you can always access that class level population value.
Right.
Globally.
And since it's static, right, it's just going to be declared once. So every time an instance is created, it doesn't reset it to 0.
Right. So then we have a constructor, just our default constructor, which is just increments population. And then we have another constructor that takes in a last name and a first name, and that'll just set those protected fields and then increment the global population. Then we have class level methods, which is get population. It returns an int. And then we have instance level get first name and last name, get date of birth. Then we have setters for the first name and last name. So it's a pretty straightforward. I mean, you can kind of see so the method names start with like the get or set, and then what we're setting. So it's like the action definition, and then the class name starts with the capital P.
Very cool, Brian. So now
it's really intuitive.
It is. Now if we wanted to implement that person class inside of another class, now we have another class here called mainClass.java is the code file, and it's called main class, which we've been working out of main class this whole time. So we have inside of our main method, we create an instance of person by just calling the default constructor by saying new person, myPerson.set first name to Wibbit, set last name to .net, and then we're going to use the the print stream, we have the dot out, system dot out, the printf method. So that's going to be my person string was born at string. So my person get first name dot get last name dot get birth date dot to string because the dot get birth date is going to return the date instance, but on that date instance, we're going to then call the dot to string method.
I mean, it's really, you have to admit, like, it is very intuitive.
Very, very intuitive. Now, on that last line, we're going to get the current population, which should be 1. So in order to get that, we're going to call this static method of get population. So person dot get population. So
right, not my person dot population.
Yes, exactly. So to compile this class, we have our 2 code files here. We have the person.java and the main class.java. So then we could just send this as a list, so we can do Java C main class.java,
awesome.
person.java. So now when we look here, we have the .class file, right? So now we're all experts in how to do all this compilation stuff now. So Brian, when we run this, remember we don't run it with .class. We're gonna get my person Wibbit.net was born at, I guess maybe that should be born on, but who cares? So
whatever.
when we on that date instance, when we call .toString, this is the default format. So it's Thursday, April 28th at this time, Eastern Daylight Time this year, and the population is 1.
Awesome.
Now, if we were to try to do something, like instead of the Java main class, let's say we try to run the person class, Brian.
Uh-oh.
Oh. What does this mean, Brian?
There's no entry point.
Holy crap! It's just a porting class!
Because don't forget, main class doesn't have to be called main class.
Exactly, right,
You just need a public static main method.
Yep.
So what if we put multiple classes in a single code file? Like, will it freak out? So will it generate like a single class file that contains both the classes? Will it generate 2 separate class files? I don't know. Let's find out what happens.
Let's find out, Brian. So let's go through the Wibbit.net virtual 1950s NASA sending rockets to the moon console, okay? What was it? The Super Adventure Club.
Nice.
Okay, so we're going to delete the class files that we had before. Now let's list this. Now, what we've done, Brian, is we've combined in this code file on the right, you can see that we have a class main class and a class person class, and those are encased inside of a code file called myprogram.java.
Right, so we just jammed them all together.
Yep, and we made sure that there were no .class files, and to prove it, we did this dir. So if I do Java C, myprogram.java, it actually worked.
Whoa.
But what happens if I clear my screen and I do a dir star.class, I had 2 separate class files.
It was like, no, we're going to separate those out. How's that?
Yep, exactly. So now we can run that again, and now we have our person class instance, and of course, what Wibbit.net's command line simulation is it if we don't run exit to get out? Oh! Wibbit was sleeping back there the whole time!
Hey, wake up,
buddy. Jeez! Oh, man. Sorry, I didn't mean to...
Oh, that was embarrassing.
Yeah.
So let's take a look at a class inside of a class, or an inner class, or a nested class.
Yep.
So we have class my class, and inside of that, we have a class declaration, hey buddy. What the hell is that? Isn't that weird? And then inside of hey buddy, we have like just a default constructor that just prints out hey buddy.
Well, that's just a method, public void. So inside that class, there's a method called hey buddy.
Right. So it's strange, and that's an instance level. So that means within the scope of my class, we can instantiate hey buddy.
Let's see how this works, Brian.
So here we declare my class that has a method speak, and that just creates a new HeyBuddy object, and then it calls the HeyBuddy method. If you remember, that prints to the console. And then inside of that class also we have HeyBuddy, and then it prints to the console, just like we saw before. So now in the main class, and in our main method, we say my class, mClass, and we create a new instance, and then we say mClass.speak. And then that speak method then in turn instantiates the class. But that class instantiation has to happen inside of the scope of my class.
That is absolutely true.
And this can't be static. It doesn't work that way. Because static is something that's like, is kind of scopeless. You know what I mean?
Yeah.
So you can't like have a class level inside of an instance. And that's really the problem, is that you can't create an instance of my class and then access it. It's just a mess. So you can't do that.
So let's talk a little bit about class permissions, right? So in Java, classes can have access modifiers or access specifiers. What? That's crazy. So in Java, a class can be declared as public?
That's awesome.
What? So if a class is public, then it must be contained in a file that is named the same as the class. So you know how before we had the person class inside of a program. Before we had that one example where we had like a myprogram.java, and inside there we had a class called main class and a class called person class. Well, neither class was defined as public.
Right.
So there were no strict rules. If I have a class that's public, it must be in case. So in this case, if I have a public class called main class, it must be inside of a code file called mainclass.java. And a code file can have multiple classes, but only one can be public.
It's interesting.
Yeah, interesting. So here, inside of a code file called public-class.java, I have a class, two classes, one called non-public class, because it's not public, and inside there it says, what am I? And it just writes out, I am a non-public class.
Cool.
And then inside of main class, I make an instance and just say, what am I? And as you can see, this one code file encapsulates these two classes, neither of which are declared as public. So if now I have a public class, this code file, it actually will still be fine with these two classes in here because only one of them is defined as public. Now, the way that Java kind of gears you is it wants you to actually have two code files with two public classes. So like there's a main class.java and a public class.java. But this just kind of illustrates the fact that I can have a public class and a non-public class inside of the same code file.
So long as there are only one.
Yeah. Inheritance, Brian.
So here we have a class employee that extends the person class. So at this point now you're kind of familiar with the person class. So now we're going to do employee, which extends person. So that means it has everything that person has, and now we can kind of take it from there. So in addition to like first name, last name, and population, date of birth. Now we're adding to it some private fields like job title prefix. So this is the employee class. And this all is inside of the employee class now. So, which is an extension of person.
Right. Now, the thing to keep in mind is we call this word extends. So extends is basically the same thing, like, you know how in C++ in an Objective-C we would have like a colon, so we would say this colon this. Well, now we actually just say extends. So by saying extends, employee will then suck in everything that a person has, and then it will be its own entity.
And it's like a very natural way of declaring. I mean, just class employee extends person.
Yeah.
Like it's very natural.
Yep. And it looks great written down too.
Yep. So let's see how this works. So here's a main class with the main method, and we create a new employee, and we just pass it, and that new employee can take in a person object.
Oh yeah.
Which is cool. So we just pass it a person, and we set it to .NET Wibbit, which is last name, first name, and then with the employee object, we'll set the job title, set the salary, set the hire date, all that kind of fun stuff.
Wow, Wibbit makes a pretty good living, huh?
So then we call print employee. Now, print employee is a class level method on main class, and that takes in employee as a parameter. And what it does is it will print out this nice little display block, and it'll say employee and show the line. The name is this. And now when we call like e.getLastName, getLastName we never implemented when we implemented the employee class. GetLastName was implemented in the person class.
Yes, sir.
That we now have access to. But now something like e.getJobTitle was implemented in the employee class, and now we have that as well. So it's really cool.
Yeah, and we also kind of introduced you, check this out, Brian, where the salary is. If you look at the top, we have imported java.text.number format, that class.
Oh, yeah.
And the number format has a get currency method, and that's a static method, and that will allow us to then call a format method on it, and we could pass that salary, so it will print it out like as dollar whatever
That's
dot
awesome.
whatever.
Very cool.
Yeah.
So now let's talk about, so we talked about abstract methods, now let's talk about abstract classes. So just like the abstract method, it's not intended to be instantiated, nor is it intended to really be like implemented when you declare it. So an abstract class is really just like a blueprint or like a design of how you want its children to look,
Yep.
It's kind of like picking the genes of your kid, sort of,
Right, because we're all hoity-toity rich Java developers.
Yeah, exactly. What was that movie with the guy in the contact lens and he runs across the street or something?
I have no idea what you're talking about.
Gattaca? I don't know. Anyway, so this can be inherited. It's really designed to be inherited. That's why you create an abstract class, and it's often used as a base class for other classes.
Right. So it is like one, kind of like in the introduction to object-oriented programming, we had that hierarchy and we had, life and blah, blah, blah. And then it broke off into like, at one point, primates break off into humans, right? But primates also break off into monkeys and gorillas. Like, even though we're not a monkey and a monkey is not us, there's like an abstract definition of what makes that type of mammal. And even we share the common characteristics, but we're not the same thing at all. And that's kind of where the abstract class concept derives from.
And that also like sets a circumstance for polymorphism too.
Yeah, that's true.
Because once you have the similarity, once you have that constraint that guarantees the similarities between a couple different types of classes, then you can interchange them within certain scopes.
And if you believe in creation, then forget I said anything about humans and monkeys being similar.
It's more like the Mennonites and the and the Goths from Palestine being similar of a similar bloodline.
Whatever. You lost me there, buddy.
I try to relate it for the creationists. I don't know.
Even the creationists are like, "What? This guy is an idiot."
Oh, it's like Cain and Abel being from the same bloodline. There you go.
Okay, that works. Okay, Brian, what the f*** is this? Okay, Brian, what the f*** is this?
I don't know.
I don't know either.
So here we define an abstract class, file input. So we have like this protected file, and we have a public string, read all text, and we implement it. We have something that reads all the characters, and we read all the lines.
But the thing to keep in mind here is that this class is designed to be extended or inherited, because this is an abstract class. So you can instantiate this class. So it's designed for something else to use it. So now that I have that blueprint for a class, and I have all the methods defined, so now what we can do is we can extend that class since we can't actually instantiate it, and we can add our own little twist to it. So here I'm going to create a class called fileIn, and that's going to take in a string parameter, which we're going to be setting that underscore file field that actually belongs to the file input abstract class. Then we're going to have a boolean exists, which just returns file exists, and then returns the length. And then here's the payoff. I know that you guys are like, well, I thought like we're just like piggybacking on the file instance. Well, I've written here a little MD5 algorithm for you cool kids. So we're importing the java.security and the java.math.big integer. So the Java.security package and the big integer class, and we're creating a message digest. We're not going to get into encryption, but this is just kind of a fun little, hey, at least we have a payoff at the end of this one. And we're basically setting this to a MD5 instance. And then we're taking an input stream. An input stream is working on the text or binary level, Brian.
Well, stream doesn't have a reader or writer, so I'm going to say binary level.
Ding, ding. So we're getting that binary level, and what we're doing is we're calculating an MD5 hash, and then we're converting that into a hexadecimal string. And we have to use the big integer because those are very large integers.
Awesome.
So it's kind of cool, yeah.
Yeah, it's really cool.
So abstract methods, Brian. We kind of talked about it, but now let's officially get into this thing.
Right. So these, similarly to the class where you don't instantiate them, these aren't designed to be implemented. These are designed to be overridden. So they only define the template for the method, kind of like a prototype. So you would define like the return type, the parameters, if it's public, if it's private, whatever. Mm-hmm. And so then when the class is inherited, that inheriting class must implement that. It's required to define out and implement that method's functionality so that you have like known methods that you know that you can rely on that will be there.
Yes, sir. Yes, sir. What the hell?
So let's take a look. So now let's like abstract out this file input class. So here's where we have an abstract class and abstract methods. I mean, because once we declare a class abstract, you know that it can't be instantiated. Mm-hmm. So it's okay to define methods as being abstract in there as well. You cannot do an abstract method in a non-abstract class. So you have to kind of like keep it in a safe zone. Anyway, so we have a protected file, underscore file, and that's not abstract. That's actually there. And then we abstractly say that we want a public returns a string, read all text, read all characters, and read all lines. So now when we go to extend this, so like let's say main class, I mean, why not? Extends file input, and we just have this public static void main, this isn't going to fly.
Why not?
Because we didn't implement the abstract methods in file input.
That's kind of... I was hoping to catch Brian on that one. I was trying to confuse him, but he didn't buy into it. All right, so what do we have to do, Brian?
All right, so now we implement the abstract methods. So now we have public string read all text, public string read all. We're just going to return null just to kind of show that they're implemented. We can run this because technically we've implemented them all.
Absolutely, even though they didn't do anything, you're right. We extended the abstract class and we implemented the abstract methods.
All right, we kind of cheated.
Yeah. Well, now here's an example where we fill it in. So we're not cheating anymore.
Yeah.
In this example here, we're just and I know this might sound weird, but in Java you see, especially in swing applications, you'll see that the class that acts as the main class that contains the main method will often extend other classes. So that's, Brian and I want to expose this to you so you don't get scared and shocked later on. So our main class is extending that file input abstract class. And
I don't know. I don't like it. That would be like melting Swiss cheese on nachos. That would just be disgusting.
That wouldn't be that bad. I mean, how about, think of something more gross, like goat cheese. Would you put goat cheese on nachos?
Yeah, I kind of would. That would be good.
Well, you're sick. You're disgusting.
I like goat cheese.
All right. Well, now that we know that Brian's a freak, we're creating a constructor here that takes in a string to file path, makes a new instance. We instantiate that file, and if the file doesn't exist, we throw an exception, and we have the read all text, read all characters, which pulls from the read all text method. Then we have a read all lines, which just basically piggybacks on the read all lines and then does a replace all. So if it has Windows new line characters, which is /R/n, we replace that /n, and we call the split method on the string, and we split that on a /n to return the lines. It's pretty cool.
Very cool. Nice.
And then we just instantiate the main class instance below, and then we read all the text of the main class.
It's awesome.
Not bad.
So method overriding. So any Java method, unless it's final, of course, can be overridden. So final is a way to protect this. It's like a method condom. Condom. So we'll discuss the two main ways to override methods, and that's to inherit and re-implement, or to override the method when you instantiate an instance, which is getting freaky with the cheese whiz.
And you'll see both of these very frequently. So let's get this out of the way, Brian. Talk to me.
Okay, so here we have a file input class, and we're kind of done with the abstract stuff. So none of this is abstract. We just have protected file. We have read all text, read all characters, read all lines. Pretty cut and dry. We got this. Mm-hmm. So that's our file input class. And then down and to the right, main class extends file input. Mm-hmm. So here we say public string array, and then on the left we have public string array, and then on the right we have read all lines, and on the left in the file input class we have read all lines, throws IO exception, throws IO exception. So because this extends file input, and the name and the structure of this method declaration is exactly the same, this will override the superclass implementation.
Yep.
So this is just returning null. It's just going to return null, doesn't do anything, and then we execute the class. So that's in the most boiled down, condensed form we can show you. That's essentially the classic. This class extended that class, and we now replaced its implementation.
Absolutely, Brian. Now let's take a look at this. Now this is method overriding during instantiation. Now I remember, I think I clearly remember when I was in college was the first time I saw this, and I stared at the code for 45 minutes, maybe 3 days. I don't know. Time is a bit fuzzy.
Still, when I run into this, I still stare at it huh?
Yeah, because I remember thinking when I was a college student, what the is this code doing? I don't know. My mind wasn't as clear. But this is basically saying file input, make a new instance, and by putting these curly braces and then we end the bottom one with a semicolon, inside of this code block, I'm going to define methods. And I'm just so happening to define a method that currently exists. So now this instance of file input will have a different implementation of read all lines. Kind of interesting, huh?
Yeah, it is.
You see this an awful lot in Java. So pay special attention to this. so that you don't get tripped up like I did when I was in college when I first saw this.
It's kind of like a category, but not really at all.
But
It's actually like on the instantiation. It's really weird.
Right. And the thing that kind of sucks about this is it could make code kind of long. But the thing that doesn't suck about it is if you don't want to go through the hassle of extending a class to override a method, you could just instantiate the root class and then just override 1, 2, 20, whatever method you want to override.
I'm going to say it's sloppy.
I'm going to say it's sloppy to a point. I'm going to say that
I can understand that there's potential use cases that this would be very valuable.
I'll tell you where it gets useful, Brian, is when you're doing graphical applications and you're overriding like events and that kind of thing.
Oh, yeah.
This is in Swing. This is all over the place, and that's where it's useful because like I don't want to make a class that inherits from a button object just to override one
every
thing
single time for every
yes,
single.
Yes, exactly right.
Yeah.
Mm-hmm.
We already talked about operator overloading and how it's really like a great way to put your objects like just dead into the programming environment you're working in. I like operator overloading. I'm a huge fan of operator overloading.
Love it.
But unfortunately, this concept, even though it's supported in a lot of high-level programming languages, like other cool languages, Java is unfortunately not one of them.
Nope.
So there is no operator overloading in Java. Yeah. And that sucks. It really does suck because you get these stupid like dot equals and dot add and passes a parameter and blah blah blah. Like it kind of blows.
The only operator overloading that exists is stuff that was like baked into the language. You know,
right? Like the concat for the plus.
Right.
Kind of thing.
Yeah, because they would feel like idiots if you couldn't do plus equals. They would feel like idiots if you couldn't do this string plus this string.
I think it sucks. Some people say it simplifies the language. I mean, some people say it's because it's not a computer science focused language. I don't know. I think it's just it takes out some of the complication. I mean, it does. I don't know. Whatever. I like operator overloading, so screw you, Java.
Well, let's take a look at this, Brian. So let's pretend like we're of the class of people that believe that if it's not written in Java, it's not written properly. And let's look at it from their eyes. So why wouldn't Java support operator overloading? Some developers are very confused by the concept of operator overloading. Now, just because Brian and I like this concept doesn't mean that some folks out there don't struggle with it, you know?
It doesn't mean everybody has to use it.
Exactly. So maybe somebody got their first programming job out of college and they got some C++ code and they were like, all right, now this banana plus a shopping cart and wait a second, these actually how does that happen? How do you add these two together? So this is something that I have at least I have heard over the years. To see an expression like integer I equals 1, integer j equals 2, integer x equals I plus j. Well, you intuitively know that a number plus a number is going to result in a number. But you don't intuitively know without looking at source code what an expression like treat cc equals new cupcake, treat c equals new cookie, treat t equals cupcake instance plus cookie instance.
Right, like are you adding the sugar, are you adding the calories, are you adding the total grams?
Right.
Like
You actually have to see code to know what that means. And that's kind of where the Java folks are coming from.
Yeah, that's okay. I can understand that. So we can agree that in some cases developers will like totally abuse operator overloading. Moderation is a good thing, you know, in anything. And sometimes like you can see people like overload operators just for the sake of trying to like reduce lines of code in these really freaky ways. And sometimes you see that in C#. So Java has a few cases where there's built-in operator overloading like strings, but generally speaking if it's not like very intuitive, like like Kevin was saying a minute ago, it's not very intuitive what's being added. Like it's clearly strings concatenating, it's clearly integers adding, it's not really supported. Java developers prefer using methods. So instead of doing like cc or cupcake plus cookie, we're going to do cc.add and then pass c in as a parameter.
Yeah, now
or instead of overloading equal, it's going to be cc.equals c, you know?
You could also make the argument that the same argument that I don't know what cc.add means.
Yes, absolutely. That's true. Yeah, good point. Now, really what the method should be is cc.add sugar.
So let's talk about interfaces. So its most common form, an interface, is a blueprint for a class. So it contains empty method declarations, and they are used to kind of promote a promise of functionality by a class that implements the interface. Now, we have seen this in the concepts in Objective-C, and now we're going to talk about it in Java. So let's talk about a simple example of an interface, okay? Now, let's start thinking in terms of like, we have smartphones and cell phones. So when you use a cell phone, like let's just say you have like an iPhone or a BlackBerry or an Android phone, and there are buttons, right? And every cell phone has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all cell phones are going to have the same basic interface. So numbers, right? So all buttons work similarly on all phones, and it's reasonable for a person to expect that every phone that I pick up, whether it's a phone at my house, it's a cell phone, it's a BlackBerry, it's an Android, it's an iPhone, when I push the button 5, it's going to do the exact same thing. So thus, you can sort of say that all cell phones implement from the same interface, but they have their own way of managing the behavior of how that interface reacts with the code that implements that interface. So here is Brian's here's Brian's cell phone. And here is the guts behind the cell phone. Now let's if we take that cell phone and split it apart, we have
fancy.
A instance of a cell phone.
Where's my little like water damage indicator? Because all my phones have dropped in the toilet like 50 times.
That's somewhere where only the phone company can find it, so that you can't.
So my little indicators are always red.
Now here is the cell phone interface. Now the interface has nothing to do with the circuit board in the back. It's just the way that something interacts with that circuit board in the back, because that circuit board in the back is the unique cell phone functionality. And that would be something, a class, you can look at it that way, a class that implements that interface, which is the numbers in the front here. So Brian, how does this all, intersect and combine and love and hug one another?
Right. So here, let's declare our interface. So we have a public interface cell phone. Right?
Mm-hmm.
We're just going to say, with no implementation, nor is it abstract. We simply say public void is just an interface.
Mm-hmm.
So public void, press button, clear, hang up, answer call, send call. So those are like the types of things that we want to make sure that are implemented in our functionality side, our implementation.
We just want to say that every single cell phone can do this.
Right. So when we make our Wibbit phone, which implements the cell phone.
Wait, but hold on, Brian.
That's implementing.
This does not extend cell phone. This implements.
Exactly.
Right? So inheritance is extend. Extending a interface is implementing an interface.
Right. So when we implement this, we need to, we didn't type out the implementation of it, but because they're all void, they don't have to return anything, and these are effectively empty implementations. So we implement all of the methods that were declared in the interface, and then we can instantiate Wibbit phone.
If there was such thing as a Wibbit phone, obviously it's pretty lame because it doesn't really do anything.
Yeah. It's awesome.
But you could make it do something.
You could send a call and answer a call and hang up on somebody.
Yeah. But there's no implementation there. There's no code there.
Exactly.
Whatever. Then we instantiate the Wibbit phone, so you can see that the upper left code file represents the buttons. The middle code file on the right represents the circuit board in the back, and then the my class represents the world in which that particular device exists. Wow, that was a mouthful, Brian.
Yeah, that was no joke. So, but that's, this, I can't express it strongly enough. Methods, classes, linchpin of Java.
Yep.
So you made it through, you understand, you learned something, you had fun, you're getting there. You're just you're knocking Java out of the park now.
That's what I'm saying, baby. You were a rock star. You're a rock star, kid. All right, guys, welcome back. And in this one, we're going to do kind of a cool little lab. So we're going to kind of build ourselves a little application that a user can use to search a directory, and we'll have the option to search recursively or not recursively. And we'll kind of give the user a readout of the files that contain a string of text.
Right. So, and this is kind of building on some of the things that we learned in console.io, file.io courses. We're going to be dealing with methods and with classes. So we're going to kind of try to take all of those ideas and sort of put them together and put them to work,
Right. So this is going to require a couple of files, and we're just going to kind of put this in its directory because we're going to package this up later. So in our Java file, or our Java directory, where we've been putting our code, let's make a folder, and we'll call this, what do you want to call the program, Brian?
wsearch. How's that?
Okay, wsearch.
Or wgrep or whatever. I don't know.
Whatever.
Is fine.
It's already in stone now.
Okay, how about this? The Windows file search kind of sucks, right? So maybe after we write this thing, somebody can make this as a replacement for the Windows file search, since it kind of blows.
So we'll call it wsearch .java, and we'll also make a new file, and we'll call this main class.java, and that will implement this class. So let's make a public class wsearch.
Okay.
And inside of here, we'll do a public class main class. with our good old-fashioned public static void main argument. Okay.
Sweet.
And inside here, we'll make a wsearch instance equal to a new instance of wsearch, and we'll just kind of take it from there. We'll just see how this compiles. So cd wsearch, java c*.java will compile all the Java code files, and then we can do Java main class. There we go.
Very nice.
All right, Brian. So I guess what we probably want to do is inside of our main class, we probably want to just capture the parameters that we want our user to use, right? So we want the user to select a directory to search. We want the user to select the text to search for. So let's write that down. So dir to search, the text to search. And this is easy, Brian, because we can just make like a little method that will get a -d, a -s, and a -r or something, right?
Okay, that's fine.
So inside of here, we can do a public, because we did something similar to this in C, and it was so much more difficult because it was C. So we can say is switch valued string args and then string switch. Well, can't do that, can I?
Oh yeah.
Yep, that's a keyword.
That's right.
So this is easy. So for int I equals 0, while I is less than args.length.
Okay.
I plus plus. And this is going to be a simple one. So like, if args sub I dot equals str.
Don't forget, you can't equal those strings.
Return true. And then if it goes through the entire array and doesn't find it, return false.
Mm-hmm. Perfect. Look at that.
And then next we'll do the exact same thing, but it will be the get the value. So we can probably literally just copy this method, and then I can do, instead of is switch valued, get switch value.
Perfect.
So if it equals that, Brian.
And the length of the array is...
We're going, well, here's what we'll do. We'll do a throws.
Okay, there you go.
If it equals that, then, actually, yeah, if we just do a throws, it should be fine. So return args sub I plus 1. And if that fails, we're going to force the calling code to capture the exception. Now, we actually, if we go back to the exception lab that we did before, we captured this exception here, which I don't remember off the top of my head what it was, but this is going to throw an array index out of bounds exception.
Yeah.
So cool. when we call this, we have to make sure that this is fine. And if it gets down here, we could just return blank. How does that sound?
Wait, yeah, just make sure the return type is not Boolean.
Yes, good call.
So we want public static string this time.
Yep.
Cool.
Now, does this compile?
And then because it's string, we could actually return null if we wanted to, but blank is fine.
Yeah. All right, cool. So that did compile. Right. So now let's just test it out. So now let's just test it out.
Look at us go.
All right, so dir, so we'll do a string. Dir to search is going to equal get switch value of -d, like that, right, Brian?
Yep. Mm-hmm.
And then we want the text to search.
-t? No,
S?
Yeah, there you go.
Like for seek.
Cool.
And then...
You mean like we are seek?
Yeah. Boolean is recursive, right?
Yep, and that's boolean.parse. Oh, no, it returns a Boolean. Never mind.
Yeah. Now, actually, I kind of screwed up because I have to send args as my first parameter. So args d, args s, and then args -r for recursive.
There we go. Cool.
Does that compile? Okay.
Nice.
So now let's do a system.out
print
line, and we'll
just kind of test it out.
Yeah. Dir to search equals dir to search, and then text to search equals text to search, and then is recursive. And on the recursive, what we'll do is we'll do this .toString, and that should actually write true or write false.
Perfect. Now let's switch this up a little bit, and let's make. Do you want to like put a try block around this whole thing? So that we can catch it if it throws it?
You're right. Well, first, just to test it out, I see what you're saying, Brian, and we'll do that. Yes.
Okay. Because it'll complain.
Right.
Otherwise.
So we'll just be lazy for a second, just to make sure that those are functioning.
Okay. Oh, no, it has to be capital Boolean, capital letter B. Yeah.
Yeah. All right, so sorry about that. I guess there is no toString. That's only if you're right. If what Brian was saying is correct, and if we put that toString back and we made this a class Boolean instead of a primitive Boolean, then that should work. Right, and it does.
Cool.
Yeah, let's do C:\, I don't know, users, /wibbits.net, /desktop.
Okay.
And then that runs, okay, we have that. And then text to search for, W search.
Right, and we forgot the -s.
You are correct. -s. Okay, so now, like what Brian was saying, is we will go ahead and pull this out. Brian was saying that we set this to null, and we'll do a try dir to search equals that, right?
Yeah, we can make just one big try block. We don't have to
Okay,
we don't have to do it for each one.
gotcha.
And we can adjust the exception that well, that's fine.
We're getting there, Brian. This is happening, like it or not. Java is happening in front of your very eyes.
Yeah, I know.
So,
All right, so we'll set those to null, and because we're using Boolean with an uppercase B, that means it could be a null value, and that's something that a lot of people make mistakes with. Is they'll forget to check for a null value when Boolean is uppercase, and that can bite you in the ass.
Okay. So now, Brian.
Right, and so when we do that, we want to print out to the user that actually go down below. Will that allow us to oh, because we're just doing throws. Okay, never mind. It's fine. Okay, so we're just gonna print out to say that invalid argument. We'll just say invalid argument. It's fine.
Okay.
I don't want to spend too much time on the details.
If you wanted to be a little more specific, you could
you could
put each one of these in a try catch, and then you could specifically say which argument.
Right. Or you could, instead of having the method as a whole throw the exception, you can set a message on the exception before you throw it. So this get message that you're getting is just the default message for a index out of bounds exception, which you can customize that message if it wasn't on the method, but this just kind of it's fine. It just keeps it cleaner.
Okay. All right, so let's test this, and we're doing system.exit1, so we have a exit code of 1, which means bad. Java C, and let's run this. It's fine. Crap. Yeah, I want to do this, and then not that. Invalid argument 3. Okay, that's cool. So then if I do -D, invalid argument 1. Okay, that's fine. That's good.
Nice.
Yeah. Then the next thing that we want to do, Brian, is we also want to check our input. Then the next thing that we want to do, Brian, is we also want to check our input. So the first thing that we want to check is, does that directory exist? So if file, I believe it'll be a, new file, directory to search, .exists.
Yep.
So and this is just, since we don't have to worry about like garbage, memory management because it's Java, the JVM handles it, we can just create an instance for this one purpose. So if the file does not exist, system.err.println. So we can do a file directory, I'm sorry.
Oh, yeah.
Does not exist.
Cool.
And that's going to be dir to search, and we're going to exit with exit code 1, right?
Perfect.
So if we compile, oh, I'm sorry, we have to import java.io. Sorry about that. Import java.io.star. Excellent. So now we'll do, let's see, does this directory exist? It does. Now let's look for desktops with plural. Directory does not exist. C:\wibbit.net desktops. Okay, so now that we've done that, Brian, I guess the only check that I could think of that's left to do as far as checking our input is just making sure that the user did not send a blank text, because what's the point of searching for nothing?
That's true.
So else if text to search dot equals blank.
Yeah, that would just be a mess.
Yep. It would just be like doing a lot of work for absolutely no reason. Say, cannot search for nothing. I'm not going to be doing all this work for absolutely nothing, you stupid turd. All right? All right, so W search, we'll just do quote, Brian.
Cool.
Okay, and I got to fix this to desktop. Cannot search for nothing. Cannot search for space. Yes. Okay, great. Awesome.
Oh, should we trim it?
No, because you may actually be legitimately looking for a space.
Oh, yeah, that's true.
You know what I mean? All right?
Yep. Mm-hmm.
So perhaps in the constructor for W search, maybe it should take all three of these parameters. It should take the directory to search, the text to search for, and whether it's recursive or not. What do you think?
Yeah, makes sense.
So back in this class, meanwhile, back in the W search class, private string underscore dir to search. So we got dir to search.
And we got text to search.
Text to search.
And then Boolean.
Boolean is going to be is recursive.
Yep. Mm-hmm. Okay, so then, and then these all come in our constructor.
Right, and that's going to be what, Brian?
Public W search. That'll be string, dir to search, string, text to search, Boolean is recursive.
Okay.
Just, I guess, without the underscores. Yep, there you go.
Dir to search, text to search.
And so this just kind of comes in the constructor, and we're just going to kind of, set our private variables just so we have access to them.
Mm-hmm.
So no big deal.
Yeah, it's beautiful.
Yep. So then, you got it.
So that equals that.
Private directory search is the one that was passed in. Private text to search. Okay, so now we're all linked up. So now the question is, how do we want this to behave? If once we instantiate a W search, as an object, how do we want to interact with it? How do we want to interact with it? So we want to, do we want to get like an array of results back? Do we want to get like a results set back? Do we want to get, do we just want to have this search and print out? So maybe let's start there. Let's just say we should be able to say like this object should be able to say like dot search, and let's do dot search and we should be able to construct this without the search string.
Okay.
Right?
Yeah. Or what you can do is
we can do both.
We can just instantiate it, but you can also do like Brian just said, have a default constructor and then just have setters.
Yes.
Right, like this.
Yep.
That way you can create an instance and you can just dynamically change what it's doing.
Right. To make it like a little more, flexible.
Mm-hmm. Right. So it's a mutable or immutable, Brian?
Mutable.
Yeah, that's right.
We'll have the object, and we'll say like dot search, and just to kind of keep this program simple, so we're not going on here for 5 hours, and we don't want to waste your time. We just want to get the concepts across. We'll just have it. Oh, we got text to speech. There you go.
Keep talking. I can do this while you talk.
All right. So we want to be able to say like object instance dot search, and then that search method will just print to the system out like a nicely formatted result set. And so you could always take this on your own, and you could change it so the result set returns back like an array. And then you can kind of do things with those results before printing them to the console, or you could have like options to set options of how the display looks. So you can like extend these types of options in this class. So you can have like more or less detail in your search results. So for the sake of this, we're gonna have a search method, and that method's just gonna write to the output.
Okay.
Right to the console. So this will be public void search. And because we are setting all of the properties, we can have search be blank, or we can have we can overload search so that it takes in text to search as we call it, and all that will basically do is then call set text to search and then call search. So the first we want is just public void search.
So we have the search method, which is just basically going to be a void that just executes based on the parameters that have been put into the class. Right, Brian?
I was heating up my coffee. All right, sorry.
Sorry?
There we go.
Sorry?
Yep.
Okay, so inside of the main class, since we have all this data here, we can instantiate this with
all these parameters.
Right. So dir to search and text to search and is recursive.
Yep. And if we go back to the W search, okay, yeah, let's make sure that. Cool. All right, so let's go back to W search, and we'll just add one more method, and we can implement this right quick. Mm-hmm. It'll be public void search, and it'll take in string text to search as a parameter, just to kind of give you a sense of like different ways of how you can approach and flesh stuff out. So it'll be public void search, and it'll take string and strings up. Yeah, you got it. And then all that's going to do is going to call set text to search, or actually it's just going to set the text.
We can just do it this way.
Let's underscore txt to search then.
Oh yeah, you're right. That way this piggybacks on that.
Yep. And then, yeah, there you go. Although it might be good to like set this so we store it so we don't have like some lingering.
But the user didn't specifically ask to set the text. They're just doing a quick search.
Yep. Okay, there you go. Fair enough.
Yeah.
Perfect. Okay, so now we want to implement our search, and this is kind of like the last leg of it. So what we're going to do is we're going to search the file. We're going to search all the files in the directory, and if it's recursive, we're going to continue going through all the directories until we don't have any left to go. And then we're just going to print them out to the screen.
Now, hold on, Brian. Before we go that far, how do you plan to handle... Because I probably have my way of handling recursive differently than you, so let's get on the same page.
If it's a directory... Oh, yeah, I see what you mean.
So what we're going to...
We want another search method that takes in the directory. We want another search method that takes in the directory.
Well, I think that it's sufficient for us to just have a private method.
Yeah, a private search that takes a text to search in the directory.
Well, in that case, then it would be a public static. Well, maybe.
Oh, yeah.
Maybe.
No.
No, yeah. You could do a public static. That way you can just...
Or a private static.
Well, no, you can just do a public static. That way you could either work in the instance or you could work with it statically for quick reference.
That works.
And the directory, if it's recursive, then it will call it again. If it's recursive, there's going to be another loop that goes through the directories, and then for each directory, it calls it recursively. If it's not recursive, it will just end.
Right, and if it's not recursive, it won't call the method on any directories, and otherwise, if it's a file, it'll just search it and print it out.
Well, what you can do, Brian, is you could just have a for loop. So you can just have
I think we're on the same page.
A for loop where you get the files, and then an if statement. If it's recursive, then a for loop that gets directories, and for each directory, it calls itself. That's what you can do.
Oh, I thought. Okay, that's fine.
That'll work.
Yep.
All right. So what we'll do to expand the robustness and usability of this, and also kind of help us in general, is we'll also create a public static void search method, and this is going to take all parameters, right, Brian?
Yep.
So this will be a string. So you can instantiate this kind of like the integer class has you can get like a toString, or you can do integer.parse.
Right.
You know what I mean? Directory to search, and then string text to search, and Boolean search recursive. And this should be fairly simple. All right, now, Brian, we're going to be listing directories, which means we're going to have to import java.io.
Okay.
So import java.io.star.
Cool.
Now, you know that in the file class, we can create an instance of that, and then we can list that directory. So what we'll do is we'll do a and this may have to throws, so we'll see how that goes. So we can do a files array, and we'll do files equals a new instance of file, and this is going to take in the directory to scan.list.
Okay.
All right, so now, Brian, we can do a for int I equals 0 while I is less than files.length.
Yep.
I plus plus. So we'll make a file instance, current file equals files sub I. How does that look? And then we can do a system just to see what we got. A system.out dot print line current file dot get absolute path, right?
Yep. There we go. Let's try it out.
Okay, so now
let's test it out, but we should be able to yep, there you go.
So search, and then this is going to be the dir to search.
Yep.
So dir to search, text to search.
Not that one, but the parameter.
Oh yeah, in this case it is. You're right.
Uh-huh.
And oops. And
we haven't implemented that yet, but we do need to pass it.
Right. So let's just see what this gives us, Brian.
Okay.
So we've instantiated that. So what we should be able to do is search.
Search.
Let's not do that. Let's call it
Let's call it
or something. What do you want to call
it? My seeker.
That sounds creepy.
Yeah.
Hi, I'm your seeker.
I actually just call it creeper.
We will. Hold on. All right.
All right, now let's. Yep. So we're gonna run it for the desktop, and then we'll just perfect. Oh yeah, desktop's plural.
Hey. And it found a directory called Java and a file called desktop.ini.
Beautiful.
Not bad. So what Brian and I have to do at this point is we have to distinguish the difference between a directory and a file.
For each one of these, once we get the file, all we want to know is if it's a directory, then we want to then search that directory, right?
Well, here's how we want to do this. If it is a directory,
right, and that's just is directory or is file. That's how we check those.
So we can also sub this with so we don't have to have two if statements. If it is a directory
and search recursive.
If we do that, then we have to have another if it's not recursive, right? Because we don't want to.
We'll just continue.
That would require here, because if you did that, if it's that and that, then what do you do if it's not and that?
We don't search the directory.
If it's that and that, we have to list it and call it again.
We don't have to list it. We just call the method on that directory path.
Here now, hold on. Let's do it this way. Maybe I'm wrong, but here's what I see. So we have the directory to search is now going to be this
current file
dot absolute path.
Yep. Mm-hmm.
Which is going to be this line here.
Perfect.
right? And then text to search is the same.
Yep.
And then Boolean is that. So that's what you're saying we do?
Yep.
Okay, now what happens if it's a directory and we're not doing recursive?
Then we don't do anything with it.
And that requires another if statement.
No. It's just else. Else means it's a file, so we know to search the file.
That's not accurate, because the else statement will also be if it's a directory and we're not recursive. So you would have to have an else if it is a directory and not recursive. Because this is like, the way I was doing it was if it's a directory, everything falls in here.
Oh, balls.
See?
I understand.
So the way that we need to handle this...
Yeah, we do have to have two ifs then. Okay.
Well,
sorry.
we can just do it like this. Because this alone does not specify it's a file if this is not true.
Right.
It could be a file or it could be a directory, and we're not going to search recursive.
Right, or we could have a separate if that says ifs file, but...
So I think that if we did it this way, if it's that, and if it's recursive, else continue. So we're just kind of nesting here.
Yep.
So now, anything that falls here...
Right, so put like a little comment in there and just kind of say like, is a file. Like, let's search the file.
And you know, Brian, what's going to happen after these sub? Do we have to continue after this too?
Actually, just say continue.
Yeah, you're right.
Just take out the else.
Right, there you go.
Cool.
So now we'll print out the absolute path, and now let's try something a little more interesting. CLS, Java C, is directory...
Oh, we're probably just missing a right friend.
And we are.
Yep, cool. Thanks, Java compiler. I like the little arrow that points you to where the issue is. Like, it's kind of impressive.
All right, so now we do not see that directory showing up, but if I did a -R, we're going to see the
Hey, cool.
Yeah, now let's do something ridiculously crazy. No! Oh, what happened?
Null pointer. Why?
Why? Why exactly? There may have been some permissions.
Oh, you have
error.
an access rights issue. Yeah, it's a permissions issue.
Yeah. So that needs to be accounted for. Look at this recursive directory search, Brian. We're just like rolling through program files. Whoa! 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 Okay. All right. That's cool.
All right. You can kill that.
All right. So let's kind of investigate this. So this is just saying that there's a it looks like we have a permissions issue.
Right. So let's go into our for loop in our search.
Well, actually, that's gonna be here.
Yep.
Mm-hmm. Yeah. So this is gonna have to be
Yeah, and we'll try to assign files equal to new.
Or we can just throws that exception on this method.
Well, I wouldn't even worry about throwing it. I would just print to the screen invalid permissions and return. You know what I mean?
Yeah, assuming that's the case, but we can just print the exception and return it. So like, so files equals, and let's just say, for instance, Brian, we don't know the exception, or we don't want to type out that entire exception.
Right. We'll just exception.
Yep. We'll just do a generic exception.
It's like the grandfather of all exceptions. I know, switching language gets a little weird sometimes.
Yeah. And then I can do a system.exit.
No, just a return. Just a return. We want to keep searching.
Well, if we return, then this is probably done, right?
That's okay.
All right.
Because if it's like some directory within some directories, we don't want it to kill the program.
Okay.
We'll just stop that branch. Sweet.
And that's one thing that sucks about Java too, is because the Java interpreter doesn't have the correct permissions. That's kind of annoying.
Yeah, it is. But
yeah, so there's the exception that printed out, but it has an exception. It can search the desktop, which is interesting.
Wait, so why didn't it continue though to? Oh, that entire directory didn't have permissions.
Mm-hmm.
Interesting.
But it can search on the desktop.
Yeah.
Whatever.
So Windows 7 has some weird permissions issues, but now if we ran this console as administrator,
yeah, that's what I was just about to do.
Let's see what that does, just out of curiosity.
Mm-hmm. Run it as administrator. I wonder if that happens on the JVM or the command terminal. That's interesting. Let's find out.
Well,
CD.
but this is going to run the JVM.
Yeah.
As administrator as well.
I don't know if that's how it works. I guess we'll find out. So CD.
Yeah.
Java.
wsearch.
Error. Could not create the virtual machine.
Oh, you forgot to pass it the main class.
Oh.
There we go.
Like that?
Yep.
Still failed.
Yeah, I guess the Java virtual machine runs separately.
Because the JVM should be running right now, right? So
whatever.
Anyways.
Okay, just clear the screen. We'll just stick with the desktop.
All right. So if it fails, we'll just print the error. All right.
Cool. All right. So now we get to the point where we know it's a file. It's a known file.
Mm-hmm.
And we want to want to like open a connection to the file, search the file, print out if it has a match, and that's it. Not too bad.
one way that we can handle this is by, assuming we're working with text, we can create that buffered reader.
Yeah.
And we can,
absolutely.
you want to try we can try catch it in here. So we'll just do buffered reader, BR equals null.
Perfect.
And then we can do, I think that's really all that we need. So then try.
Yeah, we'll try to set the buffered reader to a new buffer reader.
Equals a new instance of buffered reader.
We're just going to take a new instance of a file reader.
File reader, and that's going to take in current file.
Perfect.
This is an IO exception, and we'll just do the same thing as we did here, except for we won't return.
Well, no. We'll just continue to the next file.
Mm-hmm.
So we don't want to return. We just yeah. There you go. Perfect.
Do I have written across my head?
Generally, yeah.
All right. So, if we're unable to establish a connection to the file, we'll just say whoopsie daisy, and then we could also do a while loop. So we'll just kind of skim through the lines of the file. Is that cool?
Perfect.
So while we'll just do a
while we can read a line.
Yeah. File line.
Oh yeah. There you go.
So while file line
is that a semicolon or is my screen just kind of weird?
Nope. Good catch.
Sweet.
So file line equals buffered reader dot read line. So while that does not equal null, oh thank God we're not dealing with that anymore.
Yeah, I know, right?
Ugh.
No more nil.
All right. So while that condition.
Okay.
Right.
Cool.
Then we can do that that contains, right?
Yep.
So if
the file line contains our text to search.
Now, do you want to normalize this with case? Or?
Nope. We'll just leave it case sensitive. Yep. There you go.
I don't like case sensitive searches. I hate them.
Really?
Yeah.
Okay. Well, then just compare both to lower real quick.
So if the text is found, now Brian, you wanted to have some output here, right?
Yeah, so we'll just print out like actually let's add a counter.
Okay.
And we can just say that there was like a match found on line whatever, you know what I mean?
Okay. Okay. Read line unreported exception IO exception.
Yeah, that's fine. We gotta try the while loop. Actually, we could probably... Does that throw an IO exception? Because we could just throw it in the same try block. Perfectly fine.
I can't wait to get to C#. This kind of stuff bothers me. It's annoying.
Yeah, it's yeah, I know.
What did I do? Oh, okay. I don't mind exception handling, but I don't like forced exception handling.
Yeah.
It's like that Seinfeld episode where Jerry's girlfriend would not submit to forcible massage.
What?
You don't understand, Brian. You don't get it.
What's forcible massage?
Jerry Seinfeld was in that episode, anyways. He was dating a masseuse.
Yeah.
And all of his friends had seen her, and they said that she was the best masseuse ever. And she had never given him a massage, and he was jealous about it because she didn't want to bring her work home with her. You know. So Jerry would like try to figure out a situation to like have her bring her like oils and her table over. And there's this one episode where he like laid on the table and he like put her hands on his shoulder and was trying to force her to massage him. You know. Anyways, Seinfeld's hysterical. That's a great show.
I haven't seen many episodes of the show. I've seen like 2 episodes.
Yeah, you gotta. All right, so now we have that. Let's see if at first we can just get that to work. So Java main class -d C:\\wibbit users /wibbit.net /desktop /sw search.
Okay.
And then -r. Okay,
Sweet.
so it found it in all those files, which are these these files that we're working with.
Cool.
All right, so Brian wants to have a line counter, which we can do. Brian wants to have a line counter, which we can do. So line count equals 1, right? Something like that?
Yep, perfect.
All right, so
we'll just say like line or colon and then the file name.
Okay, so we can do something cool like this. Oh, did I cut that? Copy that. All right, so Brian, you want line number, colon, and then what? The file name?
The file name, maybe, and then a dash, and then the line from the file.
Isn't that what this D is?
No, the actual text from the file.
Oh, you want to print that line?
Yep.
Okay, so if we're going to do that, we should probably do the line number, colon, the name of the file, then a new line, and then the line.
Okay.
And then like 2 lines after
and then, yeah, there you go.
So we'll do line counts. We'll do, and we may want to just, to protect the eyes of our viewers.
Yep.
Line counts. The second one's going to be a string, and that string's going to be the file name, so that's going to be current file dot absolute path.
Yep. Mm-hmm. Is it absolute?
No, it's get absolute. You're right. Okay. Whoops.
And then the last one is going to be file line.
Yep.
Sweet.
See what that does. Oh, and look at you see this in the bytecode files.
Yeah,
so
funny.
you see some like unprintable characters in it.
Actually, let's say if the line is greater than
80?
60 characters, we just won't print it.
Or if it's and I have an idea. You could just do a string printed line. I got a good one. So check it out. So if this dot length and I think it's
like 60
Is that a method or is that a
I think it's a method.
Okay, string dot length. If that is greater than so it should be 80 characters wide. So let's make it like 75.
Okay.
Then this will equal this dot substring or substr 0 to
No, substring.
Is it substring?
Yep. All lowercase.
Plus dot dot dot.
Yep. There you go. Cool.
Else printed line equals file line. And then instead of file line...
And I don't even know if we need that if condition or not. I think it'll just, if it's shorter than 75, it'll just take it to the end.
Actually. Say what?
I don't even know if we need that if condition.
Why?
Because I think if it's less than 75, it'll just take it to the end of the line.
No, it'll crash. If it's less than, if it's like one character and we say take 75, that should crash.
Freaks out. Okay.
That should be indexed outside the bounds of the array.
Sweet.
So just to kind of eliminate that line of code down here, I just set the printed line to the full.
And what's that system out print line message on the bottom?
That's this.
Oh, sorry.
Yeah, because we did a string format.
Yep. And maybe let's take out one of those new lines. Because that was kind of...
Let's see what it looks like first.
Okay.
Okay, so look at this. Look.
Nice.
That's cool, huh?
That's awesome. Very cool.
And the gives...
Oh, and we could do like padding, like a 3-character padding on the line number. So it's like 002. So it's not like something. That doesn't really matter. Ignore me. That's beautiful.
Okay.
Look at it go.
All right. And you said you wanted to do one last thing, and that was remove one of these lines?
Yep. And maybe let's trim the printed line.
So like this?
Yeah.
Yeah.
That trims both sides, right?
Mm-hmm.
I think we want to do it if we substring it too. Oh, never mind. I'm just being stupid.
No, you're right. You're right. Because watch this. We can do that, and we can do that.
Yeah, there you go. Perfect.
So instead of comparing that, we'll just set that to the trimmed version, and we'll just compare the trimmed version.
Beautiful.
Yeah.
I hope this is entertaining you out there.
I hope so too. This is cool. I like this.
Because see this gives you a chance to like just kind of think like, whatever.
Think like a developer. So here is kind of our little output here. We executed the program. So on line 22 of this file, here is a string that contains that text. Now it looks like that text is off on that line because I don't see that in this line here. This line here, look,
I'm sure so.
There is the W search here and here.
That's awesome.
This one is W search here. This one has W search here. This one has the public class W search.
All right, so for your homework, I want you guys to go like put some other options in here and have like a file pattern. So like only search star.java files or something. And you can do that. You can kind of like make this output look a little better, change it around, take the result set back to the main driver program and all that kind of stuff.
Yes, absolutely. Absolutely. And also test it on some deep directories. Like if you wanted to do C:\Windows and we want to search for
W search
or I don't know, Windows.
Nice.
That was actually really fast. Look at that, like Windows settings. That's pretty cool.
Yeah,
that's really cool.
Bad.
Yeah, like if you wanted to do some like crazy searching, you could like pipe that to a file, and I don't know. That's
and what's really funny is it's actually searching stuff like write.exe.
Yeah, right. Yeah.
Isn't that weird that the executables have plain text in them?
Yeah, because some of them have like XML formatting, and some of them have like paths that are hard coded in there. Yeah,
it's funny
because I don't think that's like a real exe. That's like a .NET exe. I think.
So in this lab, we've kind of, by the nature of what we did, we used data types. We used exception handling. We used console input and output. We used file input and output. We used methods. We used methods that were on the instance level. We made the static methods. We made a class. We had a separate class file. We kind of it didn't take too long, all considering, and we really ran the gamut. So hopefully this will kind of give you a good sense of like how everything comes together. You can kind of take it from here and implement the type of thing that you're looking to do.
Absolutely. So Brian, if you don't mind, let's do a quick last one over, and then we'll call it a day, huh?
Okay.
So main class, talk to me.
So we had our directory to search, text to search, and is recursive. And all this is going to do is the main method is really like checking your parameters and making sure your circumstance is good so that we can actually call the searcher. So we check the parameters, and if the parameters are wrong, we're going to throw exceptions.
Right, and we check the parameters down here. Or we pull the values down here. Right,
we pull the values out of those with some static methods. And then, so if we're fine, then we try to create a new file object for the directory to search. So if it exists, then we search, and if it does not exist, we say that the directory doesn't exist, right? And the text to search can't equal nothing. So then we created a new mySecret object, which is of type wsearch, and we pass in the constructor a directory to search, text to search, and is recursive. The 3 values we got from the parameters passed in the command line, and then we just call search, the search method on our object. Now, if we go over to our class definition for wsearch, we have similar kind of fields. We have a default constructor that doesn't do anything. We have a constructor that takes in all of the parameters and just assigns the private values. And then we have a method that sets the directory sets, just to kind of show you that we can make like setters, and you could make getters and whatever you want on there. And then we have the search method, which calls the search with the parameter text to search, and that uses the stored set text to search. So then this will call a public static method.
Well, first it calls
also
this
named. Yeah, that's what I said. This just passes the internal private text to this, which then calls the static method search and passes all of the parameters. Now that's the directory to search, the text to search, and whether or not it's recursive. So this is kind of the meat and potatoes. So we want an array of files, and we start them saying they're null, and we try to get a list of the files from the directory to search that we passed in as a parameter. And if we can't, then we print out the exception and we return. Otherwise, we go into a for loop for the number of files in our array. And so for each file that we have, we set that file I, to a current file. We check to see if it's a directory. If it's a directory, then we want to search it if we have the recursive flag on. So we just call the same method, and we just call it recursively, and we pass the parameters in. But this time, we're passing the absolute path to the current file, because we know it's a directory. And then we just continue on. So if that didn't happen, we continue, and we create a buffered reader.
Right, so in that circumstance, we know for a fact we're dealing with a file and not a directory.
Exactly. So we create a buffered reader from the current file that we have, and then we go through each line of the file. And so long as the next line, we can read a line and it's not null, we're just kind of traversing through the file. We're iterating through every line of the file, and then we do a comparison to take the file line from the file. If its lowercase form contains the lowercase version of the text we're searching, then we want to just kind of print out like the line number we're on, the absolute path name to the file, and then the line that contains the text we're searching for. And then we increment the line counter and continue. Now, if we have any type of like file reading, writing exception, we're just going to print it out and continue on to the next file.
Yep.
So it's a pretty straightforward way of kind of like making our own grep, so to speak.
Yeah.
So obviously, like any program, you can always like enhance it and make other cool things with it, but this should get you going. Hey everybody, now we're going to talk about Jarchives.
Oh boy.
What the hell is a Jarchive?
I have no idea what the Jarchive is.
Now you've probably seen like a .jar file, and you're like, what the hell is that? It's like a jar of shit. Like, what the hell's going on? I don't know.
It's a jar of flies from Wibbit the Frog's poop. Okay, that's what it is.
Don't even know. So it's a Java archive file.
Okay, cool. I can get that.
All right, so let's talk. So this, you're gonna see this. Let's talk about it.
Let's talk about Jarchives, baby. Let's talk about you and me. So, Jarchive is kind of what I'm sure other people call it that, but that's kind of like Brian and I call them Jarchives. A Jarchive is a Java archive file, and it's a file that basically just has a jar extension.
Again, we don't like acronyms.
Yeah, right, yeah. So it's basically a collection of files that make up a Java program. So an entire program's contents can be compressed into a jar file for a simple and easy distribution.
That's awesome, because otherwise you got like a whole directory of files all over the damn place.
Right, yeah. So it's kind of like how Microsoft has exe or like a
tab file.
Tab or MSI.
Yeah.
It kind of like relates to that. Now, we're not going to go over, this isn't a course on how to use jar, okay? We're going to give you the basic benefits, overview of it, but technically you don't have to compress it. Now, that will speed up the execution of your program, but I'll tell you, Java is so slow anyways. I don't really know if you're going to have a difference between a compressed Jarchive and an uncompressed Jarchive. The method that we're going to show you compresses it. So you can have like 1,000 code files that are 500 kilobytes, and your Jarchive is going to be 10 kilobytes because they're all compressed. And your images, if you have a graphical application that has like pictures and stuff, they'll all be encased in. It's really cool. You can either extract a Jarchive and run
like
the
a zip
program,
file.
right? Or you can actually run the Jarchive as a compressed file. So it's
Totally convenient.
It's pretty cool. So Brian, let's go one at a time. Some files that we're going to have in our program, and we're going to Jarchive.
So we got a person class, which is, pretty much what we've seen a few times over. And then we got the employee class, which extends the person class, and that has all of our employee type implementation. Then we have our main class, which uses the employee class. It just creates a new employee and prints it out. And then we have this thing that's called manifest.txt. And this manifest text file declares where our entry point is, where that main method is going to be, because the person class could have a public static main method.
Right,
It
exactly.
could. So how do we know where the entry point is if we got this whole ball mess of files?
Yes.
So this is declaring that the main class is in main class.
Right, so let's just say we execute the jar file. Well, it doesn't want to have to scan all the damn files to find an entry point. You tell it where you want the entry point to be.
Yeah.
So we just simply make a text file, and in the text file, we just say main-class, main class, which is the name of the class. That is where our entry point resides. How do we build the jar archive?
Jarchive.
These are the files that Brian just showed us, right? We have the employee, the main class, the manifest.txt, and the person.java. We're just going to compile them by using the javac star.java. So anything that's a Java file, we'll just make bytecode. And now we're going to execute this line, and we're going to go over it one piece at a time so that you know exactly what we're doing, starting with this jar command here.
That's awesome. If we call the command jar, so that executes the jar command. This is the command that we use to work with the Jarchive files. So you'll see that the parameter that we're going to pass in here is going to be parameters C, M, and F. C creates our output jar file for create. M is for the manifest. It's add data to the manifest file, like data about how this all kind of came together. And then F to specify the output file name. So the M is going to be the manifest parameter, and that gets passed next, which is manifest.txt. So we could call that something else, but that's pretty standard. And then F specifies the output file name, which is going to be the name of the jar file. And then star.class is all of the class files that have been compiled that are going to get put into the Java archive
Right,
file.
so we're only putting our class files in here. So some folks will put their source files and their bytecode files, and some folks won't. Some folks will have directories that have images, or directories that have sounds or video. In this case, we're just simply taking only the bytecode files and encapsulating them inside of an archive. So after we run this command, we can then do a dir, and what do we see? What is that file down there, Brian?
Hey, look at that. Personprogram.jar.
What the
We made a Jarchive.
Oh my god, we're so great, awesome Java developers.
So how can we take a look at that Jarchive file?
I don't know, let's do it.
Ooh. So F being the file, that's the Jarchive, the jar file. And T will kind of give you a list of all the contents of it. So this shows that it made a meta-inf directory, and that inside the meta-inf directory it put the manifest file, and then in the root path inside of this extracted this zipped file, it has the class files. So now let's look at the other options for the jar command. Now if we do a verbose view of it, it will give us a detailed directory list, so to speak. It's like a detailed dir of the contents of this. Now you can also take a jar file, and you can take something like 7-zip, and you can just extract it into a folder, just like a zip file. But in any event, this will give you some more information about the timestamps of the files and stuff. So how do we execute a Java archive file?
I don't know, Brian, tell me.
Well, you just Java, and then throw a switch to say that we're dealing with the jar file, and then you just tell it the jar file that we're dealing with. So Java-jar personprogram.jar.
Yep, and it will
Isn't that awesome?
It will go into that jar file. It will look in the manifest file and say, "Where's your main method?" Oh, it's in this class. Cool. I'm gonna swim into that class. I'm gonna run the main method, and then poof, you have a fully beautifully distributed Java application.
Very cool.
Very, very cool. So let's talk a little bit more in depth about this manifest file, Brian. What are some other things that can be put inside the manifest file?
So we can do like a version, which is kind of awesome. And we can do like created by, we can do electronic signatures, obviously the entry classes we talked before. So it's pretty cool. And then by default, if you don't specify one, it will take the metadata that it when you kind of throw everything together into a Java archive file, it will take the values that it needs in it, and it will default create a manifest.mf file in the metadata directory.
Yep.
So if you don't specify.
And that created by, I think, is the Java version. So like it'll know just by reading the manifest
like the JDK 1.6.0, right?
Right. Yeah. So that's it, man. That's Jarchives in a nutshell.
Yeah, so you got it. It's not a weird concept at all once you kind of walk through it.
Yep. And we'll probably be taking advantages later on in labs and all that kind of fun stuff.
And I'm going to say why we're awesome here for a second. When you look through Java documentation, like they never take a step back and kind of explain why you're there, what you're doing, what the context is. Like all you get is just like balls in documentation. So really like this really is like a unique, and if you just search for like what the hell's a jar, you get kind of weird stuff and you get like weird forum posts where people are just kind of like talking about it already assuming that you know. So like this, these courses are really excellent opportunities for being able to just kind of like wall to wall build an understanding of a language.
Definitely.
It's pretty awesome. Wibbit.net is badass.
Wibbit.net is the greatest website in the entire galaxy.
Well, firstly, Brian, good to see you in the flesh again.
Oh, yeah.
Yeah.
Dude, like the Pink Floyd song?
Yeah, what?
Hey, you thought you might like to go to the show.
No, I never listened to Pink Floyd.
Really?
Yeah.
Yeah. That one's for you, Anand.
And you know who's going to watch this, too. So, guys, welcome back to Programming in Java. Kevin and Brian are going to talk about packages.
All right.
Yeah, so, Brian, I'm going to check out your packages.
So packages in Java are like boxes of classes.
Yes, boxes of boxes that have boxes inside of boxes.
Yeah, it's actually like one of those little Russian dolls.
Yeah.
So packages are basically like a collection of classes, and they're kind of like a namespace.
Except for a lot dumber.
Yeah, a lot more restrictive.
Yeah, and more jagged.
Yeah.
Way more jagged.
But they basically behave the same way as a namespace, but they contain, it's like a bunch of classes in a namespace, kind of.
Yeah, there you go.
They're declared, the classes themselves are declared as being part of that package. Packages can be broken apart by like sub-packaging. So you can have like packages inside of packages inside of packages. So like this package could have 15 packages, then it has 30 classes.
Right, yeah.
In each one of them.
Mm-hmm.
A lot of Java developers think that all of your code belong to packages. There's some merit to that. There's some not. I don't know.
Yeah, maybe.
But yeah. So you could encase everything that you do in packages, but your driver.
Yeah.
And even that, I guess, could be in a package.
Yeah, I guess maybe. So how do we make a package? So just like Brian was saying, you could think of a package like a namespace. You basically insert a package statement at the top of your code file.
Kind of like including a header file. Your code will then know how to like import all of the classes and methods that comes with that package.
Yes.
So you just kind of like stick, I want to import the system something package, or I want to import the Java lang package.
Package? What's a package?
Because we talked before about how like some of the classes that we've been using come from different packages. We just didn't really kind of formally define
like
it. So
Java.io and
like
Java.util, right?
Right. So like all of those different kinds of things, I mean, even like the print buffers and all those kind of things all come from some Java package.
Right.
And you've seen us do this before, like as we go, we were kind of like, okay, now we got to import that thing. Mm-hmm. So that's like importing the package. And so we'll kind of get into more detail of like how that functions, how that works, and how we can make our own packages and put things into packages as well.
Perfect, Brian. Now, those of you guys that have been following along should be very familiar with this. We talked about this in classes where we built a person class and then an employee class that inherited or extended the person class. So if these were the code files that we had before, we want to make the class a public class first. And then after we make these public classes, we can then insert a package statement. So in here, we're declaring that these two classes belong to a package called person. And that's just something that we have defined. So notice that it's lowercase person. The class is uppercase person.
And also, remember that being a public class, you can only have that class name per file name.
Yeah,
so
right.
You're like strictly adhering to that throughout everything that's in a package.
Yep. One public class per each code file, and the code file must be named the name of the public class. So now that we've looked at that, I mean, that's code that you guys should have already, studied and scrutinized by now. Here is an example of implementing this. So we have an import person .star. Hey, that's kind of cool because you know how we were like java.io .star?
Yeah, right.
Now we can have our own like person .star.
Nice.
And we're basically just creating an instance of that employee class and we're printing out the first and the last name with no space.
Cool. And person star, you can now have access. You can instantiate employees and people. Like a person or an employee, which is kind of cool.
Absolutely.
Also, as a side note, I think you had pointed out to me the other day that your Java will only load into your program what you use. So if you have like a million classes in your package and you only end up using one of them, it will only, the size of your program will only increase by what it needs.
Right. Because it just references the path. It doesn't include the path. Right.
To find these packages, the package structure...
I feel like Beavis and Butthead. We keep talking about the package.
So the packages have to be in like corresponding directories. So
it's one of these things. Oh,
so
boo, Java.
If your package name is like something.person, you have to have directory name something, another directory name something, and a directory name person.
Boo, Java.
Yeah, right. So to find where that directory is, because you could have multiple ones all over the place, you can pick wherever the hell that's going to be. So in order to tell Java or your computer, your system, your operating system where to find those, you have to set an environment variable, like an operating system level environment variable.
Wow.
Yeah, named class path.
That's kind of lame.
Yeah, and it's comma separated, so you can pass in multiple directions.
Semicolon separated.
Semicolon separated, right. Yeah.
As it says right there.
And that will kind of tell the compiler where to look to find this class. So if you say person, the compiler's like, oh yeah, where? And then the class path's like, right over here. And it's like, oh hey, there you are, person.
Right.
Cool. Awesome, thanks. So the package should be in the same directory, the classes in a package should be in the same directory as the package name.
So whatever directory structure you build, and we're going to do a lab after this. Like the first example we do in here in the lesson's is not going to be, it's going to be basic. We're going to do another one after this that we show that directory path. So the final destination of the directory must be dedicated to your package, just like Brian's dedicated to his package. So we want to create a package. Now let's just take a look at an example here. So we're just going to make, in our Wibbit virtual world, we're going to make a directory, wibbit.net, Java classes. And if we
haven't already.
Yeah, so basically what we're going to be doing is if this is not already in our environment variable, which we'll see, we'll take a look at it, we're going to add it. So then inside of this classes directory, we're going to make a directory called person, and that's going to represent the home for our person package. And then we're going to place the person.java and employee.java file in that person directory. And now the wibbit.net virtual console will take us the rest of the way. What is this, Brian?
Okay, so if we are on a command line and we echo a class path, it should tell us the class path.
Right, yeah.
But now if there's no value assigned to that variable name, it'll just tell us the name of the variable.
Right, yeah.
Like it'll take it as a literal, it won't actually do like a replace on it, right?
Right.
So we want to be able to set this class path variable to be something else. So the way we do that is we say set class path without the percent symbols around it. Just set class path equal to, with no spaces, a dot for whatever directory you're executing at any point in time.
PWD.
Yep. Then a semicolon, because it's semicolon separated. And then we're going to put the c:\ribbit.net/java/classes, because that's the one that contains our, person class.
Right.
So we set that. Now the environment variable is set. Now this will set it, the way we're doing this will set it for the session, the currently running session. It won't actually lock it into the operating system.
Right.
Different operating systems have different ways of actually like permanently storing that environment variable, which you can do, and we'll talk about later. So now when you echo %classPath%, it'll show you what we set that variable to, which is just a string.
Yeah, so similar to your path, your system path, like when we added the Java path, Java bin, you're saying that when I run a command from the shell or whatever, look in these paths to see if you can find it. Right. This is the same thing. It's look in these paths for a directory structure that I'm importing. So after this, we're going to go into that source directory down below where we have our code file that's going to be referencing this person class.
Right, and that's our main class.
Exactly. So in here, we can just look. There is the main class.java. We compile and run it, and it worked just fine. The interesting thing to keep in mind, Brian, is when we imported person, you see how we have person.star?
Mm-hmm.
So we don't have like a full directory path, and that's because the class path the direct class path has a folder called person.
Right.
So if you had a folder called person and a subdirectory called IO, person IO, you would want to do person.io.star to import whatever was in there.
Yeah, absolutely. So now let's talk about accessing the packaged classes. So here we have a main class in our main method, and we can say without including the package, we can just say person.employee. We can always refer to it as a fully qualified path.
Yeah.
Just like if we're going to use a string and we don't say, well, it's kind of actually included, but you could say java.lang.string.
Yeah, if you really wanted to get crazy.
Yeah. So we can just say person.employee, em, and then we have access to it, which is really cool.
Yeah, pretty
Or
neat.
a new person.person. See, and it's a lowercase for the package name, uppercase for the class name.
Mm-hmm. Nice package, Brian.
So, because that gets ridiculous, and you don't want to do that all over the place.
Nope.
You don't want your package just spraying all over your screen. You want to import. So we'll import person.employee, and we'll import person.person.
Right.
Now before we showed you could just import person.star, but here we're showing you can explicitly import certain ones if you choose to.
Right.
So now we can just say employee is a new employee, which takes in a newly constructed person.
Right, so you kind of can pick your poison. Do you want to access everything, or do you want to just access a piece? You can have your choice, and we've done this already before.
You can have it your way.
Sure, Brian.
Every day.
Sure. So packages in Java are awesome, but packages in Java are one of the worst implementations of namespaces I've ever seen in my life.
Because with Java packages, they can get huge.
Very,
they'll get like in your face.
Large packages.
And it's disgusting. I mean, it's just these huge large
Java brown Java packages just shooting. It's flying.
It's gross.
Yeah, it's just horrible.
It's nasty.
It's just disgusting.
Put it away.
Put it away, frog. So yeah.
Okay, so we're gonna pick this up in the lab.
Yeah.
And we're gonna show you how to. We're gonna kind of like walk through this as a lab, and we'll show you how to kind of do a net.wibbit.person class path, like a full class path, like you would typically see. It's pretty cool.
All right, Brian. Let's see your package.
No.
So this is the code that we talked about in the lesson. So we have the person.java. We're
So if we're not going to go through this, just kind of grab it. It should be an attachment on the site. Just grab it.
And if it's not, just send Brian hate mail because he loves it. So here's what we're gonna do, Brian. Let's go to
I hate your beard.
I hate your beard, Brian. Your beard is so stupid. Wait a second. We have a bunch of Arnold fans. Your beard is so stupid, Brian. All right. So in our C drive, we're going to make a directory called packages.
Okay.
All right. We're going to.
And what are we going to put in that directory?
Okay. Now.
Packages?
Yeah, right. What we're doing, Brian, is we're going to make a package called net.wibbit.person. Explain that naming convention.
Okay, so if you remember the class path, packages will be the class path that we assign, so that'll be like the root of all of our packages that we define. So the way this works is net.wibbit.person is like the path to get to this package and how we want to subdivide it, because we might want to have like net.wibbit a bunch of different things, or net a bunch of different things, or whatever.
Right.
So we'll make a folder called net, and then make a folder called wibbit.
Okay.
Because it's going to follow this like strictly as a directory structure, and then a folder called person.
Okay.
And then inside of that, that's what this package is. It belong. So this folder is the package.
So explain, Brian, this naming convention. Where does this come from, and what does this mean?
Well, do you mean why is it net-wibbit?
Yeah, right. Mm-hmm.
So a lot of times, like the way packages are named is like you're scoping into an idea.
Mm-hmm.
So kind of like we talked about with like hierarchy and stuff, and how an inheritance and how you go like from life down to a particular like thing.
Mm-hmm.
You always want to go like broader scope, shorter scope, shorter scope. So like if you're Amazon.com and you have a web service and you're consuming that web service, the web service like identity that you consume, and this happens with Apple apps in the App Store and stuff when you name the app package. The bundle ID, you scope your way in. So Amazon.com's like book web service would be like com, which is like the commercial domain.
Right.
Amazon, which is the particular company in the commercial domain. A web service, which for their web service, and then books,
Right.
And then you call that something in there. So like you're always scoping your way in. So like Wibbit is in the net domain.
Right.
And the particular company or category in that domain is Wibbit. And then within that is our functionality grouping.
Right.
Which in this case is person, just for the sake of it.
What's kind of interesting is because like the original domain suffix .net was always reserved for internet service providers. Classically, Whippet.net is not an internet service provider. So just to be clear,
well, now,
we don't provide any internet services.
But what it did become shortly was like
we ran out of .coms, we had to expand.
Yeah, true. But what it did become is it was used for like community oriented sites that weren't strictly commercial.
.org wasn't .org designed for that?
I think .org was like official organization representation. So like if you're like the IEEE organization, you'd have like an IEEE.org. You know what I mean?
Yeah. Whatever.
People just use whatever the hell they want now.
It's not as structured as it once was, that's for sure. So let's go ahead.
It's very subjective.
And we'll save this as, I'm going to go to my C.
Do you remember BowieNet?
No.
David Bowie used to be an internet service provider.
Oh,
in the mid-90s.
that's right. You did tell me that before.
I always thought that was awesome.
Packages, and then we're going to go to the net directory, then the Whippet directory, then the person directory, and I'm going to call this file person.java. Java. Sorry. Person.java. And then this little fella here, this little guy right here, this little guy right here, we're going to call this employee.
Alrighty.
That Java.
Cool.
Okay. Now we're going to make a main class, and we're going to save this on the desktop that we've been working out of in Java. So we're going to call this, what do you want to call it, like person driver or something?
Yeah, there you go.
.java.
Sweet.
Okay. So Brian, if you were to make a person driver, how would you write this? If you were to make a person driver, how would you write this?
I would first import the packages that I need.
Okay. So
you could declare the. So we'll call it person driver.
No, you're right though, because
class,
we'll just like.
Yeah, but that's cool.
So this will be import.
Import. Net. .whippet.
What?
.person. .star.
.star.
Semicolon.
Nice.
Sweet. Look at that. That's
Very
awesome.
Nice. Okay.
So now we've just imported our package, and we're pretty much ready to go. So we want our public static void main string args. Sweet.
Okay. Now, if we were to just do employee,
yeah,
e equals, and we'll just set this equal to null. We're not gonna instantiate it, but we may. But right now, we're just gonna show that we can access this. So if we open up our command prompt,
okay,
and we go to the desktop, Brian. In the lab, in the lesson, we showed this using the current shell session.
Right.
And in this lab, we're going to do the exact same thing just for consistency. Just so that you know there are other ways you can do this that you may want to investigate.
So you can show it real quick. Just go to like the start menu.
Okay.
Just in case you guys don't know this, and if you don't, you should be ashamed of yourself.
Yeah.
Right click on computer, go to properties, go to advanced system settings, and there's like an environment variables selection.
Environment variables.
Yep. Mm-hmm.
Yeah.
And then in here we can
System.
add it. Right. So we can add a new either user or system, depending like if you want different users to have different package locations, if you have like multiple people, whatever. So you can create a new system variable and just call it class path and just add the path.
Right.
Whatever.
And we can do that, but
it doesn't matter. But we want to show you the command line just so you can get used to it.
So setting
the
this,
other way is the easy way.
What we did in the lab, Brian, is we did an echo
%. Perfect.
Class path. Now in Windows, I don't think this is case sensitive, but I know in Unix it is. So we're just going to put it in all caps.
Yeah. It's pretty standard to keep them always all caps.
Yeah. So, Brian, now what do we do?
So we set class path.
Okay.
Equal, with no spaces. Dot semicolon. So dot is the directory we're executing from. Semicolon separates them, and then :/packages.
Okay. And that's it?
It's done. And then we'll echo the class path again. We're good to go. Cool.
Now let me just see, 'cause I just want to have a little fun here. Hey!
So it's not case sensitive. Cool.
Okay, Brian, now, actually, yes, no, this is good. So now if we go to the Java, the interesting thing is, Brian, even though I set the environment path in desktop, that dot still will represent any directory that I'm inside of. So even though now I've switched to the Java path, dot is this Java path. So now if we do a Java C, I gotta, Java, get them out of my system. Java C, and this was called, what was it, person driver.java?
Yeah.
Java.
Cool.
Java.
Moly. Cool.
Hey!
Awesome.
All right, let's make it do something, and we'll call it a day. what is this? New employee?
Yep, which is a new person.
Right. And this will be our buddy, .NET with alts.
Yeah, there you go.
Okay. Then we can just do a system.out.print line e dots. We'll do first name. Is it get first name or just first name?
I think it's get first name.
You're right, it is get first name. Just go ahead and copy that. Be a little
just
lazy.
go ahead there and
I'm gonna get that there. I just want to see the first name, Brian.
There we go, done deal.
Do you really care about
Nope.
it? No, I don't care either. So we recompile and we get a failure because
I think you have to have a new person.
I have to have a new person. Not a big deal. Not a big deal.
No. You could just do a new employee and then pass a person into the new employee.
Yeah, I know. Yeah, I'm gonna just.
No, I didn't. Sorry. Whatever.
Whatever. This is my United States of whatever. My new person. All right, that should be good, right?
Yep.
All right,
Let's try it out.
try it out. All right, we got a compilation and hey.
So I hope that clears up big packages that are flying around in your face. So
Big brown packages.
yep. Next up's reflection.
Hey guys, welcome back to Wave.net Programming in Java. And in this lesson, Kevin and Brian are going to take you through the excitement of reflection.
Reflection.
Reflection from men. Just like we did in...
Just like we did in...
Were you trying to copy me? Is that what you're trying
What
to
are
do,
you trying
Brian?
to copy me?
What?
Copy me, Brian?
Huh? What?
Stop it.
Stop copying me.
Stop copying me.
You stop copying me. Mom! Brian's copying me! All right, Brian, let's do a little recap. What is reflection?
Well, if you remember in object-oriented programming, it was when we would try to call a method on an object, but we didn't know if that object had that method or not. So we would just kind of say like, hey, maybe try this out, and if you can, then execute the method. So in Objective-C, that would be like when we use a selector.
Right. So we're interacting with the runtime, and there are pieces that come along with the application framework that help us interact with the runtime environment, so we can kind of swim around and be very fluent and organic within the current capsule of runtime space that we're in.
And just in case you guys that doesn't ring any bells with our recap, just jump back to Intro to Object-Oriented Programming and just watch that reflection video real quick before we continue.
Absolutely. Good point, Brian. Now, Java, although it does support reflection, there is a problem, Brian. And what is that?
It's kind of frowned upon. I mean, the problem is a lot of development teams have been working to like take this out of production code because it's amazingly slow. I mean, like Java's slow enough as it is. With a lot of reflection, it's just atrocious. So even though there's certain cases and times when it's needed, it's not. You have to be very careful on how you use it. It's often recommended to avoid reflection if possible. It requires elevated permissions to function. If you have like a virtual machine that's running and it's locked down, like your permissions are way locked down, the program might not function the way you expect it to. And it adds significant, huge amounts of overhead.
Ridiculous amount of overhead.
Yeah. So types, the object type is resolved at runtime. The Java runtime in itself is already at a disadvantage because it's trying to move through the bytecode and, many other things. But to do this on top of it is just kind of like breaking its back. And all internal class members are available, like including privates. So you kind of have some obvious issues with being able to kind of like jump in and get at stuff that you might not want to have somebody get at.
Right. Now, I know that out of the box, Java does protect privates, but I have seen through my time some hacks that people have used to use reflection to extract private field data. And here's where that becomes kind of like a security issue. Like, let's just say, Brian, what if you wrote some FTP or SFTP library for Java, or you were using
a private key,
and you had like a username, a server, and a password stored encapsulated in private variables inside of a class. Right. Well, if somebody was able to hook into that and extract that data, well, you've immediately compromised. Your software's been compromised.
Right. They would kind of like take your class files and import them like a package, and then use reflection to kind of get at them.
Yep.
Anyway.
In Java, we've kind of alluded to this before, but all objects come from the java.lang.object class. So remember, I know that we brought up this analogy 1,000 times, but in the hierarchy of, life is your main object, and that's where Java derives its lineage from. So for each object type, the Java virtual machine instantiates a java.lang.class object, and that is used to track properties during runtime, such as methods and members, and the access of those methods and members, and the parameters that those take, and all that kind of stuff.
So once we use like a person object, there's going to be a corresponding class object for the idea of a person.
Right. Yeah, and we kind of saw that same exact thing in Objective-C for those of you that went through there. Remember we had like the NS class from string, Brian, and that returned us like a class object, and we used that class object to instantiate another object. Well, Java has the exact same concept, and these class objects are used to perform a lot of reflection operations.
So we have the class object, but sometimes we have to get other things like methods and fields, but those methods fields are like the concept of the methods and fields and not the actual method in the field.
Right, yeah.
It's like it's like the reflection method in the reflection field. So all those types of things have corresponding objects just like the class object, and these are all contained in the java.lang.reflect package. So it'd be like java.lang.reflect.method and so on.
Right. And these are the three major classes that Java uses in reflection. So as we were talking about a minute ago, we have the class type, and the class type is an object that represents a class. So this is the class template and not a class instance. So when you look at Java and you have you have string s equals something, well, if we had an instance of a string class, you maybe do like class myString equals something. Well, now myString is kind of like the same thing as a string. You've just instantiated a template for a class. And a method is kind of the same kind of thing, but it represents a method, and a field is the exact same thing, but it represents a field. So these are all generic object types that mimic or represent pieces that are used in object-oriented programming.
Yep. All right. So let's get a few class objects, eh?
Hey, buddy.
Let's get a few Java-Lang class objects, So for example, let's say we have like system.console, right?
Yeah.
And some employee, and we'll call it like EM, is a new employee, and that's a new person .NET Wibbit, right?
Okay.
Pretty straightforward. So like we've seen this. We have a console. We could probably print that person's first name to the console, whatever. So now let's get the class objects from these two things.
Okay.
Now one of them is kind of like one that we created, and one's one that was with the Java framework. So the first one is we create a new class object, and we call it console class. And we just go to the system console, and that console returns the actual, like an object. So we get that object's class by saying get class. So it's system console, the result of console.get class. And that gives us our class object. Everything has these. So because our class extended from an object class, we can say class employee class em.get class, and it'll get the class of the employee too.
You can also get that class object from a data type itself. So in this example, we're pulling in the java.io package and we're referencing the printstream class. But then on that class, we're calling .class, which will return us a class type. So in this case, I have class C.
So instead of the get class method, we have the class property on the type. Cool. So let's take a look at methods that return a class. So for example, you can get a class using a string from the class object itself. So the class object has a bunch of methods to help you. For example, the forName method. So if you say class.forName and then you pass it in the package location of that data type, you'll say class forName java.lang.string. That will get you the string class object. So that would be the equivalent of saying class C equals java.lang.string.class. Also, you can get to the superclass from the class. That sounds weird. From class, you can also get the superclass of something by saying class.getSuperclass and pass in, the parameter that you want. And also to dump all classes, you can just say class.getClasses for whatever class that you're on. So you can say C.getClasses or C.getSuperclasses, whatever.
Whoa! Aren't you cool, Brian?
Oh, yeah.
You're so awesome. Look at all this information that you know.
Now what the f*** are we going to do with these stupid things?
You have no f***ing clue. Let's find out. So Brian, let's try to evoke a method using reflection. Now, we're going to do this the hard way just to kind of get the point across. Now, in this case, we want to call a method on an instance of an object, and the object is called, the method that we want to evoke or invoke is called getNumber. So let's do this using reflection, because you guys know that if you wanted to do this, you can do myObject.getNumber and it will get you the number. Let's just say that we want to be really cool, right? Because we went to college in the 90s, and for some reason we think we're cool. We didn't, but the people that did think they're really cool, and they do this all the time. Anyways, we have a class instance, and we're just going to call it C. And C is going to equal myObject, which is just some instance of some object We don't care what it is, just the concept. And on that instance, we're going to be calling getClass, which will return us that class object type that this current instance is. Now we're going to declare a method type, and we're going to call this getNumber, and this is going to equal now on that class instance that we set on the line above, c.getMethod, and the first parameter is going to be in quotes because it takes in a string. It's going to be getNumber, and it will use the same camel case that the method uses in its implementation code. And by saying common null, we're saying that this getNumber method does not take any parameters. On the next line, we're going to actually evoke against the method now. We're going to say the method instance, which is getNumber, and we're going to call the invoke method. This first parameter is going to be the object instance that we want to execute this on, and by saying common null, we're just basically saying that this takes no parameters, so we're going to pass null parameters.
So that's the most boiled down way to basically call a method using reflection.
Yes.
So you create an instance of a method and then you invoke it on that instance that was built from the idea of the class.
Yep.
Right?
I hope that we're not confusing anybody. So now, Brian, let's kind of take a look at this line by line from the conceptual level and just kind of have pretty pictures explain the story so that we, you and I, and the viewer have complete understanding of exactly what is happening here. Are you ready?
Cool.
All right.
I'm ready.
Start. What are we doing here?
So we have some sort of object. We're just going to call it my object. It could be any kind of object, anything from a string to an employee to a whatever. So we have some sort of object, and every object has like the class blueprint. So we pull that class blueprint off of our object instance, and we'll store that as a new instance of class type called C. We'll just name it C for now. Now, we're hoping that inside of this particular class definition, that there's going to be a method called getNumber. Now, we don't know that for sure yet, but we're hoping that there will be. That's what we're going to try to do. So in order to do that, we have to pull from that class blueprint a method instance of that getNumber method. So what we're going to attempt to do, hoping that it has one, and it will throw an error if it doesn't, is on the class we're going to call the getMethod method, and we're going to pass in a string getNumber, which is the name of the method we want to get, and we're going to pull that out of the class as like a getNumber instance. So now this little getNumber block down here is actually an object of type method. So this object here ties to our my object. This class here is that generic class type, which is like the blueprint of whatever my object has in it. And then this getNumber is a method instance that we pulled from this class blueprint that came from my object. So once we have that, we can call invoke on that method, getNumber, and then we pass it the object we want to invoke against, and if there's any parameters, which in this case there's null. So we just pass my object in as a parameter, and it will actually call this method type through reflection on our original object instance.
Wow, Brian.
Not too bad.
That's really cool. So now let's do an example where we have invoke with parameters. Now, pay attention,
so
kids.
That gets a little tricky.
Because this is not as easy as it is in Objective-C. Because Objective-C was kind of designed, like, reflection was so... This is a side note, right? So in Objective-C, reflection was designed into the language. Everything kind of has, like, some reflective thing going on. With Java, it was written without it, and then it was added later. So that's one of the reasons why when you look at reflection in Java, it's a lot sloppier looking than how other languages implement it, because it was literally just tacked on there. That's also, Brian, the reason why it's so slow is because the language was not designed to have this in it. So let's take a look at this little main method here. Inside of our try block, we're going to do a direct static class call. So we've seen this before, system.out.println, in the system class, the print stream instance out, the println method, hey buddy. Now we can invoke the same exact method using reflection. Now keep in mind, guys, that println method takes in a parameter. Takes in one parameter, and that one parameter is of type string. So let's pull out that class. So we go to the system class .out print stream instance, and we run get class, which is that same exact sample, like that sample we just looked at. We're doing the exact same thing. We're extracting that class instance, that class template. Now, after this, we want to create a list of parameters. Now, every single parameter is going to be of some object type, right, Brian?
Yep.
So that's why we're going to create a class array. And the reason why we're going to create a class array is because any type of object in Java is going to be of some class type. So, you have integer, string, print stream, file stream, whatever. So we're going to create an array of classes, and we're just going to set this of size 1, because if you look at the system.out.println method, it accepts only one parameter. And as we said before, that parameter is of type string. So when we set what that parameter is on the following line, param class sub 0 is going to equal the string class. So this is not a string instance, and we're going to call the dot class field, and that's going to return us back that class template that we're going to store in that array element.
Yeah, it's weird. So, like, when we pass parameters, we have to say, like, okay, here's the parameter types we're going to pass. And I think it's kind of dumb, because isn't that already a given? Like, shouldn't you just be enforcing the fact that the object array coming in needs those types? I don't know. Anyway. But so you have to, like, prep a class array of the types that you're going to pass as parameters in the right order first.
Yeah, that's why you got to appreciate even...
I know why. It just occurred to me. Because you could have two methods that take different number of parameters, because you can overload methods.
But that is one of the cool things, though, even though the overloading in Objective-C is not at all the same as it is in the classical type of C-style languages. Mm-hmm. But like the Objective-C style it's just so fluent. Like I can send it whatever. The compiler will accept. If you're sending to a string, but instead you want to send like a my face object, it'll take it. It may crash, right, but it will take it.
You know what's kind of pissing me off lately?
What's that?
It's like the more time I spend in Objective-C, the more I like it.
Well, I'll tell you, I'm not an Apple homer. I do like Objective-C. I don't
still
love
like
it.
C# better, but
I think that the reason why Objective-C is tantalizing, I guess, is because of it's so typeless and it's so fluent.
Yeah.
Now the language itself gets kind of lame, and I mean you have to admit, Brian, it's very rare that you start an Objective-C project and you just sit down and code it.
Yeah,
It's very often where you have to be like, how do I do this? And then you read up documentation and you say, what the f***? That is so stupid.
Yeah.
So it's easy to forget all of that complication when you want to do something that's kind of complicated, like reflection or delegation and that kind of stuff. Those types of concepts in Objective-C are so simple that sometimes it masks the fact that it's extremely overly complex for no reason in a lot of ways.
Languages are a lot like girls. Like you have that hotness to crazy ratio with languages, just like you would with a girl. So,
well, I mean, Brian, how frequently do we refer to language statements as sexy? I mean, we do that all the time.
Yeah, right.
You know what I mean? And it has that direct relation, like, wow, that is a very sexy-looking computer statement, you know?
Right, so Objective-C is like a sexy result, but man, is it bad crazy.
Yeah,
Java's kind of like heavy and like doesn't get around very quickly, sort of sluggish.
Objective-C is like that super ridiculously, amazingly attractive girl, but she has a lot of issues, and it's a lot of maintenance to take care of her.
But Java just kind of like does whatever you want.
Yeah, Java's kind of like that rock. It's that chick that you don't really like, but like she's always there for you.
Basically. I mean, you can go to like Linux, you can go to Windows, and she's like, "Oh, I'm here, baby. I'm here.
Yeah.
What do you need? I got you."
Mostly because she can't get anybody else. I don't mean it that way.
Yeah. C-sharp's C-sharp's a good balance.
C-sharp is smart and sexy. It's kind of like the who's a good example?
I mean, the only downside is she doesn't travel very well.
Right? Yeah, she likes to stay at home,
which is fine. Anyway, we digress. See, again, like we can't stay focused. Even reflection, which is a more interesting concept in Java.
I don't know what it is about Java. This is like the fourth or fifth time that we've just like flown off the handle during this. It's like the other languages, like the enthusiasm in Objective-C was so high because it was amusing. Java's just not amusing to go through. Yeah. It's very bland. You know what I mean?
It is.
So anyway, let's just keep rolling. So we have that param class of string.class. Now we're going to create a method instance, and that method instance we're just going to give it a label m_println, which is just shorthand for method println. And that method println is going to come from that C class instance that we pulled out from the print stream object above, which is the system.out. We're going to call the get method, and we're going to pass it in quotation marks the method that we want, and in this case, we want println. And as you guys know, there's many different println overloads. It will take like a number, it'll take a string, it'll take whatever, right? So in this case, we're saying, I want the println that takes this list of parameters. And the list of parameters is just of size 1, and that 1 is of type string. And then after this, then we're going to make an object array, and the object array is going to be the parameter values. Now, reflection in Java, similar to like, I guess Objective-C with like the ID concept, accept, where a lot of things will accept multiple stuff. Java, when it takes in parameters in reflection, it wants them in type object, so that it could be any type, whatever type you want it. Just pass it to me, and then I'll figure it out when I get it. It would be kind of a pain if you had to make like an array list where each element was of a different type, and that would just suck, right, Brian?
You know what they should have done, in my opinion? Instead of using the arrays, just do like the 3 ellipses, so that'll take in like some series of parameters.
Yeah.
And then just do that of type class and do that of type object. Like, what's the deal?
Yeah, right. Or since everything inherits from object, they can impersonate object.
Yeah, right.
Right, you wouldn't even have to make it an object type.
Mm-hmm. Right.
So then we make this object array of size 1, and in sub-0, the first element, we're going to set that equal to a string that says, hey, buddy. And actually, Brian, these aren't equivalent because your hey, buddy at the top has a period, and this one has an exclamation point.
Right. Well, that'll show you the difference, which one came from reflection and which one didn't.
So, Brian, how do we evoke this then?
Well, then we just call that method instance and then call invoke on it, and we pass it the object that we're dealing with, which in this case, funny enough, will be just system.out.
And that's the object instance that we want to call on, right?
And then the parameter values.
Wow.
Yep, which is just the, one-dimensional object array of an object that happens to be a string that's called hey, buddy.
Awesome.
Yeah.
Brian, here's a class called person.java, or person. And we've seen this before, right?
Yeah,
Not a big
1,000
deal.
times. We know
Not
this.
a big deal.
Yep.
Now here's a main class, Brian, that's going to then just extract data from the person class. Tell me how this works.
Cool. Okay, so we want an argument that comes in. So we get an argument, we print to the console, we say like info for class, and then whichever one we passed, right? So we want to get some information about the class that we pass in. So then we create a class instance C, and then it's going to be class, and then we're going to do it by name, and then we're going to say for name, and then the argument that we passed in. So if we passed in like java.lang.string, we'll get information on the string, and so on. So now we have a class representation of a object type based on our argument. So now we want to create a list of methods, and if we call that class instance and we call the method getDeclaredMethods, it will return back to us an entire array of methods, of all of the methods that are in that class. It'll just like dump the blueprint out. Same thing with fields. If we call getDeclaredFields, it'll give us back an array of type fields, of all the different fields available, which is kind of cool. So we can just start printing this stuff out, so we can kind of like get a sense of what's in that object. It's kind of like we could probably use this to like recreate like a framework for documentation of classes that we create. Which is kind of cool. And so like system out. So we're gonna print out like methods, how many methods, and then for each method we're gonna just print out like the name of it, so on. Same thing with the field. So let's see what this looks like if we execute this in our old console.
Let's pull up the Whippet.net virtual console. We're going to compile the person.java in this main class.java, and we're going to execute against the Java interpreter the class main class, and we're going to pass person as a parameter because that's the class that we want to scrutinize. And this is going to output us info for class person.
Nice.
And this has 6 methods, and those methods are public, void, and then person dot is just within the context of this class, dot set first name. And then check it out, Brian, it even tells us the parameters that they're taking.
And the fact that, right. Yeah.
And their access. Now look at those 2 fields down there, Brian.
Yeah, that's scary, huh?
So they're exposing your privates.
Yes.
So this is kind of like a friend that like you don't want him to be your friend, but he sniffs through your garbage and like knows everything about you. That's what Java reflection is.
Nice.
Whereas in C++, you have to actually explicitly say, "Hey, you're my buddy."
All right, so let's do another example. So we have person me, it's public, and then we're gonna create a me instance of the main class, and that's gonna be new main class. Right? So then we're going to create a field. So we have the main class instance, and then we know that main class has a field called me, right? So the field, my person, which is of type field, we're going to pull from our main class type, which we're inside of, dot class, which is that blueprint, dot get field by name, and me, and we know this exists because if you look above, we've put it in the same class. So the me instance.me is going to be equal to a new person, and then we're going to call that me instance.me set name NetWibbit, right? So that gives it some existence, right? To instantiate it, we set a name to it. Now that we have like the field, the reflected field object type, we can print me with reflection is person my person dot get. and then the me instance, and we throw it that field, and it looks for the getter, which will just kind of pull the value. And then we'll do without reflection, which we just call me instance.me. So it's showing getting the name of person through reflection and without reflection.
So let's try to invoke a method using reflection, and this is kind of just an example that we're going to take a look at in a little bit. Now, this is kind of splitting this apart into different methods that's, I don't want to say simplify, but it just kind of breaks this apart. So let's just take a look at the two methods that we're dealing with here. So we have a public, and it returns a type object, and we're going to call this run method on class, and it will take in a string, so the method name, and a class name that's also a string.
Nice.
And then below that, we have an overload of this that does the exact same thing, except for it takes in a method type and a class type. So basically, what we want to do is we want to say, I want to run this method on this class.
This is also known as Wibbit.net making Java into what we think it should have been.
Yeah, right. Well, yeah. This is, well, yeah, there you go. That's one example. So let's take a look at the top where we create an instance of main class, just call it me instance, just like we did in that last run that we did. And the reason why is, Brian, because those methods, those public object run on class methods are not static. So we need to be able to create an instance in order to access them. So now let's then make a long type, and we'll just call that Unix date. And that's going to equal of typecast long me instance, which is the instance that we just did, that run method on class. Now this is going to take the toString overload. So I'm going to run the getTime method, and I want to get that from an instance of date. Now the kind of interesting thing here to note, Brian, is there's no date instance. We're going to create that, evoke it in that method
Nice.
below
awesome.
that. So it's like, it's kind of neat. I don't know.
Yeah, that's cool.
So it's like a one-time use. Like if I want to get a random number where I want to instantiate get rand blah, whatever. I don't know. When we call that one that takes the two strings, Brian, what happens?
So we take in those two strings, and one of them is the method name and one of them is the class name. Now this is kind of like what we did before. We're just now sort of like packaging all together. So we create a temporary class, and we make a class for the name of the class that we asked, which is the Java util date. So now we have like a date blueprint. From that date blueprint, we get a method based on the method name. Now, of course, this doesn't handle like parameters and stuff, but it's okay. We don't really need it to for this example. But you could build this out to be more robust if you wanted it to be like a repeatable, reusable thing. So we take in the method name, which is getTime, and we pull that getTime method out of that class blueprint and store it into a method object. And then we return the result of running the method on the class, the temp method and the temp class. Not too bad. So now we go jump down to run method on class, and we take in a method in a class, and all we're doing is we're just invoking this on a temp object.
But check that out, Brian. We're using that class type, calling c.newInstance to create a new instance of that class.
Right. An object can just like normalize it.
Yeah.
But everything will still be inside of it, right?
Mm-hmm.
It's very cool.
And then what we're going to do is return the method.invoke and then pass the temp object and then pass no parameter. So in this case, all that we're doing is we're creating an instance of the date object, we're running the getTime method and returning that back reflectively.
Yeah, that's awesome.
Now, why is reflection bad in
Bad
Java?
reflection.
Bad.
Bad
Go
reflection.
outside. You do that outside, bad reflection.
As we stated before, reflection is bad Java.
Bad Java.
So only use it if you absolutely have to, and if it's like pertinent and relevant. Never use reflection as like a shortcut or as like a way to be cool or something like that. Just
a lot of guys do it because they think they're cool.
well, and also like, and you could also use it to be like overly paranoid. Like, oh, I don't know, like if we have a version of the software that's going to change and it'll break, like just inspect your versions before you implement them in tests. Like, don't make everything all reflective. So like, oh, just in case we update a version, it'll like just chill, you know.
Don't be bad
like,
Java.
Yeah,
okay?
and if you're doing like something like if you're using like Maven or some sort of thing that's like pulling in from repositories like all your supportive classes, explicitly set those version numbers so that it's not pulling the latest version from those repositories, so that you reduce your chances of having code break like that. So just be explicit with your versions, test, only use it if you need to. And because there is some times where you do actually want to use it, but you definitely don't want to use it while like a million times over in a program. You might want to use it for like if you have plugins and you're like in consuming, you know, other libraries and real time, or you just want to like check something, and once you test it reflectively, then it's like a known. Then you can kind of go from there and like set up in the program some way to remember, anyway, what's safe and what's not safe.
So why is reflection so bad in Java? Well, like we stated before, reflection was an afterthought in the language design. Java was not designed with reflection in mind. Therefore, reflection is literally, you take a square hole and you have a round thing called reflection and you have a hammer and you just go bang, bang, bang. It's going to leave scars. It's going to leave cracks. And that's what reflection is in Java. And this causes significant overhead in the Java runtime. And Brian and I are going to show you an example
nice.
of how horrible.
How slow is too slow.
Yes, we're going to show you how terrible Java reflection really is. So let's take a look at this class, Brian. Tell me what's happening here.
Alrighty.
All right.
So we set a start time, which is just like the current time it is now, a schlong version of it. And then we create a new instance of our main class, and then we make a temporary time, and we just kind of like do that get time. And we do that, we just keep calling get time, get time, get time, get time reflectively now.
Yeah, like a million times,
like a million times,
in a loop.
Right. So we just like
Right, and this is using that same thing that we went over before, where we create an instance and we just run that method on that instance, and then boom, we're done.
Okay, so then we get our end time. We just get time again, and then we just make the difference, divide it by 1,000, so we get it in seconds, and then we print out how long it took. So when we run this, when we like reflectively get time on the date object, which is like no big deal, it doesn't take in a lot of parameters, like it's not too bad. This process took like 31 seconds. That's a long ass time.
Now, Brian, let's run the exact same thing without using reflection. Now, functionally, Brian, by saying
holy crap,
temp time equals new date time dot get time is functionally the exact same thing that we just did.
Yep.
And we're just creating a new instance and running a method on that instance, but it took under a second to do it.
That's insane.
That is how bad reflection is in Java.
That's ridiculous.
It's insane.
Yeah, it is. It's not practical.
Right, and that's why you should never use reflection. It's really easy to spot Java applications that use reflection because you'll click on a button and something that seemingly should take 8 seconds or 1 second.
That's not that easy to spot. That's actually just Java.
Well, or you'll just get one of those pop. Yeah, that's true. That's very true. But like some Java applications that I use, in my job, I'll see those Java.reflection errors that pop up and the timeouts, and it's not worth it.
No,
it is not.
Why waste the time to learn it? You want to know it, You want to know it so that you know how to remove it. You want to know it so you just understand how the language works. You want to know it because sometimes there's practical uses of it. If you're working in Java, you're bound to find it. And it's best to know what the hell you're doing instead of like, what the hell is this field object here?
Right.
So, and if you never use it, it's like if you go on the internet and you say like, I have a software engineer job interview coming up and I need to ask the guy some questions or the girl some questions, the top 10 questions that they always ask, one of them is like, what's reflection? It's in like every one of them, Yep. So it's just like some stupid indicator to see if you know the more like fringy things on a language. It's not a tough concept. You got it.
Yeah, and back in the day when Java programmers were just like the coolest kids on the block, a lot of them thought they were super cool. And when they got their jobs in the late 90s and early 2000s, they were like, I'm going to put reflection all over my software.
Yeah.
And companies, a lot of times, it costs more money to rewrite something than it does to just maintenance it. So if you get yourself a Java programming job, and your manager says, I need you to go into this code and add this new functionality. Well, if you see reflection, you need to be able to spot it. You also need to know how to work within that because you may need to actually use reflection to implement some change that you're making because the basis of the code is based on reflective programming.
Right. Sometimes, unfortunately, there may be a condition where you have to implement a feature before somebody else has implemented in a supportive project.
That's true. Yeah.
So you could implement it for temporarily, the time being, using reflection until you've known they've implemented it and it's up and running and it's fine. You haven't been calling the old way of doing it, and then you remove the reflection. But that would suck.
So that's reflection in a nutshell in the Java language.
Man, that was a knowledge-packed lesson if I've ever seen one.
I'll tell you. I didn't learn that in college.
Nope.
I learned that one time when
I never even heard the word reflection in college. Are you kidding me?
I remember seeing the Java.reflection exception errors popping up in software, and I was like, what the f*** What is that? I have no
the
clue
teacher
what's
be like,
happening.
don't worry about that.
Hey, what's that over there? And runs out of the room. That's it.
Yep.
I'm out.
Hey everybody, welcome to our next lesson. Now we're going to be talking about threads and multi-threading and Java and stuff, which is kind of cool.
Right, we've been exposed to threads in C, C++, and Objective-C. Now it's the Java turn, I guess, to kind of show the implementation of threads. And one thing that I do have to say is that Java, and Brian and I were just talking about this, that Java has an amazing implementation of the multi-threading concept. And we're going to take a look at that, and we're going to explore that right now.
But now, like, because in other languages, the threads weren't necessarily cumbersome, but both threads and sockets weren't necessarily cumbersome, but they were like a little.
Oh, I don't know. I think they were fairly difficult.
Yeah,
one of the
little rough around the edges.
One of the big issues with threads in sockets is that they are so operating system and platform dependent, whatever code you use.
Yep.
So, like if you're doing Windows multi-threading, you do it this way. If you're doing Linux and Unix multi-threading, you do it this way. What Java did is it just kind of said, you know what, this. There's no reason for it to be like this, and then they fixed it in a big way.
Yeah, it doesn't seem like a big deal now that languages and libraries have kind of solved this problem for a while. But like in the 90s when Java was kind of kickstarting, this was a big deal. Like this was a big focus that Java really wanted to solve. They knew like the success of the language was getting this right, getting this down and getting it right.
Right. Now, Brian, let's talk a little bit about multi-threading in Java.
Just a school memory this reminds me of. They were teaching C++, So we were going through and doing everything in C++ until I got to a class on, like, networking. And once you got to the networking class, they were like, okay, they didn't talk about programming at all during the class. And they were like, okay, so our final project is going to be to, like, implement a socket and do, like, a server client and have them talk to each other. And they were like, you can use Java, Like, they didn't even have enough confidence in the students that they could write it in C++. And I you not, without the school ever saying anything about Java, the gross majority of the class wrote their sockets in Java because they didn't understand enough to write them in C++. Like it was ridiculous. I think if I remember right, I think you were one of the few people. You weren't my class, but I think you were one of the few people in your class that wrote it in C++.
Yeah, because
you were like, this, we can pull this off.
I think, and I don't know if it was the same for you because I know, Brian, you and I were in the same curriculum in college, and there was a network security class that we were in. And in the network security class, one of our projects was to write a Diffie-Hellman process, right? Where we had a Diffie-Hellman encryption, so we did like, the alley A to the power of whatever on the client side and the server side. We generate the keys on both sides, and then we transmit a message. Well, you're right. Like a lot of students, they didn't want to write it in C and C++. They said, can we use Java? And a lot of them actually use Perl because Perl sockets are easy to tell too.
Yeah.
So a lot of students use Perl and Java, and I was the stubborn asshole that said,
but now the students didn't really understand it either. It was just easier to copy and paste in Java than it was in C++.
Right. I was one of the stubborn ones, and my group, we did we wrote a Linux socket, and it was my determination. And at the time, when I was in college, I was a big Linux homer, and I still love Linux now, but as I've grown into a software developer, I've leaned more in the Microsoft direction. I'm sorry if that upsets anybody, but
but I mean, Linux still has its place.
Oh yeah, when I was in college, all my laptops had Linux, my workstations had Linux with like Windows virtual machines for like other stuff, or like I was just Linux, everything and everywhere I was Linux. I wanted to do this in Linux. I wanted to do it in C++, and there was nothing that was going to convince me otherwise. So I actually did figure it out, and I actually did get it working, but it took a lot of time, a lot of energy. And when I kind of grew into a professional developer and I got into using other APIs in other languages, and I remember, Brian, the first time that I wrote a Perl socket, I was like, what? That's
what
like,
the yeah.
Like it's like
it's like a joke.
Use like Perl.sockets or something, and it's like make socket equal to new. Oh, I just made a socket. It doesn't like.
Yeah, it's weird.
It's crazy. Java was one of the kind of the early. I guess maybe Perl would have been, but I guess Java was one of the major early adapters at fixing this horrible problem that we had. So in multi-threading in Java, as with pretty much all the other material that we've gone over, there are many ways to accomplish this task, and we're just going to kind of go over one way of doing it. There is a very common approach is to inherit from the thread class, which is something that we kind of dabbled with in C++. And there's a reason why we did that, Brian. We did that to prepare everybody for the Java
implementation. Yeah, we tried to even keep a lot of the naming conventions that we used for the objects that we created and the classes we created in C++.
Yep.
So that they would look familiar now.
Yep. It was all designed to make you an awesome programmer.
Yep.
Now, Brian, let's kind of walk through, let's take your hand viewer, and let's walk through the thread class, and let's learn a few basic things about it.
Will you be my KT Korik?
My KT Korik?
Okay, so there's a bunch of constructors for the thread class. There's just a default constructor, and there's like you can pass in a name, so you can name the thread. And there's like a runnable object type, which is the target, and the name, you can group them, you can have thread groups and stuff like that. But we'll get into those later. So there's a bunch of different constructors. And some of the methods we have is like, we can look to see if the currently running thread has permission to modify the thread, so we can check access before we do something. We can see the current thread, which returns a static thread object. So that returns a reference to the currently executing thread, which is great, extremely convenient. Destroy it, enumerate. We can get the name of the thread, get the priority of the thread so we can make decisions. We can determine if the thread holds a lock. We can interrupt it, tons of stuff.
We can check to see if it's alive too, which is important.
Yeah, and then we can see if it is interrupted. We can do a join, which kind of like waits for the thread to die. We can resume. We can run the thread, which we'll use often. We can have the thread sleep, which we've kind of already seen before in examples where we have the program sleep. We just have the thread that we're currently running sleep. Change the name, change the priority, start, stop, suspend it. Just dump to string, which just takes the name property. And, so like everything you could possibly imagine, they've just kind of baked in, kind of like when we made our own thread class in C++, and we kind of did a few of these things. They really built it out pretty nice.
Very, very well done. Now let's take a look at an inheritance example of using thread. So on the left here, we have a class. It's called thread example 1. And if you look, this extends the thread class that we had just gone over, because the thread class itself doesn't do anything. You have to either inherit from it, or you have to instantiate it and overload methods in order to get it to work, which we'll talk about. I think we do that example next. But here, we have inside of the class that extends threads, we have a private int seconds to wait equals 0. And then look at this, Brian. We have a public void run.
Nice.
Now, when you were going over the methods that the thread class provides us, you mentioned there was a run method.
Yep.
And that run method is when you start a thread, the run method is what executes. So by me overriding the run method, I am then defining what my instance of thread is going to be doing.
Yep.
So here, I'm just going to go from 0 to seconds to wait, and then just print to the screen. Well, I'm going to wait a second first, and I'm going to print how many seconds that I've slept for, and then I'm going to end the thread. And below, I just have a setter to set seconds to wait. Just takes an integer and then sets our private field. And then inside of this class, we have our main method. So then we instantiate the main class. Now check this out, Brian. We've been using my class and main class to name the class that has the main method. This is the first time that we've built a main. I think this is the first time that we have a main class that's not called main something.
Yeah, because the entry point can be in whatever we want.
It doesn't matter. Exactly. That was just so that we could identify it when we were learning the language. So we make an instance of our class that extends thread. Then I'm going to do seconds to wait 10 and then run start, which Brian also showed us a start method when he was going over the thread class. Now, while my thread dot is alive, we're going to fall into an infinite loop, and the thread is going to output what happens on the right. So I slept for 1 second, then 1 second goes by. I slept for 2, 3 to 10, and then it ends.
That's awesome.
That's beautiful. It's a very simple implementation of a thread. Now, Brian, what is this example doing?
Okay, so in this case, we changed the main method a little bit so that we have, now this is thread example 2 extending thread, but it's still the same setup. So in this case, we go through a for loop. Well, first we create an array of thread example 2s. My object, which is new thread example 2 size 5. So now we have an array of this class instances, 5 of them in an array. Right? So for each one of those thread example 2 objects in the array, we're going to instantiate a new thread example 2 into our array, and then we're going to set the seconds to wait to some random number between 1 and 5. So we traverse through the array, and then we create the threads, and we start all 5 of them like right off the bat. So like 1, 2, 3, 4, 5. We just kick them all off. Mm-hmm. And each one of those independently will start counting their timers.
Mhm.
So and then at the end of this, we'll just kind of say, like, while any of these are still alive, we'll just kind of march through them. Like, if the first one's still alive, we're just going to wait, and then when that one's dead, we'll go to the next one. If that's still alive, we'll wait, and we'll just kind of work our way through until they're all dead. So if we look at the output, what happens is, like, that for loop runs so quickly, that happens within a second. So all of the threads start within a second. So they all independently say that we've slept for a second. Then they all independently say we slept for 2 seconds. Then they kind of start getting off a little bit. So some of them have slept for 3 seconds, some have slept for 4 seconds, and then one slept for 5 because they're randomly generated. So this means that all 5 of them have at least the random number 1, 4 of them have the random number 2, 2 of them have the random number 3, 2 of them have the random number 4, and 5. So
yeah, and this is kind of fun, Brian. So if you look, after 1 second completed, we lost 1 guy. So then we were down to 4. Then after 2 seconds, we lost 2 more guys. So we were down 3. Now we're down to 2 or 3, whatever. Then after that, after 3 seconds, both of them survived. Both the survivors survived 3 seconds. Then after 4 seconds, one of them died. And then after 5 seconds, that last remaining survivor, the guy that hung on the longest, finally couldn't live anymore.
So that means we had 1, 4, 4, 5 was the random numbers. It's funny. So isn't that awesome? It's very cool.
That's really awesome. Now, let's do the exact same program, but let's do, Brian, let's instead of extending, so this is going to be a class called thread example 3, but we're not extending the thread class. Now we're instantiating the thread class.
Right, because remember, sometimes it might be like an unnecessary nuisance to always extend that class every time.
Yeah.
So
it depends on how simple or complex the threads are.
So if you remember back in overriding, there was a bunch of different ways we could override stuff, and one of them was actually to override a method when we instantiate.
Exactly.
And if you don't remember, just kind of go back to the overriding lesson to review.
Right, so what we're doing here is we're doing thread, my thread equals new instance of thread, and then we open up a block. And inside that block, we're overriding public void run.
That's awesome.
That's really cool. Now, instead of actually setting that random number like we did in that last example, setting it separately, this run method creates a random number, and this is going to, I think, was it 20 seconds? And this is just going to kind of run through. It sleeps for a second, and then it does, it functionally does a very similar thing. But then after we make that instantiation and override the run method, then we just call my method.run, and then while my thread is alive, we just hang.
It's awesome.
Yeah, so it's pretty neat.
Yeah, so it kind of condenses the code down a little.
Mm-hmm.
So did you notice anything?
No. What am I supposed to be noticing?
Oh, we're like building up on concepts. I know, it's cool.
Now, Brian, the reason why this looks familiar is because didn't we do this exact same thing in C++?
Yeah.
Didn't we?
But we did it, but we created it ourselves.
Yes, we did. Yes, we did. In C++, in our thread lab, we built our own thread class, and then we inherited from that class, and then we worked from there. And this is what Java does. It's the same thing, and that's why the Wibbit.net linear approach, when we put a lot of thought into how we design these courses, so that by the time you get to this level, you're like, oh, yeah, I've seen that. I know what that is.
So let's take a look at one last example. But in this case, in thread example 4, we're implementing runnable.
Okay, Brian, now you remember when we were talking before about the constructors for the thread class, you mentioned that it will allow us to use a class that implements the abstract class runnable, right?
Right.
Okay, so what we're doing here is instead of extending a class, we're implementing a class, which means what, Brian? What's the difference between extending and implementing?
So implementing is when you are going to be in this class definition, when you're going to be implementing the abstract methods or class from some other one. So that means that we're going to inherit the blueprint from runnable.
Right. So remember the abstract class is designed to not be directly instantiated, but you have to implement it. So remember, extending, you're taking from a class that already exists in a perfectly good form, and it's designed to be instantiated, but I'm just using it for my own purposes.
Right. So it's designed to be like finished off.
Exactly. So now we're implementing the runnable abstract class. And here we're just creating two private, have a directory path and a seek string. So let's kind of walk through and let's see what this program is doing. And I think whenever I'm going through code and trying to figure out what it does, I often try to go from top to bottom. And in order for us to do that in this example, we'll slide down to the main class and we'll take a look at exactly what's happening. So we're creating an instance of our thread example 4, which is the implementing class above, and we'll just call it mySeqThread, and that's going to equal a new instance of thread example 4, and that's going to take in a directory path as the first parameter, which is
Cool.
where I'm guessing where this source code is, and then it's taking in another string, and it just says main class. So if we slide up to the constructor of the class above, we'll see that
Just set them.
in the constructor, there's a directory path and a seek string, and we just set those global variables, making a new instance of string.
Nice.
Not too bad. And then we make an instance of thread, calling it myThread, and set that equal to the myThread constructor that takes in a runnable type. And that runnable,
Interesting.
yeah. So that runnable type will then be our thread. So we don't have to overload or override anything. That is the thread you're going to run. So then by executing myThread.run, we're going to execute the run method inside of the thread example 4 class.
Cool.
Yes. Now check this out. Now these are concepts that we've already kind of talked about.
So this isn't saying that the class type is runnable. This is saying that we're implementing some class that is runnable. Do you know what I mean?
Mm-hmm.
It's kind of it's not a runnable type. It's almost like stating that now that we've implemented runnable, we're saying that we can run this class.
Right. Yeah.
In a way. Anyway.
So now what we're going to do is inside of that run method, we're going to list the directory path by making a new instance of file, passing it the directory, and then on that new instance, we're going to invoke the list files method, which is going to return to us an array of files that are inside of that directory.
Very cool.
And then by setting a Boolean hit, it just basically is a set value that if something, we're just going to say,
It's found.
this is hit, this is hit, whatever.
Yep. So like once we find the string that we're looking for in the contents of the file, we'll flip that flag and then know that we have a hit.
Right, so for each file in that directory, so for in I equals 0, while I is less than the length of the file list array, I++, we're going to try, because if you look at the seek file method, it throws IO exception, Brian. So that means that I have to try this, or else it won't let me do it.
Right.
So hit equals seek file, and then I pass that file instance as a parameter, as you can see from the implementation of the seek file method above. Now we're going to create a buffered reader, which, Brian, we know what a buffered reader is, right? That's going to allow us to read the contents of this file. And we're going to do that by creating an instance of buffered reader, and then in the constructor, we're going to pass it a new instance of a file reader. If it's a file reader and a buffered reader, that means, what is it, text or binary, Brian?
Text.
Such a smart guy you are. So then as we're reading the file contents, while we have data, so while file line equals br.newLine is not null, right, Brian? So as long as that executes properly.
As long as there's another line to read.
Yep. We're going to then take the line in that file, and we're going to convert it to lowercase if that contains the seek string. Now, if you look at the constructor of the thread method 4, Brian, we've already lowercased the seek string.
Yep, that's true.
That just kind of normalizes it so that we're doing a non-case sensitive search.
Yep.
And then if we find that string, we're making the assumption that we're done searching the file, so we can close the buffered reader and return true because we got a hit. If we go through the entire file contents line by line and we do not have a hit, we're just going to close the file, the buffered reader, and then we're going to return false. So then below, it will print to the user every time there is not a hit, we'll just continue, which means that every time there is a hit, we're going to print to the user the absolute path of the file instance. So so if you wanted to write something that searched the directory to find any file that contains this would be your best friend.
So it's kind of like it's like a threaded grep.
Yes, there you go.
Cool. That's awesome.
That is cool, Brian. So multi-threading in Java. Talk to me.
Not too bad. So it's pretty straightforward. Everything's kind of packaged up for you in the thread class. And the main points is that you can either extend the thread class, or you can just overload the method when you instantiate the object, or you can create a runnable class, a class that implements runnable, and pass that into your thread. But however you look at it, you basically create a thread object and run it. It's really straightforward.
Yep, and it's pretty damn sexy.
Yeah. Hey everybody, now we're going to get into sockets. So this is the first time we've really got into this. This might be something you're really interested in. We've sort of like skirted around this in the other languages up to this point.
Yep.
It's kind of like what we were talking about before. There's sockets in other languages are can be like a little rough, you know what I mean?
Absolutely.
And they're very much like platform specific.
Yep.
So like what we've tried to do as much as possible, with the exception of Objective-C, obviously, is we try to stay like relatively platform independent if we can,
Right. But we had Objective-C, we had our reasons for what we did. So,
Yep. So, and doing sockets in C and C++, it just, it depends on the platform you're on. It's all over the place. So, so we're going to get into sockets, and in case you're not familiar with this concept and like how they work, we're going to go over like an overview of what sockets are, and then we're going to make some sockets and make them work in Java, which is awesome.
Yes.
Can't wait to show you.
Absolutely. So, what is a socket? Now, in a basic technical, or not technical, a basic definition of a socket, at least in terms of computer programming, is a two-way link of communication between programs on a computer network. Now, you remember in the introduction to computer programming, we had put an emphasis on discussing IPCs, or inter-process communication. And the reason why we brought that up is because that's exactly what sockets are. It's one process communicating with either itself or a separate process, and then the other process able to communicate back, and sockets is a channel of doing that. Sockets are not necessarily communicating with programs on separate machines, but they can. So a socket that's communicating on the same machine is often called a local loopback or a loopback socket. Now, when we were talking about IPCs before, inter-process communication does not mean two processes on the same computer. Like when you go to a web server in France, your computer is actually interacting with the process running on a computer in a different unless you're in France, in a different country.
That's awesome.
Yeah.
That's really, because I mean, you know by now that it's inevitable. Like most programming today, anyway, is not locally independent. I mean, like look at all the programs on like your mobile device.
Oh yeah,
or even on your. Imagine if the internet went down for a day.
Yeah.
What the hell are you going to do with your computer nowadays?
Yep, exactly.
I mean, like, maybe Photoshop, but even with Photoshop, sometimes you need to, like, go on the internet and, like, look at a picture to get an idea for, like, a color palette or something. I mean...
Yeah, but then, Brian, if there was no internet, though, you couldn't get that annoying, hey, do you want to update with Photoshop?
Yeah, right. So everything nowadays has to do with networks, the internet, like inevitably, somehow or another. Even if it's just like where you're pulling your data from. Sockets are in everything now.
And the thing that's kind of interesting, Brian, is you know how we were discussing before how Java put an emphasis on fixing the problem of making sockets less complex. Well, you started noticing post-1995 that drive to write sockets and applications using sockets because all of a sudden sockets were accessible to the average software developer.
Yep.
And that was one of the greatest contributions, in my opinion, that Java gave the development world.
Yeah, I mean, just look how AOL Instant Messenger changed the game. I know it sounds dumb, but
yes.
I mean, no joke. Like AIM, when it first came out, now we have like Facebook Messenger and Gmail chat and all this other bullshit.
Right.
But AIM, when it started, that's all there was. Like there wasn't anything else, and it was rocking. It was quick. It was easy to use. It was great.
And it's
everybody
peak.
was
And it's
that,
peak.
and then
everybody had AIM. Right.
And then to compete, and then you had like IRC or ICQ,
right.
and MIRC. Like all those.
I was gonna say IRC. Yeah, it's.
But so those were all like the grandfathers of like everything today. I mean, everything today.
Absolutely, and it was socket programming that made all of that possible,
and still does today.
Yes. So let's start talking about now we know what a socket is from a high level. Now, Brian, tell us what socket programming is.
All right. So a network socket is going to have two endpoints. And so it needs these two components. So one of these components is going to be a server side, and one's going to be the client side. So the server side is the side that's listening and waiting for data to come in. So it accepts incoming connections. So like often this is like told to listen on a specific network card, or it's configured to listen just for like local clients or whatever the case is. So usually there's some sort of restraint, so it's not just like listening all over the place. There's some sort of direction to it. Mm-hmm. And the home address is always either like localhost or 127.0.0.1. So if you're doing any like local loopbacking, whatever, to your own computer, it's always going to be one of those two. So so that's the listening side. That's the side that's waiting for a request to come in. And then on the client side, that's the one that's going to be sending the requests or initiating the connections. And that client is going to be the sending socket. So you have the sending socket and the listening socket, the client side and the server side. So the client sends streams of bits to the server accepts those and can return them back to the client. So for two-way communication, sometimes you can have both system endpoints, both be servers and both be clients.
Exactly. Now, one thing that Brian brought up that was interesting was this whole concept of the loopback 127.0.0.1 or localhost. You can also, like, let's just say you write a socket program and you're listening on this NIC card, and the IP address of this NIC card is 198. Whatever. Well, you can have your client, if it's running on that same machine, connect to that IP address. But the problem is, it actually will have to outbound into the network and then bounce back to your server. Mm-hmm. If you're connecting to 127.0.0.1 0.0.1 or localhost, then the communication never actually outbounds. It just locally loops right back into your machine.
Right.
So for speed purposes, if you're writing software that is guaranteed to be on the same machine, then use those two forms of local loopbacks to initiate sockets.
Absolutely.
And server sockets listen on channels, and these channels are called ports. And a port is basically a numerical value that represents an entry point into an application.
Right, it's very much like channel 16 on a CB radio.
Yeah, or like on a television, you know, if you want to watch NFL Network, it's on this channel. If you want to watch, I don't know, the History Channel, it's on this channel. It's the same box, but the different channel specifies the different input that you're putting into your device. And like Brian was saying about the radio, whether it's like a ham radio or CB radio or a regular AM FM, you're selecting a channel that you're accepting input from.
Why was it never explained this way, like when we were younger, first learning this?
I'll tell you why.
Like because people wanted sockets to be the most complicated, weird, freaky thing ever. Like, holy shit.
And I think that one of the issues that we had in our college was our professors didn't speak English, and they were teaching a majority English-speaking student body, which was frustrating. I hope that it's not that way anymore, but
it is.
It is. So a program can have multiple sockets listening on multiple ports. So, you know, we were talking about multi-threading before. You can have an application thread out 10,000 ports and have 10,000 listening sockets.
Yeah,
you know?
Absolutely.
And some ports are universally reserved for a specific purpose. Now, these are all documented. Reserved ports are documented all over the place, you know, and you yourself may write some application where you constantly use some port that you can actually submit to a standards board if you're big enough. Chances are, I don't want to say that because you may come up with the next best network application, but
you know what's funny is in the official like standards for registered ports, ID Software registered a communication port for Doom 2. Do you know what the port number is?
I do. It's 666.
Isn't that hilarious?
Yeah.
It's really funny.
Hey, I was a kid in the 90s, man. I was one of the first kids dabbling with networking and dialing into the what were they called? The bulletin boards?
Yeah, or there's the Gopher, there's a bunch of them.
I was dialing into bulletin boards before most people were had their moms.
I was downloading those conspiracy files like it was going out of style. Do you remember like the files of the Z?
Of course oh my god.
Oh yeah, I was nuts about those things.
Man. So some of the ports that you may know that are universally reserved are port 80, and that's for www traffic or HTTP traffic. There's also a subset of that which is 8080. I don't know if that's officially recognized, but it's often used as a www port as well.
Yeah, and it's usually kind of like an admin port, so to speak.
Right.
Sometimes
21 is universally reserved as FTP. 22 is SSH or SFTP. SMTP, simple mail transfer protocol.
Yeah, or message.
Simple message. That's port 25. That's email server. 3389 is the Windows remote desktop port, and 5900 is the VNC port.
Right, and like HTTPS sites, when you see that like a SSL lock, they go over port 443.
Yes.
You know, so there's like a ton of different. 23 is secure FTP. There's like a ton of them, and they're all very standard. But you can just search the internet for reserved ports.
Right. Yeah, but this is just an example of something that you may have seen throughout your time. Let's go through a little animation on how a network communication can happen.
Yes, let's.
All right, on the left side, we have a client, and what is the client going to do?
The client is going to send a request into the network, and you see the 00110. So that goes into the one, and it gets routed to that request must have a destination IP address.
Right.
So the routers on the network are going to route that request through the network and find the server and send that packet of information into the server.
Right.
So it's actually not going to send it into the server. It's really going to just excite the network that the server exists on with that information. And the server will be listening on the port that this is traveling on with its destination. So keep in mind, other servers in the network the server's on can see this traffic, which is why like encryption is very important when dealing with socket programming.
Oh, yeah, and every single time that packets hop from point to point, on its way to the destination, there's often a copy of it. And the reason why, that's part of the TCP protocol, where the router makes a copy of a packet, forwards it to the next hop, and if the next hop timeouts or fails, it takes the copy and sends it to a different hop.
Right, and any computer on any of those networks along the way can pull it out of the air and read it.
Exactly. Like, I'm sure you guys have heard of packet sniffing.
Right.
That's what that concept is. Or there's also like man in the middle, where you put a machine on a network that acts as a machine, and you behave like that machine, but you're maliciously taking information coming through your machine
and acting like you're the server.
Exactly. So
the server kind of like sniffs the traffic and it sees this go by and it's like, oh wait, that's got my IP address on it, so I'm going to grab that, and the server pulls it in.
What are some common types of socket protocols? Most of these you've heard of. You've heard of IP, Internet Protocol. You've heard of TCP, Transmission Control Protocol. UDP, which is User Diagram Protocol. And then ICMP is Internet Control Message Protocol. And we're going to give a high-level overview of what each one of these protocols is and how they're used.
Okay, and keep in mind, when something's a protocol, it just means that it abides by like an agreed upon standards of behavior. So there's like some sort of standards committee out there, and it says, if you consider yourself to be an internet protocol or a transmission control protocol, then you're going to behave this way.
You have to do exactly this.
Otherwise, it won't work.
Yeah, and that's how we're able to get an iPhone to communicate with your PC, you know.
Because there's agreed standards.
Because even though they're both different platforms, they both use different languages, the hardware is different, but they've all agreed that the software level is going to behave this way. Even if the hardware level is different, the software level behaves the same way. And let's talk about Internet Protocol, which is the grandfather. Well, I guess not. I guess it's the combination of protocols that is the grandfather, but this is a big one.
So this is the addressing protocol that is responsible for like how to get packets to find different locations. So like this is like the Garmin of all data, you know, the GPS of all data. So what this basically does is it's an internet protocol that specifies like a number, and that number is going to be your IP address. And that IP address is structured in such a way that when it hits another router, that router will go to the next closest router, and the next closest router, and the next closest router to the number that you specified. So it's like the packet will come in with an IP, an internet protocol address, and it will say like, I'm looking for this guy. I don't know where he is, but he's probably that way. I'm looking for this guy. I don't know where he is, but he's probably that way. And eventually, you'll get to that guy.
Yeah.
That you're looking
or even more generically, I don't know where he is. I'm just going to send this to someone else who might know where it is.
Right,
and
exactly.
Since the packets are traveling at, you know, oftentimes the speed of light or shortly below that, the amount of time that it takes to get to its destination is often instantaneous in human time.
Oh, it's weird. Yeah, I mean, like a packet will travel from here to Africa and back in like milliseconds. It's crazy.
And you're like pinging your next door neighbor's house. And like it goes to Asia somewhere, and then it goes to England, and then it comes back. And then like you could be downloading a file, and every piece of that file that leaves the same server took a different track. Most likely, the majority of them took different tracks to get to where you are, depending on the current conditions of whatever subnetwork they were on at that time. So you're getting pieces of that file from all over the world, even if it's just coming from a web server that's down the street. So let's talk about TCP. Now, some people call this, I call it Transfer Control Protocol, but I believe that in most textbooks it's called Transmission Control Protocol. I believe that either one is acceptable.
Yeah, I always call it transfer.
I think that when Brian and I were kids and we were learning this stuff, it was that, and then maybe later they officially changed the name. I have no idea. But it's basically a protocol that sits on top of the IP protocol. Now, as Brian was describing, the IP protocol designs a series of address numbers that uniquely identify machines on a subnetwork, which is a local area network, or a large network, which is a wide area network. Now, we're not going to go too much into that, but also know that IP is responsible, it's the software layer that's responsible for then taking each packet and trying to figure out where it has to go. Now, TCP sits on top of the IP, and oftentimes you'll see the combination of these protocols TCP/IP.
Right.
TCP/IP is the protocol, or the combination of protocols that rule the internet. And it is responsible for an orderly delivery of data streams from one process to another using a computer network. So IP will help it get there. TCP controls the flow of the data getting there so that it makes sure that it gets there when it's supposed to get there, how it's supposed to get there.
Without the TCP side of it, you like maybe only half of the message gets delivered.
Yes.
You know, it's like a mess, you know.
Yes.
And so this makes sure, like, did we get everything? Is it all in order?
Yeah.
Because you might transmit a packet that's like a big old fat thing. And if half of it, like, it's going to go in chunks.
Right, like your datagram is going to be broken apart into packets, and they may not all make it to the destination. The thing about TCP that it does is it also provides a robust layer of replies, and that's how when a router receives a packet and it forwards it to the next router, if it times out or if it does not, the other router is unresponsive or it receives a failed, it will then take that message and then send it off to another router because that reply, it didn't successfully know that the next router got it. And if that doesn't happen, it will continuously attempt to throw it to any hop that it can to get that packet moving.
So TCP is kind of like, it kind of has like a UPS tracking number in it, you know, and you anytime it gets to the next destination, like now your package is in Boston, you get like these acknowledgments sent back to you, and you can kind of see it all the way to its destination, and then you're like, okay, it was delivered successfully. You're like, awesome, thanks.
And TCP is often implemented in situations where data integrity is a priority. So if you're downloading a file or if you're loading a website, it's important that every single packet arrives to you. And it's otherwise you're going to get a partially loaded web page. Right. You're going to get an image that has pixels missing, and that data integrity that TCP built on top of IP creates that robust, reliable network delivery system. There's another protocol that you use if integrity does not matter, which we'll talk about in a second. Right. So Brian, let's talk about Wibbit and Buzz, and they're trying to communicate over TCP. Okay. So what is so Wibbit the Frog wants to say hello to the fly, right? Mm-hmm. So Wibbit the Frog's like, hello. It goes into the network, and that comes out and routes its way by using the IP address as its mail to address. Mm-hmm. It guides its way to the fly. The fly gets it, and then he's like, what's up? It goes back into the network, finds its way through the network, and goes back to the frog and says, what's up? Yeah, now fundamentally, although this is cartoonish, keep in mind, we had Wibbit the Frog sends a message to Buzz the Fly, and he's expecting a reply. If Buzz the Fly doesn't reply, Wibbit the Frog will continuously say hello, 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 until he gets a reply. Can you hear me? It's like those Verizon commercials. Can you hear me now? Can you hear me now? Except for when the other person says yes, he doesn't shut his f***ing mouth. He's stuck in some infinite loop just walking around. Can you hear me? He's probably sitting in like a hospital right now with like a straitjacket on. Can you hear me now? 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 Can you, Mom? Can you hear me now? Can you hear me now? And he cuts his chest, So this what's up is the acknowledgement that Buzz the Fly did receive the transmission from Wibbit the Frog. Right. What's also important to note is that Wibbit the Frog could be anywhere, but Buzz the Fly knows where he is, because in the hello message, it gives the return address too, just like on an envelope. Mm-hmm. Right. The networking, the TCP/IP system was kind of like based on how humans route mail around the world, like the addressing, sub-addressing, like city, street, country, all that stuff is built into the data packet. Now, Brian, let's talk about UDP. Okay, so now if data integrity doesn't really matter, but making sure you get it like very quickly is, then you have user datagram protocol, or UDP, and this is better for like voice, or like right now we're talking over Skype. All of my voice packets are like getting sent, but it's not making sure that the packets arrived. It's just like getting them. And if some of them miss, it just drops it and says like, I don't care. So my voice over the internet is not waiting for an acknowledgement. Right. Because otherwise my voice would be like, blah, blah, blah. Blah, blah, blah. Or the delay would just be so intense that I wouldn't be able. I would say something and Brian would be in mid sentence because I never actually heard him start talking. Right. So this is it's like a water hose. Like if you just have a water hose, like you're not making sure the water gets there, you're just spraying it. So UDP is just spraying data to some address and kind of like hoping it gets there. Have you ever watched a movie or talked on like watched something online and like it gets pixelated for a second and then it comes back just fine? Yep. That's because some interruption happened in the network somewhere. It could have been some hop in South America that it came through. It could have been your local internet service provider had some small outage. One of the routers was malfunctioning. But that small outage caused several packets or several thousand packets to not deliver. Right. But then it was able to pick back up because, okay, now this different flow of traffic is working fine. And that's exactly why that happens. That's cool. Yeah. So let's take a look at a visual example of UDP at work. So here we have Wibbit the Frog again wants to say hello to the fly, and that message goes through the network and reaches the fly. Well, that's it, because there's no response. So it just gets there. He doesn't wait for a response. He just starts talking, hoping the fly gets it. He doesn't care at all. Right. He just says hello. He doesn't care if the fly hears him or responds. He just wants the fly to know that he said hi. Maybe. I don't know. Yeah. Cool. So let's talk a little bit about ICMP ICMP, which is Internet Control Message Protocol. Now, a lot of times, if you work in IT, you use this protocol often and don't even realize you're using it.
Yep,
And
that's true.
So this is used predominantly by operating systems to relay messages between different computer systems. So it's often used to see if a service is available or if a remote host is available. How many of you guys have used ping? When you say ping google.com or ping wibbit.net and you get...
Don't you hate when people use ping in like a sentence? Like sometimes if somebody's like, oh, just email me if you get that, they'll just be like, oh, ping me later.
I use it.
Man, that pisses me
Sorry,
off.
I say it all the time. Get over it.
Do you really?
Yeah, I do.
Oh, you're so...
Yeah, sorry, I can't help it.
Really?
Yeah.
You say like, ping me about it?
Yeah.
Oh, really?
Yeah.
Man, what is wrong with you?
I don't know. What's wrong with you? You gotta... I have to sit here and listen to you scratch your beard the whole time we're recording.
Hey, I've been good about it today.
You hear that? That's like 80% of the conversation is like...
Nice. I haven't been doing it today. I've been making a conscious effort.
Shave your beard, you hippie. It ain't the 80s and 70s anymore, man.
Yeah, it is.
But I mean, you guys have used ping, I'm sure. When you ping like google.com, you'll get the IP address and you also get like the time to live and all that kind of stuff. That is using not TCP, not IP, it's using ICMP. Well, I guess it's using IP, but
yeah,
ICMP is the protocol that it uses. So the main difference between other protocols and ICMP is not often used to exchange data between two computer systems. It's most often used to gain information before a transmission commences.
Exactly.
So if you wanted to have an application ping a server before you started sending a data just to make sure the host was there, that's just one application of using ICMP.
Awesome.
So let's just kind of take a look at a high-level example of ICMP. On the right, we have 3 servers. One server is wide open in the DMZ. Then we have a server 2 that's behind a firewall, so it has to go through a firewall before it will actually reach that server. And then we have server 3, which is currently down. And Wibbit wants to ping server 1. So he sends an Internet Control Message Protocol. It's able to successfully see that this server is up. Woohoo! And I get a true. Okay, the server's up. So now I want to ping server 3. So I send the ping message into the network and it can't access server 3, so I get a failed ping message. Next, I want to FTP a file to server 2. And then I try to access port 21, and it doesn't let me. The firewall doesn't let me across. Maybe it has like some source filter, like we won't accept FTP messages from Wibbit the Frog. So he gets failed. So he gets a failed message back from that firewall. So the FTP service is not available for him to use.
Right. So the firewall's blocking.
Exactly.
Okay. So you can kind of think of sockets as files, so to speak, or like a file handle. One program is writing to a file, while another program is reading from the same file.
Wow.
Yeah, so it's kind of like a virtual file handle across the internet, right? Mm-hmm. So it's pretty cool, right?
Yeah. And it's fun. So socket programming is a lot of fun.
Absolutely. So like, we could talk about this for hours. Like I know we kind of went on at a little bit of a length, but we at least want to make sure that you have some sort of like basis to understand what we're going to be dealing with. Mm-hmm. Otherwise, we're just going to be talking gibberish. So this topic could have its own course just on socket programming in different languages, different uses, different ways. So we're just kind of like doing like a high level, relatively high level. We gave you some good meat and potatoes, mm-hmm. but.
So let's take a look at the socket class. Now you can take a look here at the constructor summary. So we have a default constructor, which just doesn't do anything.
Right.
We can also connect using an iNet address object and a port.
Nice. That's awesome. Look at that.
We can
an address and a port. That's all you need to find out where you want to go.
And if you didn't want to instantiate an iNet address, you can do a string host and an int port. So it's fairly easy to instantiate a socket object. Let's take a look at the method summary for the socket class. Now, we have a close, so we can close a socket. Connect to connect the socket. Get iNet address. Get keep alive. Get input stream. It returns an input stream for the socket.
That's awesome.
So you can remember how Brian was saying you can treat sockets like files? Look at that.
Right. So that's like a binary file stream, right?
Yes.
That's cool.
We also have other stuff like just get the port, which just returns the port that we've designated.
Right, the port number.
Yep. And there's other stuff. Is closed. We can just check to see, has this socket been closed? So maybe
is it connected?
Maybe you could if you're writing a program, you could reopen the socket if it's closed. So set like a timeout, shutdown, toString, which just returns some other data. So
awesome.
That's kind of a little taking a canal, down Venice. just swimming around, looking at the buildings. That's what we just did with the socket class.
Nice.
Now, Brian, let's talk about the server class.
I just saw the strangest thing.
What?
Some guy just walked by my window, right?
Yeah.
And it's like raining like outside.
Mm-hmm.
And this guy's like drenched.
Mm-hmm.
Like his shirt's drenched, his hair's drenched, like he just looks like a wet dog, right?
Mm-hmm.
And he's carrying a pink umbrella in his hand. But the umbrella's like not open. It's like closed.
What the hell's wrong with that guy?
I don't know. So I don't know if he's like doesn't want to look like an asshole carrying a pink umbrella, so he's just wet. I don't know. It's really funny. Anyway, sorry. It was just hilarious.
He's probably on his way to Abercrombie and Fitch, and he wants to feel cool.
Yeah, but he's just like drenched. Like what the Anyway, sorry. Cool. Okay, so now let's look at the server socket class. So this is instead of the client socket side, this is like specifically the server socket class. This is going to be on the listening side.
Mm-hmm.
So generally speaking, we don't need an IP address for the server socket because it's going to be like whatever we're naturally on. But in certain circumstances, servers can have multiple IP addresses.
Right, like you can have like 10 network cards.
Exactly.
And you can have each one dedicated for a specific purpose.
Right, so we may want to bind it to an address, but generally speaking, we can just create a server socket, which we'll define out the details later, or we can create one with a port. We can also create one with a specific backlog, a listen backlog, or we can create one with a port, a backlog, and which address to bind it to. Most common, you will probably only have like one IP address, and you're just going to be doing a server socket and a port. But if you need to bind to a particular one, you can. So we can accept. We have an accept method, which returns the socket, and so that listens for a connection to be made on the socket and accepts it. We can bind to a socket address. We can close, we can get a channel, we can get an internet address, which returns the local address of the server socket. So if it's not really known, because sometimes your internet address might be dynamic, it might change all the time. So, if the internet address changes while you're running, you might want to send a signal out saying to the client saying like, oh, hey, I just received your thing, but just so you know, my address changed. Whatever, all sorts of stuff. We can get a local port, we can, get the SO timeout. What else we got here? We can see if it's bound, if it's closed. We can do a toString, and it just kind of like returns the address and port, just as convenience. We can set a socket factory, which we don't really get into now. We probably won't cover that in this.
No, we're not. We're not cool enough, Brian.
Yeah, it's kind of, it's nice. It gives us basically all we need to kind of get up and running.
Absolutely.
And that's one of the things that Java does well is that it doesn't over-purpose the classes. Like there's other things that we're going to do with sockets, but there's other objects to do that kind of stuff. So like any one class doesn't have, it doesn't try to be like a coverall and do like every single thing you could possibly want to do. It does what the idea of that class does. So that's just the server socket class, It's good. It's good.
Now here is some code that will actually open up a server socket. So at the top we're importing java.io star and then java.net star, and we're making a class a public class, which means it's the code file has to be called wserver.java, and inside of here we have a public static void main, and this throws an IO exception, so there's no exception handling, and that's just to kind of clean it up a little bit, so you don't have to deal with watching try catch everywhere.
Yeah, and same with like the while one is one, you just want to see it run. We're not. Yeah. This is just anyway.
Yeah. So you actually have to break out of this program, but it's okay. Whatever. We're just testing it out. So let's just kind of create some null instances. So we're going to create an instance of server socket called server, an instance of socket called client, and an instance of print writer called output stream, and a buffered reader called instream. Nice. And those are all set to null. So right before we jump into this infinite loop, we're going to set server, which is the instance of server socket, equal to int.parseInts arg0. So what we're doing is we're taking in an argument from the command line, and that's going to be the port number.
Nice, so very cool.
Right, so if you want to say this program space 8080, we open up a server socket on 8080. So then we get into this infinite loop, and we're actually going to pause on this line, client equals server.accept. So the server is going to sit there and do nothing. The only time that it will change is if a client connects, we'll then get an instance of that client. So you see at the top where we have the socket client equals null? Well, now we have an instance of that client. So we've accepted a message, and we're going to set the output stream. Now check this out. This is awesome. We're going to make a new instance of print writer, and on that client instance, we're going to extract the output stream.
Cool.
Yes. And that's what we're going to be writing to. This is cool.
So what we're doing is we're kind of fluffing up that output stream that's on the server socket, and we're encasing it in a print writer for convenience. Remember, the print writer is like a luxury class.
In the print writer, we're going to be using that to write back to the client. And it works the same way as if it's a console, as if it's a file. So then if we look at the in stream, that's a new buffered reader, and what that's going to be is we're going to make an encapsulated inside of this constructor, we're making a new input stream reader, and we're going to be extracting the input stream from the client. Now what that represents, so if outstream represents the communication from the server back to the client, the instream represents the data coming from the client into the server. So if you look at this very next line, we have string client message equals instream dot read line. we are then actually accepting the message from the buffered reader. Remember when we were doing, Brian, on the console, right?
Yeah.
And we were doing read line from the console?
Yeah.
This is exactly the same. We're accepting a buffered reader, and we're reading in a line of text from a client.
It's awesome.
Beautiful. And then after this, we're going to formulate our response. Now, our response is going to be simple. We're going to just take the client's message, set it all to uppercase, and then we're going to just print that out to the screen.
Cool.
And then outstream dot print line. So we're printing a line
back into the socket.
Yes. So now that representation object, which is that print writer that represents the communication from the server back to the client, is going to then send out a message, and it's going to be the same message that I got, uppercase. And then we're just going to do in-stream close. So we're closing the communication coming from the socket to us. Then outstream close. We're going to close the communication from the server back to the client, and then we're going to close out the client, and then we're going to go back and listen for another transaction.
Yep, and server.accept will just wait until another connection is accepted. Isn't that awesome?
That's so cool.
Like, that's that easy.
Yes, and
very cool.
When you look at how Java has broken this apart, it's genius.
Yeah,
it's so good. Now, Brian, how does the client side work?
All right, so now here's on the flip side of the coin. We'll look at creating a client socket and then communicating out to the server that we just created. So we have a socket client, that's null, and we have a print writer, which is the outstream, and a buffered reader.
Oh, so it's like the same thing.
Interesting.
That's awesome.
So the client is going to be a new socket, and we're going to pass it localhost, since we're just going to run these both on the same computer. And then we're take in the port number as an argument from the command line, just like we did before.
Hold on. Sorry. I just inhaled some coffee.
Well, that sucks.
Oh, the Java gods are pissed off at me now. Okay. Sorry.
Did you just throw up?
I kind of wish I did. Now I had like a weird taste of coffee that every time I inhale I can...
Oh, I ate like a ton of guacamole and then went and worked out.
That's not a good idea.
No, and it was like coming up and I threw up like a little bit of guacamole. It was so gross.
Man.
I tried to swallow it, but I was all thirsty. It was nasty. Anyway. The horror.
The horrors.
Okay, so that'll create a new socket that will connect to our local host on the port that we specify. So now we create an outstream, which is our convenience class print writer that lets us just like print line to it, which is great. And we're going to be passing it into the constructor for that. We're going to tie that to the output stream of the client. So client.getOutput stream, which will return the client's output stream that we've connected when we created the new socket connection. And then we pass it true. So anyway, so we have a new outstream, and then we create an in-stream, which is going to be a buffered reader, and the buffered reader is going to be tied to a new instance of the input stream reader that we get from the client, so client.getInputStream. Isn't that great? So now we have a buffered reader and a print writer that's tied to the socket that we just instantiated.
Right, so when we had that outstream instance, that represents us sending data to the server. In-stream represents the server sending the data back to us.
Right, and if the server is not available, the socket instantiation will fail and the program will just throw an exception.
Right, and which is why you're supposed to try catch this, but we're being lazy by doing throws.
But just so you know how that works,
right.
you know. Mm-hmm. So then we're just going to print out, we're sending the message, and then we all we do is just outstream print line.
So it's like we're sending to the command terminal, but we're sending it to a computer somewhere else on the other side of the world.
And that'll be the second argument we pass in from the command line. And then we print a line received message, and then instream.readline. That's it. And then we quit the program. Isn't that awesome?
So nice.
Yeah, it's really cool.
Now we have two Whippet.net virtual consoles here. We're going to do kind of a demonstration of how this works. So first we compile the server, we compile the client. Next, we actually run the server. So we're going to run the Java interpreter against the class wServer, and we're going to open that up on port 1234. So you can see on the right-hand side, we just have a bunch of instances that are null. But now I'm going to create an instance of a server and just set that equal to port 1234.
Cool.
Then we fall into this while loop, and then when we hit the client, the server.accept, now our server is open and listening, and it's going to sit there in an infinite loop until we receive something that comes from the client. So now the client executes. The client says, I want to connect to localhost because that's hard-coded on port 1234, and I want to send, hey, buddy. So we have these null instances. Now we're going to instantiate the client. So the client equals new socket localhost port 1234.
Awesome.
Now, the input and output stream, as Brian was saying before, is then going to instantiate the two-way connection between these two, where the outstream represents the client to server, the instream represents the response from server back to client.
Right. Now, keep in mind, those are established on the sockets constructor. When we create the new print writer and buffered reader, we're just now creating a convenience class that references those connections.
We're allowing our program to interact with that.
Right,
yeah.
with them. Mm-hmm.
So then we're going to do system.out.println to tell the user we're going to send this message. So this is like, think of this as like AOL Instant Messenger in 1997, right? So we actually send, hey buddy, across the wire, and now the control comes back over here to the server.
Nice.
Yep, and the server has established its print writer and its buffered reader, and it's going to use that buffered reader to intake from that buffer a line of text. And that line, since the other side did a print line, this side's doing a read line. So
Very
it
cool.
accepts that transaction. So it converts this stream into ASCII text or Unicode. And then it's going to formulate the response, which is just a string of the client's message set to all uppercase characters.
Cool, cool.
Then we print out to whoever's monitoring the server what we received and what we're about to send back.
Nice.
So when Brian's sitting there at his terminal with nothing to do, just watching transactions come in, he sees this. Because Brian actually monitors the Whippet.net logs all the time. He just has nothing better to do, but he does like the tail -F on the log file of the Apache server, and he's like, wow, man.
Look at
it go. And then we send that response back to the client using the outstream.println method.
Awesome. Very cool.
All right. That's great. Here's where we left off. But at this point, we can then use that in-stream instance to read that response, and we can print out hey buddy back. So this is the actual message that was sent back to us from the server. And then the server goes ahead and closes all of its instances.
Very cool. So if we wanted to do this without using localhost, you can change it to take in another parameter that is an IP address on the client side, and then you could set this up on two different computers and run it and talk to two different computers.
Yeah, right, yeah.
Awesome. So how can we expand on this concept? You can build an extensible client and server class that can be imported into a program with ease.
Yeah, kind of like with that thread class that we designed. We build the robust infrastructure, and then we import that into a class that has a specific purpose.
So let's say like we wanted to do something like that, and we call it like Whippet server, W server. So that extends the thread class. Right. So like let's say you wanted to have like a threaded socket, right? So you can kind of like spin up a socket and have it doing its thing while your program's doing something else. And when it gets stuff, it sends it in and so on, right? Here's where we extend the thread class. And we say, we have a port number. We started at -1. We determine if it's running. We create a server, a client, an outstream, an instream, and we have a constructor. And the server can also take in the port number as a constructor. We can get the port, which will return the port number. We'll set the port, which sets the port number to something else later if we want to. Determine if it's running, and to be able to set it to be running or not. And that's protected, so that's like an internal thing. Right? So what we can do is when it runs, when thread runs, we can set is running to true, and then we can try to create a new server socket on the port that was passed in. And we'll print line if it can't. And while it's running, while this server is running, like while we set that boolean true, we'll try to accept a connection, and we'll catch it if we can't, and we'll try to create an outstream and an instream just like we did before, and then print if we can't, and then we'll also try to just print line the result of processing the message, and process message just returns the message. So this, but you can change how you implement what it does instead of just printing it. But
Right. So this is kind of exactly like the thread class, where everything that has to be that way, like the run, because I want to make my class work like this all the time. I'm going to handle the exchange, but I'm going to allow the user to override how he or she processes that message.
Exactly.
So in this case, I will allow you to process message, but I still want to have control over getting it and sending it back.
right. So when you instantiate the server, you can override process message to do whatever you need it to do.
Yeah, and as default cases, it just sends the client. Yeah, it sends the client
Just sends it
back
back.
exactly what it got. Now, if
Yep.
we take that same concept into a client, now it's common for server sockets to be threaded. I mean, it makes sense. Unless you have like one program that's 100% dedicated to a socket, which is not common, you want it to be threaded. A client, not so much. You can, inside of your program, have a thread that spawns a client, and that's fine, but it's not often that you'll see that type of thing, unless you have stuff like progress bars of, data coming in and all that stuff. But whatever.
Yeah.
Let's just put all that aside. So we're going to make a class called wclient for Wibbit Client, and it's a public class, so it's encapsulated inside of a file called wclient.java. And here we have the private string server, private string port, which is -1 because it's just a set value. The client is null, and then we have a print writer and a buffered reader, which you've seen this already, right?
Absolutely.
So when on the constructor of wclient, we're going to take in a port, and if you just send the port, it will assume the server's local host, and it will set the port. Overload a constructor will allow you to pass the server and the port, and then it will just set those two values. So once we have that established, all we have to do is say instance.sendMessage, and you can see that this throws an IO exception, which means when you send a message from the calling code, you have to try catch it. And that's a good place to do that, because if this crashes, you want that to bubble up to the parent. So when we do send message, you take in a message, we then make a new instance of client, we then set our outstream and our instream, send the message to the server using outstream.println,
cool.
receive the message back from the server, close all of our connections, and return that response that we just got back from the server.
Nice. Very cool.
So again, this is 1995, and we just wrote Instant Messenger. Get a time
Nice.
machine and go back to 1995. You'll be a rich bastard. Now, Brian, how do we drive this program? Now, Brian, how do we drive this program?
All right, so here's an example of putting this to use. So in our main method, we create a new W server instance. We'll call it my server, and that's going to be on port 1234. And what we're going to do is we're going to
Override.
Yeah. Sorry, I get those confused
Yeah,
sometimes.
I think we both get them jarbled up.
I'm gonna start calling it swap out.
That's perfect.
Replace.
Perfect.
I mean, override over, like, it's just whatever. So we're going to swap out the process message method with one of our own during the instantiation of this. So in that block, we basically just say public string process message, string message, just like it's supposed to be, because that has to be like that. And we're going to do whatever we want. So in this case, we're going to say if the message dot lowercase is by, then we're going to tell it that the server is no longer running, and we're going to close the connection. And otherwise, we're just going to return got it.
Right, so by setting set is running to false, when the infinite loop that's running, because there's a condition in the server infinite loop that while is running. So if that's false, then our thread will die.
Right. Cool. So then we just say my server start. We just start it up. So that gets the server kicked off. So then we create a new instance of the Wibbit client, my client.
Now, real quick,
it's going to be
before you continue, Brian, if we did not inherit from the thread class for the server class,
right, yes.
that dot start line would just stay there, and we couldn't go below it. So since we did dot start, it creates a thread.
Right, and don't forget dot start calls dot run.
Yes, right. So then dot start will then thread it off, so then we could actually have the exact same program have a client that loops back into itself.
Right, so server's off on some other thread someplace, and we're still executing. Mm-hmm. So then we create my client, which is a Wibbit client, and this new one, we're going to pass a 1234 as the constructor parameter. And then we're going to create a string response, and that's going to be blank, and we're going to try to get a response from the myClient.sendMessage. And we're going to pass it, hey buddy. Mm-hmm. Now, so long as it's not the word bye, it's going to keep running. Mm-hmm. So then we get a response back, and then we're going to try it again, and we're going to send it the message bye, which should close out the connection to the server. Everything shuts down, and the program exits.
Beautiful, beautiful. So just to kind of use the Wibbit.net virtual console, patent pending, To demonstrate this, we just compile our Java bytecode files. We execute the server. So as Brian was saying, we start the server, and in the same process, we're going to then send a message to our server thread. Our server thread is going to return got it because it just received something that was not by. Then we write out the response to the screen, so we say got it. Now we're going to send the server by, and there's a condition inside of the process message method that says if it dot equals by, because remember, Brian, we can't do overloading. We can't do equals by. That's one thing Java failed on big time.
Yeah.
So if it dot equals by, then we're going to then set that value to false. We're going to write out that we're closing the connection, and the server thread's going to die, and the program will end.
Okay, so now let's inherit the server, the Wibbit server class to further simplify this. So here we have the driver, and we have a new Wibbit server class, like spelled out Wibbit, which extends W server. And what that's going to do is it's just going to call set port on the port, if you take in the port number as a constructor, and then we implement a new process message where we set this. So instead of doing this in the instantiation, we're just creating a new class that extends it and swaps out the process message method. And so when we go back to our driver, we just say, Wibbit server array server listeners, and we create 10 of them. Why not? So for each one, the current port is 1234 plus I. Yeah? Kind of cool.
Right.
So we'll have like a 1234, 1235, 1236, 1237, and so on. And so the server listeners I is a new server. So now we're creating like an entire array of ports that are all threaded off doing their thing. It's pretty crazy.
Right.
So then we just print line opening socket on port, the current port, and then we start listening. Isn't that cool?
Yeah.
So yeah, it's awesome.
So we just created 10 unique listening sockets. Now, for those of you guys that may be a little confused, I just want to make sure that we explain this. So you see above when we declare the array, we call it a W server, and then when we instantiate the instance, we call it a Wibbit server. Well, remember with inheritance, a Wibbit server can impersonate a W server because it has extended the W server.
Right.
So even though those two data types are different, it will still function the way that you want it to function. You could say Wibbit server array, but in this case, we wanted to show it without doing that.
Right, in case you wanted to go back and forth with them. It's less restricted.
Absolutely. Wow, that was a lot, man. That was awesome.
Yeah. So I hope you guys have like a pretty solid understanding of sockets now. And if you have a program that needs to listen like on port, 5555 and 7777, you can just spawn off two different threads, have them both listening, and then have them pass calls to something else that spawns off an event sequence that handles the message that comes in, when it comes in, whatever you want to do.
Boy, do we have a real treat for the Wibbit.netters today, Brian.
That's right.
That is correct, Bobby. What'll he win? A new car.
So we talked about threads and we talked about sockets, and then we smushed the two and told you about both of them together, which is awesome.
Yep, both of them.
Now, what we're going to do is, just to show how
wicked
cross-platform compatible Java can be, we will, in the lab, build a server on the Mac side and build the client on the Windows side and get them to talk to each other.
Well, golly, Brian, that is ridiculous. This is a completely different operating system. How will this function? We will find out. Coming up next. All right, Brian. So when we have our two servers, so here's our Mac and here's our Windows 7. I think we had discussed that since Mac.
That's a really fast monitor switcher.
Yeah, well, I move my camera extra fast for.
And the resolutions are identical. It's really cool.
Thank you for f***ing up my thought pattern. I'm lost. I have no idea what's going on now. Oh yeah, so we're gonna make the Apple machine here, the server, because that's just how she is, Brian. She will accept anything in any port we specify. She's just that kind of gal. I really hope ladies aren't watching this video, because that was slightly sexist, but I didn't mean it that way.
But Macs are softer and more feminine, and Windows are a little more you just kind of f around the registry, and it's a little ragged.
Yeah.
Look at the recycle bin font. It's got this heavy-handed shadow, and it's all blah, blah, blah. And then you look at the Mac side, and it's
yeah, no, look at this. Look.
It's all like smooth and
You got little smiley faces here. I'm surprised there aren't little flowers and stuff here.
Oh, there are.
Thank you for using a Mac.
They're just flashing them really quickly at you.
We have a docket. It moves around. Okay.
We like to be wiggly because we're a friend and a confidant.
All right, Brian. So, just like we did in the Objective-C course, now those of you guys following along that don't have two machines to work on like we do, you can build this. You can build this on the same machine.
Whatever.
We just want to demonstrate cross-platform stuff, and then maybe at some point we'll take the class files and we'll swap, and the Windows will use the class file compiled from here, and then that way we can show that
that'd be crazy.
Something compiled on Mac will work in Windows, something compiled in Windows will work on Mac.
That's nuts.
And that's really the only reason to use Java, because outside of that, Java sucks. I mean, we like Java. We like Java. So
Java's great.
we're going to open Text Wrangler. So here is our Text Wrangler
Alrighty.
text document. And then we come back here to Windows. We're going to make a
far superior Notepad++.
Yes.
I would love to someday either see or make Notepad++ port for the Mac.
Yeah, maybe. So, Brian, since Mac is a little bit of an attention, I guess maybe we should service Mac first and build the server. Okay.
Okay.
So we'll go ahead and we'll file and save as, and on our little desktop here. Oh wait, yes, we have whippet.net drive, and we'll call this wserver.java.
That's ridiculous.
That's the greatest thing I've ever.
This changed lives.
Yes, lives will be changed, Brian. Okay, so we'll make a public class and we'll call it wserver.
Yeah.
And then inside of this, we'll just
have an entry point.
Well, why don't we build the class and then we'll build another class that actually executes this.
Okay, that works.
Yeah. So, Brian, let's talk about the wserver class.
All right.
Alrighty
So
then.
this class is basically going to be the thread class.
Right. It will implement a thread, right?
So this is going to extend the thread class.
Okay. So we're going to want to import java.io.
Oh yeah,
.star.
absolutely. Because we're going to be just like writing that shit into those. We're just going to be jamming that shit in there.
And then we're also going
jamming.
to want the network API, right?
Oh yeah, java.net.
Right. So whippet.java.net.
Not to be confused with the service provider either.
Yeah. Oh, yeah. Nice call. Okay, Brian. So now what do we do? Okay, Brian. So now what do we do?
Okay, so let's extend thread, the thread class.
That's a fantastic. That way we can run this as a thread.
Yeah. It's kind of. Would you consider that cheating? No, it's not cheating.
It's not cheating. That's not cheating at all. That's actually very, very clean.
Okay, so we're gonna have a couple fields, right?
Okay.
We'll have a port number.
Okay, so
Just editor.
private int ports.
Yep.
Okay.
And
what else?
we can set its default value to like -1.
Okay, because there will never be a negative port.
Yeah.
Oh, why can't I have an unsigned? Oh, it's Java. Listen, my problem with no unsigned values is if you're working with a number that can't possibly be negative, why give it that option? Why give it the option to be a negative port number when you don't have negative port numbers?
Don't know the answer. It's a mystery.
It's a mystery.
Life is a mystery.
All right, Madonna.
Okay, so
Lady Gaga. I don't even know the difference anymore between those two.
So we want to know if it's running or not, whether the server is like currently in a running state. So we'll make it like a private boolean, and we'll call it is running with an underscore.
Okay, so like is running like this?
Yeah, and we'll make it false because obviously like
it's not running.
Yeah, it's not running unless we say it's running. It's not running.
Right.
So then we want to have a server variable that's going to be of type server socket.
Oh,
which we kind of like went over.
Right.
Something that Java's like here's like a server socket. That's for you. You can have that. It's something you can use.
Right. What do you want to call this?
We'll call it server.
Server, and we'll nullify it.
Yeah.
Wait, we're in Mac. We're in Mac. Ah, no, sorry.
Yeah, right. Don't scare me.
I feel weird being in Mac and not saying nil. It's weird.
Or the server socket has loaded.
Yeah.
So then we're gonna have another one of type socket. So we have the server socket, then we just have a socket.
Okay.
We're gonna call it client.
That'll represent the client.
Yeah.
Okay, and that's gonna equal null as well.
And the client will be like when we accept the state from the server, when the connection is established, it will return us like that handle.
Right. So we can fire back. Right.
So then we're gonna have print writer, which is gonna be we'll call it like an outstream. O stream or out stream.
So print writer?
Print writer.
Okay. What do you want to call it?
Without the You got
print.
Printer writer.
Print writer. Mm-hmm. What do you want to call the variable?
Outstream.
Okay, so this is going to be what we outbound to the client?
Yeah, and we'll just start null.
Okay.
Actually. And then we'll also have a buffered reader, too.
All right, so a private buffered reader. What do you want to set that equal to?
In-stream. So these kind of like parallel the server and client, you know?
Right.
So you have like the server, which is the in-stream, and the client, which is like the outstream.
Okay.
Whatever. So
I'll do what I want, fool.
We'll have like a default constructor, but won't do anything.
Okay.
We'll just put it in there just for the fun of it, you know.
Like that?
Yep.
Okay. Now what?
We also need the little empty parens.
God.
Oh no.
I don't know what's more annoying, Java or you.
Eat your food, Tina.
What is that from?
Napoleon Dynamite. When he's feeding the
Oh yeah. What a great movie that is.
I didn't watch that. I
love that movie.
It really was pretty. It was well thought out.
Yeah, very well.
It came out of nowhere too. It was good.
And I was surprised that it was like pushed by MTV, which has been putting out nothing but garbage for like 15 years.
Yeah, I mean they haven't put out a good movie since Joe's Apartment.
Yeah, right. And that was like 1994.
Yeah,
man, MTV sucks so bad now.
Don't they? Okay, public int get ports.
Do you remember when we were kids and MTV would have weird stuff on it, like music videos?
Yeah, that's right.
Yeah, now it's all just like, oh my god, I was at the mall and like my hair, blah, blah, I got crabs, I'm a pregnant teenage woman, blah.
Kanye West made a joke in his new album.
Yeah.
I'm going to say this is like as white of a guy as possible. Yeah, he made like a joke in one of his songs, which is really funny. He basically said like, I'm not going to do something, like, the chances of me doing this is lesser than even MTV playing a music video.
Oh.
So it's not going to happen, which is pretty funny.
That is funny.
He said it in a smooth sort of way. I don't remember how he said it, but I thought it was funny.
All right, Brian. So we're making a public method that's of int type, and what is it?
So this is going to be the port getter. So this is going to be get port.
Well, do you want to set a constructor that will take in a port number, perhaps?
Oh, yeah. How about that?
So we'll
How about that?
How isn't that
something? So let's take in a port number for our constructor.
Okie dokie.
We could, like we talked about before, we could be like assigning an IP address, but in our circumstance, and
we're being
the default nick. That's not going to happen in this case. So
not gonna do it.
So now let's do our getters and setters. Let's do our getters and setters. So we'll do the get port, which is a public integer get port, and that's just going to return our internal variable. And then we're going to do a set port, which is going to be protected void, because obviously it's not going to return anything, at least in this case.
Okay.
They return like a true that it successfully set it, but that'd be dumb.
Protected void.
Set port.
Set port?
Yep. And that's going to take port as a variable, a parameter.
Okay.
And it will just make internal port equal external port.
Okay, that's fine. So
we'll just link it up.
It's literally aluminiumly. Sorry. Okay.
I am literally going to burn your building down right now. I'm literally so poor. I will burn your to the ground right now.
See, and we're doing this as protected, Brian, so that if we inherit this class, we can access this, but publicly we can't. And you also notice that the port variable is private, so you can't access this if you inherit it. So the only way that you can interact with this and set this is through the... Well, no, for the love of God, don't do that. If you value your client's usage of your software, you won't use reflection. But we'll just set this as protected, so if you inherit this, to change stuff, you can...
You can also use the condom keyword. Okay.
Nice.
So we also want the getter and setter for is running. So we'll just, and since it's running is kind of like an action statement, we'll just say public boolean is running.
Okay.
And then that's just going to return the internal. Yeah.
I got to do a return statement, don't I?
And then we'll do the setter, and that's going to be protected void as well. That will be set is running, or we could call it a set whether or not the program is running. Yeah, and we'll take it. Yeah, that works.
We'll take it deep in there. Take it deep in there.
It's running.
Is raining?
It's raining.
Is Rihanna-ing?
Is raining. Java.
Hallelujah.
You know how bad that would hurt if it was raining men? That would be a bloody massacre.
That would be the worst day of everyone's life.
That would be like Armageddon. You know what I mean? I'd be like, what the is happening? This is a mess. Like cars are shattering and buildings are being ruined. Like
people are
dying. Like dogs don't stand a chance. Like water turns blood red, you know, like it would be f***ing horrible, you know. And then meantime, this like f***ing crazy lady's like, "It's raining, man, hallelujah, it's raining, man," and you're like, really? You're that f***ing desperate? That's gross.
I also don't really think that she was speaking in literal terms.
I think she was saying it literally.
Literally. All right, Brian, now what?
She was a Satanist, you know.
Was she really?
I don't know.
Well, she is now. We're changing history right now.
She was friends with Dionne Warwick.
Okay.
From the Psychic Friends.
What? No. What's
You don't remember that?
No.
Dionne Warwick used to advocate the Psychic Friends network to like call for like before Cleo, Miss Cleo.
Yeah.
It was Dionne Warwick, the singer.
I don't remember. I'm sorry. I never followed the phone psychic revolution. You know, it's just I was still a kid in the 90s when everybody's mom did that. But you know, I'm sorry.
I was babysat by a lady who had no nose and smoked and was on an oxygen tank.
Oh,
so I got to see a lot of those like.
Because you watched daytime TV all the time.
So she just watched soap operas. You know. Yeah.
All right, so is running has been set and has been protected. Now what?
Okay, so she really had no nose. Really weird. It was like Bert and Ernie, but he just, you know, it was gross.
Wow, that would be traumatizing.
So let's have a method called run, and that's what's going to be overloading the run method in the thread. So when we start the thread, this is what's going to be kicked off.
Okay, that sounds fantastic.
And we also don't want anybody to like with this after we implement this.
Okay, so we'll final.
Right, so we'll lock that shit down.
Lock it down.
So final public void run.
So run all lowercase, mind you. And inside of here, we're actually going to be putting our server code.
And don't forget to return void. That's a programmer joke. Okay, so
what kind of programmers do you hang around? I've never heard anyone make
myself.
that joke.
I entertain the shit out of myself.
You sit all by yourself in a cubicle all day. What the f*** are you supposed to do?
People also got crazy at work, so I'll be sitting there like... you know what I mean? It's crazy.
Just start giggling to yourself.
Yeah, right. They're like, holy shit, dude.
I don't giggle to myself, but I do talk to myself. I'll be like, is that right? No, wait. Oh, hold on. No. Oh, got it. Yes. Okay.
There's a guy like behind me that all day long is, you stupid piece of shit. Go yourself, you piece of shit. God, is this? God. And he starts like slamming in his keyboard like a monkey. You know what I mean? So he'll take his keyboard and just
this guy's your workmate?
Yeah, and like slam, you know? But then I'll go like tepidly ask him a question because he's like kind of scary because he's like crazy, right?
Yeah.
And I'm like, do you have a say? He's like, oh yeah, sure, what's up? You know? I'm like, I was wondering about this. He's like, oh yeah. Oh no problem, I'll show you. Okay. So, and he's like very warm and like happy and loving, you know, and he has like very, very nice. And then I'll leave. I'm like, okay, thanks, that was great. And I'll leave and he's like, God, it must just like help him with his train of thought, you know.
So, does he code in Visual Basic for living by his chance?
Yeah, the odds are high. The odds are very high. Actually, he programs in Java.
So man, that's a close second.
Yeah, it is.
Close second. Okay, so final public void run, and we'll define our server code. Yeah, right?
So the first thing that happens when we start running is we're now running. So let's say
very
it's
interesting.
Running
okay.
To be true.
I don't know if you noticed, but my chair just sunk.
Oh yeah, it did.
I think I accidentally hit it with my knee or something. But
how?
I don't know. I have no idea how this. I don't know how it happened. I think I was laughing and I leaned back in my chair and I hit something. So now I'm like my face is level with the table I'm working at.
Strange.
At least I'm closer to the mic now, so you'll hear me over you.
Okay, so
okay, I'm sorry. I'm going to say this again. If I could count the times that we got distracted during the Java course,
I know, right?
If everybody on Whippet.net donated $5 for each time that we went off topic,
we would have like $50.
Yeah,
it'd be awesome.
We'd have like $10 each. Okay. Now,
and we could finally not have to pay for this. Just kidding.
That will double our income this month.
I think it'll, right.
Triple the income.
Okay, so
give us your money with it, people. We're broke. We're teaching you Java and we hate Java.
What do you want us to believe?
It's only because you guys want it. We don't want to be doing this. All right, I'm sorry.
So let's create a new server socket.
Let's do it. All right, we love Java. We're just playing. All right, so the server variable here.
Yeah, so we're gonna set it to be that server variable.
Okay.
So we're gonna stick it in that little drawer known as _server.
Okay, right? Yeah.
So this is gonna be a new server socket.
Okay.
And the parameter that we're gonna take in for constructing such a thing would be port number.
Okay, and the port number is going to be _port.
Exactly.
Okay.
Now let's try this. We'll try and catch this.
Oh, okay. So, like, you mean this instantiation? You mean?
Yep.
Okay. So you want me to do a little try action here?
Oh yeah.
And
just to be, just so we can get used to seeing it that way,
Maybe. We'll see. All right. So we'll do that, and then a catch.
Yeah.
Do we have an exception name, or do you?
Yeah. Let's say we'll just do an IO exception.
IO exception. And what do you want to do?
Let's print the system error.
Okay, that's good. That's
and we'll just print the message. We'll just do the get message on the exception.
System.err.println ex.getMessage massage, and let's also do a system.exit. That way, the program just ends. Why not? Who cares?
Instead of returning.
Yeah, we'll just actually close the damn program because we're that crappy.
Okay. Alrighty.
Unless you want to actually, that's not a bad idea. We'll just return. We'll just exit the thread.
Extending thread. Yeah. Whatever.
Fine, Brian. You got to be all cool and stuff.
So we tried to do that. At this point, we haven't left the program, so we successfully created a server. So now let's say, let's go into our infinite loop.
Hey, our little server loop.
Yeah. Let's go into our infinite loop.
Hey, our little server loop.
Yeah.
So while is running?
Yeah, so long as it's our sort of infinite loop, we shouldn't like to call it infinite, but yeah, so while we're running.
Okay.
While we're running, we might as well do some
run there.
So when we enter this loop, every time I make... We don't need this. Is this correct? We don't need that.
Yes, we do. You're looking in the wrong spot,
yeah,
you stupid d***.
Jumps.
You're a d***. All right, so now we have to define our client because at this point, we're actually going to try to interact with a client.
Right, so our server object has this accept method on it.
Right. So we've opened the socket, and then we're gonna just basically sit in accept mode until the client communicates.
Right.
So this line is going to be sitting there,
desperately waiting for somebody to talk to us.
Yes,
somebody,
exactly.
Please, anybody.
Right.
Somebody.
So basically, this code is Lady Gaga.
Nuts.
Someone pay attention to me. Look at me. I can act weird. Look at me.
Yeah, but Marilyn Manson.
Well, all right. For the first, I know I'm late to the game on this. I'm not a pop culture. You know me. I'm not like a whatever's
culture
cool.
lag, right?
Yeah. So since I'm a nerd, I'm behind on pop culture. For the first time, and I don't know, the album came out a long time ago. I saw the "I Was Born Like This" video.
Oh yeah. It kind of sucks.
Well, but there's a shot.
It's just not well produced.
There's a shot of her standing there in underwear with this tattoo on her side, and she's like, "I was born like this," and I was like, "No, actually, you got that at a tattoo shop. You did not have that. You were not born that way.
Right?
You're a fake, and you suck." I'm sorry, what were we talking about?
Well, I know what you mean. Well, unless maybe she means she was born this way.
I get it.
Inside,
I get it.
Expressing it externally.
But I do see the irony and hypocrisy in that image right there.
Absolutely.
Right. All right. So we're gonna client equals what, Brian?
Oh, it's the accept. So the server.accept, right?
Sure.
So the accept method on the server object will wait for the connection, and once it gets one, it will complete the method and return a client object.
Okay, and it will complete me. And we're going to want to
also known as a socket object.
A socket object.
That's also an IO exception.
Okay, so IO exception.
Still in the territory of input-output.
Right. Okay,
and we'll just do the same deal. You could probably even just
give it a little CP.
Just snatch that up there.
Just bang it. Bang it! I was born this way, Brian. I was born a Java developer. I came out of the womb and I said, I'm a Java developer. Sorry. Okay, so now we've, at this point, we've sat at this line of code until our client has connected. Now, once we get to this next line, we've actually established a connection, and what are we going to do?
Okay, so now what we're going to do is, let's grab the streams.
Okay.
So that we can do something with the streams.
It's like Ghostbusters when they said don't cross the streams.
Yeah, so we're going to cross the streams.
We're going to cross the streams.
So we're going to get both the input and the output stream. And I'm thinking, let's just throw it all in the same try block.
That's
this is getting try catching for try catching.
Yeah,
sake.
should we?
So
you know
let's
what?
Just get rid of all that.
Yeah, you're right, dude.
Let's just go to the top.
Let's just stop being so Java.
No, you could have left that one because that return was okay and the catch was okay.
All right, Brian. You know what? You are just a stupid, and I hate you, and you're dumb.
Your face smells like a How's that?
See, let's get more Wibbit.NET-y and less Java-y, Brian.
Yeah.
It's about time we classed it up.
Because,
a bit.
it's not like we're taking a different logical path for any of that shit. We're just being I think we just wanted to, like, show try catch.
Yeah, I think that we're doing what Java wants us to do.
No. So we want to make a new print writer and create it to our outstream. So
Okay, good.
our outstream is going to be equal to a new print writer.
Okay.
And the print writer was going to be attached to or come from, a client get output stream.
Like that?
Yep, and then true.
Yeah, comma true.
Yeah, come true.
So we are crossing the streams.
We are crossing the stream. So
All right,
then,
so
in
hold
stream,
on. Before we go too far, I want to make sure that our boys and gals can see. All right, so there's that.
Cool. Alrighty.
All right.
So now we want our
Input stream?
We want our in stream.
Okay.
Yeah. So this is going to be a new buffered reader.
And that makes sense, right? Because the client's going to be sending us something, and we're going to be buffering it in.
Yeah, absolutely.
Yeah, right.
Makes perfect sense.
Yeah. All right. Lay it on me.
This is going to be a new input stream. Think about
Like a
this.
this?
Yeah, it's going to be a new input stream reader.
Oh. Like a this.
Yeah, and we can get that input stream reader from the client's input stream.
Okay, so get input
So
stream.
get input stream, yeah. So the input stream can be passed into the constructor to create the luxury class, the input stream reader,
Right.
which can then go into a buffered reader arbitrarily, right?
Sure. Even though I don't know what arbitrarily means. Just kidding. All right, let's see if we
Okay.
got this right. Hold on. So I got new. So that goes there and that goes there. And then there's, okay.
Cool.
Looks
Nice.
good?
Looks awesome.
All right. It's guaranteed that we have a typo in here. So
Maybe.
yeah. What's up?
Okay, so now,
Now.
after this, and this is still all on the same type of exception.
Okay.
On the exception, I was just thinking about this. Instead of return, let's just say continue. So it'll basically drop the connection and just go back into the loop again.
Okay.
And then, after the in stream, let's try to just like write something to the out stream. So we will write to the out stream what we read from the in stream. Do you know what I
Okay.
mean?
Right.
So we'll just kind of like throw it back at you. So,
Well, do you want to do the process message that we can overload?
no, yeah, absolutely. All right.
Kind of like we did in the slides.
Yeah, okay.
So above the run method, Brian and I are going to make an overloadable method, public,
Right, so that you can implement what you want to do.
right, process message.
Yeah.
And this is going to take a
Taking
string message.
Yep. And it's just going to return that method.
Right.
The default one is just to return it.
Yeah, so it defaults, it just gives you back what you sent it, but you have the power, and we'll demonstrate this in just a little bit. So, all right, Brian, talk to me.
Okay, so now we're going to print to the out stream.
Okay, so this is
So
going to be
outstream.
_outstream
Yep.
dot
print line.
print line
And then we're going to pass it the result
Okay.
of process message.
process message.
Yep.
Okay.
And then that's going to be, we're going to pass into process message what we pull in from the client.
Okay, and that
so
is
the client ties to the in stream, the server ties to the out stream. So in stream dot read line.
like that.
Yep. So we're just going to take in a line, process it, and send it back.
All right, let me make sure I got this.
1, 2, 3. Yep.
All right, so I got print line, and then process message, open, close, and that goes to print line. Okay,
Cool.
cool. So we should be done at this point,
Yeah,
right?
absolutely.
So our server has accepted the client. We've extracted the streams from the client, and we have established. Well, that's what we've done. We've extracted the two-way feed, and then we sent data back. So let's compile this and see if it works.
Okay.
All right, so we saved this on the Wibbit.NET drive. So in our Mac utilities, we're just going to have to go to that and mounts. So you guys kind of do however you see fit on your side, but we're just going to jump here into the command terminal. And I believe, is that in volumes, Brian?
Yeah.
Yeah, volumes, and then
Yeah.
Wibbit.NET, and then we have a wserver.java. So this is the same as it is in Windows. We do Java C, wserver. Now I guarantee we have a problem. So let's let her sit for here for 2 hours, and
Because it's Java.
dun 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 dun. What is that song? That's like the classic elevator song.
It's
What the f? No f***ing
That's
way!
crazy.
No f***ing way!
no, it's little girl from Pasadena.
I don't know, but I'm just shocked as hell that I don't know how that happened. Let's make a driver code
I
file.
think the song is Little Girl from Pasadena.
All right, so let's make our driver file. So if I make a new text file and save as on the Wibbit.NET directory or Wibbit.NET drive, we're going to call a server lab dot Java. We're going to call a server lab dot Java. All right, so if we do a import java.io.star just because public class. You have an answer for me yet?
I'm looking.
All right, I'm going to work.
Wait, what are you working on? What are you doing anyway?
I'm building a driver so we can actually run the code. What the hell's good a class file if I don't use it?
Oh, yeah, true.
So in the public static void main, we'll take in string args, and for now we'll just kind of hard code everything. So w server server socket equals new instance of w server, and we'll just hard code port 1234. And I believe from this point, Brian, we just want to run .start because we imported from thread. So I think since this is importing from thread, we can just do the name of the instance. Which is
absolutely.
.start.
Yeah.
So let's run this and let's see what it does. So inside of here,
I mean, we could always do while that is running.
we can do that. What?
We didn't like the star.
All right. So now if I do Java server lab, the server's running.
Cool.
Not bad.
Awesome.
Not bad at all. So if do a control C to break out.
Right. So now if we go back to the server code, one of the things that we could do exactly is overload our process message business.
And is that going to be here? I always forget.
Oh yeah.
So we do public
string
void
process.
string process message.
Massage.
And let's just print it out to the screen for the first run.
Okay.
String message.
Yep.
So in this case, we'll just do like a print line.
How about we just return it uppercase?
That's fine. Just like we did in the lab. But we'll also tell the user what we got. So we're going to print message and then return message dot to uppercase.
Mm-hmm.
Okay. And then just for fun, we'll also do a system.out.print line and we'll say server is running.
Cool. Perfect. And then the L should be a semicolon after to uppercase.
No, it's not.
Cool.
All right, now once we get this working, we're going to jump over to Windows
and finish it off.
And we're going to write a client. So we're going to compile the Java code files and we're going to run and the server is running.
Dude.
So we'll just leave this server running. Actually, let me clear the screen and then we'll leave the server running. Clear. Okay. So now we're going to hop over to Windows and we're going to write the server class and we're going to have
client class. Yeah.
That's what I meant to say, but I said it completely the opposite.
Okay. So the client is pretty straightforward.
All right, so let's do a little save as action here.
We're just gonna
and desktop in Java, and inside of our Java file, what will we call this? Is the W client?
wclient.java.
.java. Okay. Okay.
So now we're going to have, obviously, our public class, wclient, and then we're going to have some fields.
Okay.
We're going to have a server, which is going to be a string. Private server. Yeah.
String server.
Yeah.
Okay.
And then that'll be like the IP address, like the destination.
And before we do that, do we have some imports?
Yeah, we're going to use Java.io and Java.net, just like we did before.
Okay, so import Java.net.
And with Sparklies.
Oh,
with the glitter.
Yeah. Oh, yeah. Okay, now back to the class.
Ding, ding, ding. Okay.
Yeah, it's like, now it's raining men. Yeah.
Our port. So we're also going to have like the private int port -1 thing.
-1. Okay.
And then we're going to have our client socket, and that'll also be private.
Private, and that's going to be a socket.
Yep.
Socket to me.
Client, and that's null.
Equals null.
And then we're going to have our print writer.
Okay, that's going to be a private print writer.
Outstream.
This doesn't look awfully familiar.
Yeah, I know, right? And that's null. Mm-hmm. And then we're going to have a buffered reader, which is our instream. Because don't forget the client has to read back in from the server too, Right. It has to get the response. So they're both kind of doing both. It's just the server's like in a listening state.
Right, exactly, right. But it's still functioning the same way. I'm sending data, I'm getting data, and I'm getting data from someone else. That's how, right?
Okay, so we'll do a couple constructor methods. We'll do the first one for wclient where we just take an import number.
Okay.
And all this is going to do, it's very simple. We'll just set the server equal to localhost.
Ah!
Because we didn't otherwise specify, right?
So there's our default server, right?
Yep.
So we'll do...
And that's assuming that the host file is setting a local host to actually be the home address.
So I do 127.0.0.1?
I think it's safer, now that I think about it.
127.0.0.1.
Yep.
Actually, can I tell you a funny little story about that? We had an issue like a few months ago. It was so weird. There was some networking snafu. So some idiot put a machine on the domain called localhost.domainname.
No way.
So on a lot of the applications that we were running that were using sockets that were doing local loopbacks, they were failing because they were sending to this localhost
never
machine.
heard of something like that
I
before.
never heard of it
Weird.
until I came into work the next morning and there was like all hell was breaking loose, and then we figured that out because when we did ping localhost, it pinged some server that was not the local
Weird.
server.
Port is going to be port,
Okay,
obviously.
got it.
Okay, so then we're going to have another one. It's going to be basically the same, but it's also going to take in the server. So a public W client server import.
Okay, so this is going to be string server
and then int port.
int port. Okay,
Perfect. Yeah.
all right.
And then server's going to be server, port's going to be port. So you could probably just
Server equals server and
port is port.
port equals port. Okay.
Okay, so now let's make a method called send message because that's what this is all about.
Public string send
Message.
message. Okay.
And then that's going to take in the message as a string.
Okay.
And throws and IO exception.
Right. That way we throw the responsibility of catching this
Somewhere
up above. Right.
Okay, so the client is going to be a new socket object, and the socket's going to take two parameters: our server and our port that we've so appropriately stored just prior to this.
We have this.
Upstream is going to be the result of a new print writer that comes from the client's output stream.
Print writer that comes from the underscore client
Dot get output stream.
dot get
Just
output.
like kind of we did on the server side. It was cool.
Exactly.
And then true.
Oh, right.
Yeah. Okay. So then the in stream is going to be the buffered reader.
I got a little bit of
underscore
issues here. So in stream.
In stream is going to be a new buffered reader. And that's going to be a new input stream reader that we pull from the client.
Okay.
And it's going to be from the client's get input stream.
Yep. So we'll go ahead and pull this out here.
Because the stream goes to the luxury class goes to our buffered class so that we can do like
input stream,
read line. It's all for convenience.
Right, convenience. Okay, so we got that. So now we've connected and we've yanked out the stuff.
Okay, so now let's actually send the message. So to send the message, all we have to do is just print line to the outstream. Isn't that awesome?
Outstream.
It's really cool.
.println. Yep. And we want to say message.
Message, absolutely.
So we're sending the message to the server.
So now let's catch the response. So now we'll make a string called response.
Response?
Yep, and that's going to be the in stream, and then we'll just do a read line and pull the...
Wow.
Yeah, we'll just pull it from there.
Like a D's.
Yeah, and then we'll close the outstream, close the in stream, close the client.
Outstream dot close. And then we'll do a underscore instream dot close. And then we'll do an underscore client dot close.
And then we'll return the response.
Return response. Is that all we have to do?
Done.
All right, so
that just happened.
Let's go ahead and see if this compiles, and if it does, we'll build the driver program, and we'll send a message to our waiting server.
Yeah.
I mean, she's just sitting there chilling like, somebody talk to me! Actually, I don't know what the address of that machine is, but we'll get that in just a second. CD desktop, CD Java, Java C, W clients.java. See if we have any problems. All right. So we can build a driver code file.
Yeah. All right, let's do it.
All right. So we
I can't wait to see these things talk to each other.
Public
This is gonna
class
be awesome.
W client driver.
Perfect.
And then this is going to be a public static
void
main string array args.
Public static void main.
And this will be W clients.
No, we also want Java IO.
We'll do that.
My Mac.
And it's going to equal null. Import.
Is that funny?
I don't know. Java.io.star. Is that it?
Yep. That's it. All right.
So W clients driver.
Yep.
All right, let's just see if this actually works, and then we'll get the IP address of the other box.
Okay.
So I want to do that, and we'll also do W client driver.java.
Perfect.
So that's
nice. Look at that.
That's compiling two code files. So Java C W client driver. Oh, yeah, sorry. Cool.
Cool. Okay, awesome. So now let's get the IP address. So We're going to open a new terminal window. If you go to shell, new window.
Yeah, I'm sure I could do that. Shell, new window. And this is not going to have my cool little... So ifconfig should give me the IP address. So we're looking at this. So it's going to be... Brian, can you remember that? 192.168.226.129.
Okay.
So we're going to be connecting to, instead of null, a new instance of W client, and it's going to be server. Server is going to be 192.168.226.129. And then the port's going to be 1234.
Perfect. Look at that. Now that we have the my client, let's create a string so we can grab the response too. We'll just kind of we'll get that thing out of the way. So string response is just not blank.
Okay.
And we'll do a try block, and we're going to say the response is going to be the result of my Mac being sent a message. So send message. And then, what do you want to say? Well, hey, buddy.
Hey, buddy.
Of course.
That's Wimpin.net. I mean, what else could it possibly be?
So then we'll catch an I.O. exception, and we'll just print to the error the message,
Yeah.
Nothing fancy.
Oh, Java, you're so... System.print line, ex.message, and then
we won't return here, because we'll try to do another one. We'll try to shut the server down, too.
Different.
Not
sorry,
comparable.
sorry. System.exit 1. So we're bailing with a bad return code.
That's cool.
And then we should be able to do then system.out.print line. That print line is going to be response.
Yep.
And our client should then shut down.
Yeah.
All right. So if this works the way
yeah, absolutely.
If this works the way that we expect.
Oh,
sent message.
That's, what do you think this is Objective C?
Yeah. Message has been sent to server.
Message did complete sending this.
Yeah, right. So let's compile the bad boy, and if we run this, are you ready?
Yep. Okay, so now let's see what happens when we kick this thing off when we send a message to the Mac.
Hey, buddy!
Now let's go on the server side and see what happens.
Yeah, let's go look at the Mac. Holy that is ridiculous. That is the coolest thing I've ever seen. Now, Brian, before we jump off of the first portion of this lab, let's swap the class files, and then we'll have the Mac as the client and the Windows as the server using the same bytecode.
Right, the compiled classes.
Exactly. Okay, so Brian,
yeah,
on the Windows side, who is going to be the server now, we have moved the serverlab.class and the wserver.class file onto this machine.
Cool.
Now, these are both Java compiled files.
Right, they're the class files.
That were compiled on the Mac.
Right.
So I'm going to move these little fellas here into our Java directory, which is the directory we've been working in. And we can run Java, wserver, what was it called again? So we can run Java, server lab. Oh, what is this? What is this?
I don't know, I'm thinking. Sun Miscellaneous Launcher App Class Load. Which just goes to show how not operating system independent Java actually is.
Yeah, Java's supposed to be something that you just pick up and take anywhere, and it's not functioning.
Now, we could recompile the Java file, but we could recompile C.
Yeah. So
or C++, so it's kind of stupid.
If we go to here, what happens on the... So we actually also moved the code to cd/volumes, cd/wibbit.net, Java. No, we have to actually re-edit the code file.
Oh, yeah. But this is
going to be actually, it doesn't matter because I just want to see if
it doesn't work then.
But actually, I don't think that I actually pulled the Java. All right, so you're right. So we'll just do a little
because the class is
Java
still...
CW client.
Yep.
Driver.java.
Hey, look at that! How fascinating. So as it turns out, the Java is not nearly as cross operating system. I'm glad it turned out this way. I'd rather actually it turn out this way than succeed because we didn't actually know.
Right. We didn't actually test this ahead of time.
But we've generally found in the past, working with Java, that it's not as operating system independent as they claim that it is.
Right. Yeah, it's very common.
Let's see you run an Android app on a BlackBerry.
Yeah.
Tell me how that goes for you.
Yeah, I don't know. It's just, the problem is you have this like version dependency and it's just, I have had a lot of, this says that it's
you can't get a simpler application. Seriously, you open a socket, you read from the socket, you close the damn thing. Like, it's nothing fancy, you know?
Right. Now, this did compile, but we got a warning, wclient driver.class, and it fails.
Yeah.
Okay. So, I don't know, Brian. Oh, well.
Same.
And it fails.
Yeah.
So, I don't know, Brian. Unsupported class version error.
Like, that's awesome.
wclient unsupported.
Yeah, that's absolutely awesome.
And we have if we do an ls*.class, we have the wclient
class file.
Do we have the wclient class file, which is supposed to be the bytecode file.
Right. So, tell us what you think about that bullshit.
Yeah. All right, you Java guys. Enjoy!
And gals.
And gals.
Welcome back, everyone, to the Wibbit.net Programming in Java course. In this lesson,
you guys survived sockets. Holy crap!
Yeah, no. See now, after we kind of like beat you up and smacked you and knocked you out, we're gonna give you a nice, easy ride down the park. We're in Central Park and we're just kind of breezing by, watching the birds chirping.
The homeless guy baiting, whatever. So let's talk about generics. So we've kind of touched on this in different things, and we've talked about templates, and we've talked about whatever. So let's see how we can talk about generics in Java. So you remember templates from C++, right?
I hope so.
So the template was like let's say you write a method and the method has a return type that we don't know what it's going to be. It'll depend on, or whatever. So that's what generics are in Java.
So generic programming is building algorithms and programming structures without considering specific data types. So the assumption is that the data types will be defined later on. So not now. At some point later on, we'll worry about defining these data types. So in essence, it kind of circumvents the static type programming system that we've been using. The majority of our programming that we've been doing, except for like an Objective-C, which is very polymorphic, has been a static type programming environment. So we define this is a string, this is an integer, as opposed to this is some thing and this is some other thing, and we'll send it over here and it will just determine what that thing is.
Cool. So let's take a look at how this works. So let's say we have a class called like Wibbit value or W value. If we do this less than and then some sort of identifier, we'll just call it DT for data type or something, but it can be like F or blah 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 blah, whatever you want.
Or Brian is dumb. That's what I usually name mine.
Yeah, and then a greater than. So we kind of like encase that class with that DT. So that is our data type that's coming into the class that we can then use for whatever we want to use it for, which is great. So let's say we have some value, and we want that private field value to be of some data type that we haven't yet specified. Well, we can specify that data type when we instantiate a class of this type, and it comes in through this DT, and then we just say private DT as if it's like a string or whatever else, And then we create a public void method called setValue, and it's going to pass in the parameter of type DT, which is awesome. And then value is going to be value, and those DTs are always going to match, so you don't have a conflict.
Right.
And then we have a public method getValue, which is a return type of DT, and it's just going to return the value.
Wow.
Yeah,
that looks exactly like a template in C++.
Yeah, so you can replace all the DTs with like integer, you can replace all the DTs with a string, but when we have that generic identifier up in the class declaration, that less than, greater than around the DT, then we can use that type throughout our class, which is awesome.
Absolutely. Now let's take a look at an example of instantiating this Wibbit value class. So we just have a class called WValueDriver, and inside of this we have our main method. And I'm going to say WValue is the object type, so that's the class, and the generic that I'm passing it is going to be of data type string. So if we go back to the slide that Brian was talking about, data type will in this case be string. I have my string value equals a new instance of W value. So we've already, at this point, we've told W value, okay, your generic is now a string. So whatever DT is, it's a string. So from that point on, it will behave as if it's a string. So when I do my string.setValue and I pass it, hey buddy, I can then print with system.out.println my string value.getValue, which, as you remember, will return that instance that's been encapsulated, and we can print that out. And then if we do it again, Brian, we can do it with another data type.
Oh, look at that. So now this time we're doing it with an integer value. So we set the value, instead of passing it a string with the quotes around it, we just throw the number in there. Now println can take a string, can take an integer, can take a float, take a whatever. So when we do the println this time, the get value returns an integer, which then in turn goes to println and prints to the screen.
That's so cool.
Yeah, it's awesome.
That's cool. And not only
so it makes it very flexible.
Not only is that cool, but that's very familiar to you guys.
Yeah.
Now, what if, Brian, what if I wanted to build a class that had multiple generic types?
Well, it's really easy.
Okay.
Just comma separate them.
No. Damn it. Why is it going to be so easy?
That's it. So it's the same thing, but now we just say DT1, comma DT2.
Damn it.
I know,
so,
right?
In this case, we're storing two private values, one of data type 1, the other one of data type 2, and then we just basically took that same class from before and just modified it. So we have a public void set value 1, set value 2, get value 1, get value 2. So if we want to implement this code, Brian, what do we do?
Okay, so let's create an instance of, we'll call it value, and that's going to be of type W value, which we've implemented before, and it's going to take two different data types as the generic data types. So in the less than greater than, we're going to do a string, comma, an integer. So now we have our instance of W value. So now we can set value 1, and since we know that the first one has been set to a string, we pass it quote unquote, hey buddy.
Hey
and then
buddy.
When we set value 2, we defined here that it's going to be an integer. So we create a new integer and we pass it an int 555, and then we print these two values out, and it prints out, hey buddy, 555. Isn't that awesome?
Not bad. Not bad.
Very cool.
Very, very, very cool. Now, one thing that's also kind of neat about using generics in Java is, you know how in C++ we would do stuff like we would make a template for a class? Like when we did our linked list, we did the template, so our linked list can be a string, it could be an int, it could be any other class that we build. Well, in Java, we can also do that exact same thing as we've demonstrated by having data type and then having multiple comma-separated data types, but we can also do that on the method level.
Oh, look at that.
If I want to have a class that inside of it has a method, I can specify the return type, or I can specify types in the method declaration. So in this case, we have a public static, and then I'm saying that this is data type whatever, string, what data type, and then DT3, which is that template or that generic that I defined. And all that we're doing, Brian, is we're using reflection.
Do you remember that? Yeah.
To do get class, and then we're just going to return the name of that class. But
from the class object, right? Okay, so now let's see what that looks like when we try implementing that. Now this is it's a little weird. So here, all we have to do, since it was a static method, we don't really have to make an instance of W value or anything. So we're just going to do a print line, and we're going to do the W value class dot the method name. Now when we do generics with methods, the generic definition precedes the method name. So we're going to do the string in less than greater than, and then the method name, and then we'll pass it the value. Isn't that awesome?
That's awesome.
Yeah, so the string is defining the parameter that we pass in.
Yep.
So you can make it do whatever you want. We can make that an integer or whatever.
Right.
Isn't that cool?
Yeah. So generics, although it seems very simple, and it really is, it's a very integrated part of the Java world. And it's very simple to use, as you just saw. Now, don't let some people try to make, because you'll see some Java documentation that blows this way out of proportion. What they try to do is show you impractical examples of this just to feel good about themselves, I guess. But, you know, like a lot of practical uses for this, most practical reasons for using generics are very easy.
Yes, that's generics in a nutshell.
Yep.
On to the next one. All right, everybody, let's get into collections in Java. Now, collections are really cool. So we talked about, arrays and stuff like that. Now we're going to be talking about collections, which are like collections of objects of whatever we want that we can kind of say like for each this in our own object type, or we can do a lot of stuff. So it's kind of like arrays, but it's not. We can traverse and we can actually, in some cases, which we won't get into, query against collections of our own objects. So let's just hop right in and take a look to see how these work and what these are.
All right, Brian, I'm going to take the pants off collections right now. So in the Java collections framework, it's kind of what we're going to be going over is like how Java handles this concept. And so Java has a vast collection of classes and interfaces that provide collection data structures. And there's tons of them, but they all kind of boil down to just a few, which we'll go over in a second. So collections are basically objects that contain multiple items in a single instance. So keep that definition in mind, because when you're defining what a collection is, you can always resort back to that description to know whether you're working with a collection or an array or a list or whatever.
Right, because remember when we would declare an array, we would say like int array of something. So everything has to be an integer, right? Not the case with collections.
Right.
Collections, you can have a string, you can have an integer, you can have a person, you can have just like a whole mix match of shit in there.
Right. So you can kind of think of them like an array, but it's very, very fundamentally different than an array. So remember in C++, Brian, we wrote that linked list class?
Yeah, absolutely.
That's an example of a collection. Because we had a single instance that encapsulated a list of items that we can add, we can delete, and we can retrieve. And we can also specify the different data types that that parent instance can be. So I'm a collection of strings. I'm a collection of integers. I'm a collection of generic objects. You know what I'm saying? So we have a lot of that kind of cool stuff in Java that we can work with as well.
So again, how is this different from like an array? We've seen arrays, and we've seen arrays that can be like a variety of sizes. Now collections contain a lot of sophisticated methods, so you can have like a seamless interaction with the data stored. So you can add data, change data, remove data, extract, condense stuff, all like on the fly, all at runtime, and it can kind of like adapt and restructure itself as you go, which is great. And this is designed specifically for encapsulating data to interface with an API.
At least in the Java framework, it's used often in sending data between different APIs that will accept these collection objects or return these collection objects. So collections are typically categorized in these basic ways. As we know, a collection is an encapsulated group of objects, and those objects are often called elements, which we've used that terminology in arrays as well, and that works in collections too. So we can really simplify. If we really want to just scrape the bullshit off of this subject, we can take this down into sets and lists. Those are really the major two, if not the only two types of collections you can have. So let's talk about a set. A set is a collection of elements of a specific type, and these elements cannot be duplicated. So let's just say for a classic example of a set is a deck of cards.
Nice.
You don't have two, threes of clovers in a deck.
Right.
You know what I mean? So you have a list of similar items, but each item is unique. Whereas a list is not like that at all. A list is either ordered or unordered, and it's a sequence of elements, and there are no rules against duplication.
That's awesome.
If I want to be freaky with the cheese whiz, as Brian would say it, and I want to play some weird, crappy, like Las Vegas, rigged game of like poker, I can take like two decks of cards and put them together, and I could have duplicates. And a list would allow that, whereas a set would not allow that.
That's cool.
That's very cool.
So let's do the walk around the block with the list class documentation. Oh, excuse me. All right. So we can add something, and we can pass in an index for like where we want to insert it into the list, or we can just add it, which will append it to the end of the list. Mm-hmm. You can add all and take in another collection to kind of do like a union of two collections, which is kind of cool. Mm-hmm. You can add another collection into a certain index. You can clear the collection. You can see if it contains an object, which is kind of cool. You can see if it contains all of the objects in another collection.
Wow, now that's these are really cool. Yeah.
Yeah, talk about convenience. That's just awesome. You can see if this collection equals another collection, which will compare all of the objects within them, which is also incredibly useful. Mm-hmm. You can get an object at a certain index. So, like, that's kind of like the bracket number bracket. That's like get at index.
If there was such thing as operator overloading, yes.
Yeah. You can get a hash code value for the list. You can get the index of a certain type of object, which is kind of cool.
Like where an object sits inside of a list.
It's awesome. Yeah. You can find out if it's empty. You can get the iterator, which we might talk about later. So we can get the iterator, which is kind of like part of how we can do like for each something and something, you know? We can remove an object at a particular index. We can remove an object by passing in the same object. So like if it's a string and the string is like, hey buddy, if hey buddy exists in the collection, it will remove the object, the string that's hey buddy. Yeah. And also only removes the first occurrence.
Right. Mm-hmm.
Right. So we can remove all from the list from a collection we take in. We can retain all, which is kind of cool. We can get the size of it, which is how many elements, the total number of elements in the list, which is great. We can do like a sublist, like from this index to this index. We can convert it to an array, which will return an object array, which is awesome.
That's very cool.
Yeah, it's really, and they also have like another one where we pass in an object, and it returns an array of all those elements in the list.
Now, Brian, now that we've looked at the base list, right? So we know what a list is. We know what different things a list consists of as far as methods and interactions with code. Let's learn a little bit about the array list class,
right?
Which is
this is really what you're going to.
Right. This is a subset of the list class.
Right, and you'll probably use this quite often.
Very often.
So we have 3 types of constructors. We have the default, one that takes in a collection that can construct an array list out of, and then another one that's an initial capacity. So we'll have an empty list, and they'll just be like empty, placeholders.
One of the reasons why you would use something like that is, let's just say you wanted to just make sure that your program has enough memory to handle 500,000 elements that you're planning on putting in there. You can then try to initialize the capacity, and if that fails, your program can't handle it.
Right. So this is very similar to like the list class, the behavior and the structure and the naming conventions of the methods. We can add something at an index and some object, an element at an index. We can just add some objects to the end. We can add all from a collection, add all from a collection to a point. So these are all very similar. The clear, is it empty, get, the last index of, the size. We can set, if we have an object at index 4, we can set that object to be now this one. So we can kind of like replace stuff. It's great. Very cool.
Yep, and you can see that it has inherited elements from the abstract list, the abstract collection, obviously object, and the list class that we had just gone over before.
Yep.
So here is an example of us using a list. Well, this is actually using an array list, and I'm specifying the data type using a generic. And since a array list is a subset or extends a list, I can set a list instance equal to an array list.
Right,
so, and you'll very frequently see this type of code. For whatever reason, you see this a lot. So I'm making a list. It's going to be of string type because we're going to have strings in there. I'm just setting my generic. My list equals new array list, and then the constructor is going to be getting that string generic as well. MyList.add hey buddy, MyList.add hey, MyList.add buddy, and then I print out the number of items, MyList.size.
Cool.
Use a for loop to traverse through and get at that index. So you can see here, it's easy to create them and it's easy to add to them. And if you really kind of like look at this, and if you take it outside the context of Java, this is exactly what our linked list class looked like.
Yeah,
in
and
C++.
And it's extremely intuitive. It's very natural.
Very natural.
But yeah, as you can now tell in hindsight, we definitely modeled the class that we had you build from scratch in C++ off of how Java implements their linked list.
Because we're just that awesome.
Mm-hmm.
Now, Brian, this is an example of using a iterator.
Cool. So let's take a look at another array list that we create, and we'll add hey buddy just like we did before. But now this time we're gonna say for string item and then colon for like in. It's kind of like for each.
So in this case, and this is in a lot of languages, pretty much most languages have this, and it's a very convenient way to just move through everything in a list. You basically just say, for each cookie in a jar, eat a cookie. So it just grabs the entire set of cookies, and it just goes every single one of them until there's none left.
And then, oh, that was really full because that was a lot of cookies.
It's sort of like for each item in my list, this is for string item colon my list. Mm-hmm. And that will iterate through all of the objects in the list object, my list, and it will get them as item. Mm-hmm. Isn't that kind of cool?
That's really cool.
Yeah.
You don't have to worry about indexing. It works very nice.
It just traverses, it just iterates through each object in the list.
All right, so now let's talk about a set. Now, like we said before, this set is the version of a collection that only allows one instance of that type. So, deck of cards, you can't have 2 King of Hearts, you only have to have 1. That's a set. So we have, your usual methods that we've been looking at in these collections. We have your add, your clear, checking to see if it contains, is empty, remove. I mean, these are things that you've already seen, converting to an array, and then sending the type of array that you want it to be using a generic.
So it works very similar other than the fact that it has that restriction.
Right. Now we have a subset of a set called a hash set, and you can see that the constructors here are very similar to that array list. We can instantiate it with a collection, we could do initial capacity, blah, 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 blah. We can just have a default constructor, yada, yada. Add, clear, clone, contains, is empty, size. This is what you can see that this inherits from the usual suspects, including the set. So this is a subset of set. So you can see, just like we had in that last example, I can create a set instance passing the generic integer, setting that equal to a new instance of a hash set. So that's kind of cool. So it's the same kind of, this is a subset of this, therefore I can impersonate this. So for I equals 0 to 10, we're going to add I. Now check this out, Brian. We added 0 through 10.
Oh, yeah.
Right? So, and then after that for loop completes, we add 0 2 more times.
But we don't see it print out.
Right, but when I print it out,
what's the deal?
The 0 is only there one time. And
Yeah.
that is because a set will not allow to have multiple types of the same thing.
Cool. Awesome.
Every item must be unique.
So here's another example where we have a set, which is going to be a hash set of type integer, my set, and then we go through a for loop and we add 10 times, add the 2 zeros like we did before, but this time we'll create an iterator object, which we'll call iterator it, and that's going to be equal to my set.iterator, and that will return the instance of the iterator from our set. So while the iterator has next is true, which means while there's still another one to iterate through, then we're going to set integer I to be, we're going to typecast as integer the iterator object itself's result from next. So the iterator's next object will return as an object, we'll typecast that object to an integer, store it as I, and then we can print out the current value as I. Isn't that cool?
That's cool. That's like manually doing a for each loop.
Yeah, so this is kind of like us implementing a for each structure, kind of, using a while loop and the iterator.
God, Whippet.net is awesome.
I know. So that's collections. So that's collections, and as you can tell, I mean, this is extremely natural, very easy to use, and now that you kind of have a foundation in C++ and have kind of gone through these things and you've gone through the concepts, I mean, you could just rock this out. It's awesome.
Oh, yeah. Welcome back to Programming in Java from Whippet.net. Brian and I are now going to discuss the Abstract Window Toolkit that's part of the Java framework.
Alright, so what the hell is the Abstract Windows Toolkit?
I don't know, but that's just, it sounds like some weird thing.
AWT.
Yeah, so the Abstract Window Toolkit is Java's first attempt at an interface builder API.
Oh, so it's like Microsoft Fried Chicken?
Sort of, yeah. So it creates an abstract layer on top of a lower level user interface codebase that sits on top of the operating system itself.
Oh, cool.
Yes. So when you present a window using an AWT widget on a user interface application, it uses the native OS method of displaying that, and it just kind of bubbles that up through Java. So when
so every Java virtual machine will have already went out and figured out what all of those methods are for you.
Right, because that specific machine was built for that specific operating system.
Right.
So the controls will look as if it was designed for that specific operating system. So a Linux app will look like a Linux app, a Windows app will look like a Windows app, a Mac app will look like a Mac app, right? Kind of cool, kind of fun.
So let's see how this is broken down. We have basically two levels, the interfacing level and the controls or the widget level, the GUI controls like text boxes and buttons. The interfacing level is how the program actually interacts between the user and the system it's running on. So here we have the AWT, the Abstract Windows Toolkit interfacing layers. So you have at the very bottom the operating system layer, and that's what everything is built up on top of. Then they created this interface layer that separates the application from the operating system, and that's what kind of allows you to just generically use like a text box without knowing if it's called a text box in Windows versus Linux.
Right, and that's kind of where the difference between the different Java virtual machines, that is one of the major parts where this is different. So like, because Windows is going to handle this differently than Linux. Linux is going to handle it differently than Unix. Unix different than Mac. Mac different than OS2 Warp, which is Brian's favorite operating system.
Or BOS. BEOS, remember that one?
Which one's that?
BEOS?
Yeah.
I don't know. It was like early 90s, supposed to be very graphical. Whatever.
Yeah.
So then on top of that, there's the events layer, which is really interesting that we have an events layer on top of that. Now, we've seen, when we've done graphical user interfaces before, how events are kind of like managed and handled and why they are particularly relevant for, graphical user applications. So they kind of build an events layer on top of that. Then the layout management layer of how we're going to like organize things, which I don't think they did a very good job of this layer, but whatever. So then we have the layout management of like how it's going to lay out onto the window or onto the display or the view. And then on top of that, we have the input devices, and then the data transfer, like dragging and dropping and the clipboard and stuff like that.
Right, you're right. The layout management in Java was a complete disaster. Here is an example of creating a basic graphical interface application in Java AWT. So obviously we're going to import java.awt, and we're just going to bring in all classes and all entities. And I'm just going to create a class called AWT example. And inside of my main method, I'm going to create an instance of an object called frame, and just call it my frame. And the constructor is going to take in a title text, and the title text is going to be AWT example program. I'm going to set the size of this frame to 640 by 480. This is 1995 right now. The set location relative to passing null will actually center the window on your monitor when it loads. You can also specify other things, but null will just put it in the center. And set visible is true, so when I create the instance and I place it where I want it, I then show it to the user.
That's cool.
So let's take a look at what this code will produce. So if you look on this command terminal in the background, right? This command terminal
is like a window.
Right. The command terminal, I've compiled this program and I ran that against the Java compilers or the Java interpreter. So AWT example will load this window, and it looks just like a Windows 7 window would look like. I have that Windows 7 theming. It looks exactly like a Windows 7 window. Now, one thing that kind of is interesting to note is if I were to try to exit this application, I can't because there's no basic functionality built in. So the only way to actually close this program is to actually go back to my command terminal and control break it or kill the process. And we're going to discuss how we can hook events to these buttons in just a moment. What is this going to do?
All right, so now let's do a little more. Let's say, so we created the frame, and now we want to add a button. So we just say myFrame.add, and then we pass it my button. Now my button, if you look at the top, is a button object type. And we created a new instance of button, and we passed it a name or a title or a label, and it's a string, and we just say click here. And then we're going to set that button to be visible.
Okay.
So we didn't really set where that button's going to add, so we'll see it just kind of like throw onto the panel.
It's going to consume the entire application.
Right.
And that's
see how the whole frame is just one big ass button.
And I think that's super lame.
It is.
That design and that philosophy is very lame. No need for it. Sorry, I just have strong feelings about this.
Yeah, I think it was just an easy way out.
So let's just say I want to then place this button somewhere. Java graphical applications, especially when you're building it from, as a text document like this and you're not using any graphical tools to simplify it, you need to have panels to put your widgets on. Right, Brian?
Yep, that's true.
That is true. So here I have a button instance, just like Brian was describing before, and below that I'm creating an instance of an object called a panel. And on this panel, I'm going to set a layout, and by saying layout left, it just basically pushes everything to the left side of the layout. So that's just a different object type that this set layout will take. And then on that panel, I add the button. So I don't actually add the button to the frame, I add the button to the panel.
Right.
And then what I do then is I create my frame like I did before, and then instead of adding my button, if you look there, it's myFrame.add my panel. So now this code will have a button in the Windows theme.
It doesn't look all
right, and it's just right up there, pushed up against the upper left, as we asked it to be.
Very cool.
Yeah, so now, Brian, let's start talking about how we can hook events to our basic application.
Alrighty. So let's add a new method that's just publicly accessible. It's static. We'll call it like add-on-close, right?
Yeah, why not?
And we'll pass it in frame. And that's just like a pointer, because as you know. So we're going to say frame.addWindowListener, and then we're going to create a new window adapter, and then we're going to swap out the internal method of the window adapter class type. We're gonna switch out the method window closing. So we're gonna replace that method window closing, which takes in the parameter window event E. And all we're gonna do is we're just gonna say system exit, right?
Okay.
So whenever we call this method, this replaces this instance of my frame when we tie these together. It will replace my frame's window closing method to when it gets called, it will exit the program.
Okay, so...
Now, like, you can have it do other things. You can have it, like, clean up some stuff before it exits.
Or prompt, are you sure you want to close? Right.
Right, and so you can see when we created it, right after we created the instance of the new frame, we call add-on close and pass it my frame. So now we've tied it all together.
Right, so now if I click on this X button, when I click on this, it will then activate this code here, which has been injected into the frame instance via the add-on close method. And what this is saying is in the system class, there's an exit method, which means we're going to it's the same thing as in the main function in C++, you say return 0. This functionally does the same thing. It returns 0 back to the operating system and closes the program.
That's awesome.
That's really cool. So this window adapter, Brian, you know how in Objective-C, those of you guys that followed that course, there were a bunch of different types of known behaviors that applications can do. So when we made a button, there was a touch up, there was a slide, there was a whatever. Well, in the AWT framework, or AWT API, I should say more accurately, there's a bunch of already known window events. So a window has been activated, a window's been closed, a window is in the act of closing, deactivated, lost focused, a window's been opened, the state of a window's changed. I mean, these are things that you can override or swap out inside of that window adapter class, so you can change the behavior of the frame on one of these events.
Okay, so now let's kind of put it all together and add an event on the button. So we want to be able to click the button, do something, and also close the program and have it close, right? So just like we did before, we have the add-on close that we attach to the frame, and that says that when the window is closing, we're just going to exit the system, right? So that's fine. We've seen that before. But now what we want to do is we want to be able to have some sort of event occur when we click the button. Okay, so we create a new instance of button, my button, and we'll just say click here like we did before. But this time what we're going to do is we're going to say myButton.addActionListener. Is a new action listener, and we're going to replace on the action listener, kind of like what we did before on the Windows adapter. On the action listener, we're going to override the action performed method. So here, when we replace that method of action listener, we're going to replace it with the method that prints a line, you have clicked the button, and it just prints it to the system out, right? Not too bad. So now we've created a action listener instance with our own custom method that's replaced action performed, and we pass that into the constructor of the into the method add action listener. So now that action listener has been bound to the action event for my button. So then we create the panel like we did before. We set the location, we add the button, we have the frame, we add on close, set the size, set them all to visible, and that's it. So now we run the program, we see the button on the left like we have before. We click the button.
Hey!
Click the button. Hey, cool. And now when we close the program,
the
program
dies.
Closes.
And here's another really cool example, Brian. Now, a lot of times when you do see applications written, especially when they're written manually like this through a text document and not through a GUI editor, you'll see that it is often that a main method will be encapsulated inside of a program that extends frame. So that means literally your main method is inside the main frame of the application.
Right.
Right. And that is a fairly common approach to graphical user interface design in Java. So in this particular case, we're using the same class. We're doing AWT example, and this extends frame. and then we have a void, public void, my AWT program, and that just adds a button that says click here, panel. So it's basically that first example where we had that button. There's no event attached to that button, but this will just display the button. And we had that public void add onClose, which adds the onClose event. And if you go down to the main method, you'll see here that we're creating an instance of ourself, and then we're just doing our prog, which is our prog, which is the instance of ourself, and then the program, and then set visible to true. So by saying this prog, that is actually the same thing as saying the instance of frame, because we're extending frame.
Right, and it's just another style of writing a AWT program, like an abstract Windows toolkit. It's just another style of making like a simple GUI.
Right, now the way that I do it, and I think Brian's the same way, is I'm kind of like the Offspring. The band, I like to keep them separated. Yeah. So I always design my graphical stuff in separate classes, and my main class is a specific purpose class to implement the other code. That's just me.
Yep.
So
I think it's a much better approach.
Oh, I
At
absolutely agree.
least you get exposed to that toolkit for writing GUI application, and it'll be kind of helpful to know that once we now jump into Swing. You can kind of just at least get like a run around the block with like how to take your newfound Java knowledge and apply it to applications. Although we understand more often than not, you're probably going to be applying your Java knowledge to things like server side stuff maybe or whatever. But it's still important to understand how the evolution of Java came to be. Swing, 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 swing. Everybody hates swing.
You know what that reminds me of, dude? That amazing scene in The Mask with Jim Carrey.
Oh,
and
yeah.
What's her name?
Cameron Diaz.
Cameron Diaz. Yeah.
Anyway, so we're going to talk about Swing now. So we talked about the abstract Windows toolkit, but we didn't talk about it too extensively, mainly because like nobody really uses it.
Yeah, I mean, some people do, but it's generally considered a depreciated
but some people
way.
use Fortran, so
That's true. Yeah, it's generally considered depreciated when building graphical applications in Java. Swing was the replacement for AWT.
Although it's kind of built on AWT, so understanding the idea of AWT and the core concept is important.
Right. But Swing had a much different philosophy, so let's kind of define what Swing is, and then we'll kind of show you how to use it.
The abstract Windows toolkit, we talked about that layer that would, if you said, like, I want a button, it would go out and try to figure out what the operating system considers to be a button. Swing is different. Mm-hmm. That had like some issues and it required a lot for the Java platforms to like implement those properly and have some issues, and it was like an unnecessary amount of work, and some people complain, is it really platform independent if my buttons look like a Windows button? I don't know.
One of the main driving forces behind this major radical shift in philosophy was Java initially thought that it would be a great idea to have GUI elements look like the platform they're on, but developers just complained like crazy. They're like, well, if I write this in Windows, but I want it to work on Mac and Linux, well, the graphical widgets don't look the same.
Right, the alignment's like a little off,
right.
Or like the pixels don't match up properly.
So people were having to put conditions in. If it's Linux, put it in this position. If it's Mac, put it in this position. So as Brian said, people were really asking themselves, is this truly a platform-independent graphical user interface API?
Right. And so one of the things Swing set out to do was to make sure that if you're in Unix and if you're on, if you're like on HP Unix running X server, or if you're on Mac OS X or you're on Windows, whatever it is, a Swing application is unfortunately horrible looking as they are, will look like a Swing application no matter what platform you're on.
No matter what you do, no matter how you configure it, you open it up on any system and it will look exactly the same.
Right. It'll look equally poor on every system.
Right. So it derives most of its functionality from AWT, although it doesn't derive its presentation from AWT. So let's start taking a look at the inheritance structure. Where did the JFrame come from? Well, there is a package called Java X, which is the first time that we're bringing this up, which I think is Java Extended, right, Brian?
Mm-hmm. I think so, yeah.
And it's Java Extended.Swing, and inside of the Swing package, there's a class called JFrame, and you can look at this inheritance tree to see where it came from. It obviously inherited from the object, but you can see that there's AWT component, AWT container, AWT window, AWT frame. So AWT is an integral part of Swing, and that's why Brian and I wanted to briefly discuss it before we got into Swing.
So let's look at some of the constructors. So we have the default constructor. We also have one that takes in a title just as a string. Then we also have a constructor that takes in a graphics configuration object, and that has some information about the graphical configuration of the screen's device. And you can pass that in without a title or with a title.
Just to kind of expand a little more on the JFrame class, I mean, here's a couple other methods that we have here. Menu bar, a root pane, other stuff as we continue on. Param string, setting the layout, which we've used that in AWT, setting the root pane, and forcing an update, so it calls the paint method.
Right, setting a JMenu bar.
Right. And then here's just a bunch of stuff that it inherited from AWT. So you can see, like, there's stuff like changing the font and changing its focus and all the events, like the add window listener.
Setting the cursor.
Yeah, they figured, let's not waste the time rebuilding the event structure. Let's just change some things about how it looks and then use everything else that we put into AWT.
Right.
And then, holy shit, I'm not going to go over this, but that's some other stuff that are inherited from AWT.
Okay, so let's take a look at an example of doing like our first swing test, right?
Yay!
How exciting. This is pretty straightforward. This is not bad. Like, so we'll just march through this. We import the Java extended swing JFrame. So now we have it. We can use it. And in our main method, we create a new JFrame object called F. We'll set the default close operation. Look at that. To JFrame exit on close.
Wow, and that's an enum.
Yeah, so there's an enumerator that has like a bunch of common things. So we set the default close operation so we don't have to, because people were overloading that exit button all the damn time.
Yeah.
You know, they're like, whatever.
Why are you making me do this?
So we set it as a default operation anyway, which can still be changed if we need to. And then we set the size to 800 by 600, make it open in the middle, and set it visible. So you can see it's very similar to the AWT, but like a little, start seeing some of the conveniences kind of worked in here.
Absolutely. So what this application will do, and since this is written in Windows 7, the innards of the window will look exactly the same on every system, but obviously it's going to be encapsulated or contained inside of a Microsoft Windows frame, so you have the arrow look on this frame. And again, if you were using different operating systems, that would look different, but the innards, the actual frame itself, is what would be the same across platforms. Now let's take a look at another example. Now, it's fairly common, at least, in JFrame or Swing applications, particularly those written from hand, like this one is, to use subclassing or nested classing to, actually it's not subclassing, it's nested classing, to define things such as events. In this example, what we're doing is we're defining a public class called swing example, and that extends the JFrame. So my JFrame is actually going to be this object instance.
Right.
So in my constructor, I'm creating a JPanel, I'm creating a button that just says click me, and I'm adding an action listener, and check this out. The action listener is a new instance of button action, and I'm passing this instance as a parameter. So let's see what the button action class is. That's listed below in the subclass. Now, as we had talked about before in nested classing, this class is only going to be accessible to entities that are inside of the swing example class.
Cool.
Right? And this will implement the action listener. So the action listener is an abstract class that contains all of the events that we can use. You know, we used this before, but you know, before in AWT, Brian, we created a new instance and then we overrode or swapped out the action performed method. Well, in this case, instead of going through all that bullshit, we can just say a new instance of button action past this. So if you look at the constructor of button action, it takes in a JFrame source, and it just kind of stores that globally. And it kind of hides that away so that you can make an instance of this for as many different JFrames as you want, or as many different buttons as you want in this case, so that every time that an action is performed, it basically runs that on the source frame that was passed in the constructor. Does that make sense?
Yeah, because keep in mind, it's just a pointer to that instance that's in memory.
Right, exactly. Right. So we did this in the Objective-C when we were passing delegates left and right all the damn time, right?
Yep.
So in this example, and we haven't shown this code before, but the JOption pane is a class, the .showMessage dialog is a static method, and the first parameter is the parent frame that this is going to pop up on, and it's going to say, "Hey, buddy." So it's going to be an alert box that says, "Hey, buddy."
Awesome.
So when we click the button, it will say, "Hey, buddy." So now let's take the flow back to the swing example constructor, because now we just explained where the add action listener, how that functions. So we have the parent class, which is in any situation where there's a parent class, that means there is a nested class inside of it. So here is my subclass or my nested class. Now here on the top is the constructor for my window or my frame, and then below here I have a constructor for my little subclass or my little nested class.
Right, so those are the two constructors. Cool.
Right. So inside of my swing application, obviously, since there's a main method, there's a static main method that executes when the program is ran. And inside of here, you can see that we're going to be creating an instance of ourself. So it's going to be a swing example, my program equals a new instance of swing example. So this is going to fire this constructor up here. So inside of the constructor, we are going to create a J panel. So if you look on the right,
now, if you look at the right of the screen, you can kind of like see the idea of what we're going for.
Yeah, and it's kind of shadowed out because, as you know, Brian, the swing example extends J frame. So the second that I instantiate this, a J frame exists, but I don't have it visible, right? So it's just like hiding. So when I create a J panel, it's also kind of in memory, but it's not being displayed. Then I'm going to create a button. Now this button is a swing button. That doesn't look like a Windows button, does it, Brian?
No, it looks like a horrible looking swing button.
Yep, that's a swing button. And it just says, "Click me" on it. Click me! They're so self-absorbed, those swing buttons.
I know. It's like Alice in Wonderland in Swing, huh?
Yeah. So now we're going to take advantage of this subclass that we created. So just like we did in the AWT example, we're going to be calling on that button the add action listener, which is going to be adding an action listener. And we're going to use the nested class of button action. So by creating a new instance of button action, and we're going to pass this, which is the pointer, to the current instance that we're inside. And once the control goes down here into the constructor, all that it does, Brian, is it's going to store in memory, since remember this is going to be passing as a pointer reference, where the frame is.
Cool, where that instance of the frame. Yeah, cool.
Yes. So you can see that down here we have a little source frame which is pointing at the actual frame itself. And then we do the panel.add button. So now we've taken that button, so instead of floating out here in space, we've stuck it onto a frame. Now we add, since this is the J frame, we don't have to do the J frame instance.add, we can just say add. We've added that button to that little grayed out window. If you look very closely, there's a little button there. But it's hidden.
That's awesome.
We'll set the default close operation, so when somebody hits the X button, the program will just close. And we'll set the size to 640 by 480, and then we'll have the application start in the center of the screen, and then we'll bring it up.
Hey, there it is.
And there's our program.
Cool.
Now when a user comes along and clicks this button, it will actually run down to this button action instance. And if you look at this button action instance, there is a overridden method, because this implements action listener, which I think I failed to mention that before, but this implements action listener, so it can impersonate an action listener. When you click on this button, the button is looking for an action listener with a method called action performed, and if that method is defined, it will run it. And in this case, we're just calling the JFrame option class the .show message dialog method, and we're passing the source frame, which is
hey, look at that.
Yeah, which is the source frame is the current frame that we're on, and then the text is the message. So we were able to just get a "Hey Buddy" pop-up window to come up.
Cool.
Very, very, very cool.
Okay, so let's walk through another example where we have like a text field and a button, and we'll kind of like start adding some different types of things going on here. So again, we're going to have a swing example class that extends JFrame, and we're going to have some sort of button action. So since we're only one, we won't really specify like the name of it, but we'll create a nested class called button action that again implements the action listener, like we're getting used to. So we're going to have the pointer reference to source frame, which just starts at null. And then the constructor takes in the pointer to the source frame, and it just sets it. And then we override the action performed method, like we did before. And this time, what we're going to do is we're going to get the first name and the last name from a text field first name.getText text field. Because keep in mind, this nested class has access to the fields of the parent class. And the parent class has this, if you look on the top, see where it says J text field first name, and text field last name. So we have two of these text field objects in the parent class that we have access to in the nested class. So we're going to set the first name and the last name to the text value assigned to those two fields. Kind of cool, huh?
Yeah.
So if the first name or the last name are blank, then we're going to say, please enter your name. Otherwise, in that same kind of alert box, otherwise we're going to say, hello, first name, last name. And then we're gonna blank out the text, and then we're gonna request the focus into the window to kind of like hide this again and go back to the main window. So that's
requesting focus on the text field. So when you come back, your cursor will be inside the first name text box.
Beautiful.
Now, one thing that we could have done here, Brian, instead of calling those globally, if we had multiple frames, we could have said, instead of text field first name, we could have said _ source frame dot text field first name.
That's true. That's true. Absolutely.
This is a little bit kind of lazy. Maybe 3 o'clock in the morning working on this.
Yeah. Fair enough. So we create a dimension object. If we go back up to the top, we see we have a J panel, the main panel. We have a J button, the button OK, and then we have this dimension object, which is the text field size, and it's going to be a new dimension size of 200 wide by 25 tall. So that's the size of our text field, just stored generically as a dimension object. So now we go into the constructor, which this program does nothing but just call the constructor. So when the constructor is called, we instantiate the J panel and store it as main panel. Then we have the text field first name is a new text field, and the last name is a new J text field. So we just have instances for the text fields, so they're not null, you know. The button OK is going to be a new instance of the J button, and we're going to pass it the title string or the name string, the label OK. Then we're going to add the action listener, and it's going to be a new instance of that button action class that we implemented down below.
Yep.
And then and this is going to be the panel that we have, so it's tied to the same pointer reference of the panel's instance. And then we're going to set the preferred size of the text field's first name and the text field last name to be that dimension object we initialized earlier. So that dimension object text field size is what we're going to be setting the preferred size to. Then we're going to add to the main panel a J label, and it's going to say first name. And then, so notice we're not like placing positions.
Right.
So the panel kind of works like a like this weird like grid thing. Like if you're in HTML, and some of you might know this or not, in HTML when you create a table, they just kind of like the table cells just kind of like fill out the best they can, and that preferred size just sets restrictions on like how it kind of fills out the space. Anyway, so we add to the main panel the J label first name, and it's going to stick it wherever it can. Then we're going to add the text field first name, the J label last name, and then the text field last name, and then we're going to add a button OK. And now because we haven't specified the flow, it's going to be a centered flow, but we could set the flow to like jump to the left or jump to the right or whatever. Then we're going to add the main panel to the frame, and we don't specify the frame dot add because this whole thing extends the J frame. Then we set the default close operation to exit. Okay, then we call pack, and what pack will do is, since we didn't set the frame size, like we could have said the frame size is going to be this, but to keep it kind of flexible and however we want to add stuff, we just call pack, and that will stretch the frame to be whatever the total width and height as appropriate to what we've added to the panel.
Right, so it'll just kind of wrap the frame around the widgets that are on there, on the panel that's on there.
Yeah, it's kind of dumb, but it's how they roll.
It is what it is.
So then we set the location relative to null, so it opens in the center of the screen. We set the title, and we set the first name field to have focus when the window's constructed, and then we set it visible.
Okay.
So let's see what happens. What's it look like when we run? Hey, look at that! Hey, the first name. So you can see it's kind of like they're centered, and they just sort of like fill out the space as best they can.
If a user were to just run this program and then select OK, they're going to get a pop-up window that says, whoa, you got to enter your name. The cool thing is, when we come back, the focus should be on the first name field, and then the user will type Wibbit in one, and then .net in the other, select OK. Now they're going to get a pop-up window that says, hello, Wibbit.net. If you look back at this, you made a good reference to HTML when you just like add items to a web page. For those of you guys that know how to do that kind of thing, if you don't specify how it looks in HTML, like if you don't put line breaks, if you don't put sizes, it will literally stack everything next to each other. And that's exactly how Swing does by default. So as Brian was adding these objects to the panel, you see that the label was there, and then the text label was catted right next to it. The next label was catted right next to it, and then that other one was catted. The button was everything's on that one line.
Yeah, and the order they were added.
Exactly. So what if we want to specify where we want to put stuff? So I don't want to have all of my... Yeah, I know.
Whoa.
Whoa. Whoa. So Java expects UI controls to be encased inside containers, right? There are multiple ways that you can do this. I mean, through my experience looking at Java apps, I've seen a lot of clever ways people have pulled this off. Some are great. Some of them are really clever, but they require a lot of understanding about how the language works. So what Brian and I are going to do is we're going to use a simple to understand way, and we're going to be using JPanels, and we're going to be setting the absolute position of those JPanels.
Right. Okay, so let's take a look at like how this layering works. So here we have the J-frame. And the J-frame will just kind of like naturally have the window around it, you know, but it's mainly just that big area. Then we have a panel. Now the panel is like kind of sizeless. Then we have a UI item. And let's say that UI item is like a label, right?
Right.
So the UI item is added to the J-panel, which is then added to the J-frame. So it's kind of like a hierarchy of objects.
Mm-hmm.
So when the UI item gets added to the J-panel, now the J-panel contains that. When that gets added to the J-frame, now the J-frame contains that panel.
Right.
And that's kind of how the layering all sort of like piles up on top of each other and like gets consumed by the next layer up.
And what's kind of stupid about Java is I can't say, hey, text label, I want you to be here. I have to say, hey, text label, go to this panel. Hey, panel, I want you to be here. You know, there's like an extra unnecessary level. Yeah, an extra unnecessary level that's added to this. Let's take a look at another example where we're going to attempt to place a text label in a specific location. Now, look at this code example here where I have the set default to close, the size is this, I'm starting it in the middle, hey buddy, I make a J panel, and I make a label, I add the label to the panel, and then I add the panel to the frame, and then I set it to visible. Now you can see by default if I do that, hey buddy is just direct in the center.
Right.
I didn't specify any positioning. By default, it slaps it in the center. Now we're going to be using this set layout method here on that we have as this top line. So if I go back, you'll see that it's not there. Now it's there. If I set that equal to null, you'll see that since this is kind of assuming that I'm going to be working with absolute positioning, this is saying that, okay, well, I don't care that you added a panel to the frame. You're going to be positioning that, so you haven't set the position. Therefore, I will not show it to you. Now, Brian, explain to us how we can set the absolute position.
So what we're going to do is we're going to just restrict the panel that gets added to the frame. So we have so the set layout is null, as you said before. So that first line, we're setting it, you know, to not be retarded. So then we're going to set the bounds of the panel, and by setting the bounds, we say x, y, width, height, and we could get the requested width and height from something that we strict on the label, but in this case, we're just going to kind of like, you know, we sort of know what it is, and it's just to kind of show you. So we set the bounds to position 0, and the positioning always works like 0, 0 is the top left, and the bottom right is the width and the height of the frame. So we set the bounds of the panel to be restricted to starting at position 0, 0, be 70 pixels wide and 20 pixels tall. Then we add that panel that has the bound properties to the frame, and then we set it visible, and that moves the position.
Right, right. So we were able to specifically place that label exactly where we wanted it. Now, in this example, we've moved it over 120, down 55, and then the label 70 by 20. So I've been able to absolutely position this label in a different location.
No, that's awesome.
That's kind of cool.
It's much better than the whole like automatic laying out of whatever that is.
Yeah, it's stupid. So, Brian, here is kind of an updated version of that what is your first name application that you talked about before. Where
it actually looks like a form, no way.
Right, where we designed this more like a form. So, what's different here?
Okay, and I'll say right off the bat, you can kind of now see like quickly why there's NetBeans has a built-in GUI editor for like doing this kind of stuff.
Right.
You know what I mean?
Right.
So we'll just kind of say that. That's why you don't actually see people write these manually that often. You do. It happens, and it's very important to understand how this works. But you can see how this is like a very simple form, and this is just getting huge.
Yeah,
fast,
I'm definitely going to say that the new breed of developers do not do this.
Yes.
But I'm going to say the old schoolers absolutely do this.
Well, and sometimes the new developers don't have they lose a fundamental understanding, and it makes it difficult for them to get a designer to do what they need it to do because they don't really understand how it works.
Right,
you know?
right.
So anyway, we have another one. It's the J frame, like it has been before, and we have the J panel. We have a buttons panel now. So now we have a FN panel, which is like a first name panel. Then we have an LN panel, which is a last name panel, and then a buttons panel. So we have 3 different panels. So then we have a button OK, which is a new button with the name OK, and then we have a cancel button, which is a J button, and the constructor has the name cancel on it. We have 2 text fields, first name and a last name. Then we have the dimension like we had before, which is the text field size, and it's going to be the same field size, 200 by 25, about enough space. And on the button action, which is implementing the action listener like we're used to, all the same kind of stuff, but the action performed is going to say if the action event that was passed in as a parameter, if its action command is cancel, then we're going to exit the program. Otherwise, the first name, we're going to get the text from the first name field. The last name, we're going to get the text from the last name field. And then if the first name or the last name is blank, we're going to pop up that alert view that says, please enter your name, the message dialog.
Yeah, that's kind of cool though, Brian, because what we're doing is we're using the same action listener for multiple uses.
Exactly,
and we're using the actual, which we can't do in Objective-C, but we're using the actual like text on the button to dictate what's happening.
I mean, obviously, we could have just as well said OK button action and the cancel button action that had 2 nested classes inside of here.
Right.
But just to kind of show that you can make decisions based on getting the action command, which is interesting. So if we say enter your name, immediately following that, we're going to return so that we don't do anything else. If that didn't happen, we never hit the return statement, so we continue on and we show a message dialog that says hello first name last name, and then we clear out the fields and put the focus back in the first name field.
Beautiful.
Not too bad, right?
Beautiful.
Okay, so now let's take a look at the constructor and how we laid this out. So we set the layout to null so it doesn't like autofill all that kind of stuff. And because we did that, you notice we don't have that pat command in here because we don't need that. We're explicitly saying what everything's going to be.
Yep.
So the default close operation is exit on close. That's fine. And then we're going to set the size. This is the size of the frame to be 300 by 135. And we know that that's going to be enough space for the objects we want. And you can kind of like play with that and make it bigger or smaller for whatever you need. This isn't like a resizable thing, so it's kind of a fixed size application or frame that we're doing. Then we set the title to what is your name. Then we say the button OK, we're going to bind the action listener by adding the button action with the reference to this frame to button OK. We're going to also add the same thing to button cancel too. Then we're going to set the preferred size to the 2 text fields, and then this is where we kind of do that collapsing that hierarchy thing, right? So the FN panel, we're going to set the bounds to be, that's the first name panel, is 0, 0, so the upper leftmost position, 280 wide, which is like almost the width of the frame, and 30 tall. And that gives us like a little bit of padding outside of the 25 pixel high field size, right? Then we add the label to the FN panel, and we add the text field first name. Now, inside of that panel, we don't set the layout to be not null because within that panel, it's okay if first name and the label auto fill out. You know, that's not a big deal. And we're going to do the same thing for the last name panel, exactly the same thing. But this time, instead of position 0, 0, it's going to be position 0, 30. And we know that the height of the first name panel is 30, so we can start the Y position at 30. Then we're going to set the bounds of the button panel. Now, the button panel is going to be kind of like down and to the right, so it's actually going to be like 60 pixels down, which is the 2 30 tall pixels of the 2 top panels. So it's going to start at Y position 60, and then over the X position 140. This is going to be 135 wide, which means a total of 275, which is like, you know, still within the size, and then 35 tall. So then we add the buttons to that panel, and they get added in the order, and we're not going to set the layouts within those. We're just going to let OK and cancel fill themselves out. And then we add the first name panel to the frame, then we add the last name panel to the frame, and then we add the buttons panel to the frame. Now, because we've set the size of the frame, we're not setting right. So because we set the size, because the layout's null, these things have their panel size restrictions that they will each individually adhere to. So we add the 3 of those. They're not overlapping, and they could if they needed to. And then we set the field first name to be the field that has the tab focus. And then we show the application.
Wow.
Whew. Holy shit.
But that is...
Man, that's a lot of shit to do just for a first name and last name.
It is, Brian, but you do have to kind of appreciate some of the elegance. I mean, it really isn't that bad. The only complaint that I have is the whole positioning thing, but other than that, you know, I'm just creating an instance of a button, it says this, and then when I click on it, it does this.
Graphical user interfaces in general is its own type of layer of complication to any application.
Right.
And that's why it's so incredibly important. Once you actually get into designing and writing applications, applications. We talk about how we don't really like this approach because it's not separated, and that's absolutely true. When you get into application development, it's crucial to keep your presentation fully separated from what the application's doing, like keep your actions and your events and the things that are called I really like the model view controller approach.
Yep, I agree.
I think it's really solid. So you have your classes that do your work. You have the controller that causes your presentation to interact with the data, and then you have your view. It's really nice. And keeping those separate, you can see how complicated this can get so quickly. Having your data operations mixed into those can just make this thing into a nightmare really quickly.
Graphical user interface design using Swing in Java the basics are fairly simple. We didn't get into anything that too terribly complicated here, but we are going to kind of expose you to a little bit. We're going to push this just a little bit more, just so that you walk out of this course with a fundamental of how to build some basic GUI applications that you can actually take with you, and you can start using this knowledge to start building some pretty awesome programs.
Cool.
Yeah. I'm excited. How about you, Brian?
Yeah, and I hope you guys enjoy this run through.
Yeah, and actually, we're going to be coming back in a lab right after this where we're going to be designing a graphical user interface calculator from scratch.
Hello, everybody. Welcome to our Grandmaster Lab for Programming in Java. This is going to be our calculator project.
Did you really call this a Grandmaster Lab?
Maybe. It's kind of like a Grandmaster Lodge, but...
Lodge?
I don't know.
I'm lost.
Like the Freemasons.
I have no idea what's happening, but what I do know is that we're about to make a calculator in Java.
Yeah.
Which is pretty awesome.
And not just in Java, but also using Java Swing.
Yeah, that's right, because everybody hates Swing.
And you'll see why.
So, Brian, we are officially awesome, right? Because we've gone through the whole Java course, and we've learned about classes, we've learned about methods, we've learned about AWT, swing, sockets, threading. I mean, holy crap, that's a lot.
Yeah, we spanned the gamut.
Now we're at a point where we're not just building a little form application to take in a first and a last name. Now we're going to actually build a practical graphical user interface application. So that's pretty awesome.
Yeah, so think about where you came from and where you started and what you started off doing, just kind of going through loops and stuff, and now you're building you're all the way up to the mid 70s building graphical calculators and stuff. It's awesome.
Nice.
So we're going to here's how we're going to do it. We're going to make a calculator class that's going to perform all of our basic arithmetic. So our adding and subtracting, multiplying, all that kind of stuff. And then we're going to build the class using a console application first, and that's going to be like our model.
Right.
And we'll use the console application to kind of test our model and make sure that it's like a properly functioning class. After the testing is complete, then we'll apply the class to the GUI so that we have that model backend, and then we'll have our GUI application that communicates back to the model.
So, Brian, this is what the end product...
Holy look at that thing. That is awesome
That's
looking.
what we're going to end up with.
That's a crazy looking calculator.
So I'm definitely excited for you guys to see this now. So maybe this will get you fired up to actually follow this lesson.
And like the buttons, like the way it looks, there isn't really anything you can do about it. That's just kind of that's swing.
Swing, yeah.
That's swing. It's interesting. You'll see. And as you'll go through swing, you'll probably start realizing oh, I've seen programs that look like that.
Yeah.
That's what the hell that is.
And you'll after a little while, you'll be able to recognize programs written in Java just by seeing them.
And then you'll also recognize how long it's been since you've seen the Swing application in real life.
Oh, no, it's so funny. I'm able to do that at work, where recently I was doing some work in some application, and somebody was showing me something, and they were saying, can you do this, can you do this, can you do this? And I was like, oh, yeah, this is all written in Java. Well, how do you know this is the first time you've seen this? No, I can just look at it. I can tell this is Java. So I was able to give them, the capabilities of what I could do just by how it looked, because it has that ugly, disgusting Java feel to it. So let's take a look at the different pieces. So, let's break this apart. Let's take the calculator with a hammer and smash it, and let's see what's going on. So we start here with a JFrame, and that's basically going to be the container for our GUI objects. So all of our widgets and buttons and text fields and all that stuff is going to be encapsulated inside of our JFrame. We're also going to have a bunch of buttons, and the buttons are going to allow the user to interact with our backend class. So this is what the view, right? So this is going to be the view that interacts with the controller that interacts with the model.
Also with the JFrame, the little icon on the top left, the title, the Windows looking, set up when you run this in Windows, and the close buttons on the top right, those are all kind of natural parts of the JFrame. And those are built differently for different environments. So that component, unlike the other components, will look slightly different depending on your operating system.
Right, yeah. The guts should look the same, we hope.
Yeah.
We'll see.
So this calculator can run on Linux, it can run on, in theory, it can run on Linux, it can run on Mac, it can run on Windows.
Although, as we learned with the Socket Lab, that's not necessarily the truth.
Yeah, just don't have any sockets in your calculator.
Don't put sockets in your calculator.
Yeah.
Send this calculation out to...
Oh my god. Well, yeah, just don't do anything more than like adding and subtracting and you're fine. Moving other platforms.
So here we're going to build a JText field, which we used before when we wrote that application to just take in a first and a last name. So we kind of are a little accustomed to how this works. Now, Brian, how is this little JPanel layout going to work?
That's crazy.
Yeah.
So look how this is all sliced and diced. You can see all the different little J panels all over the place. And that's what we use to sort of lay out. It's kind of like a table structure that lays out where things are going to be placed.
Yeah.
And this is actually not a bad thing to see if you're going to end up getting into Android development.
Yeah, there you go. Which we'll hopefully expose you to next.
So this is it's not quite like an HTML table, but it's basically just a bunch of panels that are, that have to be touching each other. You never have a gap between J panels unless you, set a padding or something, but J panels will fill out until there's another one there.
Yeah, or I think you could set the absolute positioning as well.
Okay.
Whatever. All right, Brian, so now that we kind of have the overview of what we're going to do, let's come back and let's talk about how we can plan the design and the coding of this project.
Awesome.
All right, welcome back, guys, to the calculator project. In this lesson, what we're going to do is basically talk about how we can plan building a project like this. Now, those of you guys that have followed the Wibbit guys here for a while know that we wrote a similar application in Linux. We did a Linux GUI calculator, but we just kind of wrote it and didn't explain what we were doing. So when we did this again for Java, we wanted to make sure that we went through the process of breaking the problem down into small parts, how the class structure is going to be designed, how the flow and process flow is going to work. So Brian, let's start off here. How will the calculator work?
So the first thing that we do when we plan out a project is you try to imagine the end product and what it's supposed to do.
Right.
So we picture what's a calculator and how does it work. I mean, that's pretty easy, obviously, but we chose one that would be easy. So there's plenty of conditions that have to be accounted for, and you have to keep in mind that there's an unlimited number of ways to get a calculator to function. So there's so many ways that a calculator could function, but we're going to imagine one particular way a calculator will function.
And there's also many ways, even if we have the same functionality, there's many ways that I could write it, and many ways that Brian can write it, and that you can write it. So don't take this as a best case. Take this as an example.
Right.
So if we take a look at the class overview, Brian, we're going to kind of break it apart like this. And we're going to do this to just kind of expose you to the different parts of software development. Now, do you have to design it this way? Of course not. You could just build one class and encapsulate everything in one class. But we're trying to teach you guys the different levels of development and the different parts of development. So we're going to start with a calculator base, which is an interface, which if you remember when we were talking about an interface is basically just templating out what a class can have. And the reason why we would do that is if we have different things that have the same base functionality, like the example that we had before was a phone, right? So every phone has numbers. You press the numbers do something. So it's reasonable to expect every phone to have numbers. Well, in this case, it's reasonable to expect every calculator to have guaranteed certain things like numbers, arithmetic. The abstract class is what we're going to be kind of defining some of that functionality, and then we're going to have our Wibbit calculator, which is our unique calculator. So the back two are the very back one is for all calculators. The one before it is a little more functionality, and the front one is our specific calculator. So
that's awesome.
That's kind of how it builds out.
Very cool.
So process flow, Brian. Let's take a look at the flow. Remember this, Brian, from the introduction to computer programming?
Like making a peanut butter and jelly sandwich.
Yeah. Only a lot less awesome? I don't know. I kind of want a peanut butter sandwich right now.
So when we start the application, we're going to kind of move through this flow. So the first thing that we run into is that we're going to have a number of different attributes, fields. So we're going to have a storage queue, which is going to be an array, which is going to be all of the different, we typed in a number, we did an operation, we typed in another number, and so on. Mm-hmm. And then we have the queue index, which is where we are in that queue. Then we have the string to display on the top text field of the calculator. Then we have whether or not we just calculated a value or if we're pending to calculate a value soon. Then we also have the sent operator, which is the plus or the minus or whatever that's pending the calculation.
Right.
So once we have all of those base components, then we can present the user interface, and we can determine, was a button just pressed? Was a button just pressed? Was a button? Oh, cool, a button was just pressed. Press button. Was a button just pressed? Was a button just pressed? And that's going to be our basic process flow of basically just waiting for engagement on a button being pressed, and then it commits an action, and then it waits again.
Right. So as you recall, the circle is going to indicate an off-page reference. So on this page, we're going to see the press button. Now, don't get confused by this. This is actually fairly simple if you don't get intimidated by all the arrows. But you'll see that when the button is pressed, we go through a series. Remember we have that decision list that we talked about in Intro to Programming? Is it a digit? Is it a decimal? And then we have these green ones, which are operators. Is it a plus, minus, multiply, divide? Is it an equals? We have C, which will indicate clear. N, which will... I forget what N does. I think that's negative. And then S would be a square root. And then anything else, we have a last condition. So if we start taking a look first at the is digit, so we type a number, so like 0 through 9, we fall in and we append this digit to the display. And if you follow the flow, then we just return back to the loop. So I mean, when you type a digit, that's the simplest part of the algorithm. We press a dot, we have a couple of decisions that we have to make. Is the display blank, or was an operator just sent? And we'll kind of see how that functions later. But, you know, if the display is blank, Brian, when you have a calculator, oftentimes there'll be a 0 when you press a point, then it will say 0 point something. That's just accounting for that. If the display is not blank, it checks to see if there is already a dot, because you don't want to do 1.5. You just want to do 1.5. And we just append display, and then we're gone. The numbers, there's another thing we're going to look at that does the number operator, so we'll take that as off page. But there's also, Brian, some other exciting stuff, like equals and stuff. It's crazy.
Yeah.
Yeah. And if you look off to the left, there's like that little append display. So kind of, in order to prevent you guys, I guess, from being bored out of your mind, just kind of study this. This is going to be part of the supplemental material, so just read it and understand it, because I don't think Brian and I really want to go over this anymore. Do we?
Do I look that zoned out?
Yeah, you look like you're ready to fall asleep over there. I'm talking and you're just like...
Huh? What? Where are we?
You look like you just went partying last night or something.
Little zoned out.
So Brian, process flow for the process operator. Just a quick overview on what we're doing here.
So when we go to process and operator, if the Q index is 0, then we're going to set the storage Q index at 0 to be the displayed value, index 1 to be the operator passed, and then set the storage Q index to 2. So, and then it kind of keeps us moving. And then we set the flag that we've sent the operator. So that actually processes the operator. If the Q index is not 0, which means that we're not in the beginning, that means something hasn't been passed into the queue yet. So if that isn't the case, then we go down and say, is the Q index 1? If it is the case, then we say an operator is passed. We set the sent operator to true and set just calculator to false, because that means that we have not finished completing our equation that we want to perform. We're only halfway through it. If the Q index is 2 and the set operator is false, then we append to the display, and then we append to the display the number, the result, and then return. So that's kind of the process of deciding, is this do we have just a number and we're pushing the operator? Do we have a number, an operator, and a number, and we're pushing the operator? What is our condition?
Right. And you could also see that just kind of doing this kind of makes it a little bit easier to build your application, because you already have a logical flow of how everything is going to work. So that's kind of the planning phase. Next, we're going to have a discussion about the actual code for the abstract class.
Cool. Awesome. Let's do it. All right, now let's take a crack at our abstract classes for the calculator project.
Okay. So, whoa. We just jumped right into code. What is this, Brian? What's happening?
That's awesome. So here, what we're going to do with our this is going to be the interface to calculator base. So what this is going to be doing is it's going to be telling the implementing class what we want it to implement. Right. Basically. Yep. So we're kind of setting constraints, saying, if you decide to that you're going to implement the calculator base and declare that your implementation class implements calculator base, this will force you to implement all of these methods before it'll compile the program.
Yep, exactly.
So the methods that we've set in here is pressing a button, any button, and it should be versatile enough to handle anything that you type in. Setting the display with a double value instead of a string.
Right, so you got an overload there.
Yep, and it's kind of for convenience. And then append to the display a character, so you just throw it on the end. Slap that ass, also known as. And then getting the display value, and then getting the display itself. And the display value is always going to be a double. And the display itself is just the string representation of exactly what's on the display.
That way you can get display value and you could,
perform
calculations and get display as a string. It'll be formatted properly for a string. So when we take a look at actually implementing this, Brian, now this is kind of a skeleton of the abstract class because we've implemented the methods here, but we haven't actually done anything with them.
Right.
So if you take a look at the declaration, this is a public abstract class and it's called calculator. So since it's a public class, we're putting it inside of a file called calculator.java. And this implements calculator base, so it implements this code here. Now, the way that this abstract class is choosing to implement this code is it's creating a private double array, and that's calculator Q, which is going to be storing the current values and the current operators that our calculator is going to be using. And you'll see how that works as we go along. The index Q, this is starting to look a lot like that flowchart, Brian, isn't it?
Yeah.
The display value, the just calculated flag, and the sent operator flag. Now, since we're using these as global variables, we're kind of using that underscore naming convention that we've struck before. We also are trying to implement these methods. Press button, set display overload.
And that's everything we just saw in the calculator base code.
Right.
It's just laid out, and instead of a prototype declaration, kind of it's
right.
It
It's
has
ready.
the implementing code block ready to go.
Right. So now we could actually implement it, Brian. So when we first start looking at this, we have to decide how to handle pressing a button. And if you remember our flowchart, what was the first decision in that decision list?
Is it a digit?
Precisely. So the first thing we do is and we're calling a static method on the character class called isDigit. If it is a digit, then we're going to call the append display method, and that's really all that we're going to do when we first start.
Yeah, because if it's a number, you just slap it on the end.
Right.
Get a number, slap that ass.
Yeah,
Get another
spank
number,
it on there. Exactly.
spank it on.
Because you can sit there and type all the numbers in the world. The second you type something that's not a number, we got to handle it differently.
Getting jiggly by typing on there.
So let's continue through this method, Brian. What is the next condition that we're accounting for?
So the next one is if the button value is a period, which means that you want a decimal place in the number. So if there's nothing in the display value or the sent operator is true, then we're just going to append a 0 and then append a dot because we know that there's nothing going on in there or that the screen's ready to be cleared. So we're going to say 0 dot and then wait for the next number.
Right.
Just by putting in the period.
Yes.
And that's a pretty standard way that calculators behave.
I think almost every calculator behaves that way.
And then the other thing that it checks is if it's not blank, if the display contains a period, we won't add another one in there. Because obviously you can't have 5.12.4. It wouldn't make any sense.
Yeah. Now the next condition is we're looking for an operator. So is it a plus?
Now this isn't operator overloading.
Yeah.
This is operator handling.
Is it a plus, minus, multiply, divide? So we have that index Q. Now that index Q, if you look at that comment, well, there's not even in the comment, but if you look at the index Q, that's pointing at the current index that we're working with in that little array that we had globally defined, which is the calc Q. So basically what it's saying is if we're pointing at index 0, which means the queue is completely empty, maybe you either just cleared the calculator or you just fired it up, so we're just starting this thing fresh. So we have the calc queue at the current index, which is 0. We're going to get the displayed value. So what does that mean? So let's say Brian typed 100 in the calculator. He put in 100 and he pressed plus. So now what we're doing is we're extracting that value 100 and we're putting it in Q index 0. And then by using the increment statement plus Q index, what are we doing, Brian?
We're incrementing it and then also sending the result of that increment to, if this value at this point in time is 0, plus Q index will actually not only increment that variable to 1, but it'll actually pass 1 in that array position.
So in index 1, we're going to we're just basically going to convert the button value to a double. So in essence, we're just storing that in the queue. So now the queue is going to be this.
What we could have also done, which I think is more confusing, is we could say Q index plus plus, and the first time we use it, it'll be 0. Then on the second line, we could say Q index plus plus, but it'll be 1, and it'll be staged for the next one, and then the third one will just be Q index.
You could.
But that's way more confusing in my opinion.
You could. But yeah, you're right. That will give you a couple additional lines. If that makes you feel more comfortable, then...
But it would just be, it would be stupid. Don't do that.
So at this point, what we're storing, at the end of this, so you see that the last value equals 0. So Brian types 100 in the calculator and then presses plus, index 0 with 100. The middle index will equal the ASCII integer value or the 8-bit Unicode value of the plus character, and then we're just going to store the last one as 0 because we haven't done anything with that. And then since an operator was sent, Brian, we set that sent operator flag equal to true. So there are a few other conditions, Brian. So when we press any of those different operators, if we're looking at the last index, which means that's the condition, Brian types 100 and presses plus, we're looking at that last index value.
Right.
So if we have already previously performed an operation, right, Brian? So you've done 1 plus 1 equals. The way that and when we look at the equals method, we'll see how this works. But the way that most calculators handle that is the result of that addition will be stored in the first index, right?
Right.
So that you can do stuff like 1 plus 1 plus 1 plus 1 plus 1, and it will continuously perform that arithmetic.
So you can say, let's say 25 times 2, and it shows 50.
Mm-hmm.
And then you can say plus 5.
Right.
Or,
plus 5 minus 2, or something like that.
Or you can say plus 5, and then plus, and it'll show you
the result.
55, and then you say 6 plus, and then it'll show you the result.
See,
7 plus, it'll show you the result.
You said it in a way easier to understand way than I did. So this handles that condition. So you're sending that next value coming in. The previous value was not an operator. We force an equals to perform, which we'll explain how that works later. And then we just send that button value to the calculator display. And then this last condition, if only one value is stored, then we just kind of, like what we were doing before, we just do but in this case we're just doing a plus plus, because we're storing an index value 1, but we want the Q index to move over 1, but not to return that new value, and we just store the button value. So basically that's the condition where a number is in the queue, and we are pressing the plus button after that, or the operator button after that. So, and that's why the sent operator flag is set equal to true.
Cool.
Was that explained okay?
I think so.
Okay.
I think that's not bad.
All right, so Brian, now let's continue on this rampage of pressing buttons. All right, so Brian, now let's continue on this rampage of pressing buttons.
Okay, so now what happens if we hit equal? Because equal is actually going to perform the calculation.
Right.
If the Q index is 2, so that means, as you can see in the comment, if you have one number and one operator is previously sent. So this is the most common situation.
Right.
And so what this will do is it will take the display value and it will store it into calc Q2, which means now we'll fill out, because that means we have the final value pending and we pressed equal.
So now the Q will contain value, operator, value. So like 1 plus 1, 10 times 10.
Right. So now we're totally complete with that. So now at that point, after that first line, that calc Q is totally loaded.
Yep.
Now we'll perform a switch on calc Q. Sorry. We'll perform a switch on the calc Q position 1. And that's where we're storing the operator.
Mm-hmm.
So in the case of 43, which is the plus character, we're just going to say position 0 plus position 2. And then that gets stored as calc Q0.
Yep.
Which is always the base. Always the base. In the case of 45, it's the minus symbol, so we subtract them. 42 is the multiplication symbol, so we multiply them. So on. In case 47, we're dealing with the division. We don't want to have a divide by 0 issue. So we're just going to say if the calc Q2 is 0, then we're just going to print out that you're retarded and you can't do that. And then we're just going to set the value to 0. We're just going to clear it out. Otherwise, you can just divide them and we'll put the result back.
Or
out
you could also just throw an exception there. We just chose not to do that.
Yeah, exactly. Yeah, absolutely. So then we break out of this condition. After that, apart from the fact that, the Q index was 2, regardless of that, this isn't an else or anything. Then we set the display with calc Q0, which is our result. And then we say that we've just calculated, we turn that flag on, and we reset our two Q values to 0 and 0. And then the Q index goes back to 1.
Mm-hmm.
Or actually goes back to the center value. Because we have our display value now set to calc Q0.
Right.
Our operator is kind of like quasi-pended. So we set the Q index of where the operator is going to go.
Yeah, so this condition, you could imagine if you did 5 plus 5 equals, index 0 equals 10. Now we're pointing back at that middle position. So you could do 5 plus 5 equals, and then plus 2 equals, and that will give you, 5 plus 5, 10 plus 2 is 12.
Right.
Which is a traditional way that a calculator will function.
Yep.
And for those of you guys that are confused about those numbers, just look at your ASCII chart because that's what that 43, 45, 42, and 47 are. So
and the logic of this will keep becoming clear as we actually start getting into it and go through the, you know.
Right, and actually see how it behaves.
Yeah.
So when we start talking about C, what we're using C as is that's kind of our cue to clear the calculator. So when the user presses the clear button, we're going to send a C into our abstract class. So what this is going to do is this just kind of rolls through the queue and just sets everything to 0. Do you have to do this? Nah, we're just doing it for aesthetics. Because the only thing that really matters is what the queue index is pointing at. So after we kind of set everything to 0, make it all nice and pretty, we set the queue index back to 0, we clear the display, we set just calculated and set operator flag to false. So we basically mimics putting this calculator back in its original startup position.
So in this condition, we want to set a negative number.
Right.
So if the button value is n, and we'll just use that, you know, because it's not a digit and it's not subtract. That means we want to make, you know, we type 45 negative, and that means negative 45.
Mm-hmm.
So we take the display value and we multiply it by -1, which is the, you know, the way you inverse a number to be negative.
Right, right.
And then we just set that back to the display and set the queue index to 1, and then we wait for an operator.
Yeah, simple enough.
Yep.
So when we start talking about the square roots, the first thing that we have to check for, because we're not interested in getting all super mathematical and getting into imaginary numbers, like, you know, when you do square roots of negative numbers and you have lowercase I and that kind of stuff, we're not going to get into imaginary numbers. So in order to make sure that we don't deal with imaginary numbers, we need to... I mean, because technically you can do negative square roots, but they're mathematically difficult to explain if you haven't gone, you know.
Yeah, you might want to might want to build a beefier calculator than the swing.
Yeah,
calculator.
right. Yeah. So what we're going to do is we're just going to double check, make sure that our value is above 0, so we can do a positive square root, and then we just use in the math class that comes down from one of the packages from Java, we just run the sqrt method. Run a square root, set that as index value 0, and then store that value in, or set that display, and then since we've performed an operation, because square root is technically an operation, we then set the Q index back to the middle position of the stack.
Just like what happens when we set it to hit equals.
Yes, exactly. So now, Brian, these are the two most difficult to explain methods
these ones are,
that we have.
So when you set the display, you set the display value.
Could you slow down for
Okay.
those of us that are kind of slow? And
So the view, the text view of the display value is going to be tied to an internal private variable display value, which is why we have the underscore on there. When you set the display, the value gets passed in the parameter and stored as that internal display value.
oh, that's crazy.
And then, yeah, I know. And then if it's a double, then we actually just call set display, but we just convert the double to a string. No big deal.
That's pretty simple. So when we start talking about appending a value, so there's a little bit of logic here, but not much. So basically, the first thing that we're going to account for is have we just calculated? So this is for the example where the user doesn't use a calculator in a traditional way. Well, I guess technically it is, but you're using your previous result to perform a new operation or a new calculation. So this handles the condition where somebody does 1 + 1 = 2 + 2 =. There was never a 1 + 1 = and then clear with the new value 2 + 2. So we're actually doing that 1 + 1 = 2 + 2. That whole thing is one operation.
Right.
So as we if we just calculated it, we want to make sure that we clear everything out and just kind of allow that next calculation to take place. So if an operator was sent, we just set the display to 0, set operator false, and then all we just do is append the character representation of that value, that numerical value, to the display, the private display value.
Sweet.
I guess. That sounds about right.
Nice. I get the hard ones.
You always get, yeah, what the hell is this?
So then when we call get display value, all we're going to say is if the display value has nothing in it, if the screen's clear, then we're just going to return 0.0 because it's a double.
Right.
That's no big deal. I would imagine clear screens mean no value. And then we just return double because remember we store the display value as a string.
Right.
So we want to convert that string to a double,
Mm-hmm.
which we call the double class has a static method, static public method, parse double, that takes in a string and returns the double value of it. If it can, it'll try to.
Right.
And then we'll just return that value.
So now, Brian, now we're actually moving into, so we had this discussion when we first came into this project. We're starting with the interface, which is all calculators, at least of this type, must contain this functionality. Then the abstract class took that, and then it actually put some guts to it. So then what we've done is we've defined a specific type of calculator, but now what we want to do is we want to take those two concepts and apply them to our specific calculator. So now we're actually going to make our Webbit.net calculator.
Cool.
We're going to use all that other work that we previously built to simplify this portion of the project. So as you can see here, we're making a public class, which means it'll be inside of a file, webbitcalculator.java, and that's going to extend calculator, that last class that we just talked about. And by extending it, Brian, we are inheriting
it.
Yes. So as you can see here, we're just kind of adding a few things, right? So we're doing a process string, which is the exact same thing as doing the press, like the process button, except for we're allowing to take a whole string of something and then
Nice.
So you could literally do like 1 + 1 = 5 + 6 = 10 + 10 =, send that whole string in there and the calculator will chunk right through it.
Nice.
That's what that's there for. And then we just have a get display value, which just kind of returns the value of the private value that, or the protected value.
So that it's publicly accessible.
Right. That was from the previous code.
So not too bad, right?
Yeah, and that's pretty simple. So now what we're going to do is we're going to break out of this lesson. We're going to jump into a lab where we systematically write these out, and then we're going to talk about how we can test this.
Cool. Hello, everybody. Now we're going to jump into actually writing the code. So now that you've had the explanation of the code and we've kind of reviewed how we're going to do this, we're just going to kind of do like a mad dash of it.
Yeah, why not?
We're going to be like Arnold and Running Man. And just...
That's a great movie, by the way.
Just break that collar off our neck and just knock it out. So in our Java folder, our awesome Java folder on our desktop, we're going to make a subfolder called Calculator.
Doesn't that almost sound like something the Ninja Turtles would say? Calculator, dude!
Mathematical. All right.
That's something that definitely Donatello would say that. Donatello was the cool one.
Yep. Because he was also the most versatile. Like, the other guys are like, oh, I don't have nunchucks that I could use. I just have some sausage, and that doesn't really hurt that bad.
Sausage.
To, like, make shift for a weapon.
Yeah.
And the other one had the size, like Raphael had the size.
Yeah.
But what could you use as a makeshift size? Like a fork? That's not going to really be cool. But Donatello could be anywhere and just, like, snap off a broomstick and just f*** some people up, or, like, grab a light stand or a whatever, like, anything he could find, just any kind of stick, like, break a leg off a table and just pummel some like, the guy is awesome.
Just, like, rip an arm off a foot soldier.
Yeah,
there you
exactly,
go. You're good to go.
Donatello was awesome. He just, like, all these guys had fancy swords and he just had a stick, and he totally held his own. He was awesome. Anyway.
Well, he was, like, the smart one, too. The computer guy and everything.
Yeah.
All right, so, Brian, inside this directory, what are we going to do?
We're going to create another directory called, we're going to create a subfolder called source. And that's where we're going to keep our source code files. And as soon as we've got it all built out and are ready to compile, we're going to compile and save our class files into this parent calculator directory.
Right. And then we'll jar it up, and we're going to be good guys, and we're going to leave our source code with our jar files.
We'll be jarheads.
We're going to be jarheads. Precisely.
Not at all.
What? That was almost funny.
Yeah.
I mean, I'll give you like that much. So inside of this source folder, as Brian said, we're going to just have some files. So we're just going to create some new text documents. The first one that we're going to create is our calculator base. So calculator, dude, calculator base.java.
Cool.
Yes, I do Windows. Thank you. And let's just go ahead and make all of our source code files. The second file that we're going to create, calculator.java. So we have our interface and our abstract class here, and then let's go ahead and just build our specific calculator, which
also known as the Webbit calculator.
Webbit calculator.java. All right. And inside of the parent directory, no, we'll just do it inside of source. We'll just make a driver code file, which we won't package up. Well, we might. Something that has no, we do have to have our driver code file. So
main class.
.java.
That'll be our entry point.
Right. And we'll also, later on, either in this, we have to build our graphical component, right? I mean, right now we're just building our model.
Right, because we still have to run this on a command line and, make sure it functions properly and all that kind of stuff. So this is going to be our intermediate entry point.
So let's first, Brian, start with the very complicated...
With Notepad++.
Yes. And we'll start writing in the most complicated class we have, Brian. What are we doing?
Oh, yeah. So this is going to be public interface calculator base. And we're declaring an interface because we're not actually going to be implementing any of these methods.
Right.
We're just going to basically declare them and say that whoever implements this class needs to define out and implement these methods.
All right. So we start with the
So these are kind of
press.
like required fields on a form.
Right.
Sort of, but only for programming.
Yeah, you can look at it that way, right. So just like we had discussed in the videos, we're creating press button, then a set display, and then we're going to make another set display, but this one
We'll have a double.
is going to take in a double. You like that?
A dubali.
A double. We also have a
A
public
double.
void append display, which we've already talked about these, so you guys should know exactly what we're talking about. So we have that, append display, public double,
Get the display
get
value.
display value,
Nice.
and then public string get display.
Cool.
And that's really our abstract class. So
Done. Look at that.
now, just to be kind of crazy, I'm just going to write a main class here, public class, main class, and we'll just make a public static void main string args, just because. And I don't really think that we have anything compilable at this point, but let's just say that we want to just kind of get our whole system set up for compilation. So on the desktop, which is where we stored all this stuff, we wrote a Java directory, and then Brian made a calculator directory.
Yep. And then the source directory.
So inside, ooh, wow, what operating system do I think I'm in?
Nice.
I did it again. Sorry, I work in Unix an awful lot. So if we do a dir, whatever.
Clear makes more sense. I mean, do you really need to save those couple characters?
CLS,
it's like 2 characters.
Yeah, in ls, in dir, I don't know. I like ls.
I like ls. Yeah.
For
I
anything,
think dr would have been best.
anything command line, I prefer. I mean, but there's dir in Unix.
No,
There is.
no, just dr for like directory
Oh,
list.
dir?
But that
Yeah.
doesn't even make sense. It
And
is
I
a
like
list.
the Unix MV,
LS makes
CP, instead of like COPY, MOVE. I just like the
Yeah.
Anyways, so inside of here we have an src directory. So we can, from this context, we can say Java C, right? Slash src slash star dot Java.
Sweet. That works.
Did that not work?
No, that did not work. Oh, other slash is wrong operating system.
I thought that Windows would accept those.
Maybe do like a dot.
Oh, no slash src like that.
Yeah.
So now if I do a dir, you'll notice that they're still in this context, dir star dot class. So it still compiled them inside of this context. So when we're actually done with this, we're going to move these back into that parent directory. But for right now, this is just fine. So inside of, so we just, run main class without the class. All right, it ran. So just so that you guys don't get too scared, let's just do del instead of rm.
Oh, yeah, that's right.
Let's go back to the parent context. And Brian, let's just say that I want these to compile in my current working directory. How do I do this?
You should be able to say -d and a dot.
Okay, so that would be -d.
Yep.
And then dot, which is pwd.
Right, that's
present
our
working
current
directory.
Right, exactly. So that's our current directory. So that should make the destination folder our current directory.
There you go. So check it out. Now our class files are located here. We go back up. Here's our actual our bytecode files, and our source code files are here.
Nice.
Not
So
bad.
that's nice and separated.
Right. Welcome back, everyone, to the actual coding of the calculator.
Yeah, so this is going to be the meat and potatoes in the calculator.java file.
That's right. So, as Brian was saying, we're going to take the calculator.java file, and we're going to start building this. Now, as we did in the last video, we wrote the interface that this class will be implementing.
Right.
Now, Brian, remember, implementing is implementing an interface.
Yep.
Extending is
Inheriting. So we're
Inheriting.
not inheriting the class. We're
Right.
just being forced to make sure. It's like a check and balance to make sure that we write all the methods we need to write.
right. So please remember that, because I know a lot of developers that don't know the difference.
Yeah.
And it's
And
kind of embarrassing for them.
And I think sometimes the reason is it's sort of there's like weird conditions where you would need that. You know what I mean? So it's not something that happens all the time. It's usually just in cases where you need, if you have more than one class that implements the same abstract class, it encourages better polymorphism between those classes.
Yes.
But in this, we're showing you this example so that you get used to it, so that you can recognize it and you understand it, because that's what this is all about.
Yep.
Obviously, you don't care to make a calculator that can like run on your desktop, and I mean,
right,
I do.
Because there
I
already
use it all
is
the time.
one. Do a start run CALC enter done.
Exactly. But so we want you to be familiar with the abstract class idea, and it's you're going to run into it as a Java programmer. Yeah, there you go. It even looks better than that swing crap.
Yeah.
So, Kevin was saying earlier, in this case, we're building a Wibbit calculator in particular, but we could have a Bob calculator and a graphing calculator and a whatever.
Right.
So it's more often in those cases where you have a bunch of different calculators, and then you need to have more polymorphic options between those different objects that it comes up. But it's still a very important idea, and it's a very fundamental concept, being a halfway decent Java programmer.
Yep. Absolutely, Brian. I couldn't have said it better myself. And as you were saying, get used to it, because whether you like programming this way or not, a lot of legacy code is kind of written in weird
a lot of
ways.
Not legacy code is written in weird ways
That's
too,
true.
unfortunately.
That's true,
I mean, you're not going to be the one writing everything from start to scratch, unfortunately.
That's true.
So
take it from us, learn it all.
Yeah, absolutely.
You're talking about some battle-hardened developers. Two very, we have shell shock from our development experiences. So as we start implementing this abstract class calculator, Brian, in our flow diagram, we had some values that we're going to store that we talked about in the lessons that we just went through. And we're going to store some of these as private and some of them as protected for different reasons. So what's the first one that we're going to create?
The first one we're going to create is the calc queue.
Okay. After we create this, we're just basically going to make a new instance of double, since it will, after the class instantiates itself, it's just going to keep this in memory.
Yeah.
So we're going to also be able to keep track of this
by having a queue index.
Right. Now, what's the next value, Brian?
The next one's going to be the display value, which is the string. And that's going to start off as just an empty value.
Now, we're setting this as protected so that any class that inherits or extends, which is the same thing, this abstract class can access this value directly. Because remember, the private values will still come along, but inheriting classes can't access them directly. So
inheriting classes can access this, but it's still not public to other classes.
There you go. So private.
And this will be a Boolean value of just calculated.
Just calculated, and we'll just set that as a set value to false.
Yep, and then sent operator is the other Boolean value we need.
Okay.
Whether or not we just sent the operator.
Set operator equals false. Okay.
Awesome.
So now we're kind of dealing with a situation where we're actually going to start coding our methods.
Cool. So what we can do is we can just switch over to our calculator base. And kind of like we do in Objective-C sometimes.
Oh, Brian is a genius.
We can just kind of grab these little bastards and stick them in there.
So this is why Brian gets paid the big bucks at Wibbit.net.
Because I know how to copy and paste.
Because he knows how to copy and paste. All right, so we can kind of do exactly what we did in the lessons video, right? So we're just kind of segmenting all this off. And we're creating blocks of code. However, unimpressive they are.
And just to make sure that it compiles, when we get to the double one, let's just return 0.0.
Yeah, okay, that's a good idea.
Because voids are fine.
Yep. That way we can test it, and this one will just do a return null or something.
Yeah. There you go.
All right, and that should be good. So, all right, that's a good idea, Brian. Let's, sorry. Little OCD there. You want to try to compile just to make sure at this point we don't have any issues?
Absolutely.
So, as we did before, we're just going to be going inside the local context src, compiling all Java files to this current working directory. So far, so good.
Cool.
So
we'll
I guess
just run Java main class and make sure.
we don't really. As long as it compiles, Brian, I'm totally fine.
Fair enough.
Totally fine. Jenny. All right. So, which method should we start with, Brian? Should we start with setting the easier ones, or should we just beat up the big one first? Because we have a monster.
Let's just top down. Press button. Let's do it.
We'll just kill it.
Let's grow a pair and just knock it out.
All right. So the first thing that we're going to check for is what, Brian?
If a digit was pushed.
Oh, that's right. We talked about this.
So if the character is a digit.
Okay, what are we going to do?
Then we're going to just append it to the display. That's it. Nothing else. So that's kind of a...
So we're going to call this append display method here.
Yep, exactly. Which hasn't been implemented yet, but that's cool.
Yeah, that's no problem. Just pretend like it is. We'll get there. Okay, then what?
And then otherwise, if the button is a period, we have to handle that condition. And that condition's a little tricky, so we'll need a little code block there.
Okay, so if it's a period,
yep,
we'll block this off. Then what?
So the first thing is we want to find out if the display value is empty.
Okay, so and that's going to be a public, so
that means no buttons.
Global.
Yeah, display value dot. Yeah, exactly. Yep, that's our private.
Remember on the
value.
podcast you were talking about this?
Oh yeah.
Don't do that.
And one of the things that you could actually do, which is safer, is quote dot equals display value.
That's that way you're protecting against the no reference.
Yes. So that might actually be a better way to.
Let's just do that just to show you guys. Yeah. So what Brian was saying, and I'm really glad you brought that up because we haven't even discussed this before.
Yeah.
Now, if we're going to make this comparison, right, Brian? If for whatever reason
this is null, this thing will freak the out.
That happens.
Yep.
This program will crash.
Yep.
Well, Brian is saying
you can do a try catch and catch it, and
you can do that.
Handle the condition and blah 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 blah, which kind of is just.
So what Brian is saying is we created, and there's a couple ways you can do this. You can do this as well, I think, right?
Yeah.
But what Brian is saying is to just do this, which creates an instance of a string that equals.
Yep.
And then pass the value. That way, if this is null, this won't crash.
And then the other condition is it's that or the sent operator is true.
Okay. There's an or.
Yep. Or right.
Sent operator is well, I'm sorry.
No, just
set operator.
It's a Boolean value, so just true. So if that's the case, that means that we're basically we're either in a clear screen state or in a state where the screen will be cleared on the next operation. And we just press the period so that we just generated a value, the screen's going to clear, and we want to append our zero. Our dot. So we're going to append a 0 and append a dot.
So append display zippy.
Yep.
And then...
And what we could have done is we could have made another append display method that takes a string.
Right.
Whatever.
Right.
It's fine.
We didn't do that so that we could show that in the Wibit calculator. Right. Because we expand... We start small, we get bigger, we get bigger.
Yep.
It's kind of how we're trying to do this.
Okay, so else if the display, so the condition we have to check is that the display value doesn't contain a dot.
Okay, if the display value contains a quote dot quote.
Yes.
So if it does not contain that
a period,
then what?
Then we just stick the button value at the end of the display.
Oh.
So append to display the button value, because that means we don't have to do any kind of modification. We knew that it was a digit, so that it's just going to get slapped on the end.
All right. So that was the period.
Yep.
And that's everything in period?
Yep.
Let's just make sure that we don't have any. Okay, good. So next, Brian, what do we got?
Okay, so after the condition of the period, we want to check to see if an operator was pressed.
Okay, great.
After the condition of the period, we want to check to see if an operator was pressed.
Okay, great.
So we can say if button value is either a couple different things.
Okay, so talk to me. What do we do?
So if the button value is a plus,
okay,
or if the button value is a minus,
right,
or if the button value
add, subtract,
yep, multiply.
What do we have for multiply? We have a star. Looks like he stars us, baby.
What was it, my dear Aunt Sally?
Divide. Actually, you know what, Brian? These are characters, not strings.
Oh yeah, good catch.
I don't want Java to be like, whoa, 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 whoa. Okay, so
otherwise we do a dot equals.
Yes, right. So, Brian, now that we have caught this condition, there's a few sub-conditions, right?
Oh, and so this is a lowercase char button value. So that means it's a primitive data type.
Mm-hmm.
If this was character with a capital C all spelled out, then we would have to do a character variable dot equals.
Right.
You know.
Which we haven't. We looked at some of the abstract classes, but
and in this condition, we don't really need to use that. We don't need to use that class.
But if you look here, like Brian was saying, Java does have a character class.
So definitely check to make sure that if you're going to do something equals something, make absolutely sure that you're dealing with a primitive data type.
Yeah, so here's the constructor. So, you're right. So as Brian was saying, there's a dot equals method if you're using the character class. And that would be essentially, just so that you guys know, it would just be like that, right?
Yep, exactly.
Yeah. I mean, you guys are you guys are developers now. You guys know what's up.
All right, so anyway.
Where
were we? Oh, yeah.
Now we're going to look at the conditions.
So we have our 4 conditions. Yeah. So the first thing...
Before we build the guts, Brian, let's define the conditions that we have to catch here. So we have
what? So the first is if the Q index is... We're just going to march down the Q index positions.
Okay.
So if the Q index is 0...
Okay.
If the Q index is 1...
Okay.
Or if the Q index is 2, and we have not... And the sent operator is false.
If the Q operator, so if the Q operator
if it's 2 and not a sent operator.
So because of the frequency of its use, I'll move 2 up.
Because it's more common?
Right.
Right.
Then we'll do an or not
and.
underscore.
And.
Is it and?
Yeah.
Sorry.
It's okay. It's cool.
And not, and then our global variable sent operator, and that should be the conditions that we're catching here,
Yep.
right? So if we're looking at the first position, meaning
The
either we
storage queue
just
is-
cleared it
Right.
or we just fired the calculator up.
Exactly.
What do we do?
So in this case, we want to set the calc queue at array index q index.
Okay.
We want to set that, which is 0, obviously at this point, to be the display value. Exactly.
Right.
Value.
So whatever the user typed in the calculator, store it.
Yep. And then at calc q position, oh, you got calc uq. You got to take that u out of there.
CalQ clue. That's CalQ. Doesn't that sound like some 1990s .net like .com company?
I don't know. It sounded to me like a children's TV show.
CalQ. I'm sorry. What?
CalcQ? I don't know. Anyway, so it's,
Or you. Q.
we have a tough time focusing in Java, don't we?
Double.
Right. So yeah, double representation of the button value.
Okay.
Because the calq position 1 is always going to be where we store our operators.
Right.
And then calq position 2, which is the next increment of q index, is just going to be 0.
Zippy. Right.
Yep.
And that should be it, right? Except
Yep.
for the
oh yeah, we
sent.
want to say the sent operator is true.
Sent operator equals true because
We just sent the operator.
yes, right, because we just passed an operator.
Why else would we say the sent
Yeah,
operator is
all right,
true?
just
Do you
real
think we're
quick.
liars?
Just real quick, let's just before we get too deep. All right, next, Brian.
All right.
In the condition where we're looking at index number 2. Now, this is the condition that immediately follows this condition. So Brian says 1 plus. Now, index equals 2 because you're pointing at that next value.
Right. So that means we typed in some other number and hit equals. No. I'm sorry.
We typed in a digit
I'm
and
sorry,
then
I'm
an
being stupid,
operator.
yes.
Now, this is the next most
this
common
is the
condition.
5 plus 5 plus 5 plus
Yep.
5. And every time you hit the plus, it'll show you the next increment of 5.
So talk to me, Brian. What are we doing?
Okay, so this is, all we're going to do is we're just going to call this method press button.
So we're going to simulate the user typing in equals. Okay.
And then we're going to just tell it to push values. So we're just going to kind of force pressing the equals and then repeat.
Okay.
Rinse and repeat.
And that should be all that we're doing there, right?
That's it, yeah.
All right, so then the next one is going to be what?
Okay, so this is only if one value is stored in the queue.
Mm-hmm.
So that means we only have one value and we just push the operator. So all this is going to do is it's going to say the index q plus plus exactly is going to be equal to the button value as a double, and that's going to store it in the operator position.
Okay.
And then increment the q index so that we have it for then on out.
Right.
And then we're going to set just calculator to false and set the sent operator to true.
Okay.
So we have not just calculated the value, but we have sent an operator.
Okay. Is that it?
That's it.
All right, let me just make sure. Okay.
Okay.
Line 36, cannot find symbol, press button. Line 36.
No, lowercase
it's,
b. Yep.
Lowercase b?
See, who needs an IDE?
Yeah, right. Awesome.
Although you guys are going to love IDEs when you start using them after getting up to speed on Notepad++. Not that Notepad++ is bad, but you will feel spoiled rotten. Like you'll feel like you're cheating when you use an IDE. It's really funny.
That's why we didn't want to start you there. That's why we wanted to start you here, because you get that, it's just like anybody that's rich, right? Anyone that was poor and became rich is always a better rich person than somebody that was born rich and stayed rich.
Right. Or
because they know what it's like not to be rich.
Well, it's also like a psychic.
What?
Like
I can't wait to hear this one.
Well, it's like a psychic in tarot cards. If you're going to be a good psychic, just learn how to read people's minds before you use the tarot cards. Otherwise, you're just going to be blowing smoke up their ass, and always relying on the tarot card. You'd be like, oh my God, something bad's about to happen. And then they ask you, what's about to happen? And you're like, wait, hold on, I got to find my tarot cards. That's not very useful or practical now, is it? I mean, you have to run home and grab your special set of cards. What's that bullshit? Just like grunt and put your fingers on your temples and think really hard.
You see this face I'm making right now? When we do this remotely, I make that same face. Just so you don't see it.
And then cut this section out.
Yeah.
It's not like my memory's good enough to remember what the hell I say.
All right, we're gonna cut it here, and we're gonna come back and work on the rest of the method. So next, Brian, we have another condition where we want to look for the equals, right?
Yeah.
Right.
Yeah, boy.
So outside of the context of this statement here, so we have this else condition, so we have else, and then we have an operator. Now we want to check for the equals. So
yep.
Here, else if, and what is that going to be? Button value?
Yeah, so if the button value is equal symbol.
Okay, now what?
Then we have one condition that we want to check for, really, and that's if the Q index is 2.
Ah,
so that means we have an operator and a number, and our display is probably staged with some other parameter that we want to pass in.
Okay.
And then we want to make those, perform that operation. So,
all right, let's do it.
If that's not the case, then it's just going to kind of wait, So, in this condition, okay, so the first thing that we want to check for is that the calc Q position 2 is going to be set to the display value.
Okay, so this is going to be
because when we hit equals, we just typed in, let's say the number 15.
Right.
And we hit equals. So we want to take that number 15 and add it to calc Q2.
Absolutely.
Now we want to do a switch on calc Q index 1, which is our operator.
Okay.
And we want to typecast that as an integer, so that because Java is dumb.
Yeah, Java's kind of dumb because that has to be a number.
Yeah. So in the case 43.
Okay. So this is that ASCII.
This is the same kind of thing we were doing up above.
Right.
So we could just say case 43 break.
Okay. You just want to set it up.
Yeah.
Okay. So break.
Case 45, which is going to be the minus, and maybe we could put a little comment next to 43 so that we remember which one.
Okay, so plus,
and then case 45 is a minus.
So 45 is a minus.
And then case 42 is a multiply.
42 is a multiply. Okay, and next?
Divide is?
I don't know, 47?
Yeah.
See, look at this. I have to do like a 3 slashes there.
Yeah,
nice.
Okay, cool.
Is that it?
That's it.
Okay, so the next one I guess would...
And we can just do a default break.
Default.
Yeah, exactly. Default means if nothing else happens, if you don't fit those conditions. But default break's a little redundant. We don't really need it there, but
whatever.
Why not?
Why not? Just to keep it nice and pretty and cool and stuff.
Yeah.
Yes. Now, Brian, we actually have to do the guts.
So the result... we want to set in calc Q position 0 for each of these, because that's going to be our next display value that's staging the next round of things that go, because we don't have an operator after we equal it and so on. So calc Q position 0 is going to be calc Q position 0, our current base value, plus calc Q position 2, which is our... So we want to do the same thing, but instead of adding them, we want to subtract them, in this case.
Okay, so minus...
Yep. And then after this, we do multiply. It shows multiply.
Multiply.
Star symbol or asterisk.
And then
divide.
Slash is for divide. But in divide, Brian, we have to make sure that we protect ourselves,
Absolutely.
right? We have to use the condom keyword.
So before we do that, we want to say if the integer value of calc Q2, which is our staged, that's our, whatever, is 0,
right? That
we want to print out an error because that's going to be a divide by 0 error.
Okay, so we just have like a system.err.println illegal division by 0.
You are under arrest.
Yeah. Okay. And then
we're just going to clear out. Calc Q0 is just going to be set to 0. So like you failed, we're just going to wipe you out, clear you out. Sorry about your luck.
You're a failure at life. Okay.
And then we just want to put an else before we actually perform that, because that's,
right.
That's actually
Because we don't want that to happen in both situations.
Yep.
Okay.
Now,
cool. I think we have some follow-up stuff to do, don't we?
Yeah, we do. So
the follow-up stuff is after the switch. And thank you, Notepad++, for your wonderful highlighting here to show me that.
Isn't that nice?
This is where I will continue coding. Brian, what's up?
Not much. What's up with you?
I don't know. What's going on with you?
Hey,
how you doing? Have a nice day? Yeah? Yeah? Looking good? Feeling good? Awesome.
Cool.
Yeah. Now what?
So now that we're done with all this, we stored our result value in calc Q position 0. So we want to take that calc Q position 0, our result, and set the display with it.
Right. Exactly. Just like a dice.
And then we also want to flag the fact that we've just calculated a value.
Okay. So equals true.
And we want to clear out our operator and our appended value that we...
So we have sub1 equals zippy.
And sub2
equals zippy. And then we want to reset the Q.
Yep, so we'll put the Q index back to 1.
Okay.
Which stages us to perform another operator if we choose to.
Right. Now, I believe, Brian, that is the equals.
Yep, that's the equals. So now we do clear, which is not too bad.
But let me just do a quick... Okay, we have an issue here on line 49.
Press button is lowercase.
Let's go look at 49.
Java's case sensitive. It's a little sensitive.
It's so sensitive. What did I do wrong here on 49? It said 49, didn't it? No, 30. No, that's the last one. 49.
Yeah, 49.
Calc Q equal get display. Not a statement.
Yeah.
I did a comparison and it's an assignment. Okay, Brian. So we have completed that, and at least, if nothing else, so far, our
So
compilation
good. Yeah.
is successful.
Yeah,
So
for whatever that's worth.
we have to check the next condition, which
Doesn't mean
is,
it's logically correct, but we'll find out.
Yeah, well, yeah, we'll figure that out.
Yeah. So our next condition
That's
after
phase 2.
after the equals, we're going to clear the screen. After the equals, we're going to clear the screen, and this is pretty not bad.
Okay, so else if, what is it, button, button value, right?
Yep.
If that equals, and this is going to be, we said C, I think,
C
right?
character. Yep.
Okay.
Lowercase C.
All right, this shouldn't be so bad. What's up?
Nope. So we say for int I is 0, I is less than calq length. Actually, just say we know it's going to be
we
2.
can say
so-
3. Yeah. But, all right, you know what, people? Sorry. I'm going to do it. Sorry.
Yeah, it's good practice.
Yeah.
Because usually your case won't be this simple.
Yeah.
All right, calq length I++, and then we're just going to say the calq I is 0, 0.0.
Okay.
Cool. So that just kind of clears out all of our q values.
Right.
We're going to set the q index back to 0.
Okay, so then the QUEUE index equals zippy.
Yep. And then we're going to set the display to be just nothing.
Fair enough. Fair enough.
And then just calculated false and sent operator false.
Okay, and then
So that wipes our slate clean.
okay.
That's
so
it.
We just wiped our behinds, right?
Yep. We just wiped our ass.
All right, cool. And it looks like it was good. So the next condition is what?
Okay, the next condition is the negative number operation. So that's going to be else if the button value is an n character.
Okay. What's up?
And if somebody does say this, somebody hits the negative number button, we're just gonna store in calq position 0, which is our base number. Mm-hmm. That's gonna be equal to the display value times -1, which makes it a multiple number. I mean, which makes
Makes a multiple number.
yeah, you know what I mean.
Makes it a negative number.
All right.
Ah. Now what?
Now we'll set the display with our results.
Not bad. And then what do we
No
do with
big deal.
the?
And then the Q index is 1.
We've done an operation technically, so let's simulate that we just did an action.
And we're back and staged for another
Operator.
operator to
Yep.
come in. Yep. All right. And then the last one is else if the button value is s for square root.
Don't you hate it languages that do this? Or
Yeah, I don't-
some of them are
I
like this.
Yeah, I really don't like that.
I don't understand why. Why would the languages do that? I mean, okay, I can see this, like TCL does this.
You know what I hate? I hate when it's if, and then you end the if with a phi.
If, say again?
So if is a block, not like a curly braces.
Right.
So you say if, and then at the end you say phi, fi.
What is that for, like end if?
Yeah, exactly.
Oh.
Instead of end if, it's just fi.
Well, like Visual Basic is like if, condition, end if. Like that.
Yeah, which I'm not a big
And like,
all right.
else if, condition, end if. That's
Right.
kind of dumb. How about curly braces? Yeah. Brian, what are we doing now?
Not Java. Okay, so the last one is else if the button value is the character s for square root.
Okay, so if it equals S,
Yep.
talk to me.
So like we talked about before, if the display value has to be greater than 0. So long as the display value is greater than 0, we're gonna perform that calculation.
Okay, if display value is greater than 0,
Yep.
then we will actually perform it.
So calq position 0 is going to be equal to the result of our operation.
Okay, so we're going to call
So
the
it's gonna
math
be-
class
yep, math class
SQRT.
SQRT, and then get display value, and that passes in a double.
Okay, which is what the square root
Yep.
requires. Okay,
Cool.
then
And
we're going to update our display, right?
Absolutely.
To the value that we just calculated. Now you can look at the last two that we wrote. Check this out. If you look at the
See how
negative
similar
and this,
they are, yeah.
I mean it's the same thing, just that it was a different operation, but
Yep.
same outcome.
So if you wanted to do, to the power of something or whatever else, it basically is going to function
Right.
that way.
Right. Okay, Brian. So at least the code and syntax for that method is done.
I think we've just crapped out the meat and potatoes.
I think you're right. We
that's
definitely
now behind us.
We definitely got the hardest portion of the
Yep.
model code done. So now we just have a
It's
couple
all
of
downhill from here.
Well, I mean, we still have the GUI to write,
in a
but
good
as
way.
far as the back end code, we're
Yep.
doing pretty damn good.
Cool.
So
All right. So, setting the display is balls easy. You just say the private display value is the value. We're just passing it along and connecting. We're just
Right.
plugging that wire in.
Yep. Okay.
You know?
Then next we have set
It's
display
just gonna be
value this.
and we just do the double 2-string.
So we can
for value.
piggyback on set display.
Yep.
But instead of passing it this, we have to call the double class, and we're going to call the toString method, and we're going to pass the double value. Right?
Awesome
so then that
sauce.
should pass the string value to set display, and it should work just the same. So append display. Talk to me.
Appending the display, if we just calculated the value,
So if just calculated,
then we want to clear the calculator.
okay, so then we'll do a press button, C.
Yep.
Okay, now what?
Else, if the sent operator was just passed,
If sent operator, okay, so if an operator was just passed,
then we we clear the display and set the sent operator to false.
like that.
Yep.
Okay, and then in both conditions, we're still going to do what?
So now we're just going to append the character to the display value. So display value is plus equal, which is the appending operator.
Right?
Character.toString and pass the value. So we just convert the character to a string and slap it on the end.
Okay, so does
That's
this...
it. Yep.
So far, so good.
Cool.
All right, now, get display value. This should be really tough, right?
Yeah. So if the display value is blank, then we're going to return 00 just like we have here.
Got it. So let's do a little formatting action here. All right, so as Brian said, if the underscore, or as Brian did earlier, dot equals
Yep.
display value.
Yep.
In any event, this is just another way to do it, just to kind of give you more exposure.
Yep. And then we
Return
just tab
zippy.
in. Yeah, we'll just tab that thing in, and then if we're still at that point past that condition where we
Right.
return, then we'll return we'll parse. Yeah, exactly. We'll return the double value of our display.
Like this.
Yeah. And that gives us the double value.
Okay, that sounds crazy.
Yeah.
All right, now we got the get display, which should just be the string of the
Yeah,
get
this
display.
one's crazy. Get display is a tough one.
Yeah, hold on. Let's think about this here. This should be get display value dot toString, right?
Nope, just display value.
The other one would have been fine too. Okay, thank you very much.
It would have been a waste of everybody's time.
You're a waste of everybody's time.
Maybe.
Okay, so it looks like the model code, to at least some degree,
Nice.
is complete. So the next portion of this, Brian, is we're going to come in and we're going to implement our exact specific Wibbit calculator.
Oh, and before that, we may actually just test to see if this works in the driver.
We can, but since this is an abstract class,
Oh, yeah, you're right.
we
You're
can't
right.
do
Never mind.
that.
I'm a dirty, filthy liar.
I thought you wrote in Java for a living. Huh? Apparently not.
What do you mean a living?
All right, guys, so now that we have gone through this ordeal, so we built the interface, we built the abstract class, now let's build the class that's going to implement this code, or technically extend this code. This is going to be our specific Wibbit calculator,
Right.
and it will be kind of the final iteration before we move to building a view.
Yeah,
or
so
a
if
graphical
you
application.
remember in our overview, in the overview of the model code, we had the red, yellow, green
Right.
panels. We've just knocked out the red and the yellow, and now we're going to do the green panel. Basically.
Or whatever
So-
colors they were.
Yeah, right. Or I
The
might be
back
colorblind.
two.
I don't know.
Yeah.
But so this is the final piece of implementation. And if we set up the other classes properly, this shouldn't really be too bad,
Yeah, this should be pretty simple.
you know. But this is the type of operations that's specific to a Wibbit calculator.
Right, so once we actually do this, we can use our little main class to test it. So let's extends calculator, and now I think this was just simple. This was just a couple of methods that just kind of, and again, our specific version of this calculator is basically the base implementation of
Yeah,
the calculator. So
But it's really to illustrate,
yeah,
you know.
it's
So
the idea.
The calculator implements the base class. This extends the calculator class.
Right.
And that's what we're trying to drive home.
So what we're going to do in our specific version is we're just going to extend on the previous idea. And just like we talked about in the lesson before, we're going to allow a string to come in. And then we're just going to basically allow this to take in a whole string and then process that against the back end,
Right,
which
'cause we don't wanna
requires
do
one
something for
character at
every
a time.
character, you know.
Right. Because the back end is working on the I don't know, I guess the functional... not
It's
the functional-
transactional.
Yeah, there you go. I press 5, it takes 5. I press 1, it takes 1.
Right.
But if I do 1 plus 5 equals and send that whole string in, now our calculator can handle that whole operation.
Yeah.
And the way we can do this is I equals zippy while I is less than the calc input dot length I plus plus. I mean, you guys can imagine it's going to be that simple. We have a protected or public method here called press button. I think it's public. And that will just be a calc input. And since we can't do this
Because it's-
because Java's stupid, we
Yeah.
have to do get at I.
Yep. So we just kind of march through the string and say, push this button of this character, push this character, press this character, across the string.
Right. And we're going to use that when we do our testing class here in a little bit. Public string. And then we're just going to kind of add our own take on the get display. Not that this really is a big deal, but again, this is just so that you guys can see this progression. If the display value equals...
Well, I think the display value is protected.
It's protected.
So we're accessing a protected attribute of the class that we're extending because we're implementing that class. We have access to it.
Right, so a protected field is the technical term, but yes. Else, return, and we could just, this is kind of like, if I did a return new string underscore display value, let me just kind of describe what this is doing here. So, all right, Brian, you know, right, that in Java, strings are immutable. So once you create an instance of a string, you cannot change it.
Even though Java's garbage collection and other things are so transparent, so hidden, so unnecessary to engage with, it doesn't often look like strings are immutable. But they are, because it looks like you can just say this string is equal to that plus, whatever. But really, it is always creating new instances of the string.
Right. So when
new areas of memory,
In C, remember how in C there was a instance.clear, instance.append, and that would actually not append and create a new instance of a string. It would work on the current instance of a string, meaning that in C++, the string is mutable. In Java, it's not mutable. And in many languages, that's just standard practice with strings. So, knowing that, if you wanted to create a new instance of a string and return a new memory space, you can do it this way.
That way there's not a conflict, right?
Right. In C++, this may be a really good practice, but in Java, who really gives a shit? Because even if I send you a memory address, you can't do anything with it.
Right, because it's
what I mean?
Right, exactly.
So this is just fine. So now that we have this class built, Brian, let's talk about how we can test this.
All right.
So, Brian, if we're going to test this class, we should be able to write a little basic program like this, right?
Yeah.
So, we're going to just make an instance of our specific class, WibItCalculator, and then here we just have a string input value, just set that equal to blank, just so that we have that set above. Then we fall into an infinite loop where we have a math prompt.
Nice.
Okay? And inside of this math prompt, Brian, what are we going to do?
So we just take in the input from the user, and then just keep processing the input, set the display value back out to the display, and then restart and go to the next one and so on.
Okay.
So it's going to be just basically like a command line calculator.
That sounds nice. Now let's go ahead, let's write this, and let's see what happens.
Let's keep in mind with the WibItCalculator, since we can process a string, you can just type in 5 plus 5 equals something.
Yes.
You can continue, or 5 plus 5 plus 5 plus 5 equals.
Right.
And we could actually take that string, and it will send each of those characters into our base calculator.
Yep, exactly.
So let's try it out. I'm excited.
So just like we saw, Brian, let's go to our main class.java file.
Okay.
And let's start writing that code.
All right.
So the first thing that we did was, since we're going to be using user input, right, we're going to have to import the package.
Yep, Java.io.
Import java.io.star. And we also have a little method here, Brian. Let's talk about this little method here. Public static string read line. What does this
do? So by creating a little, and we can say that it throws exception.
Okay.
And read line is just going to simplify our process to get input from the user. So this is going to be, we're going to create a new input stream reader.
Okay. Before we do this, actually, Brian, real quick, just sorry.
Yep. Oh yeah, just test it out. There you go.
Oh, look at that. It's a good thing we did this. The Java calculator, okay, WibItCalculator.java, was at line 6. We really should have done this before, but it's okay. Line 6.
Calc input get at string, Java string.
Missing a return statement. Oh, that's in this class here. Sorry, let me just make sure that we're on the same page here. Okay, so we're still cannot find symbol calc input.get at. Is it char at?
Yeah, it's char at.
Okay. Char at.
Huh.
Okay, well that's fine.
Whatever.
That works. All right, sorry about that, folks. That was Brian's fault. Okay, I'm sorry to distract you, Brian. So we were talking about
doing the read line.
Doing the read line.
Yeah.
Before we got distracted.
Okay, so since we're gonna create an input stream reader and then make the new buffered reader and then read it from the buffered reader, We don't have to like put that in every one of the while loops because it kind of interrupts the flow. It's not so
stupid.
Interrupts the flow. Interrupts the flow.
Interrupts the flow. The flow.
The bros flow.
The bros flow.
I don't know. So we're going to create a new input stream reader. We'll call it instream.
Since it's a reader, Brian, it deals with what?
It deals with none of your damn business.
Text or binary?
It deals with text.
That's what I'm saying. So we're going to make a new instance, and we're going to pass it the system.in instance.
Right.
Okay.
And then we create a buffered reader, which is also not text.
It's a reader. It's text. It would be a stream if it's binary.
Yeah, stream. That's right. I was thinking buffer or stream. Whatever.
If it ends in reader or writer, it's text. If it ends in stream, it's binary. At least generally. At least it should be. If anyone writes stuff that doesn't use that convention, they're stupid. Anyways, so then we're going to make our little buffered reader. And then our buffered reader is going to then actually return the data, right?
Right, because buffered reader has readline method on it.
Right. And remember, we use buffered reader for files, for network sockets.
Anything. Yeah, any kind of file.
Anything
any
that's
kind of
buffering input. Yep. Okay. So let's just make sure that works.
And then we don't need that other return, because that's a little ridiculous.
Your face is ridiculous. Save it. Nice. All right, Brian, let's get our little Whippet calculator here and check.
All right, so let's create a new instance of Whippet calculator.
Whippet calculator.
We'll call it calc. I know that sounded like it's hilarious.
All right, so the Whippet calculator. Awesome. Now what?
Then we'll just make a string input value, and we'll set it to empty. We'll just make an empty string.
Oh,
that's what we're going to kind of use as we kind of move through this, traverse this. Yep. So while it's true, let's do the system out print, not print line, but just print the math prompt.
Okay, print. So then we'll just say math like this. Does that look good?
Yeah. Cool.
All right. Now what?
Then the input value is going to be a read line.
Okay. Now what?
And
we want to be able to have the user create a condition where they can exit the program.
Oh,
right?
yeah. So if so let's see if the input value, and it doesn't matter if it's upper or lower, so we'll just do lower.
Right, we want to just kind of like normalize it so
you can also say
equals
ignore case too.
That's true. That's true.
But it doesn't matter. And then exit. Then we break. All right, we're breaking. See you guys.
All right, out of here. Bye. Not quite.
Break me up a piece of that Kit Kat bar. So then, so calc, we had a public method process string.
Right, so here, process string in our Whippet calculator.
And that just like pushes the button for each character that comes in.
Yep, and now what do we do?
So now once that happens, we have a display value. So now we just want to print line the display value and start this whole damn thing over again.
Wait a second. So can we have a command line calculator now? I just closed that program. How did that happen?
It was madness.
All right, so we have a command line calculator. We should anyways, right?
We should.
So the way we can try this is if we compile it, we have a problem here.
It throws an exception.
Oh, well. All right, Java, you win.
And this is obviously not the best practice for exception handling or anything, but that's not what we're trying to show you here.
Java exception handling is so ridiculous that, you know what? I don't really care. So Java, main class, right? Right?
Yep.
Math prompts.
Nice. What do we do now?
1 + 1 = 2.
Nice.
How about +3 = 5? Divided by 10 equals... Is that right?
That's awesome. Times
50?
I don't know.
60?
Sure.
Equals that. Now let's do a clear. How about
-15 + 4?
Well, we can't do -15. Remember, we have to do
15 minus
15, and then 1, 5, and then n, right?
Yep.
And then what? And then like plus
-4 or +4.
+4 equals.
Yep.
Is that right?
Yeah, that's awesome.
That's kind of cool.
Nice.
Now let's see if we can do something like this.
Square root of 5. I mean 5 squared.
Okay, so we'll do 5. Okay, and then
where's the square root? No, it's squared.
Square root of 5.
Yeah.
So if we clear it, we can do, what is it, 64 square? 64S?
Nice. That's awesome.
Cool. Let's see if there's any other things. So don't we want to like test like 1 + 1 + 2 + 2 + 3 + 3
+4.6
+4
2
+6 what?
Like some decimal number.
6.123
There you go.
equals. Is that right?
Nice. Probably.
That's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 1, 2, 3, 4.
Awesome.
Wow, Brian.
And then exit condition.
Wow. Yes. Okay, so those of you guys that followed the Objective-C course and watched us build the TicTacToe program from the command line, and then put that into the graphical interface, those of you guys are in for a real treat, and those of you guys that haven't watched it are also in for a real treat, because we're going to take this code that we built on the command line, and we're going to then build a graphical interface to wrap around it.
Awesome. I can't wait.
So, Brian, let's talk about the GUI.
All right.
So we built the model code, and now we want to wrap a graphical interface around it.
Yeah, we do.
So this is where, we have two different portions of this where there's a big fat bulk of code. The first one is the back-end model code and the front-end display code.
Yep.
Or the view code. So what have we done so far?
So we created our calculator base, which was the interface.
Mm-hmm.
Then we implemented that interface in our abstract class. Then we extended that abstract class into our specific type of calculator, which in this case is a Wibit calculator.
Mm-hmm. Right.
So and we walked through that process and we built out those classes. And the interface had the required classes that the calculator was forced to implement. And then once that calculator, that abstract class built it out, then we extended it and actually implemented the one that we're going to use.
Very nice.
So let's put the GUI on top of that. Now, obviously, you could simplify this code, but we keep reinforcing this idea that we're just trying to expose you to the different concepts, and we don't want to get lost in the project. We really just want to keep it simple so that you can stay focused on the concepts, not getting lost in what the hell we're doing, what's this project for?
Yeah.
Like we could obviously create a bunch of classes that do weird stuff more efficiently, but it's all obscure, and we call the class class number 5 or my variable or stupid class number 2. But that doesn't. So we want simple projects that keep you focused on the different concepts, and that's what we're trying to do. But the thing is the concepts like interface and abstract classes and class inheritance, these classes are used everywhere in Java.
Definitely.
To be halfway decent Java programmer, you have to know these things. And it might not seem that you would really build these out on your own at first glance, but once you start using Java more, or once you start using a lot of frameworks that sit on top of Java, they require you to use these concepts to implement their framework. So especially web frameworks, for example, they'll have a web page object. But in order to even use that web page object, you have to inherit it, override some of the methods to display the page properly.
Yep.
And then they'll kind of do all of their magic. And without knowing those concepts, you'll never do those. But once you start using those more often, then you'll find yourself actually using interfaces and abstract classes, inheritance all the time without even thinking about it. It'll be like second nature.
Yeah.
So early on, just kind of make sure that you understand these things and you're comfortable with them, and that later you'll really kind of grow into them. So enough said. Let's get to it.
Let's get
code
to
the GUI.
So when we take a look at the skeleton here of the graphical class, Brian, you see that we are importing the java.awt.
Yeah,
and the AWT events and swing.
The AWT is the crotchety-ass old version of swing that nobody wanted to use and was stinky.
So we're blowing the dust off of AWT here.
Yeah.
So we're creating a class called Calculator GUI, and inside of this class, we have some fields. And one of the fields is going to be a calculator frame, which is the actual visual program itself.
Right.
And then we're going to create an instance of our Wibit calculator, a JText field, which will be the text display. We also have some integers here, the button number width and the button number height. So we're setting them to be a static value of 60. So 60 by 60. We can change that if we wanted to. We also have the frame width and the frame height. So we've statically designed this to be of this size.
Right. And the frame is the window, basically.
Right. Yeah. So then the button bottom Y. So the way that Brian and I designed this is so that we can change the width and the height of the frame. So if you wanted to maybe pass a parameter in to make the calculator a different size, we're going to allow the program to dynamically change the positioning of the buttons based on that value. So that's what that bottom Y number represents. It's the height of the frame minus the number of buttons, or the number button heights times 2 plus 10, which is just a little equation that we put together to handle this. So we also have a constructor, a set on click method that takes a J button that's going to be setting the event for the buttons, a build user interface method which will contain the bulk of the code, and then a show dialog which will just show the application.
Yeah, it'll make the window visible.
Brian, let's talk about the set on click method.
So you remember before when we would implement the action listener, we would create a new action listener and override the action performed event.
Yes.
This is going to be no different. Now, with our set on click, we're going to be tying all these action listeners to the same functionality. You know, like every button is going to tie to the same way to perform the action when you click a button.
Exactly, right.
So the way we design the calculator is it doesn't matter what button you push, we're going to accept it and we're going to do something with it. So we don't have to have a whole bunch of different types of action listeners in this case. So everything will tie to this, and to tie it together, we can just call this set on click, pass the button, and it'll bind this action performed to the button. And so we'll put a little case in here. We get our action event passed in, and if the action passed in, we can get the command, and if that command, and the command is really going to be the string value on the button.
Right.
If it's clear, because we don't want we're using the button names, you know, the title on the button as the action command.
Yep.
So we want the button to say clear, but the model class takes the character C for clear, for example.
Yep.
So we're just going to do a little mapping. So clear is C, uppercase X is the asterisk, square root is the lowercase s. Everything else is what it is. So we're just going to say that when you click on this button, the action performed is going to be to process the string of whatever came in, right?
Yes, absolutely.
So that it's doing it as we're hitting the buttons. And so even though that string could be a whole sequence of characters, these will just kind of be the characters as a string, getting passed in one at a time, and it works perfectly fine that way. And then when the string has been processed, the display value, the private display value in the model class has been updated. So we're just going to take the text field display and set the text of that JText field object to be the calculator processor objects get display value. So that'll give us back the string, and it'll set the text into the text field display.
Very well described, Brian. So when we talk about the constructor, what we're doing is we're gonna create that instance of the JFrame, and the JFrame, like we were saying, is the program itself taking in a string with the constructor, which will be the title text on the title bar of the application. Then we're gonna create the instance of our Wibbit calculator, and then we're just gonna set a couple of basic functionality for that frame. We're gonna set the layout to null. We're gonna just set the default close operation, so when you click the X on the upper right of the frame or the window, it'll just close the program. That's what the JFrame.exit on close enum does, or that's not an enum, is it? No, that's not. That's a field. Or is it an enum? I don't know. Who knows? Who cares? So then we're going to set the size to the frame width and height, which were those global variables we set. The set location relative to null, we'll then put it in the middle of your default monitor. And then we're going to go into another method that will build the user interface.
Cool.
Which is where the big fat portion of this
that's
project.
when we construct all the buttons and do all the down and dirty and put them on the panels and stuff.
So let's not beat around the bush, Brian. Let's get right into this. Let's get inside the bush.
Let's just attack the beaver.
Yes. Let's get in the bush and let's see what's going on down here.
So we're going to kind of chop this up. This isn't for efficiency. This is just kind of broken down into sections so that it's kind of cleaner to see. So this first section is going to be when we initialize the buttons and instantiate the buttons. So for our numbers, all of the number buttons are going to be the same. It's just one's going to have a 0, one's going to have a 1, one's going to have a 2.
Yep.
But other than that, all the buttons are going to be the same. So we're going to create an array of J buttons, which is kind of cool. We got an array of J buttons. We're going to call them button numbers. We're going to initialize them of size 10 because that's how many digits we need. And we're just going to create a for loop and go through the length of the array and then create each button and passing it with the string version of I. So we create a button 0, create a button 1, create a button 2, create a button 3, all the way up to 9. So we have an array of all of our digit buttons. It's kind of cool. That saves us from having to say new button 1, new button 2, new button 3, and so that's just dumb. We create a plus button, passing it the plus, equals, clear. So on and on. We create all of the buttons that we need to use, and we just initialize them all by passing the strings into the constructors of what the name of the button is going to be.
Then next, we're going to go through that same list of buttons, and we're going to set the size by calling the set preferred size. I like how it was being polite. Oh, I would prefer the size to be this. Yes. If the index is 0, meaning we're looking at the button 0, that is the wider button. If you look at a calculator, often on the bottom left, there's a 0 button that's the size of 2 buttons. So what we're doing is we're going to accommodate for that by setting it to the number width times 2 plus 5. Now, you guys might be wondering what that plus 5 is. When you add buttons on a panel, there's going to be, by default, 5 pixels in between the buttons. So in order for the 0 button to stretch the exact distance of 2 buttons, we have to get the width of those two buttons, which in this case is 160 times 2, which is 120, plus 5 to accommodate for that space in between the buttons. So it'll be of width 125. But of course, that's a variable, so if you change the button size, that will change with it. So, and the height will be exactly the same. In any other situation, we're just going to make a regular button passing the width and the height. And the same thing with all the rest of the buttons here. We have the button dot, subtract, square root, multiply, divide. Now, we do have a few little things here with the
cases.
Yeah, with the plus, equal, and clear. The height, instead of being wide by 2, these are tall by 2. Because if you look at a calculator, you see a plus, an equal, and a plus and an equal, they're tall. And I'm
big
sorry.
Old pads to kind of like,
I misspoke. The clear isn't tall, the clear is wide. So the clear is just like the same as 0.
Right.
And then the plus and the equal are the opposite of those two.
Yeah.
Yeah. Or the inverse. Oh. What the hell's happening here, Brian?
Okay, so we talked before about that set on click method that would create the new action performed when you click on a button. And we have the cases that says, if it's quote clear quote, then we pass it as the character C, and so on.
Yep.
So we call set on click for every button that we've initialized to bind that preferred action to each one of these buttons. So this is wiring up our harness to connect all of the buttons to the preferred actions.
Definitely.
So we iterate through the button number array, and we bind it to every one of the buttons, 0, 1 to 9. And then we also bind it to all of the other buttons that we've created. And that set on click is taking in the button as a parameter, and it's binding the preferred action to each one of them. So every button calls the same method because that's kind of how we wrote the thing. It just doesn't matter what button you push, it'll figure out what to do.
So then after we have that, Brian, we're going to set up the text field. And the text field, we're going to set the preferred size to a new instance of a dimension. And this dimension is going to be the width of the button times 5, because we're going to have 5 buttons. So there should be 5 rows of buttons. That's why we multiply that by 5.
5 columns of buttons, yeah.
And then that plus 20 represents the spaces in between those rows.
Right, because there's 4 spaces, right?
Yeah, there you go. So then that's the height. So then we have the width all the way from end of button to end of button, and then the size of the buttons will be the north and south dimensions. So we want to set the font to Courier New by creating a new instance of a font object passing Courier New, and it's going to be a plain, so it's not going to be like bold or italics or anything, and we'll set that to a size of 35 points. After we do that, we're going to justify it by setting the set horizontal alignment, which will then justify the text to the right, which a lot of calculators are right justified. We're going to set the editable flag to false. That way the user can't edit the text that's inside of the text field.
Because that would be disastrous.
Yes, that would be terrible.
They'd put the freaky stuff like gopher in there.
And that will just prevent the user from manipulating the program. And then we'll just kind of set the starting text equal to a 0.
Yeah, I mean, wouldn't it be kind of funny if you opened up a calculator and the initial value was 8?
Yeah.
So every time you turn on your calculator, it starts with 8, and you're like, no, clear, and then you do what you need to do. Okay, so now we get into the panel freakiness, and this is this is kind of how you lay out the numbers. Is you create these J panels inside of your J frame, and they will kind of segment out where your buttons go. Now, inside of a panel, whenever you have like a flow layout, and that shows where the adding order is going to be. So you set your flow layout, and then when you add your buttons, your first button, your second button, your third button, those will kind of get added in the order you add them in based on how your flow layout's set. So we create a panel, and we position the panel, and we fill it out with however many buttons we want. And then create another panel, fill it out, create another panel, fill it out, and so on. So this is going to be the lowermost panel. So we create a new J panel with just a blank, just normal constructor. And then we set the layout to have a flow layout of left. Then we add the button number 0, which, if you remember right, we had that condition in the loop that created the button to be too wide, which is why you see it too wide. Now, this isn't actually adding them to the J panel.
Right.
This is just...
Well, this is adding them...
this isn't adding them to the J frame.
Right.
This is adding them to the J panel that will then later be added to the J frame. So we're kind of staging them. But the illustration on the right just kind of shows you where these are going to go.
Right, because we're setting the absolute position by using the set bounds method.
Right. And so we add the button dot afterwards, and because it's flow layout left, that's going to go on the right. And then we set the bounds, and we use that. Remember that bottom button Y, which calculates, the kind of top left of where that button's going to start or could be positioned, So we use that because this is the bottommost. So we're going to use bottom button Y with no modification. And then the panel width, the panel height is going to be, it's really 3 buttons wide and 1 button tall.
Mm-hmm.
And because it's 3 buttons wide, there's 3 5-pixel padding spaces, so that's 15. The one button spans both of them, so it doesn't really matter. And then the button height plus padding. So you're going to kind of see this happen for the rest of these. So we'll kind of just move through these so you can see how these are being built.
Okay, so then the next row is going to be numbers 1, 2, and 3. And as Brian said, same rules apply, right? We're going to create the new instance of, and we're just going to call this just a different name, panel, numbers, middle. And this one, we're going to set the bounds of the bottom Y minus the button height plus 5. So what that's saying is go down to the way bottom and then come up the height of a button and then go up 5 more
for the padding.
For that 5-pixel padding.
Right.
And then we do the same stuff where we have the width 3. There's 3 buttons and there's 15. 5 times 3 will equal 15, and then the height 5. So what we're doing is we're saying go to the way bottom and then go up. And the reason why we did it this way and not doing the absolute positioning is so that if we do make a new instance of a calculator that's bigger, the buttons will adjust to that height. So that's then we have the next 4, 5, 6. Same rules apply. The height times 2 plus 10. Blah 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 blah. Next we have 7, 8, 9. So you can just see how these are just these panels. Add the button to the panel, and then later we'll add the panel to the frame.
Right.
Lastly, here, Brian, we kind of shift off to the right.
Right. So you notice the set bounds doesn't start with 0.
Mm-hmm. Right.
Instead, it's the number width times 3 plus 15, which is the 3 button width.
Right. So we're accounting for the 0, which is of size 2 buttons, and then the point, so that's 3 buttons. So then we're going over to that next piece to then add the plus. And then the equals will just be appended directly next to that.
Cool.
Because like Brian pointed out, we did that flow layout left. So we add the 2 buttons, one goes left, one appends to the previous button. Now what, Brian?
So now this is just 2 normal buttons, so this is similar to 1, 2, 3, but in this case we add subtract and square root. And then after this, we got the last 2, which is multiply, divide. And then after this one, we just add the 1 clear, which is 2 wide.
Wow.
And that's why the width is the number button width times 2 plus 10 for the 2 padding. And then after this, we add the panel display, which is the display panel contains nothing but the text field display, which is not editable, so that's why it looks kind of gray like that. And that's going to be, the bounds are going to go from 0 to the full width. And now if you see on the row 7, 8, 9 times divide, that's 5 buttons wide.
Right.
So it's the
you got it. It's right. It's perfect. Yeah.
So it says 25 pixels for the padding total plus the button width times 5, and the height just kind of marches you all the way up, and that's also 5 rows tall as well as 5 columns wide. So that positions that top text display. So now we've created all the panels. Now I want to add these panels to the J-frame so they're actually bound to the window.
Right. So as Brian just said, now that little calculator on the right, it's not visible, but it exists in this form.
Exactly.
So we've taken all those panels and we've just like slap. So they're all on there. Now we have a show dialog method that then makes this viewable to the user.
Yeah.
So the user can then use that graphical user interface to then interact with the model code that was written before. So Brian, what do you say?
I say let's
what do you
do it.
say there, Buckaroo? We go out there and encode this thing.
Let's go code this little f***er.
So, Brian, here we had that main class that we were using.
Oh, yeah.
Let's delete this file.
Yeah, we don't have to delete it. We just don't need any of that main stuff in there.
We could rename the file, thank you, Notepad++, to calculator GUI.java. And then we'll change the name of this to calculator GUI. And we're going to kind of do it the same and a little different than what we did in the description, but the main concepts are going to be there. So I'm going to remove all this crap.
Yeah, don't need to reline.
Yeah.
Actually, I don't even know if we need Java I.O.
Probably not. Cool. Let's just remove that. And actually, we're going to have to import other stuff. So we're going to import
AWT. Crotchety asshole AWT.
Sorry, Java.AWT.
Oh, yeah.
.star. Then import java.awt.
Now, you would think that Swing would just import those.
Maybe
not. I guess we use them other ways, but anyway.
Java extended.swing. Okay, Brian. So now that we have all that stuff imported, we can then start building our application.
Right.
So here we're going to start with the fields.
Yeah.
So what is this going to be?
We want a J-frame. We'll call it calculator frame.
Okay.
And that should just be null.
Okay, next.
We have a calculator, private. We'll call it calculator or calculator processor or whatever you want to call it. Or calcer. Doesn't matter to me.
I'm going to just keep it like this because I'm cool.
Is null.
Okay.
And then these are all private. JText field, and we'll call it like a text field display.
Okay.
That'll be a new JText field.
Like that?
Yep.
All right, now what?
And then we want some numbers. So we have a bunch of integers. Number button width, number button height. Those are both 60.
Like that?
Yep.
All right, now what?
So then we got the frame width and height, and that's the height and width of the window that we see, you know?
Okay.
And that's going to be 345 is the width, and the height is 440.
Like that?
Yep.
All right, now what?
All right, and then we want bottom button Y.
Which is the Y position for the bottom row.
And that's going to be the frame height minus, and because this position is actually the top of the button that we're talking about, or top of the whatever we're talking about, you know?
Okay.
So that's going to be the number height times 2 plus 10.
Like that?
Yep.
So far, so good. Okay, and I think those are the fields that we're going to declare.
Yeah, that's it. So we want a constructor,
Okay.
calculator GUI constructor, and that's gonna it's gonna instantiate the frame in the calculator and just set up the frame a little bit.
Okay. So here we can do
Calculator frame instantiation.
a new instance of a JFrame.
Yep. And then we'll call it like Wibbit.net Java GUI calculator.
Awesome. Wibbit.net Java GUI calculator. Like that?
Just graphical user interface if anybody's getting confused. I don't know. I'm sure you know that by now. And then, yeah, calculator process is just a new Wibbit calculator.
Like that?
Yep. And then, so for the frame, our calculator frame, you can probably copy this because we're going to set a bunch of stuff on it.
Okay.
So it's going to be calculator frame dot set layout to null.
Like this?
Yep. Which means that we don't have like some XML file that we're referring to. Then we're going to have a calculator frame set default close operator.
Okay.
Operation. There you go. Just JFrame exit on close. You got it?
Like that?
Yep.
Okay.
Like this and like that. And then we're going to set the size of our frame
Okay.
to be the frame width and the frame height, obviously.
Right.
And then we're going to set the location relative to null after this.
Okay, so this dot set location.
Set location relative to, and then pass it null. And
Okay.
that will, open the window centered on the screen. Then we're going to just call build user interface, which we haven't defined, but we can just call it. It's no big deal. Not hurting anything.
So we'll just, for right now.
Yep. And make sure it compiles.
So we have a set size is spelled wrong.
Oh, yeah. Whoops. Set site.
Okay, cool.
Nice.
All
right. So now let's implement build user interface. So first things first, we're going to initialize the buttons.
Okay. And
Cool.
I think what we did here is we made some for loop, right?
Yeah, so the first one we're going to say a JButton array called button numbers.
Okay, that's going to equal a new instance of Java button.
Yep, Java button size 10.
Okay.
And then we're going to do a for loop for i's 0, i is less than the button number's length, and then increment. And then we'll just, create them all.
Well, I is less than button numbers dot length.
Yep.
I plus plus.
Mhm.
And this is going to be a
Button number sub i.
Right. So if
Nope.
no. This is the wrong
Yeah, you're
part.
jumping ahead. Yeah, so we just say button number I is a new J button.
A new instance of a J button.
And then we just pass the integer to string of I so that we create a string instance of where we are in the for loop. There you go.
Yeah, just so we can make sure that we have that segmented off. Now
Okay.
if I compile it, we have a problem. Button number symbol not found. Button number.
Oh, it's just
S.
plural. Yeah, and it's down below too.
Oh yeah,
It's got to happen again. Yeah.
it's like a virus. Nice. Okay, cool. Now what?
All right. So now let's just create. We'll just say J button plus
Okay,
is equal to a new J button quote plus quote.
like that.
Yep. And then just get rid of one of those news.
So we have J
You
button.
got new.
Oh, well, it's like a brand
It's like
new. You know what I'm
it's-
saying?
It's like NT. It's like new NT technology.
Right, built on NT technology, built on new technology.
New NT technology. New technology.
So then we'll have a equal.
Yep. And then after the equal is a clear.
Then
that's
we'll
that's
have
a minus
a-
symbol, by the way.
Huh?
That's a minus symbol.
This?
Yep.
That's the equals, buddy. Check your
Oh
eyes.
yeah. My eyes are totally jacked up. Huh?
Equal, and this is clear.
Yep.
All right. Don't be judging me. You don't know me. You don't know my equal sign.
You don't know my eyes. All right. So then we want button dot.
All right. For period.
Yep. Button subtract.
Okay.
Button square root.
SQRT.
Yep.
Okay.
And then multiply and divide.
Multiply and then divide like that.
Yep. So that's done for initializing our buttons and stuff. So now we're going to get into setting the button sizes.
Okay.
Cool. All right. So now we want to do a for loop
Okay.
that iterates through all the buttons. And this is the condition you were thinking about before, where if I is 0, then We want to change the preferred size.
Right. Okay, so if I equals 0, then I want to do button numbers sub I dot set preferred.
Size.
I'm going to butcher this. Dot set preferred size,
Yep.
right?
And that's going to be a new dimension object.
Okay.
And that's the number button width times 2. Oh, sorry.
So this is going to be number
Yeah, it's going to be number button width
like that
times 2 plus 5.
times 2 plus 5.
And then just number button height. There you go. So, because the 0 is too wide, everything else is normal.
Okay.
So you probably copy that line and paste it in the else.
Okay.
And just take out the times 2 plus 5. It's a lot of hard work being lazy.
It is a lot of hard work being lazy. All right, so then we paste that there, and we can pull you back a little bit. So then we have that, and then what we do change is we remove this.
Yep.
Right?
Exactly.
So
There
that
we
should
go.
be good. Nice. Now,
So now we set the preferred size to a whole bunch of things of just the default size. So we can actually
yeah, we can kind
paste
of
it again
yeah.
and change the names and to protect the innocent.
set preferred size to a new instance of a dementia object, and this will be number button width,
Yep.
and then number
Button height.
button height, like that.
Yep. Perfect.
Okay. So I can just copy this so I have dot subtract.
I would actually just paste it 1, 2, 3, 4, 5, 6, 7, 8 times, 7 times.
Whatever. We'll deal with this. So we have dot, then we have what? Subtract,
Yep. Dot subtract, square root,
square root,
multiply,
multiply.
divide. Now, we could have. There's better ways to do this, but whatever. Plus equals clear, and then the plus button is too tall.
Aha.
So it's going to be button height times 2 plus 5.
Okay, so button height times 2 plus 5.
And it's
right?
the same for the equals too.
Okay.
All right, and then the clear button is too tall.
Right. Like that.
Actually, I'm saying that backwards. Those are tall and that's wide. You know what I mean?
Yeah, I know what you mean.
Yeah.
Is that good?
Yep. I mean exactly the opposite of what I say.
So button height on line 68. Can't find symbol on 68. Button
What?
button equals dot set preferred size equals a new dimension.
Oh, button equals singular,
Is it?
I think.
Oh, okay. Good call.
So Java's debugging doesn't always really,
Yeah, it doesn't always tell you where the problem is.
Yeah, it tries.
But it tries in that same way that when you played baseball as a kid, there was that one kid that was just terrible, but they tried really hard. But no matter how hard they tried, they were
still-
by far the worst player on the team.
Yeah.
That's Java.
And when they got off the field and everybody was disappointed, there'd be that one guy that says, "You're still Java to me." I don't know. Okay, so now we're going to set all of our on-click actions.
Okay.
Okay, so now we're going to set all of our on-click actions.
Okay, so we'll just make a
So
little.
we'll
comment here.
we'll do another for loop for all the button numbers.
Okay, so we'll do a little for action here.
Yep. For up to the size of button number length. And I think button number is plural.
I think you are correct, sir. Okay.
And then we're just going to say set on click and pass in button numbers I.
Which is not implemented yet, but
We'll get there.
I'll make a skeleton so that we can actually test it.
Okay.
So this will be public void set on click takes in a J button.
Yep, and we'll just call it button.
So we'll just kind of leave that. That way we can actually compile this and buttons
Yay,
numbers.
awesome.
Buttons numbers. Come on, Kevin. Get your damn plurals right here. All right, cool. So that way we can actually run this and test it. So now we are going to then set the on-click action for each of the buttons. Now what?
Yeah, so now we want to set on click the button plus, and we're going to go through a whole... See, this is sometimes the boring part of programming. So that happens. It's inevitable. You're going to run into this. But the idea, obviously, is when you design programs that you write, you want to avoid stuff like this. Like, obviously, you never want to write a program where we're, like, setting all of these preferred sizes like this. You're setting all the on-click. Like, if you're going to have a series of these, you'd probably read a file in from an XML, or you'd have some, like, more intelligent way of building them out, or whatever the case is. You'd be using an interface builder in a IDE. But because we're doing all this manually, this is kind of what happens behind the scenes. Like, even if you're using like Visual Studio or NetBeans, even if it's in C# or whatever it is, when you use the graphical user interface and you build something out and you drag it around and position it and stuff, if you look at the designer code behind file or the XML file associated with the layout view or whatever the case is, this is basically what you see. you know?
All right, Brian, let me name these off just to make sure we have them all.
Okay.
All right, do you see plus?
Yep.
Dot.
Yep.
Subtract.
Uh-huh.
Square root.
Yep.
Multiply.
Yep.
Divide.
Uh-huh.
Equal.
Yep.
Clear.
Yep.
Are there any that I'm missing?
Not that I know of.
All right, so we can just kind of go from there.
Yep.
So, Brian, very good points that you made. So, now that we have set the on-click events for these buttons...
We want to initialize the display text field after that.
I was either going to have a violent sneeze or I was going to make the face of someone that was about to sneeze, and I think I made the second one happen.
Actually, I think you just made a weird, retarded face. I don't know if that was...
So, next we're going to do the...
Initialize the text field.
Okay.
So
talk to me, Brian. Talk to me.
So this is like underscore text field display because this is something that we were kind of accessed from multiple angles.
Yeah,
that's what she said.
Now what am I doing?
Size to a new dimension, and the width is going to be it's 5 wide. As if you remember, I'm sure you do.
That's what she said. The width was 5. Never mind.
I don't.
You don't have a perverted mind. Okay, well, talk to me. All right,
number button width times 5 plus 20, and then it's just going to be the number button height times 5 plus 20.
Okay.
And then comma number button height, and then we're gonna. So after this, we're gonna set the font.
Okay.
So we're gonna set the font, and we're gonna pass it a new font object, and the font constructor is gonna take a string for Courier new, and then the font dot plain value, and then 35 for the size.
Like that?
Yep. That's it. And then we're going to set the horizontal alignment, and we're going to pass it JText field, and there's a static field on that, just right, all caps.
Like that?
Yeah, but I think I have an HText field unless
I
I
don't.
again.
No, I don't.
All right, and then we have set editable to false and set text to 0.
Like that?
That's it.
All right, let me try this real quick. Not bad. That was a rush job, too.
All right, so next thing that we have to do is add all the panels and create the panels and add the panels. We're done. All right, so next thing that we have to do is create the panels and add the panels. We're done.
Okay, so let's do a level 1 panel.
It's like a video game.
Level 1. Go. Fight.
JPanel object.
How many levels do we have? We have...
Well, I wouldn't copy it, yes, because we can just copy the whole block and reuse them.
Oh, yeah.
That'll be easier.
All right, talk to me.
So let's create a new JPanel.
Okay.
And we'll call it panel numbers bottom.
Okay.
And that'll be a new JPanel, obviously.
Okay.
And then on the panel numbers bottom, we're going to set the layout to be new layout left, you know. New flow layout.
Layout, and then we have to call...
Flow layout dot left. And then, so now we're going to add 2 buttons to this, because on the level 1 panel, we want to add the 0 and the dot. So it's button numbers sub-0. And then
button dot.
Button dot.
Like that, right?
Yep. And now we're going to set the bounds of the panel. And that frames out where the panel is going to sit. So that's going to go set bounds, and X is 0, and then Y is bottom button Y.
Okay.
And then the width is the number button width times 3 plus 15.
Okay.
And then number button height plus 5, which is for the spacing that we're putting in.
Like this, right?
Yep. That's it. All right. So now we can, as long as that compiles.
Button Y. What is it supposed to say? Button bottom.
Button bottom. Yeah. That's cotton.
Condom.
There you go.
Button bottom Y. All right, let me go make sure that what did I set this as?
Or is it bottom? I think it's
called bottom button Y. All right, let me just...
Poor naming convention.
Your face is a poor naming convention.
Sometimes.
You were born, your dad was like, ugh. Let's name it Brian. All right, so now that we have
my dad's quasi Valley Girl. Oh my god!
Let's name it Brian. Let's name it Brian. Seriously, let's go get some shoes. All right, so then 2, and then we're gonna change this name to what?
Let's call panel numbers middle.
Okay, biddle.
And then we don't need the button dot one. We can clear out the line that says add button dot and just copy and paste the 0 because it's just gonna be 1, 2, 3. So we can clear that line out.
Gotcha.
You know what I mean?
Mm-hmm. 0, 1. So we got.
Yep. So it'll be 1, 2, 3.
Or 3, 2, 1. Depending on how you look at it. Glass full, half full, half empty. I just somehow did like a select all, delete that. I don't know what the hell. Select all, delete that. Anyway.
So then on the set bounds, after 0,
yeah,
we're going to modify the bottom button Y a little bit.
Okay, to what?
So that's going to be bottom button Y still, but minus, and then in parentheses, the number button height plus 5. So it's like kind of shifting up one row.
Okay.
So copy and paste this to level 3. Level 3.
Level 3. Fight.
So that's buttons 1, 2, 3. Now we're going to put in buttons 4,
Now,
5, 6.
What are we going to call this?
Top, middle.
You said this is going to be 4,
5, and 6.
5, 6.
Yep. And then the number button height is going to be times 2 plus 10 instead of plus
So right
5.
here, plus 10
times 2 plus
times
10.
2.
Yeah. There
Got
you
it?
go. Yep. And then level 4 is 7, 8, 9. And then level 4 is 7, 8, 9. So that's going to be numbers panel top. And, we definitely realize that this is the boring part of it. But
I'm having a f***ing blast. That's why I have this look of just total excitement on my face right now. Hurry up and get this done. You know we don't make any money off of doing this, right, guys? I mean, do you guys appreciate this? Donate to the site. $1 billion. Come on.
and a half.
$1.5 billion.
Okay,
Not a half a dollar. $1.5 billion.
So like 50 cents a billion times, like $500 million, $1 billion. And
I don't know what's happening. I have no idea.
Okay, so we're going to set the balance to 0, bottom button Y, and it's going to be times 3 plus 15 this time.
Okay.
And that just shifts it right on up.
All
Okay.
right.
So now we want the
Was that panel? That was the third layer. Is that what that
no, that
was?
was I thought that was 4.
So the fourth layer is 7, 8, 9.
Yeah.
So you're right. This is the fourth layer. The fourth layer.
It's like Dante's Inferno.
Sounds like the name of like a metal album. The fourth layer.
So then the next one is going to be the plus and equals panel.
Okay, so plus equals panel.
Yep. And we're just going to call it panel plus equals.
Panel plus equals. Yeah, you guys, once you guys start using, I mean, you know, we use like Xcode and stuff in the Apple development, and building GUIs was a lot easier. And if you read, Brian, those like zip files that we made, those are XML files.
Yeah.
So basically what they were doing was they were dynamically creating files that they could import and then build the GUIs off of, which Java has the same type of thing as well.
But once you understand this, when you go to do it using a graphical user interface, you'll totally understand what's happening. If any problem occurs, you'll be able to just like a ninja go in there and surgically fix the problem.
The beauty of starting at this level, no matter how boring this may feel, is when you're building a graphical interface in Java using a GUI tool, and there's some piece of functionality that the GUI program doesn't do. Like I wanted to do something. You can jump into the code and you know exactly what you have to do to make that happen.
You just get it done.
All right, next.
All right, so instead of the button numbers, we're going to have the button plus and button equal.
Button plus?
Yep. And button equal. Now we can get rid of the other one because we're just having 2 buttons in this one.
Okay, so then this is going to be what?
Is that button plus?
Yeah.
Okay.
Shut up. Nobody was talking to you. What's next?
You're like a Frenchie.
This is going to be a 4, right? No, it's not.
So so set bounds. So the left bound, the X is going to be, instead of 0, it's going to be number button width times 3 plus 15 because these panels are off to the right, you know?
Plus, I'm sorry, you said times 3?
Times 3 plus 15.
Okay.
And then it's just going to be bottom Y is the Y position.
Okay.
So we just don't need it to, you know what, I'm lying. It's just going to be bottom Y, undo that. Instead of times 3 plus 15, it's going to be just plus 5. Because it's too tall. Yeah. And then the width is times 2 plus 10.
Okay, so this will be times
2 buttons wide.
Plus 10.
And then the height is times 2 plus 10 too.
Times 2.
Because it's kind of like a 4x4 grid.
Plus 10.
Yep. Okie dokie. Now we do a minus and square root panel.
Okay, let me just copy this. And let me paste this here. Yes. What was this again?
Minus and square root.
Minus SQRT.
Okay. So those are we just changed the 2 buttons.
What is the name?
Subtract square root.
And this is going to be button subtract?
Yep.
And button square root.
And we're just building this damn thing out.
Okay, and then what are our dimensions going to be?
Okay, so it's going to be 3 times 15 is going to stay the same. And then that's going to be number button height times 2 plus 10, because we're kind of going up 1.
Okay.
And then the width is times 2 plus 10, and the height is times 2 plus 10.
Okay, so that the rest of it stays the same.
Yep.
Okay, what's next?
The times divide panel.
We are so close, Brian.
I know, we're getting there. We're getting there.
So this is times
divide.
Divide panel. What do we call it?
Panel multiply divide. This is ridiculous.
So button multiply, right?
Yep, and then button divide. So now it's going to be, in this case, you got insert kicking?
Yeah, I got it.
All right, so in this case, it's going to be bottom button Y minus number button height times 3 plus 15.
Okay. 3 times 15.
Yep. And everything else stays the same.
Everything else stays the same?
Yep. And then we got our clear panel.
All right, let me just make sure we're good at this point.
We got clear panel, divide panel. We're out of here. We're out of this.
Then we're actually going to add them to the frame, and then we're going to see this monkey in action.
Yeah.
So what is this one again?
Clear panel.
Okay.
And
So
the only button
clear?
we're adding is just button clear.
Like this?
Panel clear, yep,
So button clear.
Button clear, yep.
Button Clio. All right.
And then the bounds is, the width is the same. It's going to be times 4 plus 20 for the height.
Times 4.
Plus 20.
4 and 20. Got it?
4 and 20, maybe.
420.
Alright, then display panel is the next one. Actually, it's the last one, which is awesome.
Yeah. I'm done with these damn panels.
Yeah.
Display panel, and this is panel display.
Yep.
Alrighty. Let me just... Okay. This is going to be... What is this going to be called?
This is so we're going to add the underscore text field display.
Like that?
Yep.
And what are the bounds?
Okay, so X is 0.
So this will be zippy.
Yep. And then Y is going to be...
Minus 525?
Yeah.
Like that?
Yep. Exactly. And then the width is times 5 plus 25 because it spans the whole width.
Right.
And it's only one tall. So it's just plus 5 instead of times 2. Whoops, sorry. So then the height is, instead of times 2 plus 10, it's just going to be plus 5.
Okay. Like that?
Yep. All right, now we want to add the controls to the frame, and we're done constructing our user interface, which is awesome.
Okay, so basically, Brian, we want to systematically go each one of those and do calculator, frame, add.
Yep.
But we want to add them in the correct order.
Yes.
Okay, so let's go
So let's just
top
march
to
through
bottom.
this. Yep. Well, kind of. Opposite.
Calculator, frame. Actually, you know what? I don't really think it matters what order they're
Well,
in.
I think because we set the bounds, so they'll sort themselves out. So we want to add panel numbers bottom.
Like that?
Yep. And then panel numbers middle.
Okay.
And then panels number top middle.
Okay.
And then panel numbers top.
Okay.
And then panel numbers... panel plus equals.
Okay.
And then panel subtract square root. Panel
Okay.
multiply divide.
Okay.
Panel clear. And panel display.
Okay. Is that it?
Yep. All right. So we have so little left to go. We've
Right.
got
panel numbers bottom is not found. Let me see if we had some naming issue. Panel
numbers bottom. That should be right.
numbers. Let me see what I called it. Panel top. Panel number button. Look at that. Bottom. No, that's not. Like that. Right?
Yeah. There you go.
Little bit of a goobly there. Try that again.
All right.
Beautiful.
Okay, so all we have to do is just implement the set on click and throw in the show dialog, and we're golden. So let's just knock it out real quick.
All right, so set
So
on
set
click.
on click is pretty straightforward. We're gonna say whatever button you pass in.
We're going to do an action listener.
Yeah, we're gonna add the action listener exactly.
Okay, so talk to me, Brian.
So button add action listener, and we're gonna pass into that method a new action listener. But when we create the new action listener will have the default constructor, but we're gonna open up those code blocks to override one of its methods.
Okay, like that.
Exactly. And then the method we're going to override, and one way to show that you're overriding a method to keep track of it is you can do @override above the method declaration. And some IDs will actually kind of force that to happen, but it doesn't really matter in this case. So action performed, action event A.
Like that, right?
Perfect. So if then we kind of do our cases for the action commands. So if A get action command equals clear. This is where we're kind of like mapping the string values on
Right.
the buttons to be
For the ones that aren't one-to-one.
Yeah.
Right.
Then the calculator processor.process string is C.
Like that, right?
Yep. And then else if it's a capital X, it's going to be the asterisk.
Else, if it's X, it's going to be the shift 8.
And then else if it's squirt.
The hell was wrong with that guy's car? Did you hear
I
that?
don't know. Yeah, that was
Was
funny.
he dragging the person behind it or something?
Yeah, or muffler or something.
Else what?
Squirt is S.
Squirt.
Square root.
Squirt.
Else, in all other cases, we're going to just set the action command itself.
Okay, so this will be process string a dot get action command, right?
Exactly.
And that's it?
And then we just set the result to the text field.
Oh,
so the underscore text field display, we're going to set the text of it to show what the results of our performed action is.
And that's global, so that's why it has access to this. So
yep, that's why we defined it. We didn't have to define the buttons like that, but we had to define the field display like that. So calculator process circuit. Exactly. You got it. Pretty cool, huh?
It will be cool if this works.
Nice. Okay, so all we have to do is show the dialog, and we got our calculator.
All right, so let's talk, Brian.
All we have to do is show the dialog, and we got our calculator.
All right, so let's talk, Brian.
All right, so let's create a public void show dialog.
Okay, what do I do?
And then inside that, we just say the calculator frame, the underscore calculator frame, which is our window. We just want to set its visible to true. And then once that happens...
Oh, I got it from there, Brian.
Visible is spelled wrong.
Your face is spelled wrong.
Yeah, visible.
Visible. Sorry. All right, so now what we'll do, Brian, and one of the things that we did kind of talk about earlier was instantiating the main class.
Right.
So we're going to make an instance of this calculator GUI. Boy, that's a lot of code, huh?
Yeah, I know, right?
Look at all that.
It's crazy.
Look at all that.
And that's why a lot of times you actually see the views design code in its own file because it's just unruly, you know what I mean?
Yeah, right. All right, so now let's go ahead in the main method, which is down here at the bottom, and let's make an instance of graphical, and we'll just call it calc equals new. Make sure that works, and it should. Gorgeous. And then we'll just do calc.showDialog, right?
Yep.
Which is that method that we set
and that's
right there.
That's awesome. Let's see this little bastard. Let's see if this works.
Could it be? Could it be, Brian? Could it be? So this will be a Java. Okay, so let's just do a dir class. So what we're going to do, Brian, is we're going to run this Java calculator GUI like that, right?
Yep.
And Java is quick, of course. Hey!
Hey, look at it go.
All right, Brian, let's test her out.
All right. 9 times 56.
All right, now you do see we have a little bit. See where this times is down a little bit? We got to fix that. So there's something wrong with the multiply and divide panel.
All right, let's fix it real quick. Let's hop back in there.
All right, so the multiply and divide panel. Panel, multiply, divide. Let's check these numbers real quick, Brian.
I think we just probably forgot to increment the pad properly.
Yeah, so what do we got? What do we got? So, this is 15. Look at that. Look at that. We were off by one default pad, so that's going to be 15. Now let's recompile it. Yeah.
Nice.
All right, cool. Let's play with this thing. What do you think? So let's do 9 minus 3 equals plus 2 dot 111 dot 888 equals that, and square root of that. Whoa, okay, that's a big number. Not too bad, huh? 9 minus 2 equals...
Sweet.
Minus 2 times... What is it?
8.1.
8.1 equals...
Nice.
Brian,
cool.
Sir, I would just like to say that was a hell of a project.
Yeah,
and it was a
fun.
Damn pleasure doing that, man.
Nice.
So I'm sorry. Go ahead.
I know this doesn't seem like the grand accumulation of all Java, although it is, because that's all Java can do. Just kidding. But at this point in time, you can make any application that you can think of that will run on a variety of operating systems. You can, in theory, you can run it on Linux, Mac, Windows, whatever. You know how to create events, actions, set displays, update things, get the values, open and close windows, make GUI applications. And even stronger than that, you have a solid foundation now of your knowledge of how Java operates, which is more than most Java programmers can say.
Now, the only thing that I want to do, Brian, is I want to jar this.
Okay.
So that we can package it up and run it as a jar.
Okay, so now we're going to take all of the files in our calculator directory, now that it's all functioning and nice and pretty, and we're going to create a jar file.
Yeah.
So that instead of having like this crappy folder of these weird class files and stuff, we just have like a nice little executable jar file.
Sure, executable jar file. Not a horribly inefficient method of packaging and executing programs.
Yeah, okay,
which is what the AKA for jar is.
Yes.
All right, so Brian, what we want to do is we want to be a nice little programmer, and we want to give our source code to our users.
Okay, cool.
And we also want to allow them to execute this from a jar.
Right.
So the first thing we do is what?
Create our manifest file.
Right, or at least the data that we're going to be putting in our manifest file.
Yeah, so we'll call it manifest.txt.
Right, so we're not actually injecting this into the program. This just contains extra data that we want to include into our manifest file.
So we're going to define our main class so that the jar file knows what the entry point to our application is.
Okay, what was it, calculator GUI?
Calculator GUI. Okay. And
like
then
that?
Lowercase UI maybe.
Like that?
Yep, and we'll save that.
Okay.
So now we're not big fans of Java. You know, I mean, like we understand it, we use it, we can appreciate it for what it is. We want you to know it so that you feel the same, and you may really like Java. I mean, that's cool. We don't judge.
Unless you're a VB programmer, in which case we do judge.
Yeah. So, but there's a lot of things, you know, we kind of tried to, without being too over the top about it, we tried to show you a few things like how sockets don't translate to the other operating systems, and Java has like a lot of stupid quirks and like kind of half-assed implementations of things.
And there's issues with cross-platform promises. So Java is supposed to be something that's very usable, something that's very functional, and something that will execute on any platform. In reality, it doesn't really work out that way.
That is absolutely a lie. And that has been one of the big, deep, dark secret lies of Java for decades, or for a decade.
And it's one of the things that's killing Java now.
So we want to show you something with how creating jars works.
Okay.
So let's create our jar, kind of like we talked about in the course material for creating a jar.
So we're in this directory.
Yep.
And we want to do a jar, right?
Yep.
And then create, manifest, and then
File.
Uh-huh. So then we're going to create, and then the manifest file is going to be manifest.txt.
Yep.
The file is going to be wibbitscalculator.jar.
Yep. That will be our final product.
And we want everything in this directory that is a class file and everything in the source directory that is a Java file.
Right, so we can include our source code for fun. You don't have to add the Java stuff. The Java stuff is completely optional just because we want to stick it in the Jarchive.
Right, so we run this.
Cool.
We can do a Java. How do we list it again, Brian? It was jar TF.
Something like that, yeah.
And then wibbitcalculator.jar. So you can see here we have all of our class files, and then inside of this little Jarchive, we have a directory called source that contains our source files.
Yeah, it's cool.
So now, Brian, what are we going to do?
So the way you execute a Jarchive file is to say java-jar in the name of your Jarchive.
Okay. Jar, and then wibbitcalculator.jar.
All right, and then, what is this? How interesting. So we have a very nondescript strange error.
Yes.
There's an exception in thread main, a null pointer exception, and launcher helper. What is launcher helper? Check and load main.
Frustrating.
What is this? I don't even know what the hell this means. What happens is... if you open your manifest.txt file, and you neglect to put a new line character at the end of the line. You have to have an extra new line character at the end of your manifest file. Isn't that awesome?
Wow.
That's so cool.
Isn't that something?
Now, as a new programmer, surely if you were to write a program, you would be able to handle the case where... Whatever.
All right, so let's rerun it.
It's so annoying.
And
come on, Oracle. What are you doing? Get
nothing.
off your ass, Oracle.
They're doing nothing. So now if we run it, we actually have our calculator coming up. Yes. Yes, ladies and gentlemen.
Nice.
So we've taken you the full spectrum, okay? Coding the model, coding the
GUI.
The GUI, seeing the GUI, packaging the GUI.
Them together, packaging them, distributing it.
Yes.
Awesome. So I hope you enjoyed this lab. I hope you got as much out of it as you wanted to get out of it. And happy, I don't know.
Yeah. We're going to come back and we're going to do a basic Android app.
Yeah.
Welcome back, ladies and gentlemen, to the Java Lab on using a Java IDE.
Hola, ¿cómo está usted?
Brian, for some reason, he must have had Mexican food or something. He's in a very Spanish mood tonight.
No hablo español.
All right, Brian. So in this lab, we're going to take a look at a Java integrated development environment, which we have discussed in the intro course. We also kind of have we used an IDE yet? We did, yes. Xcode, right?
C.
Yeah. So we used Xcode. So those of you guys that followed the Objective-C course are familiar with an IDE, and those of you guys that follow the intro course are kind of familiar with what an IDE is and what it provides. So what Brian and I are going to do in this lab is we're going to download and install the famous, infamous, the great, and horrible NetBeans.
Ah, yo quiero NetBeans.
Yes. So, Brian, I know that there's lots of different IDEs that are used in Java.
Yeah.
What is your take on them?
The two big ones are Eclipse and NetBeans. Those are the heavy hitters. Sometimes Eclipse is nice. Sometimes NetBeans can be a little clunky. NetBeans is easy to use. Eclipse has a lot more plugins. Historically, I've always liked NetBeans better. I might be shifting towards Eclipse. I'm not really sure. I'm on the fence. What do you guys think? Tell us in the forums.
All right, Brian. So we're just going to go ahead and search for
Let's search for JDK.
Java
JDK. Because that's the Java development kit.
Right.
Which we know we need.
So the first hit comes up, oracle.com, blah, 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 blah.
Tech Network, Java, blah, blah, blah. Why don't they just say oracle.com/JDK? That'd be awesome.
Now, when we started this course, we had the option of downloading the JDK 7 and the NetBeans bundle, but we just downloaded this. So what we're going to do is we're going to actually now just go ahead and download NetBeans.
There is a way to download just NetBeans, but it's kind of a nuisance. You know you're going to need the JDK anyway.
And as you guys can see here, we have the different operating systems minus Mac. So we'll download the Windows installer.
Don't forget to accept the license agreement.
Oh, I fell for it again. Accept. Thank you.
Which basically means Oracle can come back and sue you after you build an operating system.
Why would you build an operating system in Java?
I don't know. You'd have to be pretty damn stupid. Yeah, that would be the stupidest thing ever. What kind of asshole would do that? Google.
So, Brian, now that we've downloaded the installer...
Yeah, we did.
It'll be here in our downloads folder.
Probably.
Look at all this cool stuff we've downloaded together. Isn't this great? It's the Java... See down here we downloaded the Java JDK 7 for Windows before? Now we have the JDK and NetBeans. Run as administrator, Brian.
Yeah, give it the rights. Give it that Tron level access.
Well, if I don't, it's going to prompt me anyways.
Yeah.
All right, so it has recognized that the JDK 7 is already installed, which we've already done, right, Brian?
Yeah.
So since we have the JDK 7 already installed,
totally cool.
We can just kind of swing by. What is JUnit?
JUnit is for testing.
Do we want to install that?
Sure. Yeah.
Okay.
I would love to do a tutorial on JUnit one of these days for unit testing.
So here we have the installer. We just keep moving along like a regular Windows installer, and there it goes. Yay, NetBeans!
Right.
Look at all those GZ files, Brian.
It's a lot of them.
That's a lot. You're damn right about that. Okay, Brian, so the setup is finally complete after all those GZ files found a home.
Right.
So we don't want to give them secret information about us. Uncheck this. The last thing Oracle needs is more information. Okay. So now let's fire up the IDE. So now we have the NetBeans IDE up and ready to go.
Ooh, look at that. It looks like it's fresh out of 1997.
Yeah, look at this. 17 updates found.
Really? You just updated the damn thing.
Yeah.
It's downloading JUnit? I thought you installed JUnit.
I don't know what's happening
here?
Java, get your together for fuck's sake.
I just want to dance with somebody.
Right. So let's make a file and do a new project.
All right, let's do it. That's always a good place to start. File new.
We're going to make a Java project, and we want to make a console application, Brian. So we'll make a Java application.
Yep, and this should come with our Ant script.
Okay, and then how about we do Hey Buddy?
Hey Buddy.
Hey Buddy. How's that sound?
Buddy guy.
And this is going to be stored in your user documents NetBeans projects
yeah, it is.
path in a directory called Hey Buddy. So our main class, Brian, check this out. Our main class is going to be inside of a package called Hey Buddy, and the class is going to be called Hey Buddy.
Nice. That's awesome.
All right. So this is going to be our entry point. The one that we have coded ourselves since day one. Now we have this IDE doing it for us. Now you see why Brian and I like to do this from text documents first, so that you understand what IDEs are doing for you.
Exactly. You understand it all.
Okay, wait. What does package mean, Brian? I don't understand. I don't get it.
Package is the container.
I know what it means, dummy. I'm being a jackass.
Yeah, I know.
All right, so we have our code file here that was generated for us. So we have a package called HeyBuddy and a class called HeyBuddy, and then here's our main method.
It's also a public class, so the file name is the same.
Yes. So if you take a look at this is our project overview, and we have packages, and these packages are collapsible. So remember how Brian and I showed that picture in the way beginning of the boxes that had little bubbles in them?
Yeah.
That's what this is. Here's a package called HeyBuddy, and inside of it, there's a class called HeyBuddy that's encapsulated inside of a file called HeyBuddy.java.
It's awesome.
Now, let's run this program, Brian, as is. It's F6 is the shortcut key, or run, and then run main project. Now, unlike some other IDEs, we're not going to be given a prompt like a DOS window. It's just going to run in this little window down here, kind of like Objective-C when we were doing the GUI applications and stuff.
Yeah, absolutely.
If we just inside of here, we have a little to-do. Let's remove the to-do and watch this, Brian. Ready?
Yep.
System dot.
Oot.
Oh.
I know. Talk about cheating. Isn't that awesome?
Print line.
Now the IntelliSense in NetBeans is a lot better than the IntelliSense in Eclipse, just in case you're wondering.
Yeah, probably. Now if we hit F6 again to run the program. Look at that, Brian.
Hey, buddy!
Hey, buddy! Alright, guys, so screw around with this, have a little fun, make your own packages, make your own code files, and screw off, and then Brian and I are going to come back and continue on with a little bit more NetBeans.
Welcome back to the Java Crash Course series. We're still here, and I see that you are as well. And Brian and I want to demonstrate a Fibonacci sequence using Java.
Right.
So Brian's going to explain to you, since he's the math geek in the room, what the Fibonacci sequence is.
First and foremost, I would have to say Fibonacci sequence algorithm is almost as essential to programmers as Hello World.
Yes, I have to agree with you. The Fibonacci is a very important mathematician.
Yes.
Was he even a mathematician?
Oh, yeah.
Oh, hell.
He was awesome.
Alright, so
the Fibonacci sequence basically is...
if you're hearing weird noises, it's because I'm drinking stuff.
the most fundamental Fibonacci sequence is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. And I don't know if you can see the pattern by me explaining this.
Is it possible?
It's kind of like you take the number...
Can we find maybe a Google image that gives us because it is a defined sequence.
Oh,
like,
yeah.
It's the same every single time.
The number added to the number previous is the next number.
Let me see if
there he is.
That's a good-looking fella.
Now, like the Fibonacci sequence in the form of a rectangle appears in nature a lot. It's also very much related to the golden ratio. Okay, so basically what's happening is you can see every time it's adding the number to the next line. So like 1, and then you see the arrow to the 1, it goes to the next line and adds that number. 1 and 1 is 2. You can see how that line crosses through the 1 and 1. The next line down, it crosses through the 1 and 2 to make 3. Then
1 plus 2 is 3. 2 plus 3 is 5.
Right.
3 plus 5 is 8.
Right.
And so on and so forth. So we're going to write a Java program that is going to calculate these numbers using recursion.
A recursion method.
So I'm going to close our Firefox web browser. I'm going to Alt-Tab back in the NetBeans, and we're going to create a new project. Call this new project Fib. F-I-B for the man. That's him, right? It's an homage.
Yeah. The Fibster.
Yeah.
Right.
The Fibmeister. So we're coming down here, and this really kind of annoys me, so I'm going to erase that now. So we're going to create a method here.
Yeah. So let's do a public static int Fibonacci. We'll just go Fibonacci. Fibonacci.
Like this?
Yeah.
All right.
And then we're going to pass the parameter n, int n.
Int n.
All right. So in this method, if n is equal to 0, actually let's do the whole. Well, we can do negative numbers. It doesn't hurt anything in this case. If n is equal to 0, return 0. Else, if n is equal to 1, return 1.
And hopefully you guys out there understand why he's doing this.
And if not,
we'll explain it in a second.
Or just go to Google. Google's awesome. Else.
Whoops. That doesn't belong there. Wonder how that happened. Alright.
So now we want to return Fibonacci. And when we call Fibonacci, then the whole word. Fib is actually the main program, which is kind of confusing.
but I don't really know how to spell.
Alright, so now the parameter we're gonna pass is n-1 plus Fibonacci n-2.
And when you actually, and we've done this in programming classes, when you actually work this out on paper, it's one of the craziest things you've ever seen. Because, like, you come down here, you're going to call Fibonacci with this, and then you're going to call it again with this, like, on the same session instance at the same exact moment.
Right.
Which is cool.
It's wild.
It's wild. So did you want to explain this, or is it self-explanatory?
I think it's self-explanatory. I mean, it's pretty much the same thing as the recursive function we did before, but now we're just taking the current one we're at, subtracted by 1, adding it to 2 prior. And if it goes back far enough to 0 or 1, it's going to just return 0 or 1 and continue on its way. Alright, so now we're just going to call this function and print it out. So we're going to do a system out print line, Fibonacci, and let's start with, let's do 21.
Set the integer 21. And whenever I have a function inside of a function, I like to have these spaces here. So that it looks pretty.
Right,
so that looks good to you.
Run that and see what we get.
Control S F6, ladies and gentlemen. Fibonacci lives. What do we have here?
All right. So when we do 21 steps of the Fibonacci sequence, that's where we come up with. So if we actually want the number 21, for example, it's going to be 1, 1, 2, 3, 5, 8, 13, 21, which is the 8th step into it.
So
if we return switch 21 with the number 8, we should get the number 21.
It's a more manageable example.
And we get the number 21.
So, Brian, before we exit this tutorial, is there anything you want to add?
That about does it.
Okay, Brian, now let us kind of take a step back here and let's make a Swing graphical user interface application using NetBeans.
Swing! Bada bada.
So how are we going to do this?
File, new project.
All right.
Java desktop application.
Oh, okay. So the desktop application is the Swing application.
Yeah?
Very cool.
So this is a nice little template that gets us kicked up, off, and running.
All right, here's a little disclaimer that we're just going to say we don't care.
Yeah, a disclaimer that says Swing's not being developed anymore.
So what do you want to call the project, Brian?
Let's call it, just call it Swing Hey Buddy. Because this isn't going to go into a lot of detail. This is just going to, you're going to see this, well, you'll get the idea. It's very easy.
All right, Brian, so remember how when we built the calculator, we had to type everything and place everything?
Yeah, that was balls.
Now, we have this little dialog box here that if we go ahead and run the main program, or the main
project,
whatever. Look at that. Look at that. It did all the work for us.
Yeah, it just kicks us off with one of those JPanel thingies.
We have little file menus with help and, oh boy.
It's crazy.
So, how do you want to build this application, Brian? Should we remove this header?
Yes.
All right. So now, what do you want to do? Now, right here, we have the form that we're gonna.
Cool. Awesome. All right. Well, let's stick let's put on like a text label, a text field, and a button.
I'm gonna delete all this stuff that it put on
get
there.
Rid of that.
There
Who cares about status panels and stuff and all that?
All right. Here we go. Just a regular form. We just deleted all the junk. Now check this out, Brian. You said to put a button on here, or what did you say?
Let's do a label first.
A label. So here's the J label. I can just click it and drag it over here, okay? And I can also change its width and whatever. And if I do a double click, look at this.
Nice. Oh, that's so easy.
Yep.
It's like we're cheating. All right, and then let's stick a text field on there.
Okay. So just kind of stick it there for right now. So you said drag a text field, which should be down here a little bit. Here's a J text field goes.
Yep.
All right. So you said where?
Yeah, towards the right, on the right side.
Over here.
Yep. And then put a button on top of that. Stretch it out a little bit. Put a button on top of it.
Like that?
Yep. Perfect.
Okay. And then we'll go up here to the button. And we'll put it what?
Yep,
here?
Perfect. And then let's make the title of the button respond.
For the button, we'll just right click on it. We'll select edit text.
Perfect.
And what do you want to say?
Respond.
Like that?
Yep. So this is going to push something down into the text field.
Okay. So let's run it real quick and see what it looks like.
Okay. Oh, status animation label. We have a lot of references to the stuff that were deleted. Okay, so it looks like we went a little delete happy, which is not a problem. Let's just double click on swingheybuddyview.java. And you'll see the little error indication on the side of the file. Click on the source tab on the top left.
Right here?
Yep. Exactly.
Okay. Oh, look at that. Here is the code, our code behind.
Right. So now let's jump down to the errors. You'll see the errors listed on the right.
Yeah, you see this here?
Yep. So the status message label is something we deleted.
Yeah.
We can leave the action performed frame there for now. It's okay. Yeah, it's not really hurting anything. Jump down to the next one.
Yeah, sorry. We did go a little delete happy, but it's okay. Not a big deal.
Nope.
So we'll just keep scrolling.
So the rest of the stuff is things that the template kind of threw in there, you know?
Yeah, and things we didn't really feel necessary for a basic form application, but for some reason NetBeans does. So we're just going to go to every one of the little squiggly marks and...
Yeah, because the squiggly mark basically means that variable doesn't exist. You know, when we deleted it, the variable initialization also was deleted.
All right, so let's,
cool. Awesome.
Let's try it now.
So let's save that, and you see the little red exclamation point on the left go away, and the thing pops up.
Now, we don't want this to have text when we first start it.
He is correct.
And
so there's a couple ways we can do that.
Now, we don't want this to have text when we first start it.
He is correct. So there's a couple ways we could do that. We could actually...
For some reason, Brian, our menu bar is still there.
Yep. Yeah, we can get rid of the menu bar on the bottom left when you see the inspector.
Right here?
Yep.
Delete?
Yep, just kill that.
Right-click and delete?
Yep, there we go, and then build it.
There's a little play button here.
So this might... Okay,
hey!
Cool. Okay, so we right-click on there, edit text.
Uh-huh.
And
make it blank?
And make it blank. All right, cool. Awesome. So now let's double-click on the respond button.
Double-click.
Yep.
Okay.
Okay, so we're going to have an action.
See how we have action none?
Right.
We want to create a new action.
Yeah, let's do it.
And then what do you want the method to be, Brian? Respond on click or?
Yeah, on click underscore respond. On click underscore BTN respond.
Like that.
Beautiful. I like it.
Okay. And this would be like if you wanted to thread it, but we don't want to thread it.
Yeah,
so.
no, we don't need to do all that. All right, so just hit OK. It's cool.
Okay.
Yep.
So now in our code behind here, in the view, right? So we have this view.java. Now we have a method here called onClick button respond. Now check this out. Let's do a system.out.println. Hey, buddy. Now if we run this application in our little window down here, we would expect to see the text, hey, buddy. Now how much easier is that than what Brian and I did with the text editor?
That's pretty straightforward. I mean, the NetBeans IDE really does make it easy for you to get up and running in a hurry.
So now, Brian, what you want to do is you want to click this button and then have text appear in this object.
Precisely.
Now, on this left side, there's this little properties pane. So if you don't know what the name of the object is, it should be in here. There should be something called name, right, Brian?
Yep. And it's also just at the top, this JText field 1, but we can rename that.
Yeah, right here where it says name.
Yep.
That's the name of the text field. So, I don't know, we can just kind of keep it generic for right now, but it's called JText field 1.
Yep.
So back in our source inside of this.
So instead of that, let's set the text on that thing.
JText field 1 dot set text. Why isn't this auto-completing? Set text to hey, buddy.
You should set it to I'm not your buddy guy.
Oh. All right. I'm not your buddy guy. Not your buddy guy. Let's see what happens.
Hey, awesome.
Woo!
Now that's known as a Hey Buddy swing application.
Now, what a fun little experiment or side project that you guys can do is why don't you guys build that calculator using NetBeans instead of typing it from a text editor and just see how much simpler that process is.
Yeah.
And if you want, submit your code and we could show everybody your awesome, maybe make a graphing calculator or something cool. I don't know.
That'd be awesome.
That'd be awesome. So now,
it's not that tough to plot stuff out.
Look at all the hey buddies down there. Hey buddy, hey buddy, hey buddy. All right, so now Brian and I are going to bail out of this and we're going to come back and we're going to get started doing a basic Android application.
Awesome. I can't wait. Let's do it.
All right, Brian. This is the lab that you've all been waiting for, or at least that Brian's been waiting for.
Kind of.
So we're going to build a basic Android application in Java. I mean, what other option do we have, I guess, for now anyways?
That's true.
So, Brian, now that we have gotten out and we've gotten out of our other swing application and our console still has Hey Buddies all over the place, what are we going to do, Brian? Because we do need to install some other software in order to make NetBeans Android workable, I suppose.
Yeah.
What do we do?
We need to get the Android SDK first.
Right. Well, let me just bail out of here then.
Yeah, we definitely have to close the program.
All right, so we want to go to get the Android SDK.
Yep.
And that should just be the first hit right here. And we want to get this for the Windows installer exe, right, Brian?
Yep, absolutely.
Okay. And we'll save that sucker. All right, now that it's saved, let's go ahead and open this bad boy. Yes. And we'll just next our way through this. So yes, Android relies on stuff with crap, and it's been found. Good, because we're awesome. All right, we can install it in program files, Android SDK, and put it in the start menu. Go. And thankfully for you, Brian, there is a Mac version of this. So.
Oh, sweet. So it looks like the Android SDK setup wizard is finished, but we still have a little ways to go.
Okay.
So this is going to automatically start the SDK manager, where we download like the images of the different devices and the updates.
So we want to start that?
Absolutely. Yep.
Okay.
Okay, so now it's going to go see if there's any kind of suppositories that we need. All right. So
look at all these APIs.
Yeah, so we don't really want all of these because they take forever to download. So for the sake of this, we're just going to do a little fast forward of us unchecking all but, like 2.3.3 and maybe 3. Leave like the first 3 and then 2.3.3. And then you could get rid of 3.0 and 3.1. And then 1.5 we don't need. And then so we can get rid of all the samples. Yep, I'll leave all that stuff. Cool, all right. Let's install that.
Install it?
Yep.
All right.
But other people for realsies doing this probably want to just get all of them for the hell of it, so you can make sure that you can test your stuff on every device under the sun. And even that won't be sufficient.
Oh, yeah.
See, it takes a long time to download all this.
All right, so a package depends on some crap. Do you want to restart that?
Yeah, of course. What choice do we have?
Yeah.
Because Google Marketplace Billing Package, revision 1. I find this to just feel very sloppy.
Yeah.
It's just my opinion.
All right, Brian, so it looks like we're done, huh?
Close it.
Hit close, and what should we do?
Okay, so now we need to make a new Android virtual device. Okay, so now we need to make a new Android virtual device.
Okay.
So with this is basically a device for our simulator.
Mm-hmm.
So let's call it
Android phone?
Yeah.
Okay. And which Android?
233.
Okay. So I think, Brian, I could be wrong, but anything in the 2s is a phone, anything in the 3s is a tablet, right?
Yep. And then 4 on, which is ice cream sandwich, will be either.
So then we'll do 2?
Yep.
And then what else do you want to do?
Let's make the SD card. Probably doesn't really matter, but we'll just make it like 32 megabytes.
Okay.
Then the skin built-in one is fine. That's all fine. Hardware is fine. All right, tab out of there.
It still wants us to do something.
Oh, you have invalid characters. You can't have a space in the name.
Oh, sorry. Android phone.
There you go. Cool. All right.
Okay.
Sweet.
So now we have a Android virtual device.
Cool.
To bail out?
You can just leave it. Just
leave it running?
Yeah, just leave it.
Okay.
Minimize the stuff. All right.
Hey, Brian, look at your favorite icon.
Ugh. So let's look for this thing, right? Let's search Google for something called NB Android, which stands for NetBeans Android, under Project Kanai.
Android plugin for NetBeans?
Yep. And there's a link on the left that says installation under project links.
Right here?
Yep. And you're gonna find this updates.xml link. Yep. You're gonna copy that link.
Okay, so copy link address?
Absolutely. Now let's switch back over to NetBeans, and we're going to add this into our plugins repository.
All right, so how do we get there?
So we go to Tools, Plugins.
Tools, Plugins.
Then once the Plugins dialog box is open, we're going to go to the Settings tab. And then we're going to click the Add button on the bottom right corner.
Gotcha.
This provider, we can just call it NB Android.
NB Android?
Yep, and it's all one word. Yeah, you got it.
Mm-hmm.
And then
paste the link.
Exactly. Yep. So now our available plugins went from 87 to 91.
Nice.
So let's go to our available plugins tab, and let's actually just stick all the Android ones in there.
Select.
Let's just select the top one.
Okay. So we select this one.
Yep.
And then install.
Absolutely.
And then let it do its thing.
Of course, I accept the terms. Well, it doesn't even give us a chance.
I like how this isn't a progress bar, but it's just like a little shooting bar.
Yeah,
like it doesn't tell me how much time I have to wait. It's just like, yeah, we're just gonna tease you here.
We'll just make it look like,
It appears like we put effort into this, but we actually did not.
Please wait for project dependencies.
All right, so we will accept all of the scary demands and install,
including the demand to not record this in a video tutorial. So this will download everything that we need to get to be cruising and moving.
All right,
so we'll continue. That's fine.
Continue.
We don't trust anything anyway. Finish.
Okay. So the Android module has been installed.
Yep.
Right?
So now we'll see it in the installed tab.
Installed Android.
Yep. Cool.
Okay. All right. Cool. So we can bang out of here, right?
Yep.
All right. So now we can start a new project, right?
In theory, yes.
And then here we have an Android project.
Awesome.
And then we'll build an Android project.
Yeah, let's do it.
Select next.
Oh, I'm so excited.
All right, so we'll just call this Android Hey Buddy?
Yeah.
Like that?
Yep.
Yeah. All right, and the package name is...
Hey Droid Buddy. The package name, we'll just say, Hey Droid Buddy.
Hey Droid Buddy.
Main activity is fine. And then the target platform, click on Manage Android SDK.
Okay.
Going to pop up this business. And then we're going to browse for our SDK location.
Okay.
And we're going to go to wherever it was installed.
Yeah, that should be the C drive, right?
Yep.
C program files.
Sometimes it's C Android, but you're probably right. Yep. C program files, Android.
Okay. Android SDK.
Yep. Let's see if it'll take that as the path.
Open. Is that good?
Yep. Hit OK.
All right.
Okay. Now we're going to select Android 2.3.3.
Okay.
Okay, and then also the package name must have two parts. So we actually, the package name should really be net.wibbit.
So do net.wibbit.
Yep, that's it. I should have said that earlier. So we'll hit finish. So now we have an Android project. So let's, just to kind of get a sense of it, let's just, once it's done refreshing the indexes, try to build this and see what it complains about and make sure it's all happy. Or we can just directly go down and, well, just say build main project under the run menu.
Build main project?
Yep. Okay, just because it's red doesn't mean it's angry. It just means it's confusing.
Hey, successful.
Alrighty, so let's hit the play button and see what happens. And the Android emulator takes quite a long time, so...
Yeah, it does. And I like how there's like 1,000 pop-ups.
I know, it's awesome.
And the Android emulator sits in the screen for like 5 years.
Yes, it does. So if your computer's kirking out, so do the phones. I'm just teasing.
No, he's not.
Yeah, I'm not. This takes a really long time. So just keep that in mind. This takes a really, really long time for this device to boot.
And we're going to edit it to make it not look like it. So when you actually do this for yourself and it takes a really, really long time, that's normal.
Yep. And in the meantime, I'm going to eat a peppermint stick.
Droid. That's my impression.
Droid.
How much of an asshole a thing is it for them to, like every time you get a text message, mark up their phone, like you're a walking advertisement? I get so irritated when people are walking around and they get a text message and I hear the droid. I'm like, ugh, I hate you now.
That's pretty dumb.
Droid.
Oh, hey, I just got a text from my droid, man. It would be the equivalent if Apple had like sound like somebody drinking a Starbucks as their text message sound.
Actually, on my iPhone, when I get a text that goes, I can't imagine why anybody would ever want to text me.
I'm glad it's playing the little Android animation to let us know that something's happening. Shame on you, Google. Shame on you.
Hey, look at this, Brian.
Hey, we have an Android.
We have a droid.
A far faster one than most phones out there. click on the center grid.
Okay, click on the grid.
Yep, and then look for our app, which is probably on the bottom somewhere.
I don't see it.
You know what?
What?
This is funny. I think you actually have to build it and run it again. Like, leave this open, switch back to NetBeans, and push play again. I know that sounds really stupid, but I think that's what you have to do.
Hey, there it goes. It ran.
See, I told you.
So here's our little stupid program.
Yeah.
Wow. So what do you want to do with this, Brian?
Not much. All right, our main objective, if you choose to accept it and follow along with this insane task, is to make our official Hey Buddy test run of a GUI setup, and that includes a text field, a button, and a label. The label starts out saying something. You type something in the text field, hit the button, and it changes the label to be whatever you typed in the text field.
Sounds good.
That's our objective.
Hey, Brian, welcome back.
Hey.
How are you,
thanks. Man? All right, I'm all right.
Awesome. Well, the last time that we left off here, you put out not a challenge, but I guess it's kind of a challenge to our viewers, asking them if they were up to the task of building an Android app with a button that populates a text field.
Yeah.
Yeah? So are we ready to do this?
We also gave them the challenge to build a swing GUI of the calculator using NetBeans.
That's true. That was another challenge, although that's probably less of a scary challenge than what we're about to embark on right now. Yeah, so the interesting thing about Android development, guys, and we don't want you to be scared of this, maybe before you actually tried to code this, watch it a couple of times, because there's a couple of aspects of software development that you have not been exposed to that you have to know to get involved in Android development. Like, for example, Brian, we're going to be modifying XML files, right?
Mm-hmm. That's true.
Yes, and if you have never been exposed to HTML or XML, you have absolutely no idea what we're about to do. So we don't.
But you'll probably figure it out in short order, so don't worry about it.
Right, and it's not hard, but it's one of those things that if you haven't seen it, if you haven't worked in it, you just don't know what it is.
Totally.
We apologize in advance for those of you guys that are scared by this, but without further interruptions, Mr. Brian, let's go ahead and let's get started here with building a graphical interface Android application.
All right.
So should we start here with NetBeans?
Yeah. Integrated dunking environment.
Yeah.
I want to dunk my in it. Do you remember Mad TV?
Of course I remember Mad TV.
Or was that in Living Color?
That was in Living Color, though.
Was it in Living? Yeah, it was in Living Color. I want to dip my in it. In Living Color was awesome.
It was awesome.
Yeah.
That's where the Wayans brothers...
A couple years ago, we went back and started watching reruns of In Living Color. Well, I think it still head up.
We went to Blockbuster one night. I think we were still in college, and we were roommates at the time, and they had, season 1 through 5 of In Living Color, and we just, rented all of them. We just watched at least the first couple seasons we watched.
They were good. And, I'm Fire Marshal Bill. It was hysterical.
Jim Carrey. Or back in those days, he was known as James Carrey. All right, Brian, so we're going to go ahead and start a new project, right?
Yeah, let's do it.
Yeah? And we kind of went through this before in the last video where we just built a basic Android app. We're going to do the same thing where we're going to select from the Android category and we're going to build an Android project.
Yep.
Yes.
Kind of like before.
And then, Brian, what do you want to name the project?
Let's call it Messenger.
Messenger?
Because it's going to be taking the text from a field and then showing an alert box.
Okay. And the package name, we'll just call it net.wibbit. Is that good?
Yeah, and the activity name, let's also call it Messenger.
Okay, like that?
Yeah.
And then we want to select which...
2.3.3.
Which is building...
Because it's going to be for the phone.
Right, a phone application.
Pony.
And should we just go ahead and bite the bullet and start the simulator now?
Yeah, because it takes a year.
Yeah. And you would not know that by watching the other video because we edited that out.
Just like we will right now.
I can tell that you are the most beautiful girl I have ever seen with a kebab.
Ooh, why don't we leave? You can go to my house and we can feel each other up on the couch. Oh no, I don't mind taking it slow. Oh no, yeah.
You're so beautiful, like a tree.
Or a high-class prostitute.
2.5 hours later, Brian. We have a Android simulator ready to go. So while this kind of sits here and consumes massive amounts of my computer's resources, let's go over here to our project and let's start working. So inside of our source packages,
Yeah.
we have our messenger.java file, and if I double-click on this little guy, hey!
Nice.
Nice.
So, kind of like before, it creates, it basically just does the super create, bubbles its way up, just kind of like we do in iPhones, iOS stuff. And then it sets the content view, and it passes in the main layout resource, the main view resource.
Right.
So that's R for resource, and then layout, and then main. So let's take a look at that main resource.
All right, so Brian, you're talking about this little R here, and that stands for resources.
Yep.
So to find what that is referring to, there's a little folder here called resources that contains stuff. And you see how it says like r.layout, and there's this little layout folder?
Yep.
So this is accessing .main, which is an XML file.
Because remember, in Java world, packages are folders.
Everything is a folder, so it has to follow the directory structure, right?
Yep. So this is our main XML view configuration, basically.
Right. Like you remember when we built that little Hello World program? You recognize this text? It said hello on there, and there was a little text field.
Yep.
This is where it came from.
Yeah.
It's pretty awesome.
So this text view component tag has a couple properties. It has the layout width, the layout height, and a text value.
Mm-hmm.
So one of the things that we want to do is we go through this, and because this is where we're going to be building out our main view, right?
Mm-hmm.
One of the things that we want to consider is it's not really good practice to put, especially for like localization and stuff. You don't really want to put your actual string values in your main view like that. So we want to take the string values, maybe just kind of put them off in a strings file. Messenger popped up.
Yep. See Messenger right there. There's our little app. So what I want to do real quick before we continue is I want to kind of get everybody on the same understanding that this text view is a widget that's placed right here.
Yep.
So this hello world messenger, that is this item here. So we're actually going to be working on this view right here.
Also, if you notice the linear layout tag, the close tag for that component is actually surrounding the text view. So this entire panel is a linear layout view.
Right.
And that we're saying that it has a vertical layout orientation.
Mm-hmm.
We can change that, and we can put multiple layouts and all that kind of stuff. But in any event, the text view that says Hello World Messenger is inside of that linear layout.
There you go. All right, Brian. Now let's do a little bit of magic here. All right, Brian. Now let's do a little bit of magic here. Talk to me.
So we know we want a couple things, right? We want we want a button, we want an editable text field, we want some other stuff. Let's first store off our string values, and then we'll kind of circle back to this so that we can use them later.
You're so beautiful. Okay, I think that's good.
You can be an air hostess in the 60s.
All right, Brian. So now that we have our font a little bit bigger and we can see stuff,
all right, yeah,
let's do it now. Let's do the good stuff.
Okay, so let's go to the values folder now.
Okay.
So the Android projects come with this strings.xml file.
Mm-hmm.
Let's take a look at this. So right now, the only string resource that we have in there is the app name, which is Messenger, which you can see in the title bar and you can see underneath the application icon.
See how these correspond, folks. This is very important.
So that's cool. So let's add a couple resources in there.
I'm so down with that, Brian. It's not even funny. This is the greatest day of my life.
Of my life. Okay. So let's say how about btn_close_text.
Like this?
Yeah, just make them all lower.
Are you sure? Because that's not very cool. That's not very camel casey of you.
I'm trying to illustrate that it's the text value.
I got
Actually,
you.
just do btn close. We'll just. I mean,
camel
we're only
casey?
gonna have one. No, because it's.
Brian, I have no idea what you're saying. BTN close like that?
Yeah.
Okay.
Because that fits the naming scheme that they're using.
Nah, screw them. Brian, you're too conformist, man.
Yeah, I try to be.
Not even.
And then,
cool.
So let's. So what do we want the button to say when we close the application? Let's just say close me.
Yeah, why not?
And then we're gonna do one more string resource.
Okay.
And its name's gonna be button_getText, and that's gonna be
get.
BT. I'm sorry, BTN.
Oh, yeah, that's right. I'm sorry.
That's all right. And that's going to be the button that gets the text from our editable text field, and we'll present it in a. And you can camel case the text if you want, since that's.
Thank you, Brian. Like that?
Yep. And then let's just say get text ! So that's going to pull the text from the editable text field and throw it into an alert.
Okay.
Cool. So now let's swing back to the.
Swing back?
Swing, yeah. Let's go back to the main layout.
Gotcha.
And let's add just like an edit text field.
Okay. So
actually, you know what we can do is see the text view. Let's change that to be
a variable.
Yeah, let's do the app name variable. So it's @string to indicate that we're pulling this from the strings layout.
Right.
/
Hold on.
app_name.
Okay. So
Perfect.
what Brian's doing here is we're going here to the strings file, and we're accessing the variable app name, which should be Messenger.
Yep.
We got to wait 15 years for the app to update, but it'll eventually get there. Hey!
All right.
Good job,
Cool.
Brian. Oh, I guess we can call that a day, huh?
Yeah.
Continue, sir.
Okay,
Continue.
so now let's make after the text view, let's make an edit text field.
Okay.
So there's a bunch of different types of components. This is one of them. The Android documentation is not that bad. They will list out all the different component types that you can use and all that kind of stuff, which is not bad. So we want to give this an ID so that we can basically, in Objective-C terms, make an outlet to it.
Or in JavaScript terms, you want to get the instance of a HTML element, you store the ID in the tag.
Yeah, exactly.
Same concept.
Yep, exactly. That's actually probably more closely approximating.
Because it is XML. Yeah.
So it's going to be Android:ID is the parameter name that we're going to use to assign the ID, and that's going to be equal to @+ID, which indicates that we're going to be adding the ID field / and then we'll just say text fields and camel case it
like that.
Yep. And then the next two properties we can actually just we can do Android:layout width, which is going to be fill parent, and then the layout height is going to be wrap content.
I'm going to steal this.
Just like the text view.
Nice.
Cool.
That was a good steal.
All right. And then we can either see what this does, or if you want,
to see
we can
what this does,
all right,
Brian.
let's do it.
I'm fired up about this.
Oh, we still got the old one hanging out there. It'll clear.
Yeah, it'll fix itself. Because it could be an air hostess in the 60s. Hey, look at this, Brian! Ah!
So no coding was involved. All we did was add that component tag to the XML layout file, and boom shakalaka, you got an edit text field.
Holy crap, Brian. That is absolutely insane.
Yeah, and look at it stretch.
Yeah, that's what she said. Anyways, what do we want to do next?
So let's put a couple buttons on there. What do you think?
That sounds fantastic. I love it.
All right, you could probably just copy the edit text one, and we'll just modify it.
It would be my pleasure, Brian.
You're weird.
I'm sorry. Is that creeping you out a little bit?
No, not really.
All right.
All right,
you
so
know
this
me
is
for
gonna
a
be a
while. You know I'm
button.
kind of weird. All right. Anyways, ID. What do you want the ID to be, Brian?
Get text. So this is going to be the button that gets the text.
You just want to call it get text?
Yep, just get text.
Okay.
And this is going to be same stuff, same deal.
Okay.
All right. So but in this case, we want to add text value because we want it to have like a title text on it. You know what I mean?
So
it's going to be Android:text equals.
Okay.
And then if you go back to the strings file, we had already kind of defined out a string variable that we can use for this, which is get text. So let's copy that name btn_get text.
Okay, I can do that.
And we'll just refer to that. So it's going to be @string /
So @string / and the name of the variable.
Yep, and that's it.
Not bad.
Cool. All right, and then let's copy and paste the button, or we'll just play it again. That's cool. We'll see what this does.
Small victories, Brian. Small victories.
Absolutely.
Cool.
Nice. So the button doesn't really do anything.
I just
want to
say, I think you said this
on
before, but I'm going to reiterate. We have not written a piece of Java code at all.
Yeah, that's true. Absolutely.
All right, what's next?
And let's keep it that way. No, I'm just kidding. All right, so let's copy and paste the button because we want to be able to close the program.
The program?
The program. That would be nice. So let's call it, close instead of get text. And then the string, we also define this string out. If you go back to the strings file, yep, button close.
Button close.
So one of the things that I don't like, and maybe if we become better Android developers sometime down the road, is the hodgepodge naming convention that you'll find in Android development.
Yeah.
But whatever. What can you do?
Android is kind of sloppy, but iOS development is annoying. So take your point. What do you want?
Exactly.
Do you want sloppy or do you want annoying? It's cool. Look at that, Brian. So
nice.
What I think, and I could be wrong, is what we have to do now, Brian, is we have to input text into this field.
Yeah.
Input text into this field, and we want the clicking of this button to react and show us the text that we have put in here, right?
Yep. Okay, so let's wire up the close button first.
Okay, let's do it.
All right, so let's go to our messenger class.
Oh boy, here comes the Java!
So the messenger class extends activity.
Yes, it does. If you look right here, we are extending or inheriting from activity.
Activity is an Android class. It really gets into like nonsense. It doesn't really matter. It extends the context theme wrapper and implements factory and callback and a bunch of other crap and stuff. But it's basically like the base. If you're used to Java development on the web, in like struts, for example, or JSP, things work on actions and activities. It's the same kind of thing, but I guess they're arguing that the launching of the application is like an activity. This is like the default activity.
You know what that makes me think of? That stupid 80s song, Let's Get Physical. Like, you remember that fitness boom and back in when we were little kids and everything was all about like energy?
Yeah, and Arnold would come visit your school and stuff.
Yeah. You have to commit to be fit.
All right, so let's declare in the messenger class a private button.
Okay, so we want to do this in the global scope.
Yep.
Okay, so private button with a capital B, right?
Yep.
Okay.
And then we'll call this like BTN get close.
BTN close like this.
Yep. Perfect.
Okay. And then just bang it off.
Yep, that's it. Okay. So now let's do something with it.
Okay. Well, hold on. I think that we're gonna have to. And if you guys don't know this in NetBeans, if you see this little squiggly, I can right-click and fix imports. And what it did here is it added an import to the Android.widgets package. And it referenced the class button, so now we have access to that class here.
Yeah.
All right, so now, Brian, you have created a variable that will represent the button close. How do we link this up to the graphical user interface from the main.xml file?
Okay, so after we set the content view, we drop down a line or so.
Okay.
And then we say, we're going to be referring to this.
Right,
at this point in
the
time,
current
because
instance?
It's this instance, right?
Right.
So this dot
open recursion, you guys know this.
Yeah, this underscore button close, you got it. Auto IntelliSense is not that bad in NetBeans. IntelliSense is a lot better in NetBeans than it is in Eclipse. But sometimes it can take up your entire screen like that.
You're right about that.
So it always happens. It's weird.
No matter
how big of a monitor you have.
I was going to say, you could have like a 46-inch TV hooked up to NetBeans and you're still like, what the hell?
Yeah, it wouldn't help. So yeah, we're going to type that, cast this as a button. And this is going to be this, and then there's a method that we're getting from extending activity, and that's going to be find view by ID.
And those of you guys that have written in JavaScript, that looks really familiar to you.
Yep. So this is going to be a R for resource dot ID, so find by ID basically.
Right.
And then dot, and then you're going to see get text right in the field. But so ID will just search out, based on your layout and based on whatever you've created and the fact that we've appended IDs to stuff, it will just kind of search out our scope and our space.
So what
context.
Brian created this variable called getTextHere, which belongs to this button. So inside of this code, by saying resource seek an ID, which is one of the layout XML files, get me the object or the widget that is getText and give me a link to it. So like Brian said, this is the same thing as an Objective-C development as creating an outlet. We have now married a widget instance on a form to a variable inside of our program.
You just said widget.
I know, because that's what. Here, look, that's what Java. I hate calling them widgets, but Java loves calling them widgets.
All right, so or at least Android does.
Well, even in Swing, they're called widgets, aren't they?
Oh yeah, you're right.
Yeah. Anyways, I'm sorry. What?
All right, so this button close has a method where we can set onClick listener.
Okay, so there's a method called set onClick listener.
Yep.
Okay.
Okay, and what we're gonna do is we're gonna pass it a new onClick listener object, but we're gonna be overriding one of the methods of the onClick listener object.
All right. So those of you guys remember when we're extending a class during instantiation. When we create the instance with the new keyword, we're going to then just open up some blocks, and then inside of this code block, we're overriding methods in the class. So I think, Brian, we have to fix our imports with this one too. Yeah. And I believe it's an Android.view.view.on.
Yes, this is a view onClick listener.
Right. And don't be confused with this little guy here, because that's the wrong...
the dialog interface is totally different.
Yep.
That's like a content onClick listener.
Yep. Okay, Brian, so what method are we going to override?
Okay, so first let's put the override annotation just for good practice, because people will be using those a lot with Enterprise Java Beans 3, JUnit and stuff.
JUnit. Come check out my JUnit, ladies.
Okay, so
I don't think that's... I tried that 100 times. That's never worked.
So it's going to be public void.
Okay.
OnClick.
Okay.
And we're going to pass it a view object.
Sounds great.
And the view object v.
Okay. Just to be simple.
And then we'll just open and close that.
Okay.
There you go.
Now, for this view, I think, Brian, we're going to have to do another right-click and fix imports. So now if we go up here, we'll see that we have an Android.View package, and then we have access to the View class.
Yep, very nice. Okay. So the only thing that we have to do to close an application, to exit an application, is call the finish method.
Like that?
Yep.
Or finish like we speak Finnish? No? Okay.
All right, so let's see if the close button works now.
Oh, that's all?
Yeah,
what?
That's it. Not too bad, right?
What? That's ridiculous, man.
So if you want, you could even put a little comment above those two lines.
Oh yeah, you better believe that's what I'll do. So, where do you want me to put the comment, Bri?
After set content view. The line after set content view, we'll just put a comment in there that says, wire up close button.
Good. I like the way you think, man. All right, now, our app is here. Get text does nothing but close me.
Hey!
Wait, hold on. Hold on, let me make sure that... What the hell is this crap?
Select your language. It's at the top.
Oh, Android. Alright, Messenger. Okay. I clicked on the get text, and it closed.
Oh, that's cool.
So let me just make sure that we have the right thing going. So if I click close me, it doesn't close. So we have...
Okay, so we wired it up to the wrong button.
We do. So let's see. On the get
happen?
text, this is supposed to say close. Brian, what is wrong with you, man? What's wrong with you?
That's called a logical error.
That's called a Brian is stupid error.
Hey.
I knew something didn't smell right because I tested the... I clicked on get text and I was going to prove that it didn't work.
Yeah.
So now get text doesn't work, but...
There we go. That's why testing is important.
Yes. Always test before you distribute your apps. Okay, Brian, so now we were able to wire up the close button.
Yeah.
So what is the next step in this process?
All right, so the only other thing we got to do is basically click the get text button.
Okay.
And do some business with that, right?
Okay, so we're going to do a very similar thing here. We're going to say wire up get text, right?
Yep.
Wire up the get text button. And you guys can imagine that we're probably just going to be copying this verbatim right here, huh? Except for we're going to create a new instance of a button, right?
Yeah, so so we want to add another global variable, and this is going to be
BTN?
Yeah, BTN get text.
Like that?
Perfect.
Okay, so then we'll come back down here and we'll replace that. And then if we go back to our...
Let's wire it up with the right thing.
If we go back to our XML file, we'll see that our ID for this one is get text, Brian.
Yeah.
Get text. So now we have pulled that item from the XML file and we've linked it up to an instance or a variable within our application. So, Brian, what do we do next?
Okay, so now we do the same thing where we're going to override the onClick listener, because the onClick listener is what happens when we click the button, and we're going to be, using this button so that we can click it.
That sounds like an amazing thing, Brian. So let me just wire up the correct button here, and what do I do?
Okay, so we're going to override the same method.
Oh.
We're going to override just grab the whole thing.
This is
now
easy.
We'll just get rid of finish.
Oh, okay.
All right, cool. So here's what we're going to do. We're going to do a couple things.
Okay.
We're going to be invoking an alert dialog box. Yeah. So that's just alert dialog, capital A and D.
Yeah, isn't that kind of similar to an Objective-C with the alert view?
And in .NET world, that's the message box. Yeah. All right.
Message box.
So this is going to be equal to a new alert dialog .builder, and builder is a static class method. So that takes in a parameter, and we're going to pass it, instead of passing it this, we're going to pass it messenger.this. So that's right. Because this is exactly.
It's in a different scope. So we can't say this because this would refer to this instance of an on-click listener. We want to refer to this, meaning this instance of messenger right here.
After that parameter, after that,
we gotta do a little right-click fix imports, and we'll see now we have an alert dialog.
Can I go back?
No.
We just have to add one more thing before we do that. So then after we pass the parameter into the constructor, we do a .create. We call .create, and that's the object. Create returns the object, the actual instance that we want. Cool.
Awesome.
Okay.
So if I fix my imports, I'll come up here, and now I'll see this Android .app
Sweet.
alert dialog.
Okay, so now let's
Brian,
let's create the instance of our edit text field.
Okay.
It's edit text, and we'll call this like get text field.
Okay.
Actually, that's inconsistent. We should. Let's do like FLD get text. So that's going to be equal to And we're going to be doing that find view by ID kind of thing again. But in this case, instead of typecasting it as a button, exactly, we're going to typecast it as an edit text, object type.
Yep. And we're going to go back here, and we're going to scroll up to our edit text, and our ID for this is text field. So I'm going to copy this, and I'm going to put this here.
I kind of messed up. We probably don't want to call it get text. We want to call it edit text. I'm sorry about that.
Yeah, you're right. Right. And we also, ladies and gentlemen, have to do the fixed imports again. And what we've done, as you guys know, is we have linked up that text field to this code. Woohoo! We are bona fide software engineers, man. We're going to make billions of dollars making Android
so I wonder
apps.
why it's angry. Oh, because we're inside of a scope, we actually need messenger.this.
Oh.
Yeah.
You're right.
Cool. All right.
Good find, Brian.
So now that we get that squared away, let's kick back to our alert dialog object. So we're going to set the title on our alert dialog, right?
All right, well, hold on. Let me, just for those folks following at home that want to know what's happening, wire up text field text box. There we go. That way, where these comments are, you can kind of link this main.xml file to the code visually.
All right, so now let's set some properties on our alert dialog box instance.
I am down with that.
So let's do a .set title method. And
okay,
let's pass in the string message, because when the alert box comes up, it's going to display a message. So we might as well just make it a message box. All right. So now the next method we're going to call an alert dialog box instance is the set message, which is actually the message that it's carrying.
Okay.
And that's going to be
right.
We're gonna get the text out of the field edit text that we have there. So field edit text dot get text. And that'll get whatever we type in that editable text field.
Nice.
Just like that. So so now the only thing we have, as far as configuring it anyway, or one of the last things we have to do, is to set the button action, right? So let's call set button on the alert dialog, and the first parameter we're gonna pass is gonna be the title text of the name of the button, and that'll be okay. And then the next one is gonna be a new dialog interface. And then on the dialog interface is going to be a .onClick listener, like we've done before. We always have to set these onClick listeners to get things to respond without the.
Okay, so we're going to extend
dialog interface .onClick listener. So we're actually extending the dialog interface's onClick listener, which is different than the view onClick listener we've done before. So before the parentheses, it's dialog interface .onClick listener. There you go. Yep. And then that takes no parameter, and we extend that one. Yeah, let's just get rid of that.
Code that just filled out for me? Okay, on-click listener.
Yep, so that's what we're overriding.
Overriding this?
So we're going to override, similar to the way we did on the views on-click listener. We're going to put the override annotation, and then we're going to override public void on-click. Now, because this is a different type of object, we're going to be passing in a dialog interface object, and we'll call that instance the dialog. And then the next parameter that it expects in this override is integer which, like which is it?
Like that.
And so because this is just closing it, we can just stick a little comment in there that says close, because we don't actually have to do anything. But we still have to override it nonetheless.
Cool.
So that's dumb. Yeah. So that's all we have to do for that. So after...
I'm sorry. Exactly. We're not closing the application.
So that's all. We just put a little... We're basically just emptying out the onClick so it doesn't call super.
Right. You're just doing the default action, right?
So after we override that, we just have to do two more small things on alert dialog so that it's visible. The first one is alert dialog.set icon, and we can give it any icon, but we're in this case just going to give it the default icon, which is r for resource.drawable.icon, and that'll be the application icon.
Right. So wouldn't that be in here, right?
Yep.
So there's drawable icon. So for like your different devices, you have a different icon. So we're going into our resources. We're accessing the drawable.
All right, and then the last thing that we do is just alert dialog.show, and that shows the alert dialog. That makes it pop up.
Okay.
And that's it. So, in my opinion, this whole like overriding things inside of things that are overridden inside of things that are overridden, I'm not a big fan of. I don't like that style of programming at all. We want to show it to you because this is a pretty conventional way of Android development, but it's not my style. I don't like overriding methods during instantiation. But to each his own. So let's see what this thing does.
Okay. All right, Brian. So let's just do. Hey, buddy. You ready?
Hey. Cool. Now hit OK, and it should just take us back. Yeah.
Look at your little icon here, Brian.
So then let's clear out the text and say, I'm not your buddy, guy.
Okay. I'm not your buddy, guy. Ready?
Hey, awesome. All right, cool. Now let's close.
We are superb
let's close the program.
Android developers.
Make sure that still works.
The program?
Nice.
The program is closed.
That was awesome.
Wow, Brian.
So now that you
How
guys
cool
have those
is that?
essential, absolute basics of fleshing out an Android app, you can kind of start getting a sense of how to wire things up. Now that you have this, we've already gone over model view control and other things, and we've gone over building out our model classes and stuff. So now it's just a matter of wiring this against your model classes, building out some nice controllers, and just getting it all to work together. But once you're past this, and the next step after this is to learn how to have multiple layouts, multiple views, and some sort of sense of navigation around the application. Well, once you get that fleshed out, you can do anything that you want. Go check out the Android documentation, see what other kind of components you can use, look to see if there's any kind of third-party components that you might be interested in, build your own. You can do whatever you want. Tie this stuff back to your model classes, and your model classes are just Java. So you can do anything that you're used to, so long as you can't do anything you're used to because it's J2ME.
I guess technically you're not accurate. Yeah, because you are limited. It's actually a different subset of ME.
But it's
not
essentially,
like the pure
you can
ME.
do a
it's
lot
like
of
a custom
stuff.
one for Android. Right. All the basic stuff. I think the Pojo stuff. I think is all fair game.
So
I just said Pojo. I think that's the first time I ever said that bore, except for when I made fun of you for saying it.
And I just wanted to describe it. I didn't
did.
actually use it in a sentence like an actual reality,
All right, guys. Well, thank you for following the Java course, and we'll see you again, hopefully, very soon in C#.
Awesome.
Bye! Hey guys, welcome back to the Programming in Java course. This time, instead of Brian, we have Jason on for this tutorial. What's up, Jason?
Nothing much. It's about time for an upgrade. Or downgrade, I guess it depends on your perspective. If you want quality tutorials, I guess this is a downgrade. But if you want annoying banter, it's a definite upgrade.
Well, Jason, I'm very happy and very excited to have you on for the first tutorial. I mean, we're already, 60 hours in or whatever, and this is your first appearance in the tutorial. And you picked a really good one to come in on, because in this one, what we're going to be doing is we're going to be basically porting that same exact tic-tac-toe program that we wrote for the iPhone to Android.
All right, player one. X flies up. Oh! Yeah! Nice! Holy shit, that's awesome. I love it. It's a draw. Oh my god, Brian.
That's cool.
I'm gonna play this all the time now. Oh, he beat me! I'll let him beat me.
Exciting.
How badass is that?
It's titillating, I'll tell you.
Now, one thing that we're going to kind of cheat on a little bit is to save time, guys. That class that we wrote in Objective-C, the tic-tac-toe algorithm, the tic-tac-toe logic, what I did is I ported that code to Java, and the function, the methods are the same and everything, so we're not going to actually write this with you guys. So if you guys are clueless on what this is, please go back to the Objective-C course where we write this in the TicTacToe Lab. Even if you have no interest in iPhone, that's not the point. The point is to watch us write the algorithm and explain the algorithm. I don't want to waste another hour doing this when we could be doing the fun stuff. Right, Jason?
Absolutely. And it's good to be a well-rounded developer anyway.
Yeah. And also, what might be a fun exercise would be to take the code from that tutorial and port that to Java yourself, like I did here. I mean, it's fair. All you have to do is change NS integer to integer and remove those expression syntax that Objective-C uses and just use the function syntax that Java uses. So anyways, we also have kind of pre-made some images. We have this blank icon, which is going to be our tic-tac-toe grid when there's nothing on it. But when there are objects on it, we're going to have the X here and the O. Also, just like in the iPhone app, we're going to have the sleeping frog and the sleeping fly when it's not their turn, and the awake frog and the awake fly when it is their turn, along with the background grid, the splash screen, and a little Wibbit.net logo. So you can keep this, get a tattoo of this on your lower back. It'll be awesome.
I just got that tattoo right on the tramp stamp. right there.
So, the emulator is running, and we're just going to fire this thing up, and inside of NetBeans JSON, we're going to go ahead and make a new project. How does that sound?
Sounds awesome.
All right, and we're going to make in the category is an Android project, which we've done this twice before. And what do you want to name this, Jason?
Tic-tacky, maybe, I guess, or Wibbit TicTacToe.
How about WibbitNet TicTacToe?
Fine, if you want to get all technical about it.
So our project name will just be WibbitNet TicTacToe, and our package name is going to be scoped in net.wibbits, and our main activity we'll make it the same name as the project for consistency, and we want to make this a phone app, so we're going to be using the 2.3.3 operating system version or platform API, whatever. Yeah. All right, Jason, so if you were to build an Android app, what's the first thing that you would do?
First thing I would do... I don't know what the first thing I would do is. Maybe... what is the first thing I would do? And I'll answer that question.
Well, when we start talking about building graphical interfaces, we kind of follow the model view controller model, right? So we build our model code, which is our back-end code, which we've already written. That's that Java code file that we looked at just a second ago. Then we're going to build the view, which is going to be the graphical interface, and then we're going to build the controller, which is basically tying the back-end code to the user interface. So, since our model code is written, let's go ahead and stick this inside of our project.
Sounds good.
Yeah, I think... And I'm not sure the best way to do this, but I'm just going to do a good old-fashioned copy and paste. So then we have the model portion of this done. So inside of our source packages, so we have our source packages and then our net.wibbit. So inside of here we have our controller code, which is our activity, which we'll be working on in a little bit. Let's go ahead and let's add a new class. So we'll do a new Java class, and we'll call it TicTacToe. Alright, now I'm going to do a good old-fashioned select all, delete that. So now we have our TicTacToe model code inside of our Android project. How cool is that, Jason?
That is fantastic. That was some good coding, Kevin.
I know, man. I've just gotten so good at this, I can just write classes in 10 seconds now. Alright, so let me just check it for syntax. Alright, so Jason, based on the model we just talked about, where we do the model view controller, our model code is already implemented here. Now we have to work on building the view, so we're going to build the graphical interface next.
Okay, so that's what everybody's seeing, but this model, that's what's actually doing all the heavy lifting for this, isn't it?
Absolutely. This is the logic. Our model code contains the logic. Our controller code will link this to the graphical interface. So you remember in our resources, we have inside of our layouts, we have the main.xml, which using NetBeans, this is going to be the main layout. So inside of the emulator, we can run the program, and we'll see the main layout pop up here in just 1 second.
There it is.
Yeah, here's the main layout or the main activity. Jason, you can see how this kind of relates, right? So we have this little layout here, which represents this black area, this text view, which contains hello world, Wibbit, TicTacToe.
Yeah.
Yeah, isn't that cool?
Yeah, very cool.
So let's go ahead and completely this thing up.
That's what we do.
All right, Jason. So let's start putting this thing together. Now, we're going to have a layout, a linear layout just like this. Actually, do I want to do a linear? Yes, I do. Now let's ID this layout, Jason. What do you think?
Okay.
You know JavaScript, so you know how when you build like a div tag and you make an ID field and you set ID equal to something, and then you could use JavaScript to reference that object by that ID?
That's what you're doing there.
This is the exact same thing right here. Exact. So you can really, once you really start to get the pieces together, Android development is pretty slick. Now we also want to set a background color, Jason, because we don't want our background to have this black nastiness, right? We want a nice Wibbit color.
Well, of course.
So if you could
a nice shade of green.
A nice poo color. If
poo green, yes.
If you could think off the top of your head a hex value that would be a nice Wibbit color, what would it be?
It would be.
I mean, right off the top of your head.
99D. Hold on, I got it. I got one. 99D83F.
What is that?
That is a green.
How about E7E9D1?
Well, if you're going to ask for my suggestion and not listen to it, I'll just be quiet.
That's the same color we use in the iPhone app.
Well, 99D83F is the same color we use on the website.
Yeah. Well, you know what? You can blame Brian for that because Brian selected this color for the iPhone app.
Brian gave me that color too for the website.
We're gonna slap him silly next time we see him.
The next podcast, we're gonna have a confrontation.
So now check it out, Jason. Look, we have a nice background color here. Is that cool or what?
That is sweet.
Nice.
So it's not as awesome as 99D83F, though.
That's true. That's true. So now, Jason, we're going to also be adding a bunch of images to our program. Now, the cool thing about images in Android development as opposed to iOS development is, with the Android development, images can accept touch-up events. So you can touch an image and it can react to your touch. So we can use images like buttons. So what we need to do is we have to define a bunch of images. First, we'll do the grid so we can have something to see. Now, the grid is going to be an image view image view, and inside the image view, we want to be able to reference this within our code. So we're going to set an ID equal to the @+ID/, and we'll just call it IMG for image and then grid. And then let's just go ahead and set some dimensions. What do you think?
Sounds good. So
we'll do a layout width of 320 pixels and then a layout height of 320 pixels to make it kind of like a perfect square. So layout width, layout height. So we're defining the dimensions of the image and how it's going to be stretched. And now let's go ahead and let's select where we want to position the upper left corner. So the upper left corner will be an Android layouts, and this will be the X coordinate, and that's going to equal, we'll start it at pixel 2, and then the next one will be the layout Y, which will start at pixel 41. Now Jason,
why'd you choose 2 and 41?
Just because I know everything.
Fair enough.
We'll take a look. We'll see if that looks okay. We'll see if that looks okay in a second. But next, what we have to do, Jason, is now that we've selected how we're going to reference the image in our code, how big we want it, where we want it to be placed. Now we have to reference the image. Now, how do we do that?
I imagine it's Android background. Would it be background?
No, we're gonna. It's just like your in HTML, right?
Yeah.
So we want to select the source. Now the source, we're not going to be referencing an image. We're going to be referencing basically a number, and that number is part of our resources. Now inside of our resources, you remember how we have these images that I forgot to add to our project?
I do remember how we have those images that aren't there.
These images here on the desktop that I had pre-prepared. Let's go ahead and let's throw those in the project because we're going to need those. So let's see here. NetBeans, Webbit, TicTacToe, resources. We'll paste those here. Cool. Now that should be. Now I should be able to access those here. Aha! So what I want to do, Jason, is I want this grid image. So to access the grid image, we're going to reference the drawable resource, which is inside of resources drawable, and then the resource that we want to, or the index number that we want, is the index grid, which is basically nothing more but than the file name without the extension. So when we are defining these resources, it's really important that the file names are only lowercase a through z and numbers 0 through 9. No other characters can be used, because as you can see, if you have an @ symbol or whatever in your file name, you're gonna f this thing up. This is the fun part of it. The waiting.
Waiting for the emulator.
Oh.
Well, look at that.
Look at that.
Nice. Your emulator has perfect 3G connection. I don't know how that has happened.
Yeah, and my battery is constantly charging.
Yeah.
Also, Jason, I lied. I don't want this to be a linear layout.
You bastard.
Yeah. I want this to be an absolute layout. That way I can just set the absolute positioning of all my widgets. So if we run this in the emulator, you'll see that now we have our grid right where we want it.
Perfectly centered.
Sort of.
Sort of, yeah. It's kind of off on the bottom, but that's fine.
So as you can imagine, now we want to start laying out the X's and O's, right? Now, the beauty of this is what we can do is all we have to do is lay out an image that represents the position where we want them to be, and then on click, we could make it whatever we want. So we're going to first just use the X so we can see them, and then we'll swap that out with blank so that they're invisible. How does that sound?
That sounds peachy keen.
All right, so now, Jason, what am I going to do?
Well, I imagine you'll make a new image view.
You catch on real fast.
I am a quick learner, yes.
Okay, so what do you want to ID this as? Since we have to have 9 of these, right?
Right.
Let's kind of give them a sequential number.
Let's do with image img tile 1.
That sounds great. So we'll have an at plus ID/img for image, and then we'll just call it tile 1. So where do you want to position this thing?
Well, first on we have to set the height and the width the width, right?
Absolutely. We have to set the layout height and width, which will be defining the size of the actual image. So what do you think it should be?
I'm going to take a guess at and say 68 by 68.
That's a hell of a guess, man.
Thank you. I'm just doing the math. I'm just subtracting pixels, and it's just coming to me.
Now let's also guess in a good starting location. So where do you want to set the X and Y position?
Well, let's set the X to 31.
All right, that sounds good.
And the Y to 67.
67. Oh man, I'll tell you, dude, you're catching on.
Yeah.
Now, just so we can see this, Jason, let's reference the X image so you can see that inside of Drawable, we're going to access the X image, so it'll be this here. So now when we run this, we should see in this upper left square, we should see our little X. See, Jason, the kind of a pain in the ass thing about this compared to iOS development is there's a very robust GUI editor, which there is not for Android. The ones that exist for Android are real sloppy and really slow, and they're all written in Java.
Yeah. Well, I mean, it wouldn't be a true Java project if it didn't go slow.
Yeah, exactly. That's a good call.
Thank you.
All right,
you gotta stick to your roots, right? I mean, it's got to have a non-GUI editor because it's Linux, and it's got to go slow because it's Java.
So check it out, Jason. Now we have an X.
Woohoo!
So the beauty of this is we're gonna be setting up 9 of these suckers, and let's just go ahead and let's just
copy paste.
Yep, copy this guy. And talk to me, Jason. Where are we gonna set the second tile in? What are the properties gonna be?
Well, I would say the height is 63 and the width is 63.
Okay.
And then X is 130 pixels and then the Y is 72.
Okay. As you can see, this one's gonna be slightly smaller.
It's gotta compensate for the grid size.
Right, because you can see that this square is smaller than that square there. So let's, we don't need to keep testing this because we can imagine what's going to happen. So let's just go and just keep moving until we get all 9, and then we'll see what we got. So Jason, talk to me about number 3.
3 is 68 by 68.
Okay.
Like the first one was, because now we're at the edge of the grid again. So I guess that's gonna stay the same throughout the whole thing. The edges are 68, the middle is 63.
Roughly, yeah.
This time the X, however, is 220, and the Y is 72 still.
Excellent. Let's keep rolling. So that's tile number 3. Let's do tile number 4, which is now going to be the first one in the middle row.
All right, so we got 68 by 68 again.
Okay.
And then we have 164 is the Y. I'm gonna mix it up on you. And then the X is 31.
Okay, excellent. So now we're going to hit the middle square, and that's going to be number 5.
All right, and so we're back in the middle again. So 63 is going to be the height and width.
Okay.
The X is going to be 127, and the Y is going to be 162.
162. Beautiful. All right, tile number 6, which is going to be the middle row far right.
We're back to 68.
Okay.
Then we have an X value of 220.
Okay.
And the Y is 158.
Beautiful. All right, tile number 7. Now we're starting to work on that last row.
Well, we're starting it back out at 68 again.
Wow, we're awesome.
Yeah, we're back. We're down at the bottom. So, and then the X is 31.
Okay.
And the Y is 260.
All right, now we'll do
You can really see how the pixels are moving down and over and everything. And, like 72 or some of these values are kind of repeating because it's the same on one axis, but then the other axis is changing. So you can actually start to reduce the size of the screen and everything from all that.
Right.
So tile 8 is...
and this one throws off a little bit.
Yeah, it's gonna be a little different. Tile 8's gonna be 70 by 70.
Yeah, now if you look at this, it's just because of the size of these... Brian didn't make it perfect, but it wasn't supposed to be perfect because it's supposed to look like somebody drew it, so...
Yeah.
All right, so give me the positioning, Jason.
125 on the X, and then 250 on the Y.
All right, now we're going to be doing the far bottom right, tile number 9.
And it's just a little bit bigger. It's 71 by 71 this time.
Okay.
And our X is 220, and our Y is 250.
Okay, so now let's get a look at our app and see what it looks like.
It's going to be a lot of X's. When it renders.
All right, so now look at all those X's.
I think X won that game.
So, Jason, let's go ahead and let's change this. So let's do a search and replace. And we do a search and replace in here? How do you do a search and replace in here?
I don't know. I'm an Eclipse guy. You just do Control F and then...
Okay, it's Control H. So find what, and replace it with blank. So now if we just do a replace all here, you'll see that now we're just pointing at blank, which is an image, which is just a PNG that it's just transparent. So now if we were to load the program again, we would not see anything, but we don't really care to see nothing. So we'll just continue moving on. So what we have, Jason, is we've defined the layouts view where these are going to be sitting. We've defined the grid that these are going to be on and the actual tiles themselves. So now we have a couple of things that we can add, like let's add like a Wibbit.net logo. How does that sound?
That sounds great.
All right, so
product placement. Let's do it.
Why not? So let's talk about where you would want to add that. Just off the top of your head, just like pretend like your brain is the template and you just happen to know where everything goes.
Well, I think if I were to, I don't know, just pick a spot, I would say that if we had to put it anyway, that the height would be 30 and the width would be 160.
Okay, that sounds good. Now, where's a good place to place it? So we want to probably put this towards the bottom right of the screen.
It's as good a place as any, I think.
Yeah.
X-axis, I would say, is 150, and Y is 442.
Okay, awesome.
Just to take a guess.
And we want to access this Wibbit.net logo image. So it'll be Wibbit, DOTNETLOGO. Since we can't do camel case and we can't have periods, DOT is spelled out and there's all lowercase letters. Now what we have, actually, you know what, let's just fire this thing up. Because the Wibbit.net logo is going to show up here. So if you guys remember from the iOS app, what we did is we had our characters, we had a frog here and a fly here. So what we want to do is we want to place the frog and the frog and the fly awake and the frog and the fly asleep, and then as the different players' turns come up, and as they're done their turns, the images will switch. So when it's the frog's turn, the frog awake will be up, and the fly asleep will be up. And then when it switches, the frog will be asleep and the fly will be awake. So we're going to place those images right now. So here's a little Wibbit.net logo. So we want the fly to be approximately here, and we want the frog to be approximately here. So Jason, talk to me about how we can pull this off.
Well, we're going to need to obviously have both images for each animal represented.
Okay.
We're going to have the awake and the asleep, and then I guess we're gonna work with the controller and the model through the view to differentiate between which image we want to display.
Absolutely.
So first thing we're going to do, I think, let's put the awake frog.
Yeah, that makes sense, because he's kind of our mascot, so we'll give him precedence here.
He is a very short-tempered host, too. So
let's talk about how big do you want the frog to be approximately?
The width is 130, and the height is 90.
Okay, so we got 90, and let's find a good position for the frog. Remember, we want the frog to be in that little bottom left area.
So the X is going to be 10.
All right, so we're going in 10, and then down how many?
345.
That sounds like a decent position. All right, so next, we have the frog awake is now placed on the view. Now let's put the frog asleep.
Well, there's one key piece missing from that previous code, and that's the actual image.
Thank you, Jason.
You're welcome. That's what I'm here for.
All right, so now where do you want to put the sleepy frog? And remember, the sleepy frog is going to be right in the same general location as the awake frog, but he's going to be just a little bit smaller because when it's the frog's turn, we want him to grow a little bit bigger.
That's
so
right.
Remember, we want to make a little smaller. So what are the dimensions that you want this one to be?
Well, the width is 110,
okay,
and the height is 70.
All right, so it's a tad smaller.
Yep.
And since it's smaller, we have to change the absolute positioning so that it matches up. So where can we put him?
30x by 365y.
And that's the frog asleep. So now that we have the frog awake and the frog asleep placed on the view, let's go ahead and let's do the exact same thing for Buzz the Fly.
Sounds good.
All right, so image fly, awake. All right, Jason, what do we do?
Well, the fly is awake, so that means he's bigger. So his width is 130.
Okay.
And his height is 90.
Did you say his nuts?
I said something, I'm not sure.
Where do you want to place him? Now, remember, the fly is going to be to the bottom right, just above that Wibbit.net logo.
Right, so he's going to be over a little bit. So he's at 190 on the x-axis.
Okay.
And 345 on the y-axis.
Okay, and this one's going to be fly awake. Fly, fly awake. Nice. And now we want to put that little son of a asleep. Asleep, fly asleep. And Jason, what do I do with him?
Well, the width is going to be 110.
Okay,
and
same
the
thing.
height is going to be 70.
Okay, fair enough.
That worked out well.
Where do we put them?
The x-axis is at 30.
Okay.
And oh wait, I'm sorry. I know why it matched the same thing, because I was reading the wrong one. So fly asleep. Actually, let's go back up. The width is 90.
Oh, so it's not the same.
Yeah, it's not the same. That's my bad. And the height is 50.
All right, so where do we want to put them?
The x is 210.
Okay, so he's far over to the right. Okay.
And the y is 375.
Awesome. Okay. Let's see what this looks like. So we'll hit play, and while this is booting up, let's kind of talk about what else we need. So, Jason, we have our X's and our O placement on the grid.
Right.
We have our Whippet.net logo that will eventually launch a web browser, so stay tuned for that. We're going to place a button over here, which those of you guys that have used the iOS app, there's a button down there that allows us to start a new game. We also want to add a label here and here that will represent the score. So we'll have the Whippet the Frog score here and the Buzz the Fly score on the upper right-hand side.
Absolutely.
Hey, look at that!
Well, that's a bit of a jumbled mess, isn't it?
Yeah. Well, it's cool though because we're going to be showing and hiding these during runtime, so it's totally fine. It looks like a mess now, but trust me, it's going to look nice. It's going to look it's going to behave the same way that the iOS app does. As a matter of fact, when Brian and I built the iOS app, we used this exact same tactic. So Jason, we had talked just a second ago about creating a button that will allow us to create a new game. So let's go ahead and talk about how we can place a button on this form, where we're going to place it, and all that kind of stuff.
Well, I think a button is a little bit different than an image.
I think so.
A little bit. So we're going to have to, first of all, identify it as a button and not an image. Instead of image view, it's button.
Oh, sucker.
Those tricky Google people with their crazy naming conventions.
Okay, but we are going to have similar types of properties, right?
Yeah, very similar. You're still going to have, your width and height and everything else. And
all right, what do you want to ID this one as?
Let's just call it new game, or
like a button new game.
Button new game, yeah, button new game.
That way we can have the type that it is followed by what it is. Okay, and the size, the layout width.
Let's put it at 100 pixels.
100 pixels. Height.
40.
40. X-axis?
23.
Alrighty. And the
Y is 442.
442. Now we're in this one, Jason, we're going to have a field that we haven't used yet.
That's right. And it's just like in HTML or something. When you want to, change the text of your button, you can just, put in there text and write out what you want it to say. So we want it to say new button. Or new game.
Right. So this is going to be on the bottom left-hand portion of the screen here, and as soon as we get the rest of the widgets placed, we'll take a look. So we also, like we just said, Jason, we want to then we're going to have 4 labels, one that's going to label who the player is, and one that's going to store the player's current score. So when we start talking about using a text label in Android, what object are we going to use?
I would say probably a text view object.
Yeah, that sounds about right.
Yeah.
Now Jason may have cheated a little bit because the text view object comes in the basic Hello World template. Sorry.
Why are you going to call me out, man?
All right, so inside of our text view, let's go ahead and let's set up the basics here. So let's go ahead and let's give it, since we don't really, Jason, this one is just going to be a label. We don't have to access it. We are never going to access it. So why waste the resources? Why create an outlet in our code if we're not going to use it? So let's not even ID this one.
Sounds good to me.
But we want to give it a label text. What is it going to say?
Let's just call it Whippet the Frog.
Okay, so he's our player.
He is our player.
So here's Whippet the Frog as our player, and let's go ahead and let's position and size this thing.
Sounds good to me. How about the width? Well, let's set that sucker to 160.
All right, so 160.
The height would be 30.
30, all right. Now give me an XY.
The x-axis will be 10.
Okay.
And the y will be 10.
Okay.
How about that?
Now, we're also going to be doing something a little different here, Jason. What other tag are we going to add to this?
Well, we're going to style it a little bit.
Just a little bit, right.
Yeah, just a little bit. We got to give it a text a color. So let's do an Android text color.
Okay.
And just make that just straight zeros.
Right, that'll make it black. That'll make the text black. So now that we have the label text, so you can imagine, right here it's going to say Whippet the Frog. Now, right next to it, we want to put Whippet the Frog's score. How do we do that?
Well, we're going to do another text view on that. We're going to do it a little bit differently, because this is something that's going to be interacted with, so we do want to give it an ID.
Okay. What do you want to ID it as?
Probably just label frog score.
Label. Okay, that sounds good. All right, now what?
We got to set the width and the height.
Okay.
So the width is going to be 160 pixels and the height is going to be 30.
All right, that's a big one, but that'll work. X and Y.
And then the X is 110 and the Y is 10.
Okay. Our text label's going to say?
Our text label's going to say 0.
Nice. Is there anything else we have to add, or is this good?
Let's keep with that text color 0. We already have it there, so I think we're good.
So we can actually go ahead and copy these previous two because we're just going to make an exact duplicate for the fly score. So here where we had, so this is the label fly or frog. Let's go to the one above it. So Jason, where do we want to place the fly score? I'm sorry, the buzz the fly text label.
The y-axis is going to stay the same, but the x is going to change. We're going to change that to 205.
Okay, so we're shifting it off to the right, but we're keeping it on the same level, same horizontal.
The width and the height should stay the same. It's just the x.
That's what I meant to say.
Yeah.
So what was that again?
The x for the fly is 205.
205. And then this just says buzz the fly, right?
Yep.
Buzz the fly. Is that it?
That's pretty. Yeah, that's it.
Nice. Now let's do the which I think is the last widget we're gonna place on our view. So let's look at the label fly score. What do we do here?
Label fly. Our height and our width is the same, 160 by 30. Our layout Y value is still 10 pixels, but we're gonna move it over a little bit. It's gonna be a 288 for the x-axis.
Okay. Cool. Let's fire this thing up.
Grab a coffee.
Yeah.
Take a walk. Read a good book.
You can read several.
I just read 3 Harry Potter novels. Just now.
Oh, look at this. All right, we screwed up here, Jason. It looks like the Wibbit the Frog score is way too far over, and you may have said the number right, and I probably typed it wrong, but we'll fix that in a second. But you can see down here, look, we have a little new game button. Kind of cool, huh?
Yeah, very cool.
So let's fix this
Android looking.
Yeah, it is very Android looking. So let's take this O. So we know that this one is the frog score. Where did we screw up here? Where does the layout X go?
The layout X is 110 pixels.
Okay.
I mean, it was kind of close. We just multiplied by 2.
So the next move after this is, since we have our model code written, which we didn't go over in the tutorial, but if you follow the Objective-C course, or if you haven't, go back and view it, and you'll see how the logic works. We've applied the view, and right now our model and our view are completely separate. There's nothing connecting the two, so the next logical step is to work on the controller, but there's still one piece that I want to add to this application before we get that far. Look at that. Not bad.
Perfect.
Those of you guys that followed this course before in the Objective-C, you know that we had a little a splash screen. That splash screen just said, you can learn to make this app for free at wibbit.net. So let's do the exact same thing right now. So the way that we pull this off is we need to create another view. And we're going to create another absolute layout view just like we did here for the main.xml. But instead of making it the main view, we're going to make a splash screen view, Jason.
Makes sense to me.
So inside of our resources, inside of our layout, let's do a right click and let's do a new, can we do a new other? I want to do I just want to make an XML file. XML documents. Next. And then we want the file name to be
splash screen.
Splash screen. Splashscreen.xml.
So for every view you want to do in an Android app, you can just make a new XML file.
Exactly. So now we have all this crap, which I'm going to delete everything except for the first line. So Jason, talk to me about this splash screen view. What do we want to put in it?
Well, just like our other view, we have to define the layout.
Okay.
So we want to do the same one we had before with absolute layout.
Absolute layout.
Yep. And we want to identify the background color.
All right, so with the absolute layout, we're going to have an open and close tag, and inside of the open tag, you said, what are we doing?
Well, we gotta give it a background color, just like we did with the other view.
Android a background.
Yep, and that's going to be E7, E9, D1.
Okay, so the same color.
Yeah, the same color. Even though I still think
we may be able to steal some of it. I know.
Yeah.
You could blame your partner Brian for that.
Well, when I build this app myself, I'm using 99D83F.
Don't be surprised if the version that ends up in the marketplace has a different background color.
I'm gonna go all off the grid. It's gonna be a red.
So let's talk. So here we have our little schema here for the parsing for parsers, and we don't want to call this one main layout. We'll just call this like a layout splash screen or something.
Yeah, layout splash screen works.
And we still want to keep the orientation. We don't necessarily want to define, but we can just keep that as vertical. That's fine. That just means that your phone is portrait and not landscape.
Right. Because otherwise, fill parent will make it a stretched image and make it look all.
Yeah, so we'll fill the parent. That just basically means that take the image and just like size it to the screen. And look at this. What is this? Splashscreen.xml.xml. Do you see that?
I do see that. That's NetBeans. NetBeans.
That is NetBeans. Here,
yeah. I guess you just needed to call it splash screen.
Yeah, but it still shouldn't do that.
NetBeans should be smart enough to not do that. Well,
yeah.
I actually blame Windows for that.
Yeah.
Windows probably did that.
Probably. All right. So now, Jason, now that we've defined the layout, let's talk about the actual image. What do we do?
Similar to the layout where we have the background taking the whole thing, our image is going to take the whole thing because that's the only thing that this view is just
cool.
That one image. So instead of defining the height and width, we just tell it to fill parent. We can we identify it, so give it an ID. We don't need the X and Y.
So you said that we'll just fill the parent instead, right?
Yeah. Just fill the whole page. Because we're not dealing with anything else on this page. We're just dealing with one picture.
All right, so then we'll call this one splash screen. Now, even though we've defined this view, if I run this program has absolutely no idea that this view exists.
There's no idea at all.
No clue. So what we have to do is we have to modify project manifest file to basically order the precedence of the views. So we want to say the splash screen is the primary view, and then once we get into writing code, we're going to have the splash screen do some fun little things, spawn a thread, wait 5 seconds, kill itself, and fire up the other view.
Sounds good to me.
So now what we have to do, Jason, is we want to make it so that our splash screen comes up first. And then our splash screen is through Java code, once we start getting into code, it's going to reference this. So let's go into our important files. And in here, those of you guys that are familiar with Java know that Java loves these manifest files.
Absolutely.
So just like when we built the Jarchives and the Jarchive lesson that we did, like when we made the Java archives required a manifest file, and the manifest file says basic stuff, like what's the version of this product, where is the main method within this product, that kind of stuff. And you can see that this is kind of similar. What is the version of this product? What is the main action of your program? So Jason, by just taking a look at this, we look at this activity tag. What is the main action of this program?
The main action of the program is Wibbit net TicTacToe.
Exactly. So when you look here at the source packages, this Wibbit net TicTacToe is the controller class. So here's the controller class, and look at this, Jason. This sets the content view to main, which is this main right here. So this is setting the main view, which is this. But we don't want to change this. We want this to stay the same.
Yeah, that's what we're doing with this app, right?
Exactly. So now let's add another activity to our program. Now remember, in Android, there's intents and activities. An activity, I mean, you could look at it as just something is happening. So an activity is loading this view as an activity. Then we have the intent. So the intent is what are you going to do with this activity. So by this, we're saying the intent of this activity is to be the main activity. So now let's change the main activity, Jason. What are we going to change this to?
Let's call it a splash activity.
Okay.
I think that sounds
okay.
That's applicable.
We have to define this class, but we'll do this first, and then we'll define the class second. So we're going to make another class called Splash Activity. So now that we've done that, Jason, we have removed our main view from the program. This doesn't exist in our program anymore. How do we add it back?
Well, we have to add a new activity.
Okay, let's do that. Talk to me. What do I do?
Well, first thing you want to do is you want to name it. So you you give your activity tag.
All right, so could I just probably steal this?
You probably could if you want to do it the quick and efficient way, but if you wanted to do it the way I do things, just type it out again. That's more fun. I do type at 90 words a minute, though. So.
Oh, not bad. So our sub-activity that is not intended to be main is going to be what?
That is going to be Wibbit TicTacToe.
Okay, so what we have done is now we're saying that this class that doesn't exist yet is going to be the main activity. So I guess the next logical move is what, Jason?
The next logical step would be to create that splash activity.
That's awesome. So let's have some splashtivity happening. So on the source packages in our net.wibbit package, let's do an activity class. The activity class is going to be called, I don't know, let me think about this.
Maybe splash activity?
Oh, okay. So splash activity. So we are now working in this splash activity. So inside of our splash activity class, which is obviously extending or inheriting from the activity, we're overriding the onCreate method. So in the onCreate method, I mean, just like we did here, although we actually never wrote this code, it was given to us from NetBeans, but like here, when we loaded this view here, we called the super keyword, which is execute the onCreate method and pass it the bundle, the saved instance state. And there is a method that belongs to the activity class called setContentView, which takes a number, and these resources are actually just integers. So I'm saying go to my resource file, which you can look at it like here, go to the layout folder, which is right here, and go get me main here, and that's actually what presents this graphical interface. So what we want to do now in the splash activity is we want to do the exact same thing, except for we want to reference the other guy. So we want to reference the splash screen. How cool is that?
Very cool.
So now if we fire this up, Jason, what we can expect to see is now when the program loads, we will see the splash screen and not the tic-tac-toe grid.
That's right. It'll just sit on the splash screen.
Yep, forever. So it's a permanent...
Let's put some ads on there or something. That's the app. We're done. Thank you for playing. Click on our ads.
Not only are we going to have ads, but we're still going to charge $80 for the app. And
so we're taking the Hulu model now.
Yeah, right. The Hulu model. Oh, God, what a... Ugh.
It wouldn't be so bad if they didn't put ads right in the middle of the shows.
Yeah. Holy crap, look at this. We have a splash screen, but now that's the only thing we have. So the cool thing, Jason, that we've shown here is that we were able to modify the manifest file to pull up a different view. So we have a different user interface view, which is the splash screen view. How cool is that?
Very cool. We've changed the defaults.
Yes. So now what we want to do, Jason, is we want to spawn a thread. Okay, the reason why we have to run this as a thread is because if we just have a sleep statement within this onCreate, the entire program is going to freeze until that statement is done. We want to spawn a separate thread that's going to wait for approximately 5 seconds. After that 5 seconds is through, we want to close this layout or this view, and then we want to create a new intention. And our intention is to modify the main intent to be the main XML file. Does that make sense?
That makes perfect sense.
Right, because we looked here that we have this as the main intent, but we want to change this to be the main intent after 5 seconds of this existing. So let's talk about, Jason, how do we pull something so crazy like this off?
Well, first thing we have to do is we have to identify that we have to start the thread off.
Right, so we'll create a thread instance, okay? And we'll just call it, what, splash thread?
Sounds good to me.
Okay, and we'll make this a new instance of thread, and what we'll do is we're going to override a method during instantiation. So instead of creating a thread class instead of creating a class that inherits from thread that overrides, or as opposed to creating a runnable instance during the instantiation, we're just going to go ahead and in the thread class itself, we're going to override the run method. So this isn't actually syntax, this is just annotation, so that does not actually have to be there, but some folks like it there. So the class that we're going to override is public void run, which is going to be the method that executes when the thread runs. So Jason, what are we going to add inside of the run portion of this thread?
Well, I think the first thing that we want to do is we want to count how long it's going to be up there.
Okay, so we're going to call the sleep static method. And how long do you want to wait for?
Let's say 5 seconds, so 5,000.
All right, that'd be 5,000 milliseconds. And thank you, Java, for making us try catch this crap all the time. Try catch exception, and we'll just leave it as a blank exception because if that crashes, then help us all.
I really wanted to play tic-tac-toe.
Okay, so now that we have the thread has spawned, the view has existed for 5 seconds. Now what'll happen?
Well, we're done, so let's finish it.
Okay, so finish is going to go ahead and it's gonna finish this layout. It's going to finish this view. So once we've terminated the view, we have to change our main intention. Jason, how do we do that?
Well, we have to first identify the intention as main intent.
Okay, so let's make an intent instance, and then we'll just call this, like you said, main intent. And what is that going to equal?
That's going to be a new intent.
A new instance of intents.
Right.
Okay.
We're going to set class.
All right, so after we create the new instance, we're going to run the method on the instance called setClass, and setClass is going to take a couple parameters. What are they going to be?
So we have two parameters. The first parameter, we want to be the current instance of the Splash activity class.
Okay, so we want to reference this class right here.
That's right.
How do we access that?
Well, we're going to call the class itself, so Splash activity, and then identify it as this class, so
right.
.this,
so that's open recursion. We're referring to this instance, right? Excellent.
Right.
Now, what's the next parameter?
The next parameter is the data type of the class that we want to run as the main activity.
Awesome.
So that would be WibbitNet TicTacToe.
All right.
.class.
So let's just bring this down. So WibbitNet TicTacToe dot, and then we're going to access the class property. So we're passing the data type itself as a class. Now, just so this doesn't look scary to everybody, all that we're saying is this is what we're moving into, right, Jason?
That's right, out with the old, into the new.
Right, replace this activity with an instance of this activity. So we're dealing with another issue here, which is we're missing a symbol, so right-click and fix imports, and now we have access to the Android.content package and the intent class. So now that we have defined our main intent, how do we start the activity?
Well, you start activity.
Oh. Damn it. That's
where do they come up with these crazy names?
So the activity we're going to start is this.
Right.
Now, so what we've done here, guys, is all that we've done is we've defined the thread that's going to be facilitating the movement from one view to the other view. The only thing left to do is actually execute the thread, so we can take the instance .start. I think we got ourselves a thread here.
Looks like it.
So let's go ahead and let's fire this off, and what we can expect to see if this works as we have it, as we hope, is we're going to see this for 5 seconds, and we're going to see our other view take its place.
Yeah, that's... I'm running out of jokes to throw out there while the thing's running anyway, so I'm glad we've kind of squashed that.
Yeah, and they stopped being funny after a while. All right, here we go. Look.
I don't think they were ever funny.
Check it out. Look. 5 seconds. And there we go.
Whoa!
How about that?
That is awesome.
How about that? So now we've defined the splash screen, Jason. Let's start thinking about what we have to do next. Now, we have to start allowing the user to interact with the application. And there's really, looking at this user interface, there's 3 ways that a user can interact with this. The first one is by clicking on one of the tiles. The second one is by clicking on the new game button. And the third one is we're going to have the Wibbit.net logo launch a website. So let's go from kind of the most complicated to the least complicated. So let's start taking a look at how we're going to manage the actions from the buttons. Now, when we built the example Android class before, where we had the text view, a button extracting text from a text view, you saw that inside of the button instance, what we did is we created an on-listener or on-click listener object that handled the on-click event. What we're going to do here is we're going to kind of simplify this a little bit because we're going to put a lot of the work inside of the button. So we don't want to create the on-click listener on instantiation. We want to create our own class that implements the on-click listener abstract class. So that's what we're going to do next. So inside of the .NET, we'll make a new, and this one is just going to be a Java class, because we don't need to have any of the activity stuff. And what do you want to call this, Jason?
Well, we're clicking on the tiles and listening for that, so let's call it tile on-click listener.
Okay, so tile on-click listener. Now, right off the start, what we want to do is since the button, the images have an on-click listener type that it will take in, and that's an abstract class with the expectation that you override the on-click method. So what we're going to do with our class is we're going to implement the abstract class by calling implement, and we're going to implement on-click listener.
Implements.
Okay, implements. And we have to right-click and fix imports. And remember, with this one, we want the view.view on-click listener. So this is kind of yelling at us because it's saying that there's a method, since we're inheriting from or implementing an abstract class, there is a requirement, and the requirement is that we override this method, which we're going to get to. We just haven't quite gotten there yet. What this class is going to facilitate is it's going to be accepting items from the main view, and what it's going to accept is a pointer to the main view itself. It's going to have a pointer to the image. So if the button that we're working on is this button, when I click on it, it gets a copy of the memory address of where this whole program is stored. It also gets a copy of the memory address of where the image itself is stored. And we're also going to create a couple other things, like we're going to store some of the resource IDs in there so that it can change the images on its own without having to ask the parent view to do that for it. So, and then what we're also going to do is we're going to launch back into the calling code at some point. So this is going to be pretty exciting. This is kind of as close to delegates in Java as you'll get.
All right.
So, Jason, what's the first thing that we want to do, I guess? We would probably want to then start defining our fields, right?
Yeah.
All right, so what are some fields that you want to store?
Okay, well, first we want to store the parent activity.
Okay.
So, to do that, we want to list it as private.
Right. That way, nothing else can access this except for us.
Right.
Mm-hmm.
And then we want to call the WebNet TicTacToe class and the parent activity of that.
All right. So our variable will be called parent activity, and just a little naming convention is what we do is with the global fields we just put underscores. That way we know that is what it is. So the next one that we want to store, Jason.
Okay, well, the next thing we want to do is we want to be able to have the user, touch on a part of the screen, touch on an image, and interact with that image.
Right.
Interact with that spot. So we're going to set a private image view.
Okay. Private image view.
And then we're going to call that image view and set that to null. And what that's going to do is when you click, it stores that image to memory, or it stores the position of that image to memory. So when you touch on a tile or an image, this is going to store the memory address of that image you clicked on so that we can change its properties, or that we're at least able to change its properties.
Absolutely. Absolutely. So that way, when we click on this image, we have a pointer to that image. So I can say what you just clicked on, make it an X or make it an O. Or if the cell is already valued, tell the user the cell's valued, or make it a picture of, I don't know,
David Hasselhoff.
So now that we have the parent view who called it, the image that you just clicked on, we're going to store an alert dialog. Now this is just for our class's purpose, so that when we have to alert the user, we just have one alert dialog instance to store. And we use this exact same alert dialog in the other lab that we did. So let's just make a private alert dialog, and we'll just kind of call this alert dialog, and we'll set this equal to null.
All right, so the next thing we want to do is we want to store the ID of the X image and the O image.
Okay.
So to do that, we want to declare a private integer.
Right.
Private int.
Now these will turn out as integers. So as Jason was just saying, inside of our resources, inside of our drawable path, we have images, right? And each one of these images is a number. So, and I know that sounds kind of weird, but that's how Android's going to store it. So, and if we want grid, this is actually number 7 or number 36. It's like the 36th resource or whatever. That's how Java's going to store it. So we're going to have the calling code tell us what that number is, so we can store it inside of our class. So, like Jason just said, we'll make some private integers. And what do you want to call it? Like
XRes, and then I guess ORes.
Okay.
Yeah, ORes ID.
All right, and we'll set them equal to -1 because those are values that they're never going to be. And when we construct this instance, those will be set. So don't worry too much about that. So what do we have to? What are we going to store next?
Well, next we'll have to store the row and the column that will be valid to those X and O images.
Right. So if we click on the upper left image, the row and column will be 0, 0. If we click on the middle image, the row and column will be 1, 1. So how are we going to store these?
Well, we store those by private integers as well, because you're still identifying what row and what column, right? We can just call those row and column, and we'll set those to -1, 2, because that's also a value that they'll never be.
Okay. What are we going to store next then?
Well, next we have to actually, say what is the value of whatever it is, right?
Okay,
Currently.
sure. That sounds good.
Yeah, so we got a private character, and we'll set that to be the current value. And since we don't have a value yet, it's just going to be blank.
Right, and that's the default value. The default value is blank. So when we load the program, these are all blank. And then as we select them, they'll be either X's or O's. Now, do we have to store this information? Not necessarily, but we're just constructing this image, this class to store all this information. So now we're just going to create some getters so that our external code can access these fields. Now we're just going to create some getters so that our external code can access these fields. So we'll just do something like a public activity. And, we may never use these, but, I'm kind of weird about this kind of stuff. Parent activity, paranormal activity, whatever. So we're just going to return the activity, and I have to fix the import. Now, I'm just calling this generically an activity, because this inherits from activity, so they're synonymous. So then we'll also do a public int get row, and this will just return _row, public int get column, return column. All right. Oops. Call. Let's make it column. Public image view, get image view. So all that we're doing here, guys, is we're just creating getters so that the private fields can be accessible to external code indirectly. Public int get x resource ID, return this. This is not the glamorous part of development. This is the boring part. And then we're going to allow access to the alerts. So alerts dialog. So now that we've defined the fields and we've defined some getters to these fields, which is a non-necessary step, but for practice we'll do it. Let's go ahead, Jason, and let's define the constructor. The constructor of our tile on-click listener is going to accept accept a lot of this data right here from instantiation. So we'll just make a public method of type tile on-click listener. So this just is the same name as our class, and this is going to accept some parameters. So Jason, what are the parameters that we're going to be passing the constructor?
Well, it's all the parameters that we're going to be interacting with, I guess. So we have image view.
Okay. So we have Wibbit, TicTacToe, parents activity.
Right.
All right. What's the next one?
We have image view.
Image view, and we'll just call it like IV for image view.
Yep. And then we'll have an integer of the X image, so X res ID.
Okay. The resource ID for the X image.
Right. And then another int for the O image, so that's O res ID.
Okay.
And then we have to also interact with the row and the column. So we'll have an int for row and int for column.
Okay. Is that all?
That's it.
Okay. So now in the constructor, we'll just go ahead and we'll store those values and we'll value some of it. Why is it so angry at me? I'm missing a comma here. That'll do it. All right. Let's see if we can blitz through this. So parent activity equals parent activity, image view equals IV, X res ID
equals X res ID
equals that, and then the same thing with O res ID equals O res ID, row equals row, column equals column.
Well, now we're going to have something new though.
What's that?
Well, that's going to be the alert dialog, isn't it?
That's right. We're going to instantiate the alert dialog that we were storing. Now, the alert dialog is going to be inside of the button. So the button will be able to react and display on the user interface when it sees fit. Like if you click on a button to select it and it's already valued, it's going to say, hey, don't you be clicking on me. So let's go.
Stop wasting my time. We got some tic-tac-toe to do.
So let's create that alert dialog instance that's going to be facilitating that functionality, Jason. What do I do?
So first we got to, say alert dialog.
The hell did I just do? Okay. Whew. Dialog.
Right, and now it's going to be a new instance of an alert dialog.
Okay.
.builder.
Okay.
And then that's going to be the parent activity.
Right.
So this parent activity is the activity that the alert dialog will appear on. So that way when we click a button, it will show on the main program.
There you go. Right. Good point. So like if you click on this button and it's already valued, that pop-up window will show here. where I can actually see it. Now what we're also going to do here, Jason, is we're going to define the standard on-click event. So any dialog that is evoked inside of this class is a warning or an error, and we don't want the user to do anything other than click OK. So Jason, if we're going to make a pop-up window, just give a message to the user and just give them the option to select OK to get out of it. What do we do? How do we do this?
Well, first we want to say it's a part of the alert dialog.
Okay, so we're gonna take this instance and do what?
Well, we're gonna set button.
Okay.
Is dot set button.
Okay.
So that way, first thing we want to do in there is what is the button gonna say, right?
Right.
So we're gonna put in there either OK, if you want to just kind of go vanilla with it, something like "you big dummy, this is already taken." If you want to go more Red Fox with it, kind of a little more Sanford and Son. And the next thing we want to do is we want to create a listener for that click.
Absolutely. Good call. So we're going to make a dialog interface, and we're going to call on that a method onClick listener. So on the dialog interface class instance, call this, and it looks like it already filled out this code for me automatically, which was kind of nice. But
yeah, except for none of it's useful. Thank you for giving me something I will never use.
I'm gonna change these parameters to be more standard, and this is just gonna be dialog interface, and we'll call this. Actually, you know what? This is correct. This is the which, and this is dialog. So, and actually, all that I want to do is I want to just value this and just put nothing in it. So that's how when I click OK, the button just closes. Isn't that cool?
Yeah, unless we wanted to do the switcher for the David Hasselhoff picture, and then, in which case we would put the code in there to handle that.
And we're actually going to be using this in a little while because these alert dialogs can have multiple buttons. So as you can imagine, when we're selecting the number of players in the beginning of the game, we're going to have 2 buttons to click. It's going to be awesome.
Ooh.
So now, if you go up here to the class, you'll see that NetBeans is still angry at us, right? Let's make it not angry at us. Let's override the method that it wants us to override. So Jason, now that we've basically created our ecosystem by when we instantiate it, we store all these values and we store them as fields. Let's create the actual action. So when my finger touches that tile on the tic-tac-toe board, this is going to be the method that fires. And what is the method going to be?
That's going to be on click.
How, I don't know.
That's, well, you're not really clicking, are you? It should be on touch or...
Well, that's what iOS
rope.
does. See, I like the fact that Android has stuck to the on-click because it's more consistent with other, I don't know, maybe it's a bad way to view it, but everything on iOS is like on touch-up or on like this, and it's just kind of dumb. I don't like it.
Yeah, I guess that is kind of getting a little bit... It's getting kind of snooty, I think, a little bit.
Now, there's a few things, and maybe I kind of went out of order, but there's a few things that we need to define in the parent activity before we can define this. So, Jason, let's just leave this alone for now, and we'll come back to it.
Sounds good to me.
Let's go back to our Wibbit Net TicTacToe activity, and let's start building this thing out. So inside of our class, inside of our program that is this guy right here, let's store some stuff, alright? So I'm going to just store a random instance so that I can just make random numbers at points because our AI is going to be basically the pseudo-random number generator, which is the same thing we did in the iPhone app. So we'll do a private random instance, and the random instance, we'll just call this thing rand, and we'll just make it to a new instance of random. I also want to store a grid view of 2 things. I want to store a grid view of all the images and a grid view of all of my tile on select instances. So that way I have a grid view, so I have a direct memory link to each one of the images here, and I also, within the context of my Wibbit Net TicTacToe class, I can also access their on-click events. So check this out. Watch this. This is nice. So we'll do a private image view, and we'll just make this a 2-dimensional array, and we'll call this tiles. That's going to equal a new instance of image view, and the image view, since it's a 2-dimensional array, we'll make this 3 by 3. As you can see from looking at the grid, 3
by 3.
Yeah.
Wow, that's pretty cool.
So now that we've stored that, I want to do the exact same thing, or at least in this implementation of the program. And hey, it's our program. If you don't like it, screw you. We're going to do the exact same thing with the tile on click listener. And this is going to be called tile on clicks. Why not? 3x3. So we're storing the images, and I'm storing the on-click events for the images within the context of this program. So now, Jason, we're going to go on a little mini rampage here, okay?
Okay, I'm ready to rage.
Okay, if you look here at the XML file, so let me kind of back this up a little bit. We have the resource and the layout and the main. What we want to do is we want to create instances in our class that reference these objects within our program, okay?
Right.
So let's go ahead and let's just create variables that will be their placeholder. So let's start here with let's store the image view of the frog and the fly. How do we do that?
Well, first thing we want to do is we want to establish a private image view.
Okay.
Now, is there any correlation between the image view in the main XML and what we're doing here?
I don't know. I guess we're gonna find out.
I guess so. Teaser, I guess. So we're going to call that img frog awake.
Okay.
To kind of keep it simple, keep the naming convention there.
Okay.
We're going to set that to null for now.
Okay.
And then image frog asleep is null as well.
Okay, so we'll just keep those null. And then what's the next two we're going to store?
Well, the same thing, but it's fly instead of frog.
All right, so we have image fly. Okay, what's next?
Well, we need our logo.
Oh, that's right. And
the all-important Wibbit.net logo.
Well, and we need that, Jason, because we're going to be putting an on-click event inside there. So when you click it, it will launch the website.
Absolutely. So it's not just there to be pretty. Even though it is pretty.
It is damn pretty.
Well done, Brian. Yeah, good job, Brian.
And then we're also going to store a couple other things. What's that?
Well, we have to store the scores, and we also have a button for the new game.
Okay, so LBL.
Let's start
frog.
with the scores.
Okay.
Yep, text view, frog score, and then fly score.
All right, that way we can update the score.
Right.
All right, and what's next?
Next, we have a private button, and that's for our new game button that we put on there.
Okay.
So private new button.
This is going to be like what, BTN new game?
Yeah, that sounds good.
Okay.
Make that equal to null.
All right. So now now that we've kind of created the variables that will represent the objects within our program here, we're going to then create an instance of our model code. Our model code is the TicTacToe Java program or code file that we never went over because we already went over this in the iPhone app lesson. So go back and watch that if you're scared and confused. So we'll make a private instance of TicTacToe, and we'll just we'll call this triple T.
Triple T works.
So that's going to be the logic. The game logic is going to be stored there. Private TicTacToe equals... Okay. Now that we've stored that, we're going to create a pair of alert views. One of the alert views is going to be for displaying information to the user. So let's say Wibbit the Frog wins the game. One alert view is going to show that. The other one's going to show upon a new game. So when you start a new game, it says, do you want to play 1 or 2 player? This other alert view is going to be responsible for that. So we'll just do a private alert dialog, and we'll just kind of call this one generically alert dialog, and we'll just maybe alert dialog message. Yeah, we'll just kind of change that up a little bit to null, and then we'll make another one alert dialog, and we'll call this select, because this one will be responsible for the user actually inputting data into the alert dialog, and that will interact with the program. We also want to store a couple of global fields that will be important for the flow of our program. So let's go ahead and store the score of the game. So what do you want to call this? Like what, frog?
Frog wins.
Okay, we'll set that
equal to 0. Yeah. And then fly wins. We'll set that to 0 as well.
All right. And we're also going to store a couple of other variables. The CPU row and CPU call is going to be used when we have the AI, which is going to be stupid. It's just going to be random. So we'll have these stored when the computer makes a move. Private int CPU row, and we'll set it equal to something it will never be. CPU call. Okay, Jason, and we have I guess technically 3 other fields that we want to store. What's next?
Next, well, how many people are playing the game?
It's the phone.
That seems like it's important. So, yep, there's always going to at least be one, right? So,
yep.
So next we want to set a Boolean marker to identify whether or not the computer's thinking about making a move.
Mm-hmm.
Right?
Yeah.
If it's one player, you don't want to jump ahead and cheat, right?
Right.
So let's set that to CPU thinking.
Okay.
That's equal to false.
All right, cool.
We're going to put a second timer on that so that, the computer can figure itself out and make its move.
Right, and that way when the computer is thinking, I can't screw around with the game. Now, this next field that we're going to store is kind of advanced. Now, I'm going to say this at a high level because I don't want to make it scary, but Android is not what they call multi-thread friendly. Okay, it's just if you have a thread that interacts with the graphical interface, it crashes. So as a workaround, what a lot of a lot of Android developers do is they will create these handler instances that will handle manipulating view items after a thread has executed, and this is actually embedded inside the thread. So bear with me when I do this. Well, you'll see how it works in a minute. So we're going to make this final, which means that once it's been instantiated, it can't be reinstantiated. So this is going to be of type handler. We're going to call it CPU handler. We'll make it instance to a new instance of handler. So don't be too scared about this. We haven't talked about multi-threading in Android yet. And this is going to be a Android.OS handler. So you'll see how this works in a little bit.
Every time you said don't be scared, I got even more scared. Not gonna lie.
Let's before we do this, I'm gonna just make a little getter here so that our backend code can call this a public boolean is CPU thinking, and this is gonna return the. And you'll see how this works. Our backend code is actually going to be using this. The tile on click listener is going to be calling this. So you'll see that in a little bit. Alright, Jason, so now that we've defined the fields and this one getter within the WibitNet TicTacToe class, we can go back to the tile on click listener and finish that because that actually references fields inside of the parent activity.
Very good.
Very, very good.
Very good. Yeah. I like it when a plan comes together.
Yeah, me too. So when we go back here, Jason, let's go to the on-click method. What's the very first thing we want to apply?
Well, we want to figure out if the CPU is thinking or not, right?
And if the CPU is thinking, what do we want to do?
If the CPU is thinking, we want to block the user out from being able to do anything else.
Oh, genius. So how do you pull that off?
Well, the first thing we want to do is we want to see if, is the CPU thinking?
So we're going to access the parent activity instance.
Right. And then we're going to access the is CPU thinking method.
Okay. And if that is true, what do we do?
If that is true, return.
Awesome. This is what they call a classic block move.
Absolutely. We should have called, instead of is CPU thinking, we should have called it is block.
Alright, so we're going to just define some exception handling here to facilitate what we're about to do next. Now, inside of the TicTacToe Java class, you'll see that these throw as exception, which means that we have to exception handle them. That's fine, no big deal. So in the try, Jason, when the user clicks on a button on a grid item, the first thing that we want to do is we want to see, is it already valued? Because if I want to select the middle square, but Buzz the Fly has already selected the middle square, I can't select it. So how do I check for this?
You're going to get the value of that square.
Okay, now that is stored inside the model code. The model code instance, it belongs to our parent activity. So we'll go to the parent's activity, and I think this is accessible. If not, we'll change the permission. So TicTacToe get value, and then this is going to take in the row and column, which this has already auto-filled. So get the value of this row and column. So get the value of this row and this column.
0, 0, or
right.
0, 1. Right.
If that does not equal blank, we have a problem, Jason. What do we do?
Well, we want to tell the person that that cell is not available.
I gotta change. Hold on, real quick. I gotta change the access to that. That's the TTT should be, or I'll do it the proper way. Sorry, I'm really sorry about this, but I'm brainwashed. Let's do a public TicTacToe get TicTacToe. Sorry, I'm so sorry. Sorry. I can't say that enough. So instead of this, we'll do get TicTacToe. Okay.
Okay, sounds good to me.
Now what do we do?
Well, we've said that, is the if it's not equal to blank, we need to set an alert. We need to use that alert dialog that we've been working with.
Okay, so we'll do the alerts dialog. And then we're going to call the set title method, and the method parameter is going to be what, Jason?
Message.
Okay, so that means the title's just going to say message.
Right.
Now the actual message. What do you want the message to say?
say anything you want, but let's go with cell is already valued.
Cell is already valued.
Yep. And next we want to actually display this brand spanking new message.
I'll be damned. Okay. Now we can't really see this yet until we can get to a point where our program will function, but we'll get there soon. So now we're going to return once we get through that. So now we run into a condition where the user has selected a cell that is available, right? So now what do we want to do first, Jason? What do we want to do? And this is really exciting.
This is where we have to figure out, well, first of all, whose turn is it?
Right? Okay.
So we need to figure out whose turn it is.
So get TicTacToe. So we want to find out whose turn. So if the turn is of X, so if it's X's turn, let's go ahead. Now X is you. Remember, X is the frog, O is the fly, you are the frog. So X is you. So what we're going to do is, in the case of X, what do we want to do to that image, Jason?
We want to set that column and row position to the image of X.
Oh, man. This is cool, huh? So we're going to set the image resource to _X res ID. So now what we're doing is we're actually changing the image.
From that blank image that we established.
Yeah. And then if it's not, we're going to give it the O res ID. So then at this point, we're going to store the current value. So whose turn is it is going to be the current value. We're going to call the model code to make the move. And then we're going to call a method, which we haven't defined yet, inside of the parent class called tile has been selected. And this will kind of modify things like change the images, from the frog asleep to the frog awake and that kind of stuff. So we'll do current value equals, this is going to be parent activity dot get TicTacToe dot whose turn. Then we'll do, now we actually want to go back to the model code. So our controller is going to interact with the model to do make move. The move is going to be at row column. And then we're going to do a method that I haven't defined yet, which we'll go back, and I'm sorry that I kind of went back and forth through it. It wasn't my intention to do this, but inside of this class, which is the Wibbit TicTacToe Java. See, I guess I'm in kind of antsy, though, Jason, because I just want to get this class over with, because this isn't the fun part.
Yeah.
So,
understandable.
Inside of this, all that we're going to do is I'm going to create a public void method called tile has been selected. And if you guys remember our iOS app, this was the exact same thing. And it's going to be taking in an instance. And the instance is going to be the data type tile on click listener. I don't know, I'll just call it image for now. Alright, so now what I can do is I can finish this class totally. So I'll do parent activity dot tile has been selected. And the tile has been selected will take this instance. Ugh, it was a marathon getting through that class.
But it's done.
Yeah, this class here is done. Now I think the fun begins. Now really, we haven't wired any of this up, but let's actually start having fun. So let's start looking on this onCreate method, and Jason, talk to me about some of the methods that we have to make.
So we want to make a method that will tie that beautiful GUI we have to our code.
Okay, great. So we've created these variables here. Now let's actually set them. So we'll make a method here, and we'll just call it we'll make it a public void. We'll just call it wire GUI.
Wire GUI sounds good.
Yeah, we're just gonna wire it up. Okay, Jason. So in wire GUI, let's first go ahead and let's set up the select box. Now remember, the select box is going to present the user with how many players they want to play with.
Right.
So talk to me about how we can configure that.
Well, first we have to, again, call that alert dialog set select.
Mm-hmm.
And we're going to make that a new instance of the alert dialog builder so that we can create the alert box itself. So this and then .create. Next, we want to actually set the title of this alert box.
Okay.
Like we did before with the error, with the you were cheating error.
So we'll just say what?
We'll set it to just Wibbit TicTacToe.
Okay.
Next, we actually want to ask the question.
Oh, this is just a little icon that shows up in the pop-up. So we'll just use the application icon.
Okay.
So we'll do the set icon, and you'll see what this looks like. And those of you guys that follow the other tutorial, you know what this is. So resource dot drawable dot icon, And then, like you were saying, Jason, we want to set the actual message.
Yeah, so we want to set the message. The message being how many players are we working with here?
Okay.
So we'll make that message just say how many players.
With a question.
And now we have to, after that, we have to set the buttons. We have 2 buttons, right?
Absolutely.
We have the 1-player option, the 2-player option, because 3-player tic-tac-toe does not work.
All right, so the first thing that we want to do is we want to pass a integer that represents the button number 1. So I believe these can have up to 3 buttons. So what I want to say is in position number 1, so I'm going to call the alert dialog class, and then there is a field here called button 1. And then on the button, what do I want the text to say, Jason?
Well, we're just going to put in the number 1. That's 1 player.
You make it sound so easy.
Oh, it's easy as pie. I mean...
And now we're going to just create another one of those dialog interface dot on click listener. This time it didn't fill it out for me. Let me just bring this down so I can see it, and I probably need to fix my imports. No? Yes? Alright, so let's go ahead and start coding this out. So we're going to do an override of the... I hate autocomplete with a passion. It never does what I want it to do. Public void on click, and on click will take a dialog interface. We'll call it dialog or just D, and then int which is which button we're talking to. And I think that got it to stop yelling at me. All right, so Jason,
yes.
When the person has that dialog box and they press the button number 1,
yes,
what do you want to happen?
I want the application to understand that we're dealing with only 1 player.
Okay, so we'll set num players to 1, right?
Right.
And I can literally copy this exact same piece of code. And instead of this, we'll say button 2. And instead of this, we'll say 2. And instead of this, we'll say 2. Nice.
Now we can play 1 player or 2 player.
Absolutely. Or at least we can select it. Now, just for kicks, just because we haven't seen anything fun in a while. Let's see what that looks like.
Roll into a finish line. There we go.
Splash screen comes up.
1, 2, 3.
Oh, you know what?
4,
we never actually called the
5.
method. Are you kidding me? Are you kidding me? We never called the method.
Oh, man. So we get to wait for the emulator to do that again.
So we're going to call the method on create. Yes, we do have to wait for the emulator to do that again.
Oh, man.
Yeah. But while we're waiting for the emulator to go, and we're just doing this so we can have something to look at, because we haven't actually seen anything in a while. The next thing we're going to do is we're going to wire up the elements from the user interface to object variables inside of our code. So the first thing we'll do is we'll wire up the tiles. So since we set up the tiles as a 2-dimensional array, we'll set up 0, 0, 0, 1, 0, 2, all the way down the line, and we'll match those up to the IDs that we defined inside of our XML file. All right, so here's the splash, and... Oh, hey, see, there's the icon, Jason. You see it?
I saw it. Very nice. Very nice.
Cool, huh?
Very cool.
It feels good to actually see something.
It really does. And you know, while we were waiting for that emulator to boot, I had a thought. It would be pretty easy, I think, on the one hand, to take what we've done here with TicTacToe, or what we're doing here with TicTacToe, and apply it to certain other games. Certain other games like, I don't know, Chinese checkers.
Yeah, or Connect 4 or chess or something like that, yeah.
Right. Well, this next part we're going to do where we kind of identify the tiles would be a nightmare for Chinese checkers.
That's why you would want, you'd want to do this in some kind of a loop structure. You wouldn't do it manually like this if you were dealing with that many elements.
Yeah, because Chinese checkers would be a lot of tiles.
Absolutely. So let's start talking about this, Jason. We created that 2-dimensional array called tiles. That 2-dimensional array is an array of image views. So now what we're going to do is we're going to wire up. Let me close some of these programs here because we're not looking at these anymore. We're going to wire up these IDs to our code. So Jason, talk to me about how we could start doing that in the wire GUI method.
Well, we have to start identifying a tile at a time, basically.
Sure, why not? So sub-0,
Yep.
sub-0. And what are we going to set that equal to?
Well, we're going to have to, call that image view.
Yeah, typecast an image view.
And we want to find view by ID.
Find view by ID. Now, just like in JavaScript, you've seen this. We're going to look in our resources. We're going to look for an ID called img tile1. How cool is that?
Very cool.
Yeah, so now, dude, this variable here actually corresponds to our graphical interface now. We've actually finally started making that connection.
Yep, we just need to repeat it another 8 times.
Yeah. So we have 2, we have 3. This is going to be 0, This is going to be 1. This is going to be 2. So this should be pretty easy. We're just going to copy these. We're going to paste those here. And this is just going to be changed to 1, 1, 1. And this is going to be 4,
4, 5, 6.
5, 6. Then next is going to be the last triplet. And this is going to be 2, 2, 2, 7, 8, 9. So we've hooked those buttons into our code. Now, Jason, let's go ahead and let's hook the images to the frog and the images to the fly.
For when they're awake and asleep.
Exactly.
All right. We're pretty much going to do the same thing, aren't we? Except for, instead of we don't have a multi-dimensional array anymore, so we're just calling image frog awake and image frog asleep and doing pretty much the same thing.
Now, we were smart enough to name the variables the same as the IDs, so we can just copy it like that. So I have image frog awake, image frog asleep, and I should just be able to copy that and paste that. So now we have a link to the images of the frog. Now let's do it for the fly. Image fly asleep. Image fly asleep. Oop.
Delete all the code.
Yeah, select all, delete that. Image fly awake. Awake. So now we have access to the image of the fly. And now, Jason, since we have the frog and the fly, we want to be able to access the text view that contains the score, right?
Absolutely. Even though we're not really switching one thing out for another with the text view, but we still have to interact with it, right?
Yep, we're going to be updating the score after each game.
Yep.
So yes, so label frog score, and then LBL fly score.
So now we have all the tiles linked together. We have all the awake and asleep images linked together.
Yep.
With second to last thing I guess we need is the new game button.
Right. So we'll do the what do we call this? BTN new game. Mm-hmm. Yeah, so we're gonna get a link to the game. Now, the thing about the button is we need to call a method, and we'll just kind of define what this method is. So it'll be a public void start new game, and this will be something that we will define later. But so, Jason, what are we gonna do here? We have to set the on-click listener for this button. What are we going to do here? We have to set the on-click listener for this button. So let's do that. Tell me what to do.
Okay, we have the new button new game, and we have the set on-click listener.
Okay.
And that needs to be a new instance of on-click listener.
Okay, and then we're going to override... stupid autocomplete. I hate autocomplete. So we're going to override the on-click method, which is a public void on-click. And this just takes in a view, I think. So what are we going to value inside the on-click method, Jason?
Well, we want to start a new game, so call start new game.
Okay, so that start new game method here, we'll just run that. So that basically means somebody wants to start a new game, so damn it.
Loop back over. Start it all over.
View on-click listener import, which we had done that already in a class before. And what are we missing here? Expected a parenthesis. I think that's what's needed, right?
Nope, just one.
Expected a semicolon? Oh, stupid autocomplete. Okay,
yeah.
Cool. So that means that when we click this button, it's going to come into this code here, and it's going to run this method, which has yet to be defined. So now that we've defined the action of the start new game button, we want to then access the image logo, Jason, so that we can fire a web browser. What do we do?
Well, first we have to define image logo.
Okay.
So...
And this will be we'll test this right after this. This will be fun. So this is what? IMG logo?
Yep, IMG logo.
You are? Really?
I am. That's going to be my new name. I'm changing my name, my username. IMG logo.
Okay, so now that we have hooked that image into our code, let's go ahead and do the exact same thing. We're going to set on-click listener. The difference being in here, we're going to specify an intent because we're going to be launching an external program. So, Jason, just like we did before, talk to me about creating a new intent.
Well, first you have to declare the intent.
Okay, we'll do that.
We'll call it browser intent.
Okay, so we intend to open a web browser.
Right.
Okay.
And that will be a new intent.
Okay.
And the intent.action view.
Okay, so we're going to call the action view fields, and then we want to then parse a web address, right?
Yep. So URI.parse. so we can send it the address of the best website in the world.
And if I could, real quick, get the best website in the world.
That would be http://www.wibbit.net.
Oh, man. How cool is that? So, okay, now just like we did before, like, remember, Jason, when we set up the splash screen, we had to call a method to actually execute this. What is that method?
Right, well, that method would be browser intent.
Well, we got to do the start activity, right?
Right, well, yeah, start activity, browser intent, sorry.
So we're going to pass our intent. So let me see here. If I click on that image logo on the bottom right, we should get a web browser. Let's see what happens.
We should, but I fear the emulator, so how long is it going to take to launch the web browser?
I don't know.
So this is uncharted territory here. We have yet to launch anything but our app in the emulator so far.
Here we go. All right. I see something. It's coming along.
Yeah, here we go. Coming along.
This is cool, isn't it?
Yeah, it's good. It's nice to be in Android land.
All right, I click on wibbit.net, and
you got the browser.
Hey!
Yeah, all right.
It launched the website. Cool. So at least we can see our program is starting to do stuff.
Cool.
All right.
It goes back to Wibbit.
So now what I want to do next, Jason, is I want to, that alert dialog message box that we have, that message box is intended to be presented to the user after a game is done. So, Wibbit the Frog has won the game. So there are some static things that we want valued. What are they? So let's do the dialog message box. Well, first, I guess we got to instantiate it, right? Well, first, I guess we got to instantiate it, right?
Right. So that would be a new alert dialog builder. And then this.
Hold on one second. I was thinking maybe launching the web browser wasn't such a smart idea.
Maybe not. Yeah.
I thought it would look cool.
Well, let's see. Well, there's this. Look at that. All right.
Hey, well, what kind of ads are they giving me here?
Browse singles. Now.
Sexy singles.
Woohoo.
All right.
Is there any other kind? Yes, there is. There's lonely. There's depressed.
There's real singles.
There's that too. Well, I suppose there's lots of kinds of singles. That was a silly thing to say. It's right there, builder. I can see it.
I clicked on it. I'm trying to get this thing to respond to me. Okay, so builder, and then on this, we want to pass the current instance .create, right?
Right.
All right, cool.
And next thing we want to do is we want to set the button that's going to at least be able to dismiss that dialog, if not move on to another action, which in this case, we are going to move on to something else.
Okay, so this will be alert. Okay, so we're starting to really get the hang of this on-click thing, huh?
So it would seem.
Yeah, so it's pretty easy. Now this one's slightly different because this is, well, I can't really copy and paste that because it's not similar. So we'll do set on click listener. No, set button. Sorry.
Yeah, set button.
Set button. Okay.
Button.
And then a new dialog interface dot on listener. Oh, it filled it out for me again. Nice. Okay, now we don't want to do what they want us to do. There's going to be a method in here called reset GUI, and that's going to reset the game. So we'll do public void reset GUI.
I get the feeling we're going to use that reset GUI more than once.
Yeah. So let's go ahead and let's call reset GUI right here. Now, that should have wired up all of our user interface elements.
Sexy singles.
So
I don't know what it's trying to say about the Wibbit viewers. I mean, you go to the Wibbit page and the first thing you see is sexy singles. Just because we're nerdly doesn't mean we're alone. I mean, some of us might be. Some of us might not be.
All right, now let's go up to our onCreate, and let's add that start new game method. So what we're going to do is when the program first launches, we're going to display the view. We're going to wire the GUI up to our control code, and then we're going to start a new game. Now, that hasn't been set yet, so let's go ahead and let's set what this is, because once we start building this, we're going to actually start to see the program function. And really, all that this is going to do is what? And really, all that this is going to do is what?
Well, first thing we want to call that alert dialog select method.
Okay, so we're going to ask the user to select how many players they want.
That's right.
And then what?
And well, it's the first time we're launching the thing, right? So nobody's won anything yet. So we have to set frog to 0, frog wins to 0, and fly wins to 0.
Okay, so we're resetting the score.
Right.
And then what?
Well, we're resetting the GUI, I guess.
Right, yeah.
Even though we're kind of setting it once, but I guess we might as well have one thing to do both things.
Right, because the game has just restarted. So when we reset the GUI, there's a couple things we have to do. We have to set the images how they're supposed to be on start. We have to, basically set a couple of flags, like turn off the thinking flag, and we have to go through each one of the on-click methods, and we're going to set a new on-click listener. And that's going to be that tile on-click class that we wrote already before. So now, Jason, let's start from the top. What's the first thing that you want to do when we reset the GUI?
The first thing I think that would be the smartest first thing would be setting that CPU thinking flag to false.
CPU thinking is false because it's not thinking.
Right.
Okay, and now what we want to do is we want to set the visibility of the images. So we want the frog asleep and the fly awake to be hidden. How do we do that?
Well, we're going to call the frog asleep.
Okay.
And set visibility on that.
visibility. That's a lot of eyes.
That is a lot of eyes.
Okay.
Way too many eyes.
And what are we going to pass? What field are we going to pass here?
We're going to pass the image view field.
Okay.
And then have it be gone.
Okay, so it's going to be gone.
Yeah, not there. Gone.
And then
it's not available.
And now we want fly awake to suffer the same fates. Right?
Absolutely. Yep.
So now that we have that, what we're doing is, so we're going to make the sleepy guy go away and the awake guy here go away.
Yep.
Let's do that. So we'll, that's what that is. So next we'll do the frog awake.
Awake.
Set that equal to what?
We want that visible.
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 And what else do we want visible?
The fly being asleep needs to be visible.
Fly asleep. Okay. Now we also want to set some fields. And what is that?
Well, we want the scores to be reset, right?
Mm-hmm. We want to set them to the current score. So we have frog score dot set text, right?
Mm-hmm.
And now what do we want to set this text to, Jason? Call the integer class and then what?
Take it to string.
To string, and then
we're going to use the frog wins.
Nice guess.
Yeah.
Frog score, fly score. Okay, so now the score has been updated. I'll launch this so we can see it change in an hour. But what we want to do is now we want to go through that two-dimensional list of images. And what we want to do is, since we've already set the images, now we want to attach some of the on-click events to the images. Since we've already set the images, now we want to attach some of the on-click events to the images. Now, you may argue that this is not very memory conscious, but remember, this is Java. Java is the memory management's handled in the virtual machine, so we don't have to be very conscious of it. So every time we reset the GUI, we're actually going to be resetting the on-click listeners. Now, do you have to do it this way? Of course not. This is just the way that we did it. So, Jason, how do we do this?
Well, we're going to start a for loop.
Okay.
First and foremost.
Int I equals 0, while I is less than 3, because it's a 3x3 grid.
Right.
I++, and we're going to have a nested for loop.
Mm-hmm.
And the nested
for the second layer of the array.
Yep. And we'll do J, and we'll do J, and we'll do J. And what are we doing inside of this nested for loop, Jason?
Well, we're looking for the on-click events and to assign things to tiles.
Okay. So that on-click, so remember we had those two-dimensional arrays.
Right. And since we have we have our two-dimensional for loops, we started off with the I and the J, and that's going to be a new tile on-click listener,
which was that class that we wrote already. That was a big pain in the ass.
Yes, well, it's done now, so let's we don't need to dwell on the past.
So now,
I guess we do.
Now what we're going to do is this is all going to start coming together. The first parameter is going to be this. Now remember, this is the parent activity. So we're passing the instance that is creating this along with it. So we're passing a pointer to the program.
Whoa.
The next one is going to be a pointer to the actual image that was clicked. So, it's a pointer to the image that this corresponds to. So tiles, I, J. Now it's really starting to make sense. It's starting to come together. The next parameter, the next three parameters, we want to pass the number of the resource for the image X. R.drawable.x. Then the resource for the drawable of O, and then I want to pass the row and column that this currently belongs to. At least that's how we set it up. So now we have created that instance. Now, Jason, let's take that instance and let's inject it inside of the tile on the graphical interface. How do we do it?
Well, we're going to, use the tiles that we have, and we're I and J, so we set our row and column. And we're going to set an on-click listener.
Okay.
I kind of said that weird, but set on-click listener, and then call the tile on-clicks, and then use your row and column.
Awesome. Very, very slick. And there's also one other thing we want to do is we want to blank out the image. How do we do that?
Call that same tiles row and column that we've been doing. And we want to set image resource.
Okay.
And we're going to pull the R drawable, just like we did with the X and the O resource. And then instead of X or O, we're using blank.
Okay. And then the very last thing that we want to do is inside of our model code, we want to reset the game logic. So TicTacToe.reset. So if we run this, we should get the starting setup, like our grid in our program should look exactly as it would when it's ready to start. Now, the only thing left for us to do, there's only two methods left to do. The first one is to handle what happens in the graphical interface on the on-click event, and the second one is to allow the CPU... Cool.
It's weird seeing this game in Android.
Look at this, new. Look at that. New.
Very cool.
And it's resetting too. Oh, it crashed. No, it didn't crash. I'm sorry. It's reopening because I hit play again.
Oh.
All right, so here's a fresh run. It is kind of weird seeing it in Android.
It is. The dialogue's totally different.
Yeah. So if I click, look at that. You see that?
Yeah.
Now if I click this, it's an O. X.
Well, we have the two-player game also. Two-player game's done.
X O.
Well, it's kind of done.
You'll see
you just won twice.
Yeah. Now here's the problem. These guys aren't like if I do a new game and if I select, although I'm doing one player right now, there's no difference between one and two player, so I'll just select two player. If I select X, I want him to go to sleep and him to wake up. That's not happening right now.
Yeah, it's not happening at all.
I want him to go to sleep and him to wake up. That's not happening right now.
Yeah, it's not happening at all.
All right, so let's go to the tile has been selected, and I'm going to change this to tile listener. And, Jason.
Yes.
The first thing that we want to do is what?
Well, the first thing we want to do is we want to determine if there has been a winner.
Okay, so let's do that.
Okay. So if, call that TicTacToe, and that's going to reference back to that code we did in Objective-C, right?
Yeah, it's the port of the Objective-C code. Yeah. So it's the model code that we did not discuss, but if you go back to the iPhone course, it's there.
Yep. And so the who is winner, and we're going to say if that's not equal to blank.
Okay, if it's not equal to blank.
Right, so we're just kind of saying if there is a winner first.
Okay.
So now we're determining who's the winner. And the first thing we got to do there is set a message, right?
Right, so if the winner is not equal to blank, which means, Jason, that there is a winner, right?
There is a winner, and we've established already that X is the frog and O is the fly.
Yep.
So we need to say if the winner is...
Well, first let's set some variables here. Let's set a string variable that will represent the message and a string variable that's going to represent the title of the pop-up box. So we'll do string what do you want the title to say, man?
We have a winner.
We have a wiener. Okay. So now you were just saying this a second ago. What do we check next?
Next, we're going to check to see, who is the winner, right?
Okay. So
we're going to call that TicTacToe, that TTT. Who is winner? If that's equal to X, we're going to set a new message.
Okay. And what is the message going to say?
Well, we've already said that the X is the frog, so the message is going to be the winner is Wibbit the frog.
Okay.
And we're going to put quotes in there, so use your escape characters.
Right. So we'll do Wibbit the frog. And just like you said, we're going to just, for the hell of it...
Yeah, just why not?
Put some quotes around.
It doesn't have to be there, right? But might as well.
Just makes it fun. No, Jason, check it out. Since we're playing a game, what's going to happen after Wibbit the Frog wins the game?
He's going to get another credit in his tally corner.
Yep, he's going to get a point.
Yeah.
So Frog wins ++. Now, we have to check for the other condition, which is what?
The other condition is if O is the winner. So we're going to kind of copy the same thing, but do an else if it's O, and then the message is Buzz the Fly instead of Wibbit the Frog, and we're going to credit Buzz the Fly with the win.
That little turd. So Fly, the winner is Fly Buzz. Now we have one other condition in the game of tic-tac-toe, and that is what?
Stalemate.
Yep, that the game is over, but there is no winner. It's a draw. What do we do in the case of a draw?
Well, we don't have to increment the wins for either of the players.
Mm-hmm.
Though we probably could increment them both one.
Or subtract one. I don't know. I would just leave it.
If we went the hockey route, we would increment them both by one more, I guess. Because a tie in hockey kind of... Well, anyway, we don't need to do any of that. It's just nothing. The title is We Have a Draw, so we can set the title.
So instead of We Have a Winner, it's We Have a... do you want to call it a tie or a draw? I don't care.
Either way, tie. We'll go tie.
We have a tie.
We have a tie.
And then, what does this say? It's a draw?
Here we'll use draw, so it's a draw, just to confuse people. Is it a tie or is it a draw? It's the same thing. Oh. Of course, if we were building a global thermonuclear war app, there wouldn't be any if else. The only answer would be, we have a loser. Because there is no winner in global thermonuclear war.
Have you watched War Games recently?
No, I'm actually just planning on being Sarah Jessica Parker for Halloween.
Oh, God.
So Matthew Broderick has come up.
I gotta watch that movie again. That's a good movie.
Yeah, it's good. It's good. Sure.
Now we want to present this data to the user, right?
Yep.
And
so we got to set message.
Set the message.
Yep. That would be
and
message.
Then what do we do?
We got to set the title too.
Oh, that's right. We went through all that trouble of setting the title. We might as well display it. Then what do we do? We're
going to show it.
Holy shit.
And then return it.
All right, so we're going to bail out of this code. Whew. Okay, so now we've figured out what to do in the case of a winner or a draw. So now once we get past this, then we have to handle the circumstance where someone just made a move and the game is not over. So now once we get past this, then we have to handle the circumstance where someone just made a move and the game is not over.
This is where we're going to switch those images like we were talking about earlier.
Yes, exactly. So let's go ahead and do that. What do we do?
Well, we're going to first set the condition of, whose turn is it? So we're going to create an if statement, and we're going to call whose turn.
Okay.
And we'll make that equal to X to start it off.
All right, so if it's X's turn, then what?
We could probably copy that same code we have up above.
Okay.
For setting the image frog asleep, image frog awake. No, not that code. I'm talking about...
Yep, I'm getting there. This one here. No.
Yeah, underneath the reset GUI.
I don't know why it's not finding it. Oh, it's because I typed it wrong. Yeah, this.
Yeah, all that. We could probably just copy those 4 blocks right there.
All right, and we'll take her down here?
Yep, and then just set them differently so that...
Okay, perfect.
Well, maybe...
No, you're right. Let's do this.
It's exactly the same for this condition. And then we just do an else if, or just an else. We don't need to do an else if, just else. And then do the same thing, but switch them so that it's the gones become visibles, the visibles become gones.
Okay. All right, so we'll paste that there. And you said if it's gone, make it visible.
Right. And if it's visible, make it gone.
Visible, gone. Okay, let me think here. I wonder what would happen if we ran the program right now.
I don't know. Let's find out.
Uh-oh.
I have a packed lunch. I can wait for the emulator.
I think I might be able to watch the whole movie War Games while we wait for the emulator to come up.
No one wins.
Hello, Professor Falcon.
Would you like to play a game?
Yeah. Oh man.
Isn't he trying to play tic-tac-toe in that movie?
Yeah, actually, yeah. That's how the computer learns that nuclear war is a loser, because of tic-tac-toe.
So we've started everybody on the path to global thermonuclear war.
At least they'll be able to write the global thermonuclear war apps in Android and iOS.
That's good.
So we don't have this one-player, two-player stuff set up yet, so no matter which type of game I select, I'm going to get the same game. So let's see here. If I click this, look at that. The fly is up, the frog is down. Okay, now we have it the opposite. Okay, if I select this, it's able to detect that Wibbit the frog is the winner.
Wonderful. Now is it able to tally Wibbit the frog is a winner?
Oh,
it is!
Oh, shit.
It is!
Oh, I get so excited about this stuff. Now let's let the fly win. Oh! Yes! The only thing that we have left to do, Jason, is well, let me make sure that the new game clears everything, and it does. See, the score was reset. Now, what we did in the iOS app, and it was really lame, and we're going to do it again here, and perhaps offer a new challenge to our Wibbit.netters, is we're going to just do a basic AI algorithm with absolutely no intelligence. It's just going to be at the mercy of the random number generator, the pseudo random number generator, right?
Yeah, absolutely. Good. Hopefully we have more submissions for the Android.
I hope so. Let's create a method, and we'll just call it CPU, the public void, CPU, select move. Now, this one is not going to actually perform the move, but it's going to detect the move. Now, Jason, as a basic stupid algorithm that has no intelligence, and we're just going to select a random location, tell me how you would write that.
Well, I think the first thing we have to do is we have to establish that the CPU is moving, right?
Right, it's thinking.
Right, so we have to
because Joshua wants to play a game.
Joshua does want to play a game, so we're going to set CPU thinking equals the true.
Okay, Joshua.
Stop it with the war game.
I'm going to watch that movie right as soon as we're done. I'm going to watch that movie.
I've had it on Netflix this whole time.
Really? That's awesome.
No, I don't even know if it's on Netflix. I just made that up.
Okay, so now we're going to simulate the computer thinking, and how do we do that?
Well, first we're going to try something. So
right,
try.
Because this is Java, after all.
Yeah. We're going to try thread, and then sleep.
Okay.
Okay. And now we're going to call random.
So we're just going to use the pseudo random number generator.
Right.
Okay, so inside of the sleep method call, we're going to call rand, and we're going to call the next int method.
Right. And
we're going to select 1000, so it's basically going to be a number between 0 and 999. And by adding another 1000, what we're saying is, at the bare minimum, the random number is 1 second, but it's between 1 second and 2 seconds of a wait time. That's what that says.
Right.
After that 1 second, when the CPU is thinking, it's actually just sleeping.
Right.
So we'll set that to false. All right, so now what?
Now we have to set the columns and the rows, right?
Yep, to a random number.
Yep.
Because our algorithm is not smart. So we want to select a number between 0 and 3, but not 3. So it's going to be either 0, 1, or 2.
Right.
So select row or CPU column. Now, the danger of just selecting a random cell, Jason, is that cell can be valued. So how do we protect against that?
Once again, we're going to have to try the cell one at a time, I guess, right?
Sure.
So we're going to do try and then a while.
Okay.
And we're going to get the value of the column and the row. So the CPU, we're going to set CPU row and CPU column. First we're going to call the TTT get value, and we're going to set CPU row, CPU column.
Right. So we're going to check to see while CPU calls Oh, it's not plural.
No, just one.
While that is what?
Empty. While that is empty.
Or while it is not empty.
Well, it's not empty, sorry.
Right. While it is valued, so while the pseudo-random number generator is randomly picking cells, it's going to try to find one that's not valued.
Right. So we're going to just kind of redo that same bit again.
Cool.
Yep. So while it's, got something, try it again.
Now that is the dumbest algorithm you can possibly have, but hey, that's what you get at
No,
here.
it could be dumber. It could it could just keep trying the same one over and over again.
Now
we could take away the exclamation point, and while it's value, just keep trying forever.
There you go.
Well, that's not really an algorithm, then, isn't it?
No.
Then it's infinite loop.
That becomes insanity at that point.
Yeah.
So the next thing that we have to do, Jason, is now the last part of our program that we have to implement is we have to account for the one-player situation, right?
Right.
The one-player situation is simply going to hand over control to the computer to make a decision. And we have to do this using that handler that I was talking about before. So Jason, get us started in this condition here where we check in the tile has been selected.
Whose turn it is?
Right. So if the turn is O, we know that it's the computer's turn. So
right.
If it's the computer's turn, how do we know we're dealing with a one-player game?
By checking the num players.
Oh.
By checking how many players there are.
Okay, it's got to be that easy.
Right.
All right. So if we are playing a one-player game, what can we do?
Well, we start a new thread.
Right, so we want to create a new thread, and I think we want to extend a runnable instance, right?
Yep.
Okay, so now what we're going to do is we're going to instantiate this thread and start it on the same line. So I'm just going to go ahead and end this. So inside of this thread, we're going to pass a new instance. We're going to of an abstract class called runnable, and inside of the runnable instance.
Well, that's where we're going to declare a public void of run.
Yep. We're going to override, so we have public void run, and this is going to actually perform the magic. So once this thread triggers, Jason, what's the first thing that it's going to do?
It's going to call that amazing algorithm in the CPU select move method.
Awesome. So once that move has been selected, like you guys remember in the way beginning of this when Jason and I were setting the fields for the WibitNet TicTacToe Java class, I said that there was some issue with multithreading in Android. Well, there really is, and it's a big issue, and I think this is really stupid that you had to do this. But one way to get around this is by using one of those OS handler objects. So once our thread has performed an action, in order for us to update the UI elements, it is recommended that we encapsulate that inside of a CPU handler, which was one of the fields that we set in the beginning of this program right here, the final handler, CPU handler. So that instance, we're going to call a method called post. And the post method is going to be taking in a runnable instance just like this thread did. So run able, it's able to run. It's going to seem kind of redundant, Jason, but what method are we going to override inside of the runnable?
Run.
Yeah. Sis. So we have a run method inside of a run method. Nice.
Yeah.
Way to go, Java.
That's why it's so slow. It's running in circles.
Yes, exactly. Hello, Java. And what do we want to do, Jason, with this image? So basically, we know which image the computer selected. What are we going to do with that image?
Well, we're going to simulate a click event.
All right, now how would you do that?
Well, call tile on clicks.
Right, and that's that two-dimensional array of the tile on click listener objects that we collected earlier.
Right, so and then we need to pass it the row and the column.
So CPU row, that's the row the CPU selected.
Right.
And the CPU column, which is the column that the CPU selected. Inside of here, we have a method called onClick, and since it doesn't actually use it, we can just pass null. So that's simulating a click event.
Yep.
And if I am not mistaken, Mr. Jason, I think we actually have pretty much, it could use some prettying up and some comments, but I think we have the Wibit.net Android app in the flesh.
Woohoo!
Let's check it out. I guess the next step is if we want to stay up all night is we can like make remote features so that I can play your Android simulator from here. I'm not going to do that.
Okay.
Hello, Joshua. Oh, we should we got to name the Wibit.net server Joshua just so we can say hello, Joshua.
Yeah, that's a good idea.
So here's our splash screen. Oh, come on, baby. I'm so fired up about this. All right, Jason, what game? Should we do one player?
Yeah, might as well.
Okay, I'm going to select this. Now the fly is going to go, and boom! How you like that?
Right there in the middle. The worst move to do.
I'm going to select this, and the fly is going to go. Oh, see? No intelligence at all. I'm going to beat him.
Woohoo!
All right, let me do a new game. That's 2-player, so now the fly will not react, right? Exactly. The fly is going to sit there until I choose the move for the fly. Jason.
Yeah.
We just wrote a freaking... Look at this, there's the draw. We just wrote the tic-tac-toe game for Android.
Wonderful.
From scratch. Every single line of code was written. How cool is that? No GUI editors, no nothing.
Well, we didn't write every... I mean, we had borrowed some code from our Objective-C course.
Well, but we still ported the code to Java. So...
Yeah.
That's...
That's pretty good.
Yeah.
Pretty good. Okay.
So I'm going to do one last thing, Jason. I want to change the name of our app because when I hit the home button and I go to my Droid apps and I look at my... This just looks like crap. Okay?
Yeah, it does.
Yeah, so let's fix that. And the way we fix that is we're going to jump into the strings file, which is here in the resources and values. There's a strings.xml. We'll change the app name to Wibbit.net TicTacToe. Let's try this, and this should be the last run of the night, and then I get to go to bed. Woohoo! Check it out, look, Wibbit.net TicTacToe is at the title bar, and as soon as this loads, we'll bail out to the desktop, and we'll check it out on the app view. Come on. Come on, Droid. There we go, Wibbit.net TicTacToe.
Very nice.
Very cool, Jason. Very, very cool.
I look forward to playing it on my HTC Thunderbolt.
Yes, yeah. So we're gonna get Jason to distribute this out to the market so that you guys can donate and appreciate the love from Wibbit.net. The source code will obviously be available, and if you guys have any cool ideas for any algorithms for the AI, please submit them. We'd love to have them. We may release our own just so that the game doesn't suck so bad if you play it on your device, but we would still like to see what you guys have to come up with. All right, guys, that's it. Java is done. Bye.
See ya.
Hey, guys, thank you for following the Android TicTacToe Lab in the Programming in Java course from Wibbit.net. Please feel free to access the source code for this Android project, which is available on the website. We're offering 2 different versions of the source code, the version that we wrote in this tutorial, and another version that is actually the one that is on the Android marketplace, which contains a lot of code improvements and efficiencies, as well as a basic tic-tac-toe AI. So please help yourself to the source code, and we hope you enjoyed yourself. Happy coding.